What is up, guys? Welcome to the Python AI tutorial 2021 for beginners. All right, so I'm Aaron. If you haven't seen me before, I'm on the channel a little bit. I'm not Kazi. I look different than Kazi, but this is gonna be a crazy tutorial. We were looking around on YouTube a few months back and we didn't see that much AI stuff, so I started dropping these cool tutorials. I was doing some face detection and everything, and we kind of lumped all these projects together into one so that you guys can learn how to actually start your AI journey and take the first steps towards being an actual data scientist. So this is very beginner friendly. It's not too advanced. If you've never coded in anything related to artificial intelligence before, that's totally okay. This is built for you. I explain everything in detail. Me, and then there's some other instructors too. I think Naz and Kazi and Sunny also teach a little bit in here. But I'm throughout the whole thing, so I hope you like me, because if you don't, then all right, so we're gonna be building 4 amazing projects, okay? 4 of them. The first one's gonna be the face detector app. So this is very useful for things like Instagram or Snapchat, where people, you know, that you have your phone and you're like, hey, and you have like the face filters. So this is actually what they're using to be able to like detect your face and like superimpose something over. So that's really cool. The second project is actually gonna be a self-driving car app. So it's gonna be like car detection and pedestrian detection in real time. And this is the kind of stuff that Tesla uses, and companies like Lyft and Uber are actually starting to implement over time, because computer vision is the way that they want to go forward with self-driving cars. Okay, so Elon Musk has even said that it's all computer vision, no weird sensors and stuff. It's just complete AI. Okay, so we're gonna be doing that as well. The last one is smile detection. That's pretty cool because it can actually like distinguish 2 different expressions on your face, and we're gonna be detecting that in real time. And the 4th project is we're actually going to be doing a intro to TensorFlow, which is pretty much the most popular machine learning platform, library, framework, whatever you want to call it, out there, that's available for Python and a few other languages. But we're going to be doing an intro to that, pretty much building our own neural network from scratch, and actually having a cool image classification app that can actually like classify different types of images. So if you're excited for this, please let us know in the comments below. Yeah, guys, and that's really it. So I handpicked these 4 projects for you because I feel like they're just really like a good bite-sized projects for beginner, to go from complete beginner to maybe like beginner intermediate in AI and really get you started. Okay, other than that, you guys, hope you enjoyed the video, but if you're interested in actually excelling your skills in Python and actually making a real income from it, a real living, then please click on the link below to check out our course Profit with Python, which does just that. It pretty much assumes you're a beginner and takes you through the complete roadmap from beginner to actually making an income from beginning to end using Python, and to actually become a full-fledged Python developer. All right, you guys, I know we've been sleeping on Python for a long time. We've been doing all the JavaScript stuff, you know. This mic's not even plugged in, by the way. But we've been doing JavaScript, React, Merge Stack, all that stuff. But don't sleep on Python, because Python is huge, okay? For the backend, pretty much everything uses Python. Python's everywhere. So you really need to know Python as well. Make sure you know your Python. So other than that, hope you guys are excited. Let's get started.
Today I'm here with
Mr. Aaron Burnap. What's up, you guys?
from the Python tutorial. And by the way, guys, I want to kind of just show you what we're going to be working on today. Look at the screen. Yo, Aaron, what are we looking at right now?
This is Robert Downey Jr.'s glorious face with his
Going to be learning real-time face detection with Python. If you are excited, please drop it in the comments below and let us know that you are excited about this. This took us forever to put together. I apologize, we were late today to the stream. We're 45 minutes behind, but to get a lot of things set up for you guys and make sure that you guys get a great experience. Now that we're here, guys, take a look at this. Here is Aaron's face, and it is actually being detected right now. Right?
Yeah.
He can. So look at that. He can move around. Right? It detects his face with a pretty high level of confidence. And this is all real time, you guys. This is with Python. And today, the biggest thing we want to do for you is show you how you can do this yourself with a few lines of code. And we want to make it as simple as possible, because there's so many different places to show you how to do this, but they don't make it simple. Right, Aaron?
Yeah, a lot of the other tutorials, like they added a bunch of unnecessary code to get up and working. Like this is actually a pretty small app, to be honest. There's not that much code, but there's a lot going on behind the scenes, and we're going to build it first because that's the fun part. We're going to get it all going. You guys can have it on your own computer running. You can detect your own face and whatever other embarrassing videos you have of yourself. But then I'm also going to explain it at the end of actually what's going on instead of just like a bunch of like code in your face. I'm going to explain in layman's terms. So it's going to be interesting, a different approach than what you've probably seen before, but it's going to be good, you guys. Excited.
Awesome. Okay, beautiful. We are pumped. So I think at this point, what should we take a look at now, Aaron? Should we go ahead and look at like how the algorithm works?
Yeah. So, first of all, here's the Robert Downey Jr. photo I caught from the internet just to prove that it's what didn't already have the green square.
Yeah.
But yeah, I have this little presentation here. So let's just start this up first, just to give you a little debriefing before we jump into the code, you guys.
Yeah.
So first thing here. So in a super simplified way, but just to give everybody context, because I know a lot of you guys are beginners. We were all beginners once, me, Kazi, all of us.
Yep.
And I just want to give you a short step-by-step thing of how like face detection actually works with Python. All right. So first step, the first thing you want to do is, of course, this is going to be a machine learning thing. That's really the only way or the most popular way to do this kind of things. You have to train it on what a face actually is. And then from there, then you're able to classify faces down the road. So step one, get a crap load of faces. Clear? Good.
Yeah.
And from there, we actually don't need it to be color. So step two, we're just going to make them all black and white.
If you just real quick go back to step one, I want to highlight what you're saying because you're saying something really awesome there. And I want to make sure everybody truly, really understands this, you guys. So this is awesome how Aaron is putting this together for you. Take a look at that. Like, first thing we do is like we give our algorithm, like we want to give it tons of faces so it knows how to detect a face. So we're just giving a ton of faces. You can see George W. Bush in the middle, and then you can see like there are thousands of faces around it. So that's our first thing that we're doing. Get all of the faces, right? So what are we doing then on step two?
So after you have all the faces, we actually don't need it to be color. Reason being for this is because what defines a face isn't so much the color, it's more so the composition of like this set of pixels. Like, okay, there's two eyes, a nose, and then there's like some reddish or like dark color or lighter color lips, depending on maybe some teeth or something like that. So we get rid of the colors because it hurts the performance of the algorithm, I believe. But the way OpenCV does it, which we're going to be using it, OpenCV, if you don't know what OpenCV is an open source computer vision library that some people put together. I don't know who put it together, but it's called OpenCV. We're going to be using that. And they have a lot of cool computer vision functions that we can use to build our app. So the first step we're going to do is we're going to turn everything black and white. All of those faces that we had at the beginning here. That's the very first step.
And we turn them black and white because the computer, the only way that algorithm knows how to look at a face is in black and white. So you want to give it that. It's not going to be looking at it in color. So we turn it into what we call grayscale.
Grayscale, that's the word, yeah. And then from here, once we have all of our black and white images, our face images, we can pump those into the algorithm, and it will eventually learn how to detect faces. So as you can see here, it's detecting all these different faces here, whether you have glasses, open mouth, frowning, smiling, eyes closed, hair. I mean, the hair is all similar here, but you get the idea. If you train it on enough data, it can recognize babies, females, males, even monkeys. So that's pretty much the oversimplified three-step thing. You just get a bunch of faces, you change them to black and white, and then you train it, and then you run your face classification code, and it will find all the faces in your image.
Awesome. So that's a pretty simple three-step formula, right? So step one, just go to step one real quick. Step one, get a crap load of faces. Step two, turn them black and white. Step three, train the algorithm. That's it, guys. It's just simple 3 steps, okay? Hopefully you guys understand that. So again, get lots of faces. 2, turn them black and white. And then 3, just train the freaking algorithm. And now you're good to go. Now it's going to start detecting everything. So like to actually use it, you guys, it's stupid simple. It's like 10 lines of code, and then boom, your webcam is working and everything is working. So like step one, get away from the fear of like what it means to actually use these types of algorithms. First use them, play with them, and then go deeper into the complexity and everything so you can start to understand and make your own models. Wow, we have 664 people live. That is awesome.
What's up? That is awesome.
Yeah.
Welcome, you guys. Anybody just coming in? We're making a face detector if you came in a little bit late. But yeah. So with that said, this simple 3-step process, let's just jump straight into the code, you guys, okay? Let me give one more quick demo in case there's anybody new.
Aaron, and what I was actually even thinking of, maybe you could have code on the left-hand side. So you could actually like make your code like on the left-hand side. On the right-hand side, you could have the webcam open the entire time. You see what I'm saying?
Yeah, the thing is, the way this is implemented is...
You're gonna have to keep running it. You have to keep running it. Yeah, that's okay. That's okay. No worries. Okay. Let's keep going.
So we'll just keep it this way. The code is big enough for you guys to see, right? I think that's big enough.
And by the way, you guys, if you are enjoying this video, Aaron, open up your face detection again, just so we can see it. Unless you comment that. So guys, if you guys are enjoying this, and if you think this is cool, I think this is so freaking cool that we're doing this with Python right now, make sure to hit that like button. It's free. It doesn't cost you anything. It helps us get the video out to so many places. So please go down below and like smash that like button. Subscribe to the channel if you want to learn from Aaron, myself, and all of us that we just give you so much value. So please hit that like button and let's keep it rolling. Piyush says, by the way, Piyush says, read this comment, Aaron. He says, Aaron taught me how to code in Python. Today, I finally completed my Titanic dataset. Thank you.
Titanic dataset? Titanic.
So, probably something he probably learned from you and then went and like applied it on something else. Yo, we
right on, man. Right on. I don't know what that means, but it sounds like something I wouldn't understand. So keep at it.
That is awesome.
All right, you guys.
Aaron, 826 people live.
826. What's up, you guys? Let me just keep this running. It seems like people keep flooding in. Where's here we go, you guys. Okay, this is what we're building, you guys. Let's just jump into the code. I think we're almost at 1,000, so let's just get started. All right, so let me comment out all the code that is pre-existing here. So we can start from scratch for all you guys. And actually just all of it. Okay, so the very first thing that we're gonna have to do is obviously install OpenCV. So if you're following along with me, then please install OpenCV. And you can do that with the command, wait, I gotta quit out of this, 1 second. It should be pip, if you're on Linux or a Unix system.
Do me a favor, a few things, Aaron, do me a favor. Take your terminal, put it in the middle, and then also hit Command plus multiple times. Hit Command plus just to zoom in. Yep, and make your screen smaller, and then it's easier to see for everybody.
Terrible habit. That's big enough, right?
That's really good. That's really good. So it's easier to see for everybody.
All right, you guys. So the first thing you're gonna want to run is pip install python-opencv. Okay, I've already installed it. Also maybe add headless here. If you're getting errors, this is optional, but like if you're getting weird errors, try running this as well, and it might work. But this -headless is optional. But point is, install OpenCV. That's the very first step. Honestly, there's no way I can help you install it if there's an endless amount of errors you could get, but you're gonna have to probably Google it and look on OpenCV. So like if you are getting issues, let me just do that. Let's see, OpenCV installing issues or something. I'll just give like a brief thing. Find a Stack Overflow here, OpenCV installation problems. You probably come into here and there's no answers on this one. But I mean, point is, yeah, just install OpenCV. And hopefully that command should work for you, the one that we were just looking at here. And once that's installed, then you're pretty much ready to go. All right. So from here, you can come into our code. And the first thing we're going to want to do is simply, first, you're going to want to make a face detector.py file, of course. So start with making your first Python file, face detector there. And just to make sure that it's running, let's just do this. This is a little
quick
convention
shout out.
I like doing.
Just a real quick shout out to Pratik. He says, today I had an interview and I showed yesterday's project of Amazon Price Detector and I got selected. Holy crap. That is amazing, you guys.
Go Team Jacob.
Yo, we literally built the price detector. Exactly. We built the price detector yesterday, you guys, with Jacob. So that is huge. That is awesome. All right, let's keep it going.
Congratulations, dude.
Yeah, that is so
Great.
sick.
All right, you guys. So once you have your Python file created, facedetector.py, then let's just make sure it's working correctly, okay? So the first thing you're gonna wanna do is just run well, make sure you're in the right directory. So you wanna make sure that the facedetector.py file is in my, in the same directory. And then from there, then you can just run Python and run facedetector.py just like that, okay?
Nice.
And then hit enter. And as you can see, it says code completed here, which is the print statement. So everything is hooked up and working correctly. That's the very first step. And I like, personally, when I'm coding, I like to keep this at the end of my program, because then I know that if this shows up, everything in my code ran and no errors popped up. So I leave this at the end. So that's just kind of an error convention that you can adopt if you like. But now that we have OpenCV installed, the first thing you're going to want to do is actually import that library. So that library is called CV2. This is, I think the 2 just means version 2. It's been CV2 for a long time, but it's called CV2. You have no choice. Just type it in. And from here, go again, and then let's see if we get any errors. Run the same command. And as you can see, it says code completed, which means it ran this and imported the library without any issues because it reached this line. So from here, now we can actually start coding with OpenCV. So coming back down here, one thing you're going to have to do is, here, actually, let me go here. So OpenCV, like I mentioned earlier, is a open source computer vision library provided by some people. And they provide a lot of pre-existing code. Of course, it's a library, so they have code that we can use that we're going to be using that we just imported. But they also have some data files for us. So what this is here is actually pre-trained data. So if you look here, there's so hard cascade is an algorithm. We'll get into that in a little bit, but just ignore this big scary word. Hard cascade, and then it might say this is the one we're going to be using, the frontal face default, because this they provided us with a bunch of data, and they actually trained this on a bunch of face images like the ones I showed you in the presentation before, like this. But they're
basically
black and
that. Yeah, so that data is actually trained on tons and tons of faces, like frontal faces, right? Just like this one.
Hundreds, yeah, like all of these, like
Yep.
all ages, all that kind of stuff. But frontals, you know, so there's no like blockages, there's no side faces.
Yep.
None of that, just front faces.
Yeah.
So from there, they provide all that. So what you're gonna have to do is actually download this. So if you can just go to this URL, okay, github/opencv/tree, blah, 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 and just go to the default, this one, frontalface.default.xml, and download it. It'll be right here, and it's just a big XML file. And all this is basically a machine learning machine. And when you pump an image through all of these numbers, it'll tell us and find if there's a face in the image or not. And as you can see, this goes on forever. So this is actually what was already trained on like thousands of images. So you want to download this because OpenCV provides it for you. Training it yourself is a gargantuan task of its own. So we're not doing that in this video. We're just using what they're providing for us. Maybe we can do that in a future video. But point is, download this from this URL, and then we can continue on from there. So any comments, Kazi?
Awesome. No, I love it. Basically, guys, to summarize it, all we did so far is literally just downloaded that file. That's it. So it's really simple. Just hard cascade frontal faces, I think default or whatever, and then download it, put it in the same directory that you're in, and that's all we've really done so far. And
I have mine right here. See, right parallel to here, along with my Robert Downey Jr. photos and stuff. Oops, not this one. So once you have this installed, then we can go and import it into our app. So the first thing is, well, first of all, I called my variable trained face data because that's what the heck it is. And this is the name of the file we just downloaded, an XML file. I forget what XML stands for, but it just looks like this with all these tags. From here, you're going to want to call the OpenCV library and call this function to make a classifier. So all a classifier is, it's a fancy word for detectors. So detector. So we're making a face detector app. A classifier can classify something as a face. That's all it really is. And then cascade is, again, the algorithm, the hard cascade I was talking about. We'll get into that later. Just ignore the scary word. But what we're going to do is we're just going to pass in that training data and create a classifier for this. And since this is the front-facing training data, then this classifier now will be able to detect frontward-facing faces, and that's what we have here. Okay. So as you can see, I put a comment here to load some pre-trained data on face frontals from OpenCV. From there, we can continue to choose an image or a video stream or our webcam, and then we can actually pass that into this classifier and be able to find the location of faces, and then we can put the rectangle around it. And you have to like draw the rectangle on the image or the video, and we'll get to all of that. But moving on, the first thing we're going to do, let's just do the Robert Downey Jr. Photo. I'm just going to copy and paste it just so I don't have to type it out. But I'll go slowly so you guys can type it out yourself. So the first thing we're going to want to do is choose an image to detect the faces in. So mine is the Robert Downey Jr. photo. So the way you do this is you want to call the image read function from OpenCV. So very simple. The image, you're going to read it in, and it's going to be the photo that I just had of Robert Downey. So that should be this one. Okay. So it's on my desktop here. And once you have that there.
Somebody just donated to us, bro. That is awesome.
Really?
Yeah. Hashtag Yo Garage.
Dang, I can buy lunch today. Yes.
Yeah, finally.
Thank you. Appreciate that.
So that's awesome. Thank you so much for that. He's like, please make a Uber or OLA clone app using React Native. So we might not be using React Native, but we're going to be making a bunch of clones with React. So Uber is not on our list yet. We might think about putting it on our list. We are definitely going to be doing TikTok and I think Spotify and stuff like that. And then Uber, we might do it at some point as well.
I'm not sure what OLA is.
Yeah, not sure.
I'll look that up later. But anyways, this is how you import an image into OpenCV. Okay, so this is actually, I mean, an image is just an array, like a big matrix of a bunch of numbers. You know, pixels are just numbers. So really what this is, you're just reading the image into a big, like double two-dimensional array. So a big image, a bunch of numbers and bits. From there, now we can actually change it to grayscale. So again, let me see if I can actually show this. Yeah, so let's just go one step at a time.
For the har cascade frontal XML file link. So maybe you want to just go to the GitHub real quick and maybe just show the URL, and then they can pause it on there. So just go there and show the URL. So you guys can pause it here and type that in, and then go to it. Okay.
Yeah, maybe we should put it in the description or something. That might help.
Yeah, we'll put it in the description too at some point for sure.
After. Okay, here, and make sure you're downloading the frontal face default, this one. Okay, there's also cat faces and stuff. I mean, you could actually use all these other ones like lower body, upper body, just the profile with face.
You can detect smile.
All this stuff. Cool. Yeah, just eyes. Yeah, what's cool about this is you can detect anything pretty much. You could detect Coca-Cola cans and stuff, but we're just doing faces. Like the same algorithm works for anything. Like it's very generic and robust.
Russian plate number.
I don't know what that is. Oh, probably like a
car license plate.
Probably a license plate.
Right.
Yeah, like for Russian cars.
Yep.
But anyways, yep. So here again, URL, download this one. Okay. And once you have that, then we can continue on. So let me just show this image first. So I imported the Robert Downey Jr. image, and so image read, we read it in, and then to show this image, there's another OpenCV function called image show, IM_show. And this string here is just going to be the name of the window that pops up, and then this is the image you want to display. So let's just save this and run this to show you that the Robert Downey Jr. stuff is going to pop up. And what is wrong? Oh, I forgot. You also need this thing. Let me just make sure it works first before I explain.
So the wait key basically waits for it. Yep. So the wait key, you need it because guys, otherwise it just closes instantly. Go ahead.
Yeah, so what this does is it actually pauses the execution of your code. So it will show the image, and then it will continue on to the end of the program, and it'll terminate the program because it got to the last line here, and it's like, okay, I'm done. So it'll open this for a split second, you won't even see it, then it'll close it immediately. So what this means is this will wait until a key is pressed. So you can press any key to continue in the execution. So it gets here and it waits, and it keeps this open so that you can view the image. That's just the way OpenCV is implemented. I mean, if you like it or hate it, it's just how it is. But once you have that, then you can run the program. And of course, Robert Downey Jr. pops up here in color, just like I said, okay? And of course, you can hit any button on the keyboard. I just hit space bar and it just closes it. And then of course, it says code completed and I'm back to the terminal. So I'll show you step by step as we're going what it looks like. So we'll just keep these two together, okay, at the very bottom. And okay, so we have a Robert Downey Jr. image in here. Next, we are going to, like we said in the presentation, we got to make it black and white because the algorithm that we're going to be using, the HAR cascade algorithm, the way it's implemented only takes grayscale images because we can still identify faces in grayscale. We don't need the color. I mean, you can do color, but that's a much more complicated. Like if you want to classify like skin color or race or even like actually identify people, that's even more advanced. That's what Facebook does. You know how you can like tag your friends, it automatically knows their face. That's way more, you need way more training data of like one person to do that. So we're not going to be doing that here, but I just want to mention that. So
Aaron, one real quick side note. What can they do if they want to learn not only these types of skills, but also learn how to make an income with these skills? Where can they go?
Yeah. So if you like coding in Python and you want to learn how to actually make a living from it. So if you want to start coding and landing clients or land a job and just like get your skills and your confidence up and have projects on a portfolio and all those things and really just do this for a living, then we have a course called Profit with Python, formerly called Profitable Programmer. So if you hear either names are the same. And the link is in the description if you want to join that.
Yep.
We can actually...
And I'm showing it on the screen, actually. So I don't know if you can
right
probably not see my screen, but yeah, I'm showing it on the screen. So guys, the program is called Profit with Python. So in this program, we show you all of these things that you're going to be learning today. You know, whether it's like detecting faces or building e-commerce stores or any kind of project that you can take from Upwork, web scraping, as advanced as you can think it. And then we show you how to actually land those clients. So one of the biggest things we focus on is like, how can you actually earn a killing with Python? That's huge for us. We have dedicated Python success coaches. And really one of the most important things in this program is the fact that you get weekly live Python training calls. Now, Aaron, like, what do you think is a benefit of those like live calls, you know, for the Python like live training calls?
Live training calls, I mean, humans learn live. That's how we've been learning all throughout history. So having somebody there to give you real-time feedback and answer your questions right then and there is like evolutionarily, if that's even a word, the best way to learn. So it's pretty much like you're in a college course, you know, but a cool one because you have a cool teacher and you can show up and do whatever you want. But there's live calls where you build apps together and you can ask all your questions. Yep. Directly to a Python expert.
That's you guys Jacob, are literally building full projects every week. So like Jacob is building an e-commerce store. Like you guys think we're building live projects on our YouTube? Wait till you get inside of the program because there the conversation turns over to you and you are the one building all these projects. And then we're giving you personal video feedback on each of your projects that you build. And we get tons and tons of submissions from people. Like even right now, you know, if I show you guys here, like we have tons of projects that people are sending in that they're building with Python, that they're building, like people are building COVID trackers and all kinds of stuff. So here's an example of a project. Boom. Here's something that was built and I can switch it up into any different country and you can see that it pulls the queries, it shows all this data, and people are using these skills to freelance. So if you guys want to learn these skills, you want to be able to make an income with Python, then definitely go and check out in the description below. The program is called Profit with Python, and we would love to see you inside of there.
Yeah. So, because coding's fun, you know, building projects like this is all fun. But I mean, if it's fun, then it's just a hobby. If you can make a living from it, I mean, I say why not? Because then you can have your fun and make a living from it and do it more. So that's why we provide these courses. We love helping people like do what they love, being coding, and just live the lifestyle they want instead of, you know, slaving away at a job they hate, whether it be like retail or fast food or whatever it is. So that's why we're mentioning that. Optional for you, but definitely there. We would highly recommend it and just check it out. Man, let's just keep going. going.
Go for it.
For the viewers.
Yep.
Where was I? I imported the image. So like I said, we need to make it grayscale because the algorithm requires to be grayscale because it's just easier to only deal with one number on each pixel. The color, it's like on a range from like black to white instead of like there's no RGB in each pixel. It's just one number instead of three numbers across red, green, blue channels. So we got to change it to grayscale. So of course, OpenCV allows us to do that too. And let me just go grab that code down here. And I will just paste it, and you guys can type it out yourself as well. So as I said here in the comment, you must convert it to grayscale. And so I just called the variable grayscaled image because it's the same image, but grayscaled. And the function that you want to call is convert color. So opencv.convert color, and then you give it the image you want is the first argument. And then the second one is what kind of conversion you want to do. Because this function, actually, you can do a lot of different things. Why don't we pull up the documentation? I'll just show you a little bit really quick. Convert color, so OpenCV documentation. And let's just go here. Not this one. This one.
Just looked ugly.
Yeah, it is. I got out of there quick. We just lost 600 people in 10 milliseconds. Where is it? Probably, I guess there's a bunch. Gray, basics, thresholding options. Is this the right documentation? OpenCV 2.
Okay, once
here
you
we
find
go. Okay, CV2.convert color.
Found it? Awesome.
Yeah. So here, convert color, you have a bunch. So the first one is the source image, which is the Robert Downey Jr. image that we had first. And then there's a bunch of different things you can do. So for us, we're going to be using grayscale, but you can also change, like you can change the gray, you could change color to just the red channel or just the blue channel, or you could like dim the whole thing. Pretty much you can convert the image to whatever you want. There's a bunch of stuff in here. Definitely check out documentation, but just wanted to show you guys that because this is actually where you would find how to do that instead of just like, oh, Aaron told me to type it. No, the documentation has all the information you need. So you can go check it out. You can play with it. But for now, we're just going to do the very simple one, cv2.color, BGR to gray. One caveat to, or one little quirk to OpenCV is, I'm sure everybody knows what RGB is, red, green, blue. That's how each pixel can like mix those three channels colors together and make any color for each pixel. But in OpenCV, the channels are actually backwards. So instead of RGB, it's BGR. And that was very frustrating when I was first learning it, but just be aware of that. And that's why it's BGR to gray, because it's taking this image and then turning it to gray. So let's just show you what that looks like. So instead of displaying the color image, I'm going to display the grayscaled image. Let's go back to our terminal and type in Python facedetector.py again, enter, and voila, we have a grayscaled Robert Downey Jr.
Beautiful.
Looks just as sexy.
That
as
is nice.
in my opinion.
That is nice.
All right, you guys, and then of course any button to quit out, and we are back to our terminal. And now we can continue. So that's pretty simple, straightforward. I'm sure you guys all understand at that point. Again, go check out these different settings. There's a bunch you can do, and of course you could even convert it from gray back to RGB, and it would be considered an RGB. But the thing is, when you lose the color and it's gray, then it actually is just gray. So you won't actually get the color back, but it'll technically be a color image, but it's not actually going to look like it. But I'm getting off topic there. From here, the thing we're going to want to do next is, going back to our little presentation here, is we want to train the algorithm, right? But that already happened. OpenCV was already able to do that. So all we want to do now is to plug that gray image into our algorithm that we were given by OpenCV, the XML file we downloaded. And from there, it'll be able to open up all these, or detect all of these faces. So like this is actually one image and it detected all 8. And that's what we're going to be doing next. So let's just quit out of here, go back, and let's just detect faces. So yes, some of you guys are probably like, oh, maybe this is kind of fake. It's just one liner that is detecting all the faces. That is true, but like I said, at the end of this video, I'm actually going to go through the whole algorithm and explain it in layman's terms so that you can actually understand how this is working and why it's working and all of that, because then you'll have a full understanding. And there's no point of coding it yourself if it already exists. So this is actually the better approach, because you can understand it, you can get the result,
And that's all you need. Once you have those two things, then you can innovate further and go on and optimize or create your own algorithms for your own problems. So yes, this is just one line to to detect the faces. But I mean, shorter code is better, right, Kazi? Shorter code is better.
Because like, look here.
What was that?
But shorter code is always better, less errors. I hate having a lot of code. I even try to get my functions never to be more than like 4 lines of code, or I'll refactor it.
Yeah, nice. Having nice encapsulated code, that's the word for it. Like if your function is just, it does one thing and one tiny thing, then you want to encapsulate it in one thing and keep your code very modular so you can plug and play functions all over the place. So
says, you guys are amazing. You guys are putting so much effort to make us understand things like Python, and you were doing this at midnight as well. So amazing, you guys. Love you all. Thank you so much, Johnson. We are not doing this at midnight. It's 12
it was
p.m. my
7:30
time
a.m. for me.
Yeah, yeah, really early for Aaron. But thank you. We appreciate the support, guys, and thank you for the positivity. That really keeps us going.
Yeah, guys, we wouldn't be doing this if it wasn't for you guys. Like there's no reason. If nobody's watching, then what's the point? So
yeah,
thanks for sticking around and putting up with us.
Yeah.
All right, so here, what's happening here is, before we created our classifier, the trained face data that OpenCV supplied for us within this XML document that we downloaded, and from there we're going to call a function called detect multiscale. Okay, so this probably sounds a little bit maybe scary, maybe not to others, but all this means is whatever this classifier is, which is a face classifier, since that's what we trained it on, the trained face data, then we want to detect all of the faces with a multi-scale thing. So all that means is no matter the scale of the face, if it gets smaller or bigger, then if it's small or big, then it'll detect it anyways. It's just looking for the overall composition, like the relations of the eyes to the nose to the mouth, whether it's small or up close, or if there's multiple of them, then it just wants to detect all of them. So that's what detect multiscale is too. Why don't I actually pull this up on the documentation as well?
Quick question, Aaron. Prakar says, can we use phone camera for detecting the face in real time?
Phone camera. I mean, you would have to somehow connect your phone camera to your laptop so that you could run OpenCV on there. I think OpenCV has mobile support, or to some extent. I've never done OpenCV on mobile, but they might.
I'll take a look at it.
Do it. Yeah, but you would have to somehow hook up your phone camera. I mean, I'm sure it's possible somehow. I haven't personally done it, but you'd have to hook up your phone camera to your laptop and then pipe that into OpenCV somehow. Like maybe you make it your default camera. I actually think.
Yeah, I'll take a look at that. You don't have to worry about that, but I'll take a look at it and see if something like that exists. But if you guys do understand how to use it this way, then you'll be able to even use it later for phone camera and things like that.
Yeah, we're focused on teaching a thorough understanding of the basic building blocks, like all-encompassing everything, so that when you learn this, then you're equipped to actually go do your own innovation, implement your own creativity and do those kinds of things, because that's where the real learning happens, and then you can be original. Like, I don't just want to be like, hey, here's this project. It's like, here's the skill. Now you can go do what you want with it.
Awesome. All right, let's keep going.
So let's just open up this detect multiscale. Here we go, cascade classifier. And here we go, so detect multiscale. This one, it basically detects objects of different sizes in the input image. So objects is just faces in our case, because that's what we trained it with. We could have trained it with dogs, we could have trained it with cars, with houses, but in our case it's faces. And from there, the detected objects are returned as a list of rectangles. So pretty much it just returns the coordinates of those green rectangles, and once we have those coordinates, we're able to actually draw those rectangles on our image. So that's what we're going to be doing next, okay? So from here, detect multiscale, we feed in the grayscale image, which is a Robert Downey Jr. image, and like we said, this returns the coordinates of the rectangles. So that's why I called it face coordinates, because it'll give us the coordinates of the rectangles surrounding the face. And then from here, once we have these coordinates, it's very simple to just draw rectangles onto the image or the current frame of the video if we're doing a video, and it just runs on every frame. So from here, why don't we actually print out, first of all, we don't need to display Robert Downey Jr. anymore, but why don't we actually print out the coordinates, okay? So face coordinates. Did I spell that correctly? Yeah. And let's just run the code. Okay, so the coordinates of Robert Downey Jr.'s face should be displayed in the terminal. And
Can you do me a favor? Can you make your terminal like wider? That way your line of code can show on one line instead of wrapping. Perfect.
Yeah, my dirty coding habits. Like, I've got bad habits beaten into me, but all right, you guys. So this is the location of Robert Downey's face in the image.
Is it possible, Aaron? Is it possible to also later show the face coordinates, but with your face with the webcam open, and so then as you move, it like actually prints out the console logs in the terminal?
Yes, actually, yeah.
Okay, so let's do it like that.
Idea. Well, let's do that. Yeah, let's do that once we get to the webcam. But right now we're just focused on getting one single image up and running.
Got it.
So I'll explain this. So what this is, like I said, it returns the coordinates of the face. So all this is the upper left coordinate of the face, and this is the bottom right coordinate. So just a bounding rectangle. That's all it is.
Can you just show it visually? Like, can you open up the Robert Downey Jr.'s photo and then like show what you mean?
Yeah. So like I was saying, of course this is going to be grayscaled within our app right now, but just for demonstration purposes, the face is about right here.
Okay.
So this 307 115 would probably be right around here, the upper left hand of the face, and then this 336 would be right around here.
The bottom right corner.
Bottom right, so that you have a bounding rectangle. And then from here, it's very easy to just actually draw the green box surrounding the face, and that's how it happens. Okay, we're doing all that manually. We're actually we're finding the location of the face, and then we're drawing the rectangle around the face, and then we're displaying that new image with the rectangle. So that's exactly what's happening with it.
And the rectangle that we're drawing it from a module in OpenCV. It lets you draw as well?
Yes.
Got it.
And wait, how do I get rid of...
Yo, Tony, how's it going? Awesome. This is Tony that was actually... Yeah, you know him,
Tony
right, Aaron?
Orbis?
Yeah.
Yeah, Tony Orbis. What's up, man?
Yeah, this is awesome.
Dang it. I think my terminal bugged out. Let me just terminate and open a new one.
Cool.
Terminal. And LS desktop. And clear. And again, Python is going to be face detector.
You're not in that file, I think. You have to go in that file. Why don't you open up your terminal in Visual Studio Code?
I could do that. What is it?
Command J.
Command J.
Yep.
All right, and go to my bash.
You can be in your...
So CD, that's fine. Desktop. Yep. And from here, we can run Python. I think it was face detector. Or .py. And there we go.
Awesome.
I actually haven't run it from here. Let's see if it actually displays the image. I haven't actually.
Swipe up. No. It's running. It's running. So use your 4 fingers to swipe up on your mouse pad, and then and then it'll show. Oh, it doesn't have. Yeah, it's. I thought it would visually show it.
Key. It's because I'm printing the coordinates and then the wait key, but it's not displaying something. It's just bugging out. So let's just terminate this. Is this how you terminate it?
Yeah, just open up a new. Yeah, perfect. You can just open up a new terminal if you want.
Yeah.
Oh,
I'm gonna stick to this one because then I can. Because I like having the full code open, the whole thing at one time.
Okay, got it.
So back to desktop, Python, face detector. .py. Okay, there we go. So from here, then we can continue on. Yeah, the wait key bugged out because there was nothing popping up. There was nothing to close, so nothing to actually capture a key and then continue. But that's not that important. Oh, hello, Kazi.
Hi, guys.
And yeah, so those are the coordinates. Now from there, like I said, we want to superimpose a rectangle over the image so that we can display it back. And of course, we want to do it with the color image again. So once we have the coordinate, we can go back to the color image and draw the rectangle on the color image once we get the coordinate from the grayscale image in the algorithm. So let's just comment this out. And the next thing is we're just going to draw rectangles. And of course, if there's multiple faces, then it'll draw rectangles around all of them. So we have a loop. But actually, let's just delete that for now. Let's just start with one rectangle. So to draw a rectangle, this is the function. So OpenCV again allows us to just call something called rectangle. And what it takes is an image that you want to draw a rectangle on. So of course we want to use our color image originally, the Robert Downey Jr. Then the next one, it takes a tuple of the upper left hand coordinate.
Got it.
This is the lower right hand coordinate. So this x, y, and x, this doesn't work because I had the loop. So let's actually just delete this for now. And like I said, the face coordinates is what we want. So the upper left hand would be whatever face coordinates gives us.
Yeah, so face coordinates gave us like that 305 thing, right? Like 305, 116, whatever we had in the command line earlier for the Robert Downey Jr.'s face.
Yeah, so actually, why don't we
manually run it.
Type that out.
Perfect.
Or just actually just manually put in the numbers just to show you guys that it actually works.
Okay. So I'm just going to show visually what we're doing here. You might not be able to see my screen for a second. Okay, so just hold on, and I'm going to just explain this also visually. All right, guys. So basically, if you guys are with us so far, what Aaron is about to do right now is we're going to have Robert Downey Jr.'s face like this, okay? And I don't know if he's smiling or whatever. And then around this, we're going to draw a rectangle. Now, what we need is the top left. So, Aaron, the 307 and then the 116, do both of those coordinates refer to like
X and Y pixels?
X and Y pixels. Okay, so one is the top. So basically just 2 points, right? One is the top left point and one is the bottom right point.
Yep, that's it.
Okay, so this is going to be, and what are the first two numbers, Aaron? Is it 305, comma 1? What are they? Can you tell me?
307 and 115.
Okay, so guys, that's that point over there, okay? Then we have the second point here, and what are the coordinates for the second point?
336, 336.
Okay, so it's 336, 336. All right, so here are the two tuples. This is tuple 1. This is tuple 2 right over here. And that's how we're going to draw the rectangle around somebody's face. We need those 2 points. Once we get those 2 points, CV2 allows us to actually make a rectangle around the face. Okay, so that's what Aaron, the line of code that Aaron has, if we go look at his screen right now.
Right here.
Yep, so that's those coordinates that he's referring to.
These right here.
Yep, and that's what we're going to do.
I just hard-coded them in just to show you guys for now.
Exactly. And then I imagine the 0255 or whatever, that's the color. Like it's going to make a green color or something.
I choose green. So this, of course, OpenCV is backwards. So this is BGR instead of RGB. So if this was 255, this would be blue. If this was 255, this would be red if I zeroed this one out.
Yeah.
But I like green, so I just chose green. But you could even make it white. You can make it black.
That's
whatever
fine.
The heck you want.
And what's the last two at the end?
The thickness of the rectangle.
Okay, perfect.
So how thin? That's all it is. So of course, if it's 10, it's going to be really thick, but 2 is a nice thin line.
Awesome. So this is, guys, this is a cartoon way of looking, more cartoony way of looking at it. How I've drawn here. You saw Aaron's the one line of code that he has right over there. So now let's go ahead and actually run it.
Got it. So here we have the rectangle being drawn on image, okay, and then down here we have an image show, and here we still have the grayscale image. So all we got to do is just change this back to image, because now image has the green rectangle drawn on it around his face. Let's give it a save. Let's go to the terminal and let's run it. And something is wrong. Might have these backwards.
Yeah, that's I'm trying to think.
No.
Let's just
Yeah,
go to
what-
rectangle documentation. No,
Yeah,
I mean,
what,
like that'll give us the answer.
What it does is it adds them. So if we actually look at the code that we had earlier, Aaron, the one we commented out or whatever, it's like x plus w and then y plus h. So you want to take
Yeah, it
the
has
x
the width,
coordinate
the width and
exactly.
height.
So you want to take the x coordinate and add the width to it, and then you want to take the y coordinate and add the height to it, and that will give you what you're looking for. So just add the width and add the height, whatever.
Yeah, you're right. I forgot that detail. It's so this is actually the upper left-hand point. Let's go back to there. Let's confirm that. So whoever developed OpenCV decided to implement it this way, probably because it was smarter in the long term. Instead of having the top left point and bottom right point, they actually have the top left point and then the width and height of the rectangle, so that you can just add this to these points to get the bottom right point. So I guess equally effective. It's the same data, just in a different way. So actually, what this would be 307 plus 336, and that would make sense why it's 336, because it's a square. It's the same number because the width and height of a square is the same. So now let's try it. Now it should run correctly. Back to the terminal. Oops.
Yeah.
And much better.
Nice.
Okay, so that bug was fixed, and there we go. So this is the hard-coded solution.
Is it still true that the top left point is 307 and 115? Is that still true? And then the bottom right point is 336, comma 336?
No, the bottom right point. This is the width and height of the square because it's a square, so width and height is the same.
So what's the bottom right point then?
That would have to be this point. To get the, I mean, it's just some coordinate math. So 307 is the x location of the top left point. So this is 307 this way.
Okay. And
Right
then
here,
the bottom
307.
right is just 115.
Yeah, and then this is 115. No. You have to come on, Kazi. You gotta add the 336 to the width and the height to this point. And once you add 336, it'll come out here and go down. So that's how you get the rectangle.
Okay. Got it. All
Yeah,
right.
the offset. So from there, we have Robert Downey Jr.'s face. Okay. The problem with this though is, of course, we hard coded it in, so we do not want to do that. Okay. What we do want to do is actually just get the points dynamically and then print those out. So like we just did, it's going to be like this.
Nice.
The thing is, we are going to want to make sure we are getting the coordinates from the face coordinates correctly. So x, y, width, and height, like we said in the terminal, okay? So this is x, y, width, and height here. And we can do that using a for tuple and just set this equal to face coordinates, okay? And this will automatically assign each of those four numbers, 1, 2, 3, 4, to these four variables, 1, 2, 3, 4. And now that we have these in a tuple, then we can just pull those xy and the xy wh out just like this. And this should work, unless I got my math wrong again, which could be very
awesome. We just broke 1,000 likes, I heard, on the video. That is amazing. Thank you, guys. Thank you.
One more value to unpack. Face coordinates. What is the last coordinate? Wait, what was it complaining about? Face in line equals face coordinates. Value error. Need more than
You
one
never
value to unpack.
Oh yeah, you actually did define.
Buggy. Maybe.
Wait, hold on. Isn't it face coordinates of 0 or something? Because it's a array with it's a list within a list. So you might have to like
there's the double brackets there, right?
Yeah.
I don't know why that is, but yeah, that'll probably work. So let's give this a shot. There we go. Yeah. Oh, I guess that makes sense because it's a list of here. That would make sense because if there's multiple faces, then you want a list of lists.
Yeah.
So you would have a second
Right.
face. Okay, that's why that's like that. That makes sense.
Yeah.
But there you go, guys. So now we have it dynamically getting the face with the coordinates here.
That
okay?
is so cool. That is so cool. Can you turn it red real quick? Just like
Sure.
real quick. Like that's awesome.
So there we go.
Sunny
So
was
you
telling
can
me you have like
HDR.
scary amount of knowledge on color.
Oh yeah, I worked at a I had a data science gig for 8 months doing OpenCV stuff, like exclusively, like 4 years back. So I
crap!
went
I
crazy.
didn't know
Yeah.
that.
Oops. Oops. Oh, I killed the terminal. But you guys gotta
Command T,
start
Command T,
over.
Command T.
Oh my
Okay.
God, no! I murdered it, Kazi.
Nah, that's
I'm
fine.
sorry. Brutally. It's dead.
That is
It's
hilarious.
dead.
Damn.
Oh, wait.
This guys, this is the right person. Keep opening it up, and once you open it up, do let me know. But guys, this is the right person to learn OpenCV stuff from. Like he just was doing this for almost a whole year.
Yeah, edge detection, motion detection, background. Like you can do a lot of cool stuff. But right now we're just doing face detection. So desktop, and again, let's go Python face detector.
Yo, Aaron, maybe like upcoming few weeks, just like go crazy. Edge detection, like bring all of that back. So yeah, you guys like look at that. We just turned it red, super fast, super
From
easy.
green.
Yeah.
So
Awesome.
you can change the color. I mean, minor detail, but yeah,
Yeah.
let's change it back to green because I like green better. And of course, this is the thickness. So let's just do a quick.
Yeah, change it to
That's
real
bad.
thick, like 5 or 10. That would be awesome.
Kaboom!
Nice.
Black.
That actually looks great. I like that level of thickness.
Like it? All right, let's keep it then.
Yeah.
So we'll keep that there.
That is so cool. Like we're detecting a face in real time and drawing the circle dynamically around it. And this code already works on any image you give it. That is mind blowing.
You could even have a circle instead of a rectangle.
But
You
it's
can
only
draw a
gonna.
circle.
But right now, it's only gonna draw it on the first person it sees. You guys. So if there are two people, it'll only draw it on one person's face. But once we write a loop, it's so cool. We're looping through humans. Like that blows. Like you're looping through human beings. That is insane.
Yeah.
It kind of blows my mind. I almost want to take a picture. I almost want to take a picture of us right now and send it. Can I do that? Can I just take a picture of both of us split side by side, and then you open that image up and run it on it, or is that too
Let's
much?
go for it. No, it should work.
Okay,
I mean,
cool.
Yeah, this algorithm isn't 100% accurate. The algorithm, the Har Cascade algorithm, is more concerned with speed than accuracy, so it might not 100% work, but like 90% it'll work. So let's just try it. Just make sure you have good lighting, and then it should work fine.
Yeah, I got good lighting. Let's detect it right now. So I pulled it from our live stream, and I'm sending it over to you in Slack. So what you can do in the meantime is just go ahead and pop it in to your, like, it's so cool to me. So just go in Slack and then pop it into your image. See what I'm saying?
Mm-hmm.
Okay, cool. But like, guys, this is so mind-blowing to me, the fact that you can actually like detect images. So like what I'm talking about, looping through human faces here, right? If I can just draw it out for you guys. So let's go over here and I'm going to draw it out. But let's say that we had, I'm going to clean this up. But let's say the image I gave Aaron has two people in it. So if you have actually two human beings here like this, right? What we're about to do right now, which is mind-blowing, is right now our code, all it's going to do is draw a circle around like one person's face. It's going to decide who, whether it's Aaron or me, and that's it. But then once we write a for loop, it's actually going to make a square around Aaron. So that's person one. And then it's going to loop through, find me, right? This is Kazi. It's going to find me. And then it's going to make a circle around my face, like a for loop that loops through human beings. That is just cool. Like that's the power of, you know, being able to actually do like face detection and AI with Python or really any language. Like it's so freaking cool to me. You know, if you guys think it's cool, go ahead and smash that like button. But to me, it's kind of mind blowing. And then whenever you're ready, Aaron, just let me know.
Got it. Yeah, so I got the picture of me and Kazi here on my desktop, and instead of reading the Robert Downey Jr. photo, I just want to read in this photo. So I just named it Kazi Aaron, okay, and I'm gonna comment.
Is it in the same directory? Okay,
yeah,
cool.
just on my desktop. It's kind of
Cool.
sloppy. I mean, to be
That's
honest,
fine.
but
That's fine.
I just keep it there just to get it up and running.
Can you show the image first? Can you show the image first by itself, so they don't think I sent it to you with green squares around it?
There we go. So this is the image, okay?
Mm-hmm.
I wonder, nah, I think, yeah, it'll detect my face there.
Yeah, maybe.
So,
We'll see.
so that is the image now. We're using that instead.
Yeah.
And from there, we want to detect all the faces. So right now, we only going to detect one. So let's run it and see who it detects first, Aaron or Kazi.
Yeah.
Let's just give it a shot.
Or if it breaks, we'll see. We'll find out.
And hey,
Whoa!
looks like it gets me first.
That is so cool.
And for that reason, it probably goes. I think it gets me first because it scans from
Can
upper
you,
left to bottom.
yeah,
right.
can you do me a favor and change that index? Like, dude, this is an array of us two, like in one fucking array. Like, I'm sorry, guys, excuse the language, but like, in
Censor.
one list, it's two human beings. Can you index that array? Can you index the list with one? So then it puts me maybe. Let's take a look.
Yeah. So because you're second in the list, so if we did
Yup.
this, then it would.
Oh, dude, this is about to blow my freaking mind right now. I'm so pumped.
Kaboom!
Oh my god, dude, that is cool. Like,
Yo,
that is so cool.
Let's see if there's a 3. Let's see if I got your shirt. Let's see.
Oh, if it got oh my
Maybe-
god.
maybe it did.
Yeah,
Maybe
maybe it detects my face. This is so
The next
cool.
one.
This is so
Let's-
cool. I can't get over it. I cannot get over it. I don't care if people think it's cool or not. I think it's so freaking cool.
Ah!
Oh my god.
You got it on your shirt. Yeah, see, so that's what I was talking about, you guys. When it says
my
text multi-scale,
God.
it's what it's doing is it's taking the trained data and it's checking for all sizes. So it's starting big or starting small, and then it's iterating. So it starts
Oh,
with
man.
rectangles. And it's called a sliding window. So it'll like slide the window all the way across, tiny. Did nothing. Bing, found a match. Then go a little bit bigger. Nothing.
Damn, that is sick. It's an array an array of 3 items of 3 human beings in a little list. 3 human beings in a list. How does it make you feel? Yo, that is so cool. Like, I'm blown. Like, Logan is like, damn. Paula is like insane.
I know, right? And all we did is copy and paste like 6 lines of code. It's amazing.
It's so crazy. It's 6 lines of code. That's right.
Yeah, we're
People are like, oh, we got somebody's like, that's actually epic. Dude, can we loop through it and draw the squares around all of us?
I don't know about that, man. I don't know if my skills are up to par for that. But
I mean, we had the loop. You wrote the loop earlier.
yeah,
I have
know.
the.
I'm kidding. I'm kidding.
Oh, okay. All right.
Yeah, we got you guys. So now we're just gonna have this be a loop. So we have a list and a list of three faces that we detected in that image, and now we just want to loop over them instead of just doing it one by one. Of course, we could probably do this. This is a sloppy way to do it, but why don't we do it just for sake? So this is actually like running a loop 3 times, but just manually.
Yeah,
And
it's
let's
just
go
listing it out.
here.
Okay, got it.
And run it, and kaboom.
Oh man,
Yeah.
that is nice. So this
All
is just
3.
manually doing it.
Yeah, and let's make this nice and big. Her nice thumbnail, you know?
Wow. Oh, that should have been the thumbnail of the video.
Nah, I mean Robert Downey Jr. is too sexy, man. Or Justin Timberlake,
That's true. You're right.
we're ugly, bro.
Yeah, 6 lines of code, man. Like, that is so cool to me. Yeah, even Logan is going. He's like, bro, this is literally input in the 6 lines of code. What the hell?
It'd be cool if you can change the color, you know? Like you even like label them and stuff. But
Yeah.
anyways, let's go back and make this actually loop the proper way. So the way we're gonna do that is
Oh yeah, change. Also, yeah. Once you write the loop, let's also like change the colors between 0 and 255. It just picks randomly, so then it'll be different colors.
oh, that's fun. All right.
Yeah. Okay.
Dude, on the webcam, when we're doing the live webcam, it's gonna be like rainbow. It's gonna be like going crazy. It's gonna be pretty cool.
Yeah.
But all right, so let me just go in here. So I'm gonna type it out. Here's the loop. All right, and we're just going to replace this top line. This one, we're gonna replace it with this. Okay. So instead of manually getting it here and getting the first face in this list of faces and then assigning it, we're just actually going to loop through all of them. So because this is a list, we can loop over it using the word in. So for this tuple in this list, which means it's going to iterate over everything, then it's going to have the same functionality, okay? So do this, make sure you tab correctly. So for this tuple, x, y, width, height, in face coordinates, then this is unchanged, okay? Because we had the variables exactly the same. So this is actually going to work, minus the randomization of the colors. But let's just give this a run and see what happens. And it might even pick up extra stuff if it failed. There might even be like a fourth face somewhere. No, there is none. But there we go, you guys. So this is functioning so far.
Oh, that loop worked?
Yeah, it did.
We're looping through 3 human beings right now?
Well,
Or 2 human beings?
2 human beings and 1 cartoon.
Man, this is so crazy to me. Wow.
Why do we look so derpy? We have the same glasses, man.
This is awesome. Yo, okay, I got you with the different colors. So Aaron, go all the way to the top of the file and just do hold on. Import, so do from random, import rand range all the way at the top.
Like that?
Yep. I am. So you misspelled import. Yep. And then where you have that 255, you see where you have 0, 255. So just do rand range. No. Don't do that. Don't do that. Just the 255. Just wrap the 255 in the function rand range.
Got it. Like
and so now
that, right?
you could do 250, 256 because it's gonna go up to but not including.
Okay.
Yeah. So now it should be randomly like making the colors. So now if you hit save and run it, everybody should have like a different color. Hopefully, it would be really unlucky if all 3 of them were randomly generated.
This is just the green. This is just the green channel, so it's going to be different scales of green, but not different colors.
Oh,
so
I see. Oh, so then you can actually just do rand range for all of them. Like for all of the coordinates, you could do. So go back. You could do for 0, you could do that, and all 3 of them, you could do the same thing.
There we go. And now let's run it, and now it should be random colors.
Nice. That
Blue,
is so cool.
Red and green.
Damn. Okay. Awesome.
That would be useful for identification. Like if we ever actually trained, if you got enough of your images, enough of my images, and enough of this little shirt, we could actually like train it and be like, okay, Kazi's red, Aaron's blue.
I just can't get over that we're in a list. We are in a list right now in a Python like that. Okay, dude, I can't get over that. All right, let's keep going.
We know. One thing I do want to try though is I feel like those colors are a little bit dark, but if we keep the range in the upper half of the 256, then they won't be so dull all the time. So let's actually go 128 to 256. Okay.
Oh,
let's try this, and then I think the colors will always be brighter.
Color science.
I mean, it kind of looks.
It's fine.
Like ass,
it's fine.
But that's fine.
Yeah. You can remove the one. Yeah, just so it's less confusing for them. But yeah, rand range is awesome, right, guys? It's pretty cool. Kazi, Logan goes Kazi 2020. I'm in a list.
You're getting excited. Coronavirus got us all screwed up, you know? Like we're getting excited about a list. Like
awesome. Thank you guys. We just broke 1,000 likes. Thank you guys so much. Really appreciate you guys. Our team just notified us. Frankie just notified us like 1,000 likes on this video. Frankie's pumped.
Awesome, you guys. Thanks for all the support. We appreciate it. I don't know how long we've been going for. Like almost an hour already, right? This is going way longer than 1 hour for 6 lines of code.
This is so fun. This is so fun. I think everybody's pumped. I think everybody's totally like, what do you guys think? But I honestly think that everybody's freaking pumped out of their minds because I think this is the coolest freaking tutorial that's out there on face detection. Everything else is like so boring, dude. Every time I try to learn it, I go to fucking fall asleep.
Wait till I explain actually how it works, like mathematically. Like it's not complicated, but like that'll blow your mind. Because right here we're just calling a piece of code. Anybody can copy and paste this. But if you actually understand how it works, that's the mind-blowing part. So stay tuned to the end for that, okay, guys? We're almost done. So we're gonna move on to video now because actually our image is done. So we have already gotten the image and we're displaying it here. And then I would display it here. So we display the image here. Display the image with the faces. And And then we have the wait key, of course, which is just waiting until we press the key to close. And once it closes, then code says code completed, and we are done. So, okay, we are detecting faces on a single image, but what if we want to detect faces in a video? But what if we want to detect faces in a video? Well, all a video is a bunch of images one after another. So we can actually just run this code on every single frame of an image, of a video, I mean, whether it be a video file or our webcam stream. We're going to be using the webcam stream. And that will basically give us real-time face detection. So it's pretty much the same exact code with just a loop added on the outside. So let's do that now, okay? I'm just going to continue modifying this code. So let's go down here, and the first thing we're going to have to do is actually, instead of capturing an image, we're going to want to capture the webcam. So let's start from here. Let's comment out the image, and instead let's paste in this. Okay. So instead of calling image read on an image file to get an image like this, we instead are going to call CV2 video capture. So all video capture means is you're going to capture a video. If you put a 0 in here, it's going to get your default webcam. So for the person asking about your iPhone, if you can make your iPhone the default cam, I think using 0 would actually work. You just have to like specify on your computer system.
Unfortunately, I went and checked, and OpenCV does not work with iOS. But I honestly think that if you figure out how to make this work, you can easily make something with JavaScript and then host it online, and then people can go and use it. But the most important thing is to get experience using it, learn how this technology works, and then you can go and implement it in any language you want on any system.
Absolutely. So, I mean, I think it might be possible. Like, look into it maybe. It won't work natively on the iPhone, but you could use your iPhone camera, hook it up to your computer, and then use your iPhone and look around and have that be in this app. But the point I was saying was, if you have 0, it automatically goes to your default webcam. But if you put a file name in here, then you could have like, video.mp4 or something. If that was on my desktop, it doesn't exist. Well, actually, I do have a video here. Where is it? It was a funny one.
You can detect a face. That's actually cool.
LOL memes. So let's just do this.
Oh, nice. I didn't know you could give it a video. That is so nice.
Yeah, you can. It's actually not going to work because we haven't coded it all out. So let's actually do this later. But first step is calling video capture, which allows you to get the webcam or a video file with the same function, which is nice. So thank you, OpenCV, for being smart and efficient.
So Ahmed asks, where's the training part? The training part is on line 6. That's where we trained it. That's where we trained the data. But keep going, Aaron.
Yeah, we actually didn't train OpenCV because training takes a lot of time. Like, we would be sitting here for anywhere from probably like half an hour to multiple days, depending on what kind of data you're training. So that's why we didn't do that here. We stole the trained data that OpenCV already trained for us like years ago, and then they just supplied this machine learning network for us to use, and we just downloaded that, which is right here. So this is actually the trained data. So all these numbers, the -4, the -2, and all these crazy numbers, if you pump an image through all these crazy numbers, it just filters through and it finds the faces magically. The same way your eye can find a face when you look at a picture, this is doing something remotely similar that your brain is doing, but in a different, like in a computerized way. So that's what this is. So yes, the training is happening in here in essence. Hope that's clear. Kazi? I cannot hear anybody.
No, you're good. You're good to go. Keep going.
Got it. So let's just get this going and then actually display the webcam, okay? I believe we need wait key as well. Yeah, I'm pretty sure we need wait key. And webcam release. Let's see if this works.
And this is awesome. We still have 685 people live. This just tells us we got to be doing a lot more of this, Aaron, because it seems like everybody loves this stuff. Because most of the times by now we drop to like 100 live people watching. This is awesome.
Yeah, people are loving it, right?
Yeah.
Dang.
Well,
Okay.
done says, yeah.
Well, it's not going to work because we need the loop. So this is a little bit confusing. So if I were to do this and display what this gave us, it would only give us the first frame. So we're going to have to kind of do a big chunk of logic together, guys. We're going to have to code up the whole loop and get it going as one. So just bear with me and we'll get that going. So once you get the webcam here, what you're going to want to do is get a while loop. Okay, so this loop is going to go right here, and what this does is we just want it to loop over all the frames in the video forever until the video ends or until we kill the webcam. So for the webcam, we just want it to run forever because it's just is real time until we tell it to stop. So that's why we want a while loop running forever. And then from here, now we can actually go and fetch the current frame and display the current frame. So let's go down and get this. So this is the next call. So this is actually how you would get the image out from the video. You could technically run this outside the loop, but then, like I said, it would only get the first frame, and it's essentially just an image again, which is kind of the same as what we did before. So I'm just jumping into the loop. So there is this webcam that we made, okay, from the video capture. We called it webcam, and webcam allows you to read from it. So you just call the read function here, and what this returns is two things. Tuple. So the first thing it returns is if the reading the frame was successful or not. This is just a Boolean. It'll be true or false. And then this is the actual image. So the frame that is being read currently from the webcam. This we actually don't need, but we need to be there just to like for placeholder. But we're never going to use this. This should always be true. Okay. But this is all we want. We just want the frame. So once we have the frame, now we can actually take the frame. And instead of frame, use the frame instead of image. So before we were using image with Robert Downey Jr. and everything and being Kazi and all that. But now we just want to actually change the image to frame because this is the image we're using. It's the current frame. So why don't we actually do that? And let's comment this out. And just show the webcam in grayscale. Okay, so we're not going to do any detecting yet. Let's take this, paste that in here, and show this. Okay, remembered. Yeah, so the one thing about wait key is actually, let me demonstrate it first, and I think that'll be better. So let me just run this and see what pops up. I don't think anything's gonna. There we go. So as you can see, this is just a single frame. It's not moving because the wait key is waiting on something, and it got a little bit screwed up. So actually, what we need to do, if I hit an image though, you can see it skips to the next frame. So I can move around, and then when I hit my space bar, then it automatically goes to that frame because it's waiting for the key. So one way to get out of this, I gotta force quit this because there's no way out of it. Force quit Python. There we go. We are going to put a delay in here. So wait key here, if there's nothing in here, it'll wait infinitely until you hit a key for it to quit or to go to the next frame like we did. But if you put a number in here, it'll wait this amount of milliseconds before it automatically hits a key for yourself. So we can wait 1 millisecond, then it'll auto hit a key, which means each frame will be happening every millisecond. So let's try this, all right? And this should actually be live webcam footage in grayscale from our webcam. So as you can see, it's just grayscale. There's no face detection yet or anything. I'm just doing this, and then the wait key every millisecond is it just keeps pressing a key every millisecond.
It like already. Wait, so hold on one second. So that's so sick that already has you in grayscale in real time, like from Python. I did not know you could do that. That is so cool. And what are you saying about this 1 millisecond thing? I'm not understanding it. Like, what is it? Okay. What is it doing?
It's a little bit.
No. Just show your screen. Show your camera. So like, okay, so what's happening? Like, without it, would it close? Would the window close?
No. So wait key. What wait key does in OpenCV, the way it's coded, the way it's implemented is, it's going to wait for a key press to execute code. So the code will just wait at wait key. That's why it's called wait key. It's waiting for a key to be pressed.
I'm just trying to understand in English, like what happens if it's not there or you don't do it the right way. Like, does the code break? Like, does the video stop playing? Does the next frame not load? Like, just in pure English, like what is it that it actually does?
Wait key, if it's not there, then it just won't work. First of all, but
okay,
what
that's
it's
great.
doing is it's like you need wait key to actually display something. Like you cannot in OpenCV, the way it's designed is you cannot display something if you don't call wait key.
Okay, that's it. That's all. That's the most important thing I care about. Like if I just want to use this, like all that's for me that's really important. So okay, so if I don't have wait key, it won't display. Got it.
Display. Yeah, you
Perfect.
can think of it. It's not actually what it is, but that's the behavior that comes from it.
Beautiful, beautiful. Got it. Okay.
So yeah, because if it's not here, then it won't work. So let's quit this. Again, you gotta force quit. We'll fix that in a bit, you guys. We'll be able to like hit the Q button and it'll quit instead of having to force quit. But here, if I run this, then I don't think it's gonna work. It'll like pop up for a second or something and then disappear. Yeah, see, it just freezes up and there's nothing for here. Yeah, so it gets there and then it gets stuck in an infinite loop. So that's not a good idea. Nothing pops up. You need wait key because you want it to wait here and you want to show a frame and then wait at that frame. That's what you want it to do.
Got it. Okay.
So let's close. See, yeah, Python not responding because we're stuck in this infinite loop with no way to get out. So it just bugged out. All right, continuing on now. So let's put this back. You can think of it as display. But what I was saying was if there's nothing in here, it'll wait forever and wait for you to actually press a button for it to continue to the next iteration of the loop. So if you go back to the code, this is a while loop, right? And it's going to run over and over and over again. And each time it runs, it's getting the current frame and then displaying it in grayscale to the screen, okay? It's turning it to grayscale and then displaying it with image show right here, the current frame. Then it waits here forever until a key is pressed. So that's why the behavior is weird. It's frozen, it's the current frame, and then when I hit a key, then it goes to the next iteration of the loop. The next one, and if I spam it, then you can see that I'm kind of like moving. But then if I stop, then it breaks. So what wait key does is it waits for a key infinitely. But if you put a number in here, then it'll only wait for that many milliseconds before it automatically just continues on and goes here. So that's why we're saying then I don't have to press any buttons. It'll wait for 1 millisecond, then automatically go to the next iteration, aka the next frame. And so we're getting 1 frame every millisecond. I mean the camera rate will be lower, but that's what it does. So we'll quit out of this again one last time. Force quit this. And run this to get the correct behavior. And there we go. So we're in real time. Every millisecond, the loop is automatically restarting with the wait key because we put a 1 in here. You could even put like 1,000 in here, and then every 10 seconds it would go automatically. So, but we'll leave it at 1 because we want it to be real time. Now, moving on from here, we have the grayscale, but now we want to plug in the face detection into this. So just the same as before, we're going to want to take the detect faces, and of course we want to apply it to the grayscaled frame. So instead of just displaying the grayscale image, we want to find the coordinates of that and then display over it. So the grayscale image, this is all the same code. The face coordinates are going to be using the trained face data, and then of course the detect multiscale, and then we're giving it the grayscale image from right here, just the same as the image. Then we need to draw the rectangle. So this is the same thing again. Let's just steal this loop that we wrote earlier and pop it in right there. And this should work as well. So let's just double check. Image, actually this won't work because image was the image before. This actually needs to be frame instead, okay? And I think that is it. It's just the frame has to change. So what we're doing is we're detecting the
I
face.
see. It's pulling the frame, just to be clear, because I got confused at this. I'm sure people are going to get sometimes confused. It's pulling the frame from line 18 when webcam.read unpacks. Okay, cool.
The current frame of this loop, every millisecond, the current frame is called frame. So we want to detect the face in this frame, grayscale, and then we want to draw the rectangle on the frame, not on the Robert Downey image that we had before, but on the current frame of the webcam, because we have webcam now. So that's how that works. Now let's just run this and see how it goes. I think that's everything. So of course we're going to need to force quit this again and go to terminal. And why is it not working? Because I am displaying the grayscale image, not the colored one. One second, I must have got a bug somewhere. So yeah, so the image show, it's showing the grayscaled image. What we want to show is actually frame, okay?
Nice.
Because that's the colored frame, going back to color, and then we put the rectangle on top of it. So we want to display that instead of grayscale. So now it should work, but knowing my luck, it probably won't. There we go. And there's the RAN range.
Oh, nice! And the color is changing every second. Look at that. That is so nice.
So you can see, yeah, you can see the 1 millisecond refresh rate. So that's actually pretty cool. The color you can see like in real time.
Dude,
actually, you can see every time the
so
loop.
Cool.
Every time the loop iterates, it's getting my face. It's not perfect though, because this is actually a pretty lean algorithm. There's more powerful algorithms, but of course, there's always a trade-off of speed and accuracy whenever you're doing algorithms. For everything in like computer science and data science, there's always multiple algorithms you can use to solve a problem. This one we're using hard cascade specifically because this is the most commonly used one. Like this, like on your little cameras, digital cameras, your iPhone is probably using this.
That's so cool that we're looping through on your face and like drawing, like looping through and making new colors. Like that is just the coolest thing. Damn.
And we're gonna have to force quit this.
Wow.
Okay. And let's continue on. So we can actually get rid of this stuff and keep code completed. So I forgot one more thing. So I kept having the force quit, which is pretty dang annoying, to be honest. So I threw in this thing earlier today of giving us the ability to, and we got to clean up after too, but being able to actually quit using a key, a specific key. So, wait, did I copy the right one? Yeah, this one. So if I pop this in here, all this means is, first of all, I screwed this up. So actually, when you're getting the wait key, you can actually capture which key was pressed on the keyboard. So it's waiting for a key, and then you can actually get it. So if I don't press a key, then this is probably like 0 or null or something, or none in Python. But if you press a key, then it'll go into this. So what I decided was if you press the Q key, then Q for quit, then it'll quit out. So I looked up the ASCII characters for Q. Very simple. You can just type in ASCII. If you didn't know, every keyboard character has its own ASCII code. ASCII is just ASCII. I don't know what it actually stands for, but every letter has its own number. So if you go to Q, you can see Q is 113, lowercase q is 113, uppercase Q is 81. So 113 and 81, that's where I got these numbers from, 113 and 81. So uppercase or lowercase q will actually break out of this infinite loop. And that allows us to exit the real-time face detection without needing to force quit the way I was doing it all this time. Okay? So let's give this a shot and see what happens. Run it. And it's going good. And let me hit the Q key. Q. Oh, is it connected? Q. Must have had a bug. Let me go double check. What is wrong? Oh yeah, forgot the webcam release. I always forget these things, good things, like especially when you're doing memory allocation or any kind of like streams of data, you should always clean up your code afterwards. So in this case, you're gonna have to release. So I think this might be the case. Let me see the. Yeah, let's try it again. There we go. Now let's hit Q. I think it's lagging. I think it was actually working, but it's just taking a long time to actually. There we go. Okay, so it was working. I think the color, maybe the random color, was doing some stuff. I don't know. It's just being laggy, but pretty much it has the working functionality. I'm actually curious. Let me just try to change this and see if this is actually what is holding it up. And let's run this again. Go here, so it's just green, back to what I had before, and then hit Q. Nope, my computer is just slow. I think it's just bogged down from the live streaming and everything at once. I think that's why it's slow. Really slow. Anyways, it'll close after a few seconds. Not important. But let's change this back to the multicolors because that was cool. And that there, guys, is pretty much the completed real-time face detector app. Okay, we have the ability to detect faces in images, to detect faces in webcam, and even video. So actually, let's. I have a video here called LOL memes that you guys have probably seen before, and let's pop this in. So instead of reading from the webcam, we're going to be reading a video file on my desktop.
So if you give it an argument of 0, it reads it from your webcam. But if you give it and if you give it a name, it actually looks for that file path.
It's just capturing video from somewhere. You just gotta tell it where to capture video from.
Awesome.
That's all it's doing. So now let's try to run this, and we can see it work.
Whoa! What is going on? Whoa, that is crazy.
It's getting that guy a little bit. You can see it's not perfect.
I mean, it's really difficult. Like, this is a crazy video, and it's already pulling it. Like, that's insane. Wow.
Yeah, so I pulled this video, and you can see it's getting his face at the end there.
People are like, wow, it's amazing. Very nice.
Awesome. And then, of course, if you hit Q, it will quit. That one happened a lot faster.
Can you? Oh, I see. Okay, interesting. I'm trying to think. Okay, cool. Is there any other videos you have on your computer that it can pull from?
Yeah, I have this funny baby that I got.
Okay. Let's see. Yep, right there.
I was testing these earlier.
Nice.
And there's no audio, but here's an.
Oh my god, that is so cute. That is so cute. I love that. I love that.
The dad is basically like tormenting the baby by making them say stuff. But yeah.
Logan says super impressive, Aaron. Logan says super impressive, Aaron. Thank you for the content.
Absolutely. We haven't even gotten to the interesting part yet. This is the fun part, but the interesting part is about to happen. Yeah. So this is working here. Again, I'm going to try capital Q this time, and it should quit. Look at this baby.
Wow, our loop is still working and going through the random colors. I love that.
Yeah, I think we're giving the baby epilepsy. That's what's happening here. He's going crazy.
You know what you can even do is like right next to it, draw random captions, like draw like random, so like how have that people have that like speech thinking bubble next to them.
Yeah, something like that.
So we could even
exactly.
So you can detect faces and automatically put like speech bubbles in real time next to it that like writes out text.
Or Morty, I think we could superimpose our faces.
I don't know about that, Rick.
Yeah, we're thinking of doing that. We're gonna superimpose Rick and Morty's faces over our faces, but it was too hard to do that with the stream at the same time. We couldn't technically figure it out to stream live.
Oh, jeez. I mean,
I mean,
We can do that
we could
too.
probably do that, you guys. You would really have to just let us know if that's something you're gonna like. I mean, you can go ahead. I mean, oh geez, just go ahead and smash that like button. That'll be so awesome.
Yeah, Morty.
All
Tell
right,
him,
awesome.
I didn't actually know you had a head on your shoulders, Morty, but I'm proud of you today. But today only.
People are loving it. They're like, this is amazing. They're like, I wish I could code like this.
I still hate you, Morty, you piece of shit.
Logan is laughing.
Yeah, I love Rick and Morty, man. Oh, I love Rick and Morty.
Yeah, awesome.
Anyways, that is that, and that completes the app. But now, I mean, this is a lot of hand wavy woo woo stuff. We just called this detect multiscale and downloaded this file, and then it just kind of magically started detecting faces. Like, cool, like a 5-year-old could have done this, which is true, but which is also awesome because, I mean, you got this up and running with like minimal work. But I do want to give you guys understanding of how the algorithm is actually doing it. But I do want to give you guys understanding of how the algorithm is actually doing it. Like, how the heck is a computer looking at an image, and how does it know what a face looks like and actually understand it? So that's where I want to actually go to here. Okay, so let's just look at this for now. I put together a little presentation to actually transition people over into thinking like a data scientist, because most data scientists are coders, but not all coders are data scientists. Like, you can be a coder, you can be a front-end developer, which is amazing, web developer and stuff, but like if you don't actually understand like some of the underlying algorithms and stuff, you can't actually pursue anything in data science if that's what you want to do. And that's what Python's known for, so that's why I want to touch on it. So instead of being a coder and just like copy pasting what I taught you now, you need to actually understand what's happening behind the scenes, so that in all the little tricks that are happening, so that you can actually innovate on that and continue forward and actually come up with like new and faster and better face detection down the road. So, but you got to understand the basics before. So let's continue on, okay? Face detection. So what the hell is HAR cascade? That's the big question, because if we go back to the code, then all this stuff was like HAR cascade, HAR cascade. What the heck is HAR cascade? Why does it say HAR cascade? And we just downloaded this thing. Well, this is just an algorithm, okay? So HAR is the name of a dude who invented the algorithm, and cascade is just the word cascade. So cascade is like a chain of events pretty much, and you're just going down, like you're going down a funnel. So what it's doing is it's going down a funnel until it finds a face at the bottom of the funnel, and then it's like, here's one face, and it keeps doing it over and over again for every face. You're cascading down. That's the one paragraph explanation, but let's actually go to
one second, Aaron, real quick. If you want to cue me to show your face, just be like, hey, so, camera 1 or something like that, and I'll switch over to your face, or you can just tell me. So right now I have the camera on both of us. So now when you're drawing, like moving your hands physically, it'll show, and now I'll hit 2 and it'll go back to the screen.
Got it. Yeah, well, just show me really quick while I'm explaining it. So like I was saying, the HAR cascade is just like a chain of machine learning things that the image is being passed through, and then it's going to funnel it down until it finds the exact square where there's a face. It kind of looks at like every square of every size on the image, and it passes each of those squares through this machine learning thing, and then it cascades down. Eventually it's like, okay, if you pass all of the cascades and you get to the bottom, it's like, okay, this is close enough to a face to actually be considered a face. And that's why it's called cascade. HAR is just a name. You can kind of ignore that, but hopefully this makes it seem a little less scary. You kind of understand. But now it's time to reveal the magic trick of face detection. Okay, it's pretty mind-blowing. Like, honestly, I wouldn't have been able to figure this out on my own. Like, these geniuses did it, but I learned it in my schooling at Georgia Tech when I took computer vision, and now I'm just going to share it with you. Okay, so yep, time to reveal the magic trick. Don't be this guy. I have this GIF here. So it's actually pretty simple how it works. And I want you to understand, instead of being like this guy, like, how the hell does face detection work? I want you to just know like how it works, because it actually is this simple. Like, you can see it from the third one. Like, once you understand, it's that simple to understand.
I love that. That is awesome.
So
that is hilarious.
Let's continue on.
Yeah.
So as you know, the algorithm is called HAR cascade. So let's start with HAR. So what HAR cascade does,
you can also, by the way, you can full screen this. You can just hit Command Enter and it'll full screen it, so everybody can see it in a better way.
Yeah,
and you can actually use the pointer. So at the bottom left, click pointer, And then when you actually move your mouse around, like people, you can actually, yeah. So it's easier to know what you're talking about.
Okay. See, I'm just a coder. I don't know all this fancy Google Slide stuff.
Yeah.
But anyways, so these are HAR features. So this is the first part of the HAR cascade algorithm. So it's a very, very simple thing. What you can think of HAR features as rudimentary building blocks. So this is one HAR feature. This is another HAR feature. This is another HAR feature. This is one, and this is one. All this really is a little block. So what we're going to be doing is we're going to be placing this over a portion of an image that has a face in it or doesn't have a face in it. And all it's doing is it's kind of showing the relationship from the white portion to the black portion. And then what this allows us to do is it kind of allows us to approximate the relationship of these pixels within this box. So if we overlay this over somebody's face, then we could be like, okay, down here in relation to the pixels up here, there's some kind of relationship. And then, or this way, you could be like, okay, the pixels on the left have some kind of relationship to the pixels on the right. Or like this, you can do the three thing, like, okay, there's a relationship, a three-way here, or a diagonal. And this is like the most elementary ones. Like you don't have to go any bigger because you can just kind of chain them together. But these starting blocks is what you start with. And if you chain these together over and over again and you layer enough, you can actually, some combination of these 5 things will actually give you a template for a face. It'll look like a face, and then that's how they actually find faces, by layering this over and over again and cascading all the way down these different layers, and then actually finding one that matches a face. And the way it does that is you give it faces, so it finds out the combination of these things to know what a face is, and then you can just filter through it again. So that's kind of the idea of HAR features so far. So these are HAR features, and let's continue on to the next slide. I think it'll make more sense when I show this one. So this is how a HAR feature is applied to an image. So like these, let's say these are blank images or background images that have no faces in them. One HAR feature is here, and here's another one, a different type where it has three columns. Another one is here, and as you can see, this is how you would overlay it on an image. So this is the raw image, but then if you have the HAR feature here, what we're looking for here is, the relationship of this black box to this white box. And what's cool is if you look on this face here, you can kind of tell that this rectangle here of his eyes is a little bit darker than his cheeks and his nose. And you see how that corresponds to the black and the white here. So we can actually say that this HAR feature is closer to a face than something else, like placing this like all the way on the bottom left, where it's kind of like not, because there's kind of like a black bar here and a white bar here.
So the white one means that is more like a face, and then the area that's black is like that's less like a face.
The black is like, you can think of it as like it being darker, and the white is it being lighter. So you're saying like there's some kind of like going from light to dark in this direction, or dark to light to dark in this direction. So if you see, like literally. A dark bar going to a light bar. You see right here is exactly what this HAR feature is.
Okay, so one second. So basically the face detection, it doesn't look for facial features. It's just looking for like how dark and light it usually is around faces.
And that's why you only need grayscale.
Holy crap. That is
this
crazy.
This is only one algorithm. There's a bunch of different ones, but this is the most well known and most widely used.
Like literally just looking at, so for this one specifically, it's just looking at like, here are 100 different faces. Frankie, bring your face in real quick. So like it's like it'll like have like a certain thing for like dark and light for his face versus a dark and light
dark eyes,
it trains them on
cheeks. Yeah.
So then it's just looking for white and black. Like okay, cool.
Like if we went back, like this would even be a better match, because you have forehead, then eyes, then cheeks. You see what I mean? If we had that here, you could also have a white bar up here. You can kind of see it's like white, then dark, then white. So we're basically saying there's some kind of 3-layered relationship of this block of pixels, and this is only one layer of HAR cascades. Basically, we're going to layer 1,000 of these little matches together, and eventually those added up will add up to a face.
Wow.
So you can see the second one here. You can kind of see like, okay, the eyes are darker and the bridge of the nose is lighter. See, the eyes are dark and the bridge of the nose is darker. So this HAR feature plus this HAR feature is even closer to what the heck a face is.
Yeah, this is what Logan is saying too. He's like, he goes, this is why we used grayscale, right, Aaron? And he goes, because color is irrelevant. We're actually just looking for brightness. Yes, exactly.
Well, you can start using color when you want to get like really, like if you want to like profile like race or skin color. or if somebody has freckles or not. You could even start doing that, but it would, of course, you would need more data and longer time to train. But this is the most generic case, but I want to teach you guys from the ground up so that you understand how this works, because this is the prerequisite to everything else, okay?
Yeah.
So this is how a hard feature is applied to an image. And of course, you would just take this box and you just drag it all the way around the image. You would even resize it, like, because again, you could have like this similar thing might be like, it might match on the mouth a little bit, but let's move on, okay? So these are hard features. These are the 5 rudimentary hard features. And this is how hard features are applied to an image. And if it's like this, then there's no match. You know, there's like, it's just a white, flat background. Or if it was like a landscape or like your wall or something, then there's going to probably be nothing there. But let's go on. There's a little bit more nuances, but that's the general idea so far. So now, actually, how did OpenCV train that face detector that we downloaded, that XML file? Because that's where the magic is. We just downloaded it and just like called a few lines of code, which is kind of like, okay, cool. But how do they actually do it? Because from here, if you understand it, then you can actually start thinking correctly and do some real data science stuff. Like, you're not a data scientist unless you actually understand the algorithms. So step 1, like we mentioned at the very beginning of the call, you want to start out with your training data. So in machine learning, the way it works is you have positive images and negative images. And all these are just labels. So this would be labeled as face, labeled as face, labeled as face. This would be labeled as not face, not face, not face. That's all it is. You just need faces labeled as faces. And
so just to contrast, just to contrast that, guys. So here is a face, right? But here is like, this would be a negative image, right? A phone would be a non-face. So like,
anything
for example,
that's not a face.
So again, non-face is
coffee.
Yep, cup of coffee. This is a non-face when it sees it. This is a face when it sees it, right? And this was through supervised learning. So it fed the data to the Hardcade cascade, right? And it told it, yo, these are all faces and these are all non-faces, yeah? So this is so this is called supervised learning. We're probably not going to go too much into unsupervised, supervised, but like at a high level, it's like a human being's telling it what is a face and what isn't, and then it feeding it like lots and lots of data.
Yeah. Another way to explain it if somebody didn't catch that is there's 2 fields of machine learning. There's supervised machine learning and unsupervised machine learning, which is what Kazi just said. Supervised means you know these are all faces and you know these are all non-faces. It's supervised. You're supervising the actual data and you can tell it like, these are faces. Okay, that's what a face is. These are not faces. Okay, that's not what a face not is. But if you're doing unsupervised, you're literally just given a bunch of stuff and you have no labels. And then you can just at the end be like, oh, was it right or wrong? So you have even less data. But that also is a lot better because when you're gathering photos from the real world or data from the real world, usually it's not labeled. You'd have to go in there and manually label it by a human because how else would you know these are faces? So there's kind of 2 fields of thought. Supervised is better to learn first, but unsupervised gets very, very messy. And it's kind of like the cutting edge right now.
Yeah, that's where like you really get into AI and all that stuff.
Deep neural nets and all that stuff. Deep neural nets.
Awesome.
This is just machine learning. So start out with training your data. So you have a bunch of labeled images, and from here you'll go to the next thing. So after you have all of your images, so we have face images, and then also non-face images. You want to find the winning HAR feature. So like I said, this HAR feature matches nicely with the eyes and the cheek. And then even if we had like the other HAR feature with the lighter bar on the forehead, that would even be a better match. But for this one, we're just using this. This is a fairly good match. And this one is also a good match, okay? So basically what we want to do is we just want to chain together all the HAR features that kind of match and add them together, sum them up until we get a face template. These are like little Lego blocks to like doing it. And this is why it works for nothing, because they're rudimentary building blocks. This can work for a Coca-Cola can. You can distinguish a Coca-Cola can from a Pepsi can eventually because it looks different, and like the brightness relationships within these boxes and sizes of boxes is all different. That's why you just start with like plain old boxes and you add them up.
Kind of insane that you can tell the difference of everything based on brightness. Like, this is where algorithms are so freaking cool, because
I mean, it's what your brain is doing, right? Like, what is your brain doing? It's doing the exact same thing. It recognizes a face versus not a face, and we're just teaching the computer how to do the same thing.
Damn.
So it blows your, like, self-driving cars. This is this is absolutely like essential. Like Tesla, Tesla stock is going up like crazy. Elon Musk just passed Warren Buffett and his net worth as of like 3 days ago. Like, go Elon
Are
Musk.
you serious?
Protect Elon. Yeah, he's 70 billion. Warren Buffett is 69 billion. He just passed.
Whoa.
But Elon Musk is now number 7 in the world. He's exploding, bro. But yeah, the Tesla self-driving cars, they use this heavily. It like with other things, but there's a lot of computer vision. So like you could detect pedestrians.
Whoa,
detect
I am
cars,
showing
detect
that on
stop
my
signs,
screen,
detect traffic
Elon.
lights using the same HAR function.
That is insane. I just I have an ad blocker on, so I have to turn that off real quick. But I'm just showing them on the screen that Elon Musk actually passed. Oh my God, is this website annoying? Holy crap. Jesus Christ. Okay, I'm out of here. They can keep their. We don't need to look at that. Business Insider. Yeah, Elon Musk just passed him officially. That is insane.
Yeah, Elon Musk is my guy, man. Like, Daniel works at Blue Origin, right? That's like the competitor of Elon Musk's SpaceX.
Yeah. Oh
we have
my
a guy here, a clever programmer, who works at the competitor of SpaceX.
Jeff,
right?
yeah, he worked for Jeff Bezos' company, and he works on an actual rocket ship at Clever. He's going to actually be here next week, and he's going to be teaching everybody algorithms and maybe even some stuff with Python.
Yeah, he makes me look like a baby.
Yeah. Awesome. So keep going.
But yes, so after we have all of the images, the face images and the non-face images, we want to find the winning HAR features. So which HAR features align with a face, and then on the reverse for non-HAR features, we want to see which HAR features don't match. So like you're doing the reverse. You want to find HAR features that like do the anti-match, and then eventually, if you do enough reps, then you can kind of understand the HAR feature that determines a face versus not a face. So this is how it works. So if we go back to this, you have a bunch of faces and a bunch of non-faces. So the way the algorithm actually works is, I'm actually going to come out of here for now. And can I zoom in? No, this is big enough though. So we have to test every HAR feature. Okay, that's pretty much it. There's only 5, but of course we can scale the size. So what we want to do is, you literally want to start here and check, 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 and then go down. Check, 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 of course. And do this across the entire thing. And then again, do it with a smaller one. Check, 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 blah, blah, blah. And then go to the second HAR feature, and the third, and the fourth, and fifth. And you keep doing this on every single image until you can find which ones actually match a face. So after, like I said, every type of HAR feature, every size of HAR feature, and every location. Kazi, there's a lot of background noise.
My bad.
So what was that? There's and every location of every image, okay? And each HAR feature, after it goes through the whole thing, it'll give you a number. And this number tells you whether it is a face or not a face, like what this HAR feature will say. So after this HAR feature goes through this entire image, okay? Or let's make it a little bit bigger, like there. So this is the good matching one. So after this goes through the entire image, each of these spots, it's going to get a number. So the way it does this number is, it takes all of the pixels in the black and adds them up to one number, then takes all the pixels in the white, this box, adds them up into one number. Again, grayscale is useful because we only have to deal with one number instead of RGB. And from there, you have a white number and a black number, then you just minus them to get the difference. Like, how far away are these numbers from each other? Like if this was 0 and this was 100, then the difference would be 100. Or if this was 20, this was 70, the difference would be 50. They're 50 apart from each other. So this would be a 50, and we could say, okay, this match is 50. So this HAR feature in this location on this image has the number 50, and then we give it a threshold of saying, okay, if it's 50 or higher, say it matches good for a face. If it's 50 or lower, then say it's not good for a face. And so that's what we do. So you say, okay, this HAR feature goes all the way through, and here, and then at the end, it gets a final number for itself. And then you can say at the end of this, you're like, okay, this HAR feature in this location was really good. Let's keep this. Okay, this is level 1. This was the best performing HAR feature. Let's keep this because it was the highest. Like maybe it was like closer to 100 or something. And then after you do that, that was just one HAR feature on one image. You'd have to do this on every single image to find it, because it would also find the same kind of pattern on other people's faces, because their eyes are going to be dark and their cheeks are going to be light too, because that's what a face is. And then after that, you could be like, okay, this is the winner. That's cascade 1. That's level 1. So whichever hard feature matches the training images closest is our first winner. So if you go back here, it matched this one, like her eyes are darker than her cheeks. Then you can say, okay, that's a match. That's the first winner. Then we would go to the second one and go here and then see that this is another good match because the light nose plus the dark eyes. And we would do that too. But of course, you would have to iterate through the whole thing. And then, of course, all the different sizes too. You'd even go like tiny on every single image and all the background images too. But that's how that works. And eventually at the end, because if you take this black segment, add it to this black segment, and then subtract it from this white segment, you get a number at the end again. And then if it's above 50 or closer to 100, that's the idea. Then you can say, okay, this is a pretty good match versus here where it would be like not a very good match. And you just do this over and over again, and you want to get like 1,000 HAR features that match. Right now, we're only looking at 2, but you want to do this over and over again. That's why computers are so powerful. And that's how you actually train the Cascade object detector, or in our case, a face detector, but you can detect any object depending on this, on the training data. So that's how that works. You have to test every HAR feature. And then after that, after you've gotten 1,000 winner HAR features, you can take that and then put it all together into a big machine learning algorithm for face detection. So that's what this diagram here is. So step 3, this is the cascade, which is just a chain of HAR features. A chain of HAR features. This was the first best match. This was second best, third best, fourth best, all the way up to 1,000th best. And you would go through in order. And if a picture passes all 1,000, then you can definitively say, hey, this is a face. If it only passes 900, it doesn't get to 1,000, you'd be like, it's not good enough to be a face. So that's the kind of the mark there. That's how that would work. So you take all the images that are faces, all the images that are not faces, then you train it with these HAR features. You find the 1,000, or it can be any number. Is you can kind of decide like when it's close enough. But you choose, let's just say 1,000 winner HAR features in order, and then we can chain them together into our face detector, which is called a cascade classifier, because you cascade from stage 1 to stage 2 to stage 3, all the way down to stage 1,000. And then that is stored as an XML file, which is exactly the data that is stored in here. So in here, it probably has 1,000 of these little things. So this here is one HAR feature. Could be one HAR feature. Like from this tag to this tag is one single HAR feature. That's the idea, okay? And then all these numbers are actually the HAR feature we're looking at. It has the brightness and the color and the location and the size of it. And you would go through, and then of course there's like 1,000. So you just fish the image through here, and then it looks for every single thing in the image until it finds faces. So that's why it's called a cascade classifier, or a HAR cascade, because using HAR figures, and then you're cascading down all the matched HAR figures until you find a face. Okay, so that's the explanation of how it actually works. One final thing I want to do is the way it actually, well, actually, let me continue on in the slides.
Can you full screen it, please?
Yeah. So the nice thing about that is OpenCV does the hard work for us, okay? OpenCV provides all the pre-trained classifier data that has the chain of HAR features that best match a frontal face, which is exactly what we downloaded. Remember when we were at the GitHub, I said download HAR Cascade frontal face default. They have all of that data for us. They trained it already, and they have that data. And then from there, then after it's classified, we can just pass a sliding window. So a sliding window is just a window over the image or the current frame or whatever, and pump it into this classifier and run it through all 1,000 HAR cascades. And if it makes it past all 1,000, it's a face. If it only gets to 999, it's not a face. That's the threshold. And so yeah, if it gets all the way to the end, it's a face. But if it doesn't, then it's not. So that's why it's called a cascade, because you're like funneling down into what a face actually is. One last thing, let me just explain how that actually works. So what we would be doing is you would have like a sliding window. So you would have, or let me make this full screen. Or actually, I can actually just add a square, can't I? Shape. Nice. So let's just say we have a square here.
Good question by Evil Name Kian. He said, is it possible to use face detection into a Flask application?
Absolutely. Yeah. I've never done it personally, but I mean, yeah, you can tie this into web development. Awesome. You can take this and then you can somehow call the OpenCV code in your Flask application. I mean, you could use Flask to like house something or house a web page, but you would need some way to get the OpenCV code running on your Flask, but it's definitely possible. Django might be better, but Flask might be cleaner. But look into it. But it's definitely possible. Just
Got it. Beautiful.
Check it out. That's homework
Beautiful.
for you. But the way this works is you would take this little square, pass it through all 1,000 hars. It's like, oh no, this is not a face, 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 not a face. And this is so tiny, this would be not a face the entire time. And eventually then you would check a little bit bigger. Not a face, not a face, not a face, not a face. But eventually when you got this big, you'd be like, okay, not a face, not a face. Matches 900, blah, blah, blah. Matches 950, not quite 1,000 yet. Matches 950, but 950, boom. And then boom, it matches 1,000. And then that's when you get the face. So that's how it would work. And then it says ding, 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 that's a face. And if there's multiple faces, then it'll find all of them in the current frame. And that's kind of the full algorithm of how the face detection actually works in practice, and actually like through and through with the math and numbers. Okay, so now I want to show you the final
Romano, one interesting thing, Romano says you can adjust the sensitivity of face detection, and he basically says that that face classifier detect multi-scale thing you have, the last argument is actually for sensitivity. So you can actually change the sensitivity you're looking for.
Yeah, you can go here, detect multi-scale. So you will have all of these parameters. You can do min neighbors, scale factor. So you can say like, okay, how many faces can be close to each other? Like, do the faces have to be far away? You know how we're getting random little squares here and there? You can say, oh, if there's a little square next to a big square, prioritize that big square and just omit those little squares to kind of clean it up. So you can kind of fine tune it. That's the nature of algorithms. You want to fine tune things until they're working nicely. But you just want to get it really close to working effectively. And of course, there's always a trade-off of speed and accuracy. That's always the case. That's just how the universe works. There's always going to be that trade-off. So, but yes, you are correct. Go check it out. You can play with all of these things, like scale factor is 1.1 by default. Min neighbors is 3, and it explains what all these things do. And there's even other things like set image that I didn't go over. There's a bunch. I mean, it would take forever to go over everything. But definitely look at the documentation for OpenCV. But good catch. That is correct. Now let's go to this video. So this is actually hard code visualization happening live. So everything I just explained and everything we just coded, this is what's happening. After the hard code is trained, this is actually how the algorithm goes forward, okay? So let's start here. We have a lady here. And as you can see, like I said, the window will go across, right? And as you can see, whenever the current red square will run through a bunch of hard features. So you can see it's spamming a bunch, and it's saying, okay, all those 1,000 hard features within this red square, did this red square pass through all those hard features? Yes or no? And it's saying no, 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 because it's not a face. Obviously, the face is down here. So it's saying, okay, is this box's face? No. Is this a face? No. Is this a face? No. Is this a face? No. By running through all of these crazy hard features for each of these red boxes. That's why it's going so freaking fast. And it'll keep doing this for every face at every size until it finds the face. So let's just speed this up. And we're getting close. So as you can see, the stage, look, see it says 100% match here. Features 16 of 135. It's matching. There's 135 instead of 1,000 in this case. And you can see that this is what makes up a face. So you can see the match is pretty close.
Oh,
There's
wow.
22 stages. So see how it's seeing these red squares are a match? And then at the end, it probably averages all those red squares and the red squares to find the actual face. And that's where those tweaking things, that's where those tweaking numbers come into play, because you can be like, okay, if all these squares are so close together, you can kind of approximate and just make it one square. Instead of 6 faces, that's the same face, just be like, nah, this is just one face with a bunch of square matches.
Dang.
So this is
cool.
It happening in real time. And of course, if there's multiple faces, then it'll catch all of us.
People want to see the video. They're like, can you share the link of the video? Maybe you can just show
I'll post
the
it all
URL.
in the description. Yeah,
just no, but hit escape for now, so you can show the URL. And hold on, give me 1 second. Just show the URL, and so you guys can pause.
Just search this up. Anchor Divacar Hard Cascade Visualization.
Yep, there you go. And you guys can also just type in the URL at the top. There you go.
Yeah.
Yeah,
and that's really it, you guys. So that's the entire algorithm. You guys coded it up. You guys followed along with how it actually works mathematically, why it works, and how effective it works, and the efficiency and all that, and the trade-offs. And then also the extensions of it. Like you could do actually start like recognizing people. Like we could distinguish like Jeff Bezos from Elon Musk, or you could distinguish
Oh,
Pepsi
snap.
can from Coke cans and stuff like that. If you do it enough, depends how much you want to train the data. I mean, train the algorithm, how much data you want to do it. But as you can see, this is getting pretty. See how it got bigger? The red square is getting bigger because it's a sliding window algorithm, which is how most of like self-driving cars, same stuff. It's very similar kind of idea. And that's really it, you guys. So it's getting close to the end here, and boom, there. At the end, it got all the boxes, and it approximated that is the face in the image.
Dude, I love that all of that is happening in literally milliseconds. Like that to me is insane. Can you open up the webcam again? Like I want to just see it happening in real time. That is crazy.
Yeah. I did omit one optimization, so I didn't get into the nitty-gritty math. I'm just explaining the general idea because the math is really simple once you like. If you know 1 + 1, you'll understand the math. I just didn't bother because it gets really in depth. If you want to read it, you can read the paper. I'll link that in the description too. But let's go back to the code, and then you can actually see it happening with the
Cam for this one, so you might have to go at the top and change the MP4.
Yeah. You're right. To 0. Save that and run this and get that going. And Kazi, text me a picture.
There we go.
To my phone because I'm gonna pull up on my phone. I'm gonna hold it up.
Send
so that
you.
We can get 2 faces in the webcam.
Oh, I see. Okay, I'll send it to your Slack right now.
Got it.
Okay, cool. So
this is working in real time. Every single frame, it's doing the sliding window thing all the way across the entire thing, and it's doing the entire HAR cascade of all the HAR features that it was trained to within each of these squares until it finds this square at this size and finds my face, and it's doing that in real time just because the computer is so dang fast. So.
All right, about to send you. I'm having trouble actually finding.
I got different ones, so we can actually. So real time, we can.
Oh wow!
Get my face and both of our faces. It's kind of not getting Kazi, but see.
There we
the
go. It got me.
Squares,
it got me once you went close.
Squares. Yeah.
Dude, it is looping through in real time. That is insane. It is literally looping through in real time.
Every frame, every size square across the entire image with all the thousands of HAR functions. And it's just like number crunching, fast enough. That's all it is.
Wow.
It's really cool, and you gain an appreciation once you understand how it works.
Aaron, this is how we gotta demo it next time. We gotta just have like you holding like 3 phones, one with your foot, and then just like showing the 3 phones in your face at the same time. That's like mind blowing.
One issue is going sideways doesn't work, so it's not super robust, but you can do that. There's also side profile, like there's different. Like this looks different than a frontal, but you could like combine a frontal. You could combine a frontal machine learning algorithm with a side. You can be like, oh, if it matches either of them, then detect it. Then you can be like, okay, this, or even a back head. You could even be like, okay, if it matches anything. And of course, like different hairstyles, mine might be different than a girl or a bald guy. But I mean, eventually you could really detect anything. And
damn.
That's really it, you guys. Face detection with OpenCV and Python with the entire theory and math behind it, so you guys understand it through and through. Hope you guys had your curiosity spiked, and maybe you're inspired to go learn how to do self-driving cars and work at Tesla, because that's what I want to do one day. Yeah.
That is so exciting. That was awesome, dude. Thank you so much for that demonstration. Guys, if you enjoyed this so far, first of all, drop it in the comments and let us know if you enjoyed this. And also go ahead and smash that like button, because if you enjoyed this, chances are somebody else will get value out of it. Somebody else will also enjoy it. All you got to do is smash that like button to get this video out to as many people as possible. And if you haven't already, subscribed to the channel. Yep. Awesome. I think that's it, guys. Thank you. Hopefully this gave you value and taught you guys something new. This was a mind-blowing experience for me. Hopefully it was also a mind-blowing experience for you. With that said, guys, we love your face. This is Kazi, and
this is Aaron. What's up? You see me?
Yep. And that's it. With that said, we'll see you guys in the next video. Peace out, guys. Bye.
Here, let's check out what we are going to do.
What's up, guys? So this is the app we're going to be building. I'll just let this demo running. So what we got here is some urban city driving, some guy on a motorcycle. There's some cars and pedestrians. These guys are about to get hit. And yeah, as you can see, the pedestrians are outlined in yellow and the cars in red and blue. So yep, this is what we're going to be building, you guys, with Python. Super excited. Yeah, as you can see here, there's cars in the background. Some girls crossing the street here. It's doing a decent job. It's not perfect, but you know, it's good enough. So
this is some guys. This is some Tesla shit right here. I'm not kidding. I mean, take a look at this, right? It's able to detect pedestrians. It is able to detect cars, which is just crazy, right? I mean, it's like, imagine basically, you're in a Tesla, right? And you have to figure out, what car's in front of you, right? You need to figure out when to stop. You need to figure out when to go. This is a system something that Tesla would build for their cars. Like, who is up to build a system like that, guys? Huh?
Tesla Autopilot, man. Elon, we're coming for you.
Guys, Elon, exactly. We're building our own startup company to compete with you, Elon. There we go. That's how we're doing it.
I mean, that's ambitious, but yeah, that's the hope. That's the hope.
Exactly. So, guys, yeah, like I said, who's excited to build this? Drop that in the comments below. This is an epic system. Again, we are building an AI for detecting what? Detecting pedestrians and cars with Python.
Pedestrian and car tracking.
Exactly. Pedestrian car tracking. And this is what? This is beginner friendly, right? This is beginner friendly.
Yeah, beginner friendly. The app is not hard at all. If you're a beginner, you should be able to follow along pretty easily. We're going to be using Python and OpenCV. So OpenCV is an open source computer vision library. So that's it. Just Python, OpenCV, and that should get this entire app finished.
Yep. Guys, now before we get going, guys, so here's what I want you to do. I want you to make sure that we defeat the YouTube algorithm system. Help us defeat the AI of YouTube by smashing the like button, subscribing to this YouTube channel, and of course, sharing the video. Is that right?
Yep, that's it. So if you want to see more stuff like this in your feed, then help the YouTube algorithm, like this video, and then YouTube will show you more coding stuff, and that's what you want, right? So definitely do that.
Yeah, guys. I mean, look how cool this is. Such an awesome tutorial. Look at this, guys. It's just like it's making boxes around the actual cars, and and it's able to detect them like in real time. We're talking like split seconds.
Pedestrians.
We're talking milliseconds. This is
epic. Maybe not milliseconds. Like, it's pretty good. It's not
that's
quite
milliseconds. I mean, life is happening really fast, right? So it needs to detect really fast, right?
Yeah, it's good. Like, even like you can like see that pedestrian in the distance for a split second at least.
Yeah.
But yeah, I'll just let this demo keep running. It's pretty dope. But yeah,
detect the bus?
Probably move forward. Oh, by the way, guys, if you're interested, if you guys like coding, and I mean, assume you guys are because you're watching this video, then here at Clever Programmer, what we do is we teach people how to become developers. Like, we teach them how to make a living from coding, pretty much. So we offer courses. We have a Python course called Profit with Python that gives you a whole 15-week roadmap of becoming a beginner to expert and landing your first job or client with Python. So check that out. If not, feel free to watch the free content on YouTube. This video is free, and we also have a free training if you want to check that out too in the description. They're both down there. Other than that, that's really it.
We have a masterclass training in the description below if you want to check that out. And one thing I really want to mention, we recently had an amazing story from our students. How about you tell this, Aaron? Huh?
Oh yeah, this morning. Or yesterday morning. I think yesterday, we had a student land a $90,000 a year $90,000 a year job. So the story is she lost her job due to COVID. She enrolled in our course. She got a $45,000 a year job by being in the course. Lost that job, and then a couple days later, just yesterday, she got a call randomly for a job offer for $90K. So
twice as much.
Really awesome there, but just shows that we do get our students results. But check it out.
Awesome.
But other than that, let's just get into the code, Nas, because that's what people are here.
Let's do it, guys. Who's excited? Who's excited to build an AI system like this? Drop that in the comment below, and we're going to be doing this together, guys. We're going to be learning this together. So make sure to smash the like button, subscribe, and let's get into it, Aaron.
Heck yeah, man. Okay, so, I think this has been going on long enough. Let me just cut this and clear my terminal. And let's go to a presentation. So I just want to give you guys a quick presentation, a little bit of context before we actually start coding. If you want to skip this and just skip right to the code, feel free to jump to the timestamp. The link will be in description. This will take like 5 or 10 minutes. It's fine. I'm just explaining how the algorithm works and stuff. So let's get started. So car tracking with Python, okay? With a couple cute little emojis there. So first of all, we're only using computer vision. So you guys might have seen some self-driving cars. They have like this weird radar thing on the roof of the car, and it like spins and stuff. It's like
like the Google one, like the Google one.
Yeah, like the Google one. And I mean, that's like using lasers and radar and stuff, and it kind of sucks. But we're not doing that. We're only using computer vision because that's how a human works. You just use your eyeballs. You don't have like a laser sensor. Okay, so only computer vision.
Yep.
And the reason we're doing that is because Elon Musk says so. Okay, Elon Musk here, he's my dad. I coined him as my daddy Elon. But I'll show you.
Sure. Okay, sure.
Computer science only, and a little bit Elon there.
Damn,
Don't
that is
smoke, guys.
some
Everybody
cool
knows
Elon.
this. Tesla stock is up. So
Yep.
this worked.
Guys,
But,
don't smoke though. We don't encourage smoking, okay?
yeah, none of us smoke anymore.
Exactly.
Anyway, so yeah, this is the little article that I found. There's actually a video of Elon saying it. He's kind of curt about it. He's like, anyone using LiDAR is doomed. And pretty much the reason for that is it's bulky, it's expensive, it's not effective, and humans can do it with just their eyes, so a car can too. Okay, so we're going to be using computer vision just like this and not like this, all right?
Beautiful.
That's really it. So let's explain how this works, okay?
Yeah, let's do it, man. I'm very curious. Ooh,
What?
the slide didn't load? Oh, there you go. Interesting. Now they do. Okay, let's keep going.
All right, so let me get rid of this Zoom thing. It's in the way.
Mm-hmm.
All right, so step 1. So how does this actually work?
Good question.
One of this is gone. 1 second, guys.
There we go. What happened there?
Uh,
That's all right, guys. That's okay. We got, you know.
No.
There we go. Step 1.
Anyways, I mean, that's kind of screwed up. But anyways, so step 1 is to get a bunch of car images. So what's supposed to be here is actually this image, but in color. Okay, so just pretend that that's there. So step 1, get a bunch of car images that look like this. Step 2, you want to make them all black and white. So that's what it'll look like. And the reason we do that, I believe, Naz, you asked earlier, is because when it's black and white, it just makes the algorithm faster because there's less data. You don't have to worry about color data. It's just relationships, and you can still tell that it's a car even though it's black and white. Am I right? Or am I?
That is true. They can still take a lot of things, but yeah, I mean, yeah, and if you have RGB color, right? So you have to have colors. I'm guessing it's gonna take a lot longer to process because there's just so much more data in there, and so we kind of scrap that and be like, nope, no, we don't do that. And interestingly enough, actually, if you look deeper, I think Tesla does the same thing. So Tesla, when they actually go ahead and process their videos, they process their video that comes through cameras, they turn that into black and white, guys, and we are doing the exact same thing. Like, how epic is that? You know?
Yeah.
I think it's
so.
epic.
I mean, yeah, it's the first step. You just got to turn black and white because it makes things faster, and Tesla's all about being fast. And then step 3, once we have the all the images in black and white, like you get a bunch of car images, make them black and white, just like Tesla. Then you're able to detect and track cars. All right. And basically the same thing with pedestrians, but I'm just using cars as the example here. Yeah. So that's kind of the brief explanation of how it works, like overall. I'm going to go into a little bit more detail here for some context, and then we'll get into the code shortly. So how does the computer train the algorithm? Like, how does it go from this to knowing what a car is in each of these images? How come it didn't put the red like square like over here where it was incorrect? It's actually correct in all of these. How does it do that? So very
That's a good
simple
question.
Yeah, I mean, computer algorithm behind it. We're just going to explain it in simple terms for people to understand. So very simple. We use these. So these little box-shaped things are called hard features, and pretty much what they are like little building blocks, like little Lego blocks that you can use to define something. And that doesn't make any sense. But on the next slide, I'll show you how it works. So pretty much we just do this. Let me zoom here so I can show you guys. So as you can see, this is a picture of a car here. Okay, a rear end view. And as you can see, this little window is like a dark patch, right? And this little thing down here is a little bit lighter. Like this area is lighter. And then again, the shadow is a little bit darker. So what we can actually do is we can take one of these hard features like we have right here, this one, like this one, but inverted. And we can actually say that this kind of matches right over here because it's kind of darker up here and lighter down here. So we can say that this hard feature matches this location on the car better than it would match here where it's just flat or flat green up here. Okay? So,
Right,
and the way
okay.
it does that is it just takes all of the pixels. It just takes all the pixels in that black square and adds them up, and then all the pixels in this white square and adds them up to one number, which is just like
Interesting.
the way to really boil down like to a single number how dark or how light that entire box as a whole is. And then you can compare those two numbers to be like, if those two numbers are far enough away from each other, you can be like, okay, this rectangle is a lot darker than this rectangle, or this rectangle is a lot lighter than this rectangle. And that's what essentially what's happening here, because this rectangle is
and so it
darker
almost
this
creates
one.
like a shape. It almost like creates like a shape basically, because if it knows, right, darker up top, white at the bottom, and then I can continue on doing with that, it creates like a shape, and then it remembers that shape basically, right?
It'll
Damn.
just find that this match is pretty good when you're training the data, and you're like, okay, this heart feature of this size kind of matches a car pretty good.
Right,
Okay.
right,
And then
right,
we
right.
can also say, likewise, like I said, there's a shadow down here, and this one's a little bit bigger, and there's a white strip. You can kind of say that this heart feature would match down here, because if you cover the shadow, it's kind of darker on the shadow and lighter on the bumper. So you
Yeah.
can actually say that this is also a good match for a car.
Yeah.
And then these two in added together, you can actually see that this dark window in the bumper and then this dark shadow in the bumper are kind of like, these two hard features together kind of define a car even better than any of them by themselves.
Yeah, so you guys want to take a
So
look at
the
the shadow,
idea-
at the shadow below, and if you look at all the other cars, guys, they have a shadow below as well, right? So that's kind of how it kind of starts to recognize that. So that honestly is so interesting. Like, guys, who's excited to learn something like this? Because honestly, applying this into your real world, into your life, is so extremely important. Mainly because with Tesla, with GM, with all these companies, they are going towards this. They are going towards autopilot. So just imagine, right? Let's just
Self-driving cars.
imagine the amount of jobs that this will create. Right? Like, it's just the amount
Yeah.
of jobs with Python, with machine learning that's going to create in the future, in the coming future, and already is insane, bro.
Yeah, the Uber's going out of business, man. Like Elon Musk said that there's going to be robo taxis soon.
Oh,
So
yeah.
I might have already said this, but if you're an Uber driver, you're going to lose your job soon. You should probably
Yeah.
become a programmer instead, because then you can program the cars instead of drive them.
Exactly.
But,
Profit with
got
Python,
about
link in
5
description.
years, maybe 10 years
Exactly.
max, and then your job is done. So
Well,
hop
okay,
on
well,
that
okay.
quick.
Well, okay, we don't know about that, but
I know.
let's not be so harsh. But let's continue on, bro.
I got faith in Elon, man. Like, what are you doing? Doubting my daddy. Don't do that, bro. End the stream right now.
Let's continue on.
But anyways, so that's how it works. The idea is these two hard features match nicely for a car, and you can chain like thousands of these together, and all added up, all of those hard features added up will kind of match to what a car is. So these are just two examples, and same thing works for detecting pedestrians. So I'll show that next. Okay,
Okay.
let's go to the next slide real quick. So yeah, the same exact idea with pedestrians. You get a bunch of images, okay, of pedestrians. You make them all black and white. You want to run all of these hard features over all these images to find which ones match in which locations. And then eventually you'll train it enough for it to be able to detect actual pedestrians. So for example,
interesting.
like if you look at this pedestrian here, then maybe this hard feature will be really good. Like if you took this hard feature and stretched it taller and put it over, you can kind of say that like maybe here is like a darker person, or here is a darker person, darker person, darker person. And then you have the lighter areas on the sides. Okay, so you can kind of use that. That's kind of a good match. Also, you can see her pants are very dark here. They're basically like dark blue or black or something. You could say that this hard feature, if it was a little bit stretched taller too and skinnier, then you can say,
Right.
okay, this hard feature matches good. And same here, because usually people are wearing pants and shirts of different colors. So you could say that also matches a human.
Yeah.
A pedestrian.
And so
those will add
again,
up.
it basically it almost like creates a shape again. It uses all those black and white boxes, it counts them in, and it creates a shape. And knows, okay, so if this kind of a shape matches, right? This kind of shape is created, it matches a human. If this kind of a shape is created, it matches a car, or it matches a pedestrian, right? So that is the
or a
interesting
face,
part about that.
or a Pepsi
or a
can,
face.
or a Coke can.
Yeah,
Yep.
or an apple. I don't know, whatever you want.
Anything.
you know. Yeah, but
I
this
mean,
is
like
it. But
distinguishing apples from pears, like that's a little bit trickier, and then you probably
Yeah.
need to keep the color in there at that point. But I mean,
Sure
this
that.
is just a generalized explanation. Of course, there's always a trade-off of accuracy and speed. So
yeah.
it takes a lot more work to distinguish an apple from a pear than it does from a human to a car, because they're just very different things.
True that. Sweet, man. All right, let's continue on.
Yep, that's it. So let's just jump into the code. Let's code it up. I know
Hey, let's go, guys.
we're probably like 12, 15 minutes in. But again, timestamps in the description if you rewatch stuff or skip anything.
Yeah.
But let's get into the code, okay, guys? we still live, Nas? Just wanna make
Yeah,
sure
we
'cause
are
got
live.
cut off.
We're all good. We're all good. We're all good. We're all good. Let's
Dope.
continue
Dope,
on,
man.
guys.
Yeah,
Who's
on my
pumped to
phone.
build? Who's pumped to build an AI system like this? Who's pumped to build an AI system for car and pedestrian tracking? I'll put it in the comments below, and we're going to get started right now.
Got it. All right, guys. So I got the code up here and running. This is what was running the demo code. It's actually not that long, as you can
Okay.
see. It's just a few lines. All this here was doing all of that. It was taking in the image, not the image. It was taking in the video of the guy, the dash cam, and the pedestrians, and then it was finding everything, detecting everything, and displaying it to the screen. That's all happening right here. Okay?
Right. Okay. Okay.
So let's just jump into it. We're gonna start with just an image, and then we'll go to video second. But yeah, feel free to follow along. So if you guys don't have VS Code, you're gonna want to download VS Code. You're probably gonna want to pause this video and download it because I'm gonna be going a little bit faster.
Yeah.
But download VS Code, get it all set up, and that's it. Next, what you're gonna want to do is you're gonna want to create a Python file. And you can call it whatever you want, but I called it car and pedestrian tracking.py. Okay, this is the one I had before. I'm just gonna be copy and pasting code over to show you guys how it works. I don't want to have to type it out. It's the same thing pretty much. But you want to start here, okay? Next thing you want to do is install OpenCV. So you can do that through the command pip install opencv-python, okay? And if that doesn't work, then try running pip install the same thing, but just add headless at the end. Okay, there might be an issue there.
Yeah.
One of those should work if you're running on a Mac or a Linux computer. If you're using Linux, you're probably already a badass programmer, so you don't even need to know this stuff. But again, you can just do a Google search like how to install OpenCV on your computer. If these don't work, you're gonna kind of have to figure it out yourself because I can't help with every error through this live stream. But
Wait,
just
guys,
get that installed.
we're about to cross 100 likes, so let's keep liking the video, guys. About to cross
like the
100
video.
likes. Like the video.
you guys.
Let's continue on.
Yeah. Where was I? Install OpenCV. So once you have that installed, you should be good. Okay. The way you can test that is you can just put Python, okay, and you have your little Python environment here in your terminal. And if you know what this is terminal. So you want to go, you can do command space on Mac, and then this little spotlight thing pops up and type in terminal, and just hit enter, and then it'll pop this up, and this kind of tells you, gives you access to your computer. So if you type in Python, then you can do stuff like hello, okay,
Yeah.
and then it'll print hello, whatever it says there, or
Nice.
daddy.
Oh my God. Elon
Anyway.
is not your dad, bro. Come on.
Man, you just let a boy dream.
You look very
okay?
different.
My dad.
No. Don't even think about it. No, Aaron. Don't
Anyways,
even think about it.
back on track. So to make sure you have OpenCV installed, you can just import CV2, which is short for Computer Vision 2. And if you hit enter, then this will happen. Nothing will happen. It'll be fine. If you get an error, it means it installed incorrectly. So just make sure that when you run this, it just goes to the next line. There's nothing happens. That means it's installed correctly. Then you're good. To get out of Python, you can just do Control D, and it'll go back here. And I'm just going to type clear so that we're back to the terminal. But once you have OpenCV installed and you have your Python file created and you have it open in VS Code, we are ready to start coding. Okay.
Okay.
So
Now, guys,
very
looks like Edwin just gave us a €1 super chat. Edwin, thanks so much. Appreciate it. And let's continue
man.
on. Yeah.
Dang, I think I took my lunch now, right? With that money.
I know, right? I know.
Anyways, so let's just start with a simple code completed. So this is a little thing I like to do. I put this print statement at the end of my program so that I know if it prints that the whole program completed without any errors. So let's just run this first. So this is the first thing that I'm going to run. Go to the terminal. Make sure you are in your desktop. So PWD stands for present working directory. And as you can see, I'm on my desktop. If you're not, then if I'm not on my desktop, let's say I'm at my user file, then you want to put in CD, which is change directory, and then just type desktop, just like that, with a capital D, okay? And then once I do that, then I am in desktop, okay? Then once you're in desktop, that's where I have my files housed. Or if you have all your files housed in a folder, then you got to go there instead of desktop. But for me, I just have it on desktop right here.
That's a massive file structure, bro. But anyways.
Bro. I used to teach them how to code. Like, I don't know how to keep my computer organized. Like, this is free content, you know?
All right. Okay, fine.
This is Aaron's stream, bro. Get off the stream now. Just kidding. I need you to help me. Anyway, so let's run this code. So the way we do that is we just write Python, because this is a Python program. And then we want to run car, I think I gotta put dashes. Car, there we go. So car and pedestrian tracking.py.
Okay.
These little slashes mean it's a space, because it's kind of silly when there's actual spaces. Like I had underscores in the other file, but ignore that.
Yeah. And the
so
way,
these
by the
are-
way, and the way Aaron was able to get that is he simply started with so he typed in car and then he pressed tab right away, right? So he pressed
Yeah.
tab, and that's what basically right away it autofilled, because we got
Yeah, it
autofill
find-
and
it auto finds any files that has car at the beginning, and then it gives you all the
Exactly.
options.
exactly.
You can just type it all the way out. Maybe just use underscores, because then it gets rid of this nasty, complicated thing with this stuff. If you just use underscores in all your file names, and you can just type out this exact thing, and then you won't have all this weird stuff.
Yeah,
It'll just look like that.
yeah.
Okay,
Exactly.
use underscores. It looks nicer.
Nice.
But for this video, we'll just use this. Okay.
that's fine.
So
that's
when I
fine.
run this, because it says code completed, then we should see code completed pop up here. And voila, it does. So that
Okay,
there,
okay,
I mean,
cool.
unsurprisingly, because there's just a print statement. But like I
Alright.
said, when you're running OpenCV, you want to run import CV2. Make sure you save. And if we run this now, then and this prints out, we know that this is working correctly. If this doesn't print out, then that means there's an error here importing, and then we'll see it. But I mean, I think it's going to work. So you can press the up arrow key to repeat your last command and just hit enter again. And as you can see, no errors. So
Guys,
looks
and that's it. Our program has been completed. Thank you very much. No, I'm kidding.
Your whiteboard joke, man. Get out of here.
Let's continue.
All right, so let's start with just detecting cars and images. All right, so I have a little mini program up here. Let me just comment this out. To comment out in Python, you can just use triple quotations like that, and everything between will be commented out. And let me
Okay.
just get these. And there we
Okay.
go. Save this. And here we go. So it's even shorter for just an image, but we're going to go through all of them one by one and explain how it works, okay?
Interesting.
So let's start with this, all right? So
Okay.
first thing we're going to do is we're going to want to decide on an image. Of course, if we're going to be detecting cars, we need an image that has a car in it to detect, okay? So I just have an image on my desktop called carimage.jpg right here, carimage.jpg. This is the same one that was in the slides I was using. I just cropped it out.
Yeah.
The same exact image.
And we literally,
this
and we
is-
literally got, guys, we literally just got these images from the internet, so don't think it's anything special. It's just an image from
Nah.
the internet, and we're
Yeah,
using that
the
kind
videos I'm actually
Yeah.
using in this tutorial, the links to the YouTube videos I stole them from are in the description. So credit to those people. The guy on the motorcycle, he has like 2 million subscribers for riding his motorcycle around cities and
Yeah.
like revving his engine at hot chicks. Like it's pretty cool. But
of. All right,
but
all right, okay.
I use a video from him, and that's where I get it from. So this isn't spoofed. Go check it
Alright.
out there. You can also use a YouTube downloader to get the videos yourself. If you want to use
Alright.
the same videos, then by
Okay.
all means do it.
Dope.
So this is the carimage.jpg, okay, right here. And that's it. So the image file we have is just carimage.jpg. Very simple, okay? And let's just run this. This is called unit testing. Every time you write a new line of code or like a different group of code, I'm a little bit OCD and psychotic and do it every single line. I run it to make sure code completed prints, because if it doesn't, that means the line I just added screwed something up.
Right, okay.
Okay, called unit testing, because you want to test every single unit of change in your code.
Right.
Even you can be redundant, even if it's like as simple as, oh, I deleted something. Like maybe
Yeah.
you thought you deleted the D, but you actually deleted this. That's gonna screw you. It's gonna
Yeah.
break the code.
True.
But yeah, pretty self-explanatory. That's the importing the image there. Second thing is we are gonna want some way to be able to detect and track cars, okay, and pedestrians. But let's just start with just cars.
Okay.
So let's start here. So these are our image. Let me put in some comments, because comments are good. It's good coding practice. And our pre-trained car classifier. Okay, so this is a little bit wordy, but all it is, like I said, when you train the algorithm with the HAR features, and you have a big list of HAR features that defines a car, when they're all added up, like the dark boxes and the light boxes, all of those added up define what a car is. Like it kind of captures the pattern of what a car looks like in an image or in a frame of a video. Then you encapsulate all of those numbers and HAR features in a file, an XML file. So
Okay.
I think, yeah. So what this looks like, I can
okay.
actually open it right here.
Okay, let's take a look at
If
it.
I just open this up, then this is what it looks like. So car
Interesting.
detector.xml. So all this is the result of training the algorithm. This is what the algorithm at the end spit out after you put in thousands of images. Oh, by the way, I totally forgot. The car images, the data set that I stole. Sorry, guys.
Stole.
I,
We borrowed.
I got
We
hiccups, man.
borrowed.
I'm gonna die on the stream.
You got some water?
But I got
You
it.
gotta get okay.
What's up?
Get some water, you know?
Yeah, I got some right here actually. So
Okay.
I'm gonna drink while I'm talking.
Alright, cool.
Should be good.
Alright, awesome,
I'm a
guys,
master of conquering hiccups.
Okay.
Anyways,
Alright.
so we're not actually gonna train the algorithm ourselves on this video. That takes way too long because like it takes like a long time for a human to learn and build a habit. It takes a long time for a baby to understand what a car and a pedestrian is. The same way it takes a long time for a computer to learn what a car is because you have to give it thousands of images and run all the thousands of hard features at every location of every size of every orientation until you eventually decide on the hard features that match nicely for a car. And then once you have all of those, then you're good to go. But the end result is pretty much this. Okay, so this is just like some encoding. I actually don't know how this works exactly. It's just the XML encoding is what they use. But the idea is you can generate one of these files, and it has all the numbers. Like these numbers are like different coordinates and different colors and different thresholds of like, okay, is this a hard feature? Is this good enough? It needs to be above this number, below this number, and it just goes through the entire list of thousands and thousands and thousands. Oh, yeah, guys, Kazi called me. I don't know if you guys can hear. 1 second, guys. We got another donation. Dope. Got it. Yeah, I'm not in the chat, guys. I think we overlooked that, but somebody donated. Are we still live, Nas?
Yeah, we're live, of
There?
course. All right.
Here?
Yeah,
Okay,
let's
dope.
keep going. Let's keep going. There's no. I was just talking with Kazi. Kazi called me. We were like,
Yeah,
you know
he
what?
called in.
Yeah.
All right, guys, so we're back on track. Somebody else donated. I think we missed on the chat because we're focused on the code, so we overlooked that.
Yeah.
But Nas, keep an eye. So
I'll
whoever
keep an
that
eye.
was, I don't know their name,
Appreciate
but
it.
appreciate that. Very appreciate that. Appreciate the gesture. And where was I? Yeah, so this is the long list of hard features. It's gonna go through all of these, and if the image passes all of these, you can say, okay, yeah, this is a car. Awesome. Or like a little patch of an image. If the little patch passes through all these and it's a yes all the way through, then it counts as a car. If not, it's not a car. And then that's how we know where they are. So you're gonna need to specify this file because this is what's gonna tell us what a car is and what a car isn't. And
Right.
the link to this file is actually in the description, so you can just go download this. It's just a URL. Just go file, save as, and you can download this. It's actually just called car.xml, but I added detector for the video. So download that. Okay, that's the explanation of that. A lot of explanation for one line of code, but I don't just want to be like, hey, just download the work. Like, nah, I'm gonna explain how it works so that you have an
Yeah.
overall holistic understanding. That's the proper way to do stuff. Okay, we're actually
Yeah.
programmers. I mean, we're lazy half the time, but it's fine. All right, so moving on. Now, the next thing we're going to want to do is we're actually going to want to create an image within the OpenCV format. So this here, of course, this is actually just a string, okay? Car image is just a string in Python. But we want to give it to OpenCV, remember CV2, and actually read the image so that OpenCV can actually use it correctly, okay? So all we're going to do is we're going to call OpenCV.ImageRead and pop in the image file, the name of the image file, which is just carimage.jpg. Again, carimage.jpg right here. So we're reading this into our program. And from there, we have it in here image. So that image is actually now in this variable here in our program, okay? So why don't we just show, I believe,
So the image read file basically like takes in the image and all and it processes it as like data. Is that what it does, right?
Yep. So it just reads in all the pixel data from that image file and then reads it into some double multi-dimensional array. So like a big
Right.
array, a double array of an array of arrays, so that every pixel has its own data, and then it's just all encoded into this one variable here, image.
Right.
Okay?
Gotcha.
And now what we're going to do is we're actually just going to this is not a face detector. This is a car detector.
Okay.
We're going to display this image. So there is a, we're also going to need this. Just one
What is
second,
that
guys. So these 2 lines of code that we're currently working on, we got the image in our program. Next, we're going to need to show the image. So OpenCV has a function or method called image show. And the first thing is the name of the window. So the name of the window, like here is car and pedestrian tracking.py. That's what'll pop up there. And then the actual image you want to show. Okay?
Okay.
That shows up. And then in OpenCV, this basically just means display. So OpenCV.waitKey, you need to run this line of code so that it actually displays. Otherwise, it'll display for a split second, basically 1 frame. So like literally a split second, then it'll disappear. But this says wait until you hit a key before it disappears. So it kind of like, this displays for a millisecond, but this makes it pause. And so you need both.
Okay.
This is kind of just like display.
By the way, I just want to say thanks to Lars. Lars donated, looks like a euro as well. So appreciate that, man. And we got so many guys. We got so many people in the comments between Abdullah, between Kristen, between Chax, between Kant, Usma, Vicky, right? Joshua. So many of you guys amazing and so excited in the comments. I'm excited that we have such a great community, man, literally. So yeah, I just wanted to mention that because so many amazing people. Let's go ahead and continue on.
Awesome, you guys. So let's just run this code now. All right. So again, we imported OpenCV. We got the image file. We have our car classifier. We import the image. Okay. And I just want to show you the image now real quick, okay, to prove that the image is actually showing up and is within our Python program. So this will actually pop up a little window with the image, and that's it. It's not detecting anything yet. It's just going to show the actual image. So boom, right there. As you can see, it says Clever Programmer Car Detector, and that's the image.
Right.
Okay. And remember, this title is from here. Okay. So that's that. All right. Now let's just quit out of this. So it's waiting for a key press. If I hit spacebar or any key, it'll just quit out. And now we can continue on. All right. Okay. So now we're going to be coding in here because, of course, at the end, we want to make sure we're displaying the image at the end. But now we have our image in our file. Okay. So now that we have the image and we have our classifier, how do we actually find where the car is in that image? Because I mean, there's a car here, there's a car here, there's a car all down here. I mean, granted, these are half cars, so it might not detect these. I don't think it will. But these full cars, it definitely will. Okay? Oh, Kazi's calling again. Hey, what's up, Kazi? Live stream is dead? Stream is dead now.
No, you're not on mute.
No, it's running. Is the stream up, guys? In the comments, can you guys?
It's running. It should be running, guys. Right? It's running. You guys hear us? It's working. Yeah, it's all good, guys. All is good.
Got it. All right,
it's all good. It's working now.
All right. We don't want another dead live stream. You guys, it's terrible because it keeps getting cut off. But I think we're good, right? I think we're good.
Yeah, we're good. We're good, man. We're good.
Anyway, so this is the image that's going to be read in, and from here, we want to be able to classify that this right here is a car. So it's like if we pass this little rectangle of the image through that whole XML file, and if it gets all the way to the end, it's like, okay, cool. This square counts as a car, and this square does not count as a car. Okay. So that's what we're going to be doing. So the next step to do is to actually create our classifier. So that's pretty simple. That's just this line right here. Let me show you guys. I'll copy and paste this. And we want to create our car classifier. So all it is we run this function, opencv.cascade classifier. Because again, we are running a hard cascade algorithm. That's why it's called cascade, because there's a cascade, a long list, a long chain of hard features that we're going to run it through. And classifier is just classifying something as a car, or classifying it as a pedestrian, or classifying it as a face or an apple or whatever, but in this case, a car. And the classifier file is what we just specified, the XML file. So we just pop that into here. And so OpenCV, we're just going to create a classifier from that file. And then we're just going to call it car tracker, because once you have a car tracker, now we can apply this car tracker to this image, and we can actually find where in this image if there is a car or not. So here there's a bunch, but it might only detect a few, but that's the idea, okay? So in an image, we have a car tracker. Now we just want to apply this car tracker to the image and then spit out the rectangles, okay?
Right.
So let's move on. I mean, again, this doesn't show anything. We just have the car tracker created. If I displayed it, it's just going to be the image again. So I'm going to move on. Like I said in our presentation, we do want to convert it to black and white though first. So let's just do that next. And the reason for this is because it speeds up the algorithm, makes it essentially 3 times as fast, because instead of 3 colors RGB, we can just focus on black and white. That's it. So
you're simply converting basically from color to black and white.
Yep. Same as the face detection. If you guys want to,
why don't you do that before you classify? Is my question. Like, why don't you do that before the classifier?
I mean, you're just creating it. We can shuffle this up. It doesn't really matter.
Yeah. Doesn't matter. Okay.
Yeah, doesn't matter.
All
I mean,
right.
this might make more sense because you have the image, then change it to black and white, and then create the classifier.
Gotcha.
I mean, we could even do this. We could keep the order different. So like we've got an image here, and then we read in the image, and then we change it to black and white, and then we get our classifier, and then we create the classifier, and the point is, what we want is we want to have this classifier and this black and white image ready. So once we have both of these, we can do this in any order. Then we can pair these together and actually get the images. Okay.
Nice.
So I mean, I guess I'm gonna put it back here because I like keeping all of the static stuff together, because these can change. Like you can change the file very easily here, or the file very easily here, just by changing this, and all this code remains unchanged.
Right.
So here's
we got somebody asking how can I donate? Oh my gosh, so many of you guys are asking how can I donate? Dang, really appreciate that, guys. That is so awesome. My PayPal is my
my Venmo, my OnlyFans, like I got everything.
Just PayPal to that,
Yeah, my Snapchat.
Oh man.
No, I actually don't know how you can do that. Do you know, Nas?
I don't know. I think Kaji's got it. He's got it taken care of. All's good. Yeah.
Cool. Yeah. Or we can hook you up with something. Maybe there's something like a $5 course, something. I don't know. We can hook something up. Yeah. Who knows? Anyways, back to the code, you guys. So once you have the image read in, you want to change it to black and white, like we said, because it speeds up the algorithm, and you can still tell what a car is and what a car isn't in black and white images. So it's totally fine. You want all the improvements you can have. There's always a trade-off of speed and accuracy pretty much in everything in life. So algorithms are no different. So you kind of want to change, like again, like an apple and a pear. If you go black and white, it's going to be much harder to distinguish the difference. But a car and a human, very easy to distinguish. Okay.
Right. Yeah. That's true.
So the way we do that is OpenCV. There's a function called convert color. So all you're going to do is this allows you to convert color to black and white. It allows you to convert black and white to color, and there's all different kind of color encodings. I'm not going to get into crazy details, but the point is this allows you to convert the color stuff of an image to whatever you want. I could even make it all red, like have only the red channel and it'll look really red and stuff like that.
All right.
So I'm not going to demonstrate that here, but let me see actually. Now I don't want to go down that rabbit hole. The point is you can convert the color of any image. So we're going to feed in the regular color image here, and then all we're going to do is we're going to say we want to go from color from BGR to gray. So BGR is just RGB backwards in OpenCV. RGB is like the color of a pixel. Everybody should know that. If you don't, well, now you do. Then they just use it backwards, so it's BGR. A little bit confusing. I don't know why.
That's so weird. That's so weird. Like, it's like the standard was like. By the way, if you guys didn't know what RGB is saying, it's red, green, and blue. Those are the 3 main colors that all the other colors are made up of. If you didn't know that, so yeah, that's something interesting for you. Yeah.
Each pixel has a red, a green, and a blue light, and then it just like makes the brightness of those 3 different levels, and the combination of those 3 levels can make any color pretty much. If they're all max, it's white. If they're all off, it's black. Okay, for RGB. But for gray, it's just one number. There's no 3 channels. It's just is it 0 to like 100 or something? Okay, from 0 to 100%. Like what's the brightness? That's all it is. So we're just converting RGB to gray. And once we have that, I just call it black and white because why not? Now we can actually display this black and white image. So let's take this, and in our image show down here, which was showing the color image before, let's just change this to the black and white image. And of course, we need this to display for longer than a millisecond. And this should actually give us the black and white image. Okay, so let's just run the same thing again. Again, your up arrow key will allow you to go to the last command you ran in your terminal, hit enter, and voila, we have a black and white grayscale image.
Okay, interesting, guys. Give Aaron some round of applause in the comments below.
I ran 6 lines of code, you know. I've been coding for 8 years.
And
this
we
is what it
converted an
took, 6
image
lines.
to a black and white image. That's what we just did.
This is all I learned in 8 years, guys. This is all.
Exactly.
This is it.
all
Please give me
all
the
eight,
grades I
eight,
deserve.
8 years in college. 8 years in college, you know?
It's at grad school,
Yeah,
pursuing
yeah.
masters and everything.
Oh, man.
Anyways, so that's the black and white image. So now that we have the black and white image, we can actually apply the card classifier to that image, and then we can get the car in the image out. Okay.
Yeah.
So next thing we're gonna want to do is actually detect where the cars are in the image. So let's run that next. Okay.
Okay.
So I'm gonna
You got
kind
it? Are you trying to figure out
Yeah.
what line to write this on?
No, I just kind of want to like segment like these are the 2 files. Shut up.
It's just like, wait, no, right, this line? Or this line? Or this line?
Duke it out. They would like that on the stream, you know?
Guys, drop in the comments below what line should Aaron write the piece of code on.
Who
You
would
know?
win in a fight, Aaron? Nas. That's what I want to know.
Actually, cool. Good question. Who would win in the fight? A good question.
I mean, you're more
Drop
jacked
that in
than
the
me.
comment. Drop it down in the comment
I think
below.
my ego would
I'm
win.
very-
This
I'm
was
very
an ego
curious.
fight, I would win. Physical fight would be you.
We'll
but
see. We'll see.
whatever.
We'll see. One day.
Anyways, yeah. So the way you detect things in OpenCV is once you have a classifier object, okay, a car tracker, you can apply this to an image. So all we're gonna do is we're gonna say car tracker, and we want to detect multi-scale. So what that means is detect cars of any size, of any scale. Okay, so we're gonna detect cars. It doesn't matter if the car is big or small. It's going to detect it no matter what. Or even if it was even bigger, it'll detect that too. Okay.
Got it.
So
But wait,
detect-
some of you guys, what editor is this, guys? This is using VS Code, guys.
Yes.
Okay, VS Code. So
Yep.
like, you just download VS Code. It's the most important one you'll ever use as a developer. So yeah, it looks like what wait, who is this? Hanshika asked that. So yeah, just download that and you should be good.
Yep. Oh, by the way, if you guys want to have the documentation for OpenCV, I'll link. That's linked in the description too, so you can check all these files because there's a lot of cool little things you can tweak. I'm not going to go over all of them extensively. I'm just getting the app done. But detect multi-scale, there's cool things you can add on to the end to kind of like tweak the algorithm to make it perform better or worse.
Yeah.
That's linked in the description. I'll just show it right here though. Detect multi-scale. So this is documentation. Again, link in description. Just click there. It'll zip
Link
you
in
right
bio,
here.
guys.
Yeah.
Cool,
Link in bio. Link in description, man. This ain't Instagram.
Link in bio. I'm used to that, you know.
I know. You fucking dirty millennial.
Okay, listen. Let's focus on the work here, okay? Alright.
It's fine, man. Like I don't like those boring videos, boring live streams. Like we just have fun. Anyways, so detect multi-scale. So of course you take the image in first, which is what we were doing here. We're just passing in the image, the black and white image. But then there's other stuff you can add on. There's all this cool stuff, reject level, scale factor, minimum neighbors. You can read all the details here if you're interested. But you don't need it for the app to work. I'm not using it. So that's really it. So detect multi-scale. You just plug in the black and white image with the car tracker that we got, again, from this XML file, which was trained with the images and the hard features. So that's the whole entire holistic view. And once we apply this tracker to this black and white image, it'll pick out all the places in that image where there's a square that contains a car, and it'll give us the coordinates of all of those cars. Okay?
Yeah, okay.
So why don't we just print this out and see what the hell is in cars?
Okay, guys, this is getting interesting. Guys, this is getting really interesting. All right, let's see.
Let's run it, and boom. So again, the black and white image is popping up because I still have these 2 lines of code down here running.
Okay.
But before that, I printed out cars. So all cars is
just the numbers.
Yeah.
Really?
It's just
That's
2
it?
coordinates.
Really?
So, yeah. I mean, I guess it's only detecting 2 cars in this. We'll see exactly where they are in a bit. I already know ahead of time because I ran this before, but it detects this big car in front and this little car on the right. Reason being is because these are all half cars, so it's not quite smart enough to get the half car. But actually,
that's a good question, guys. Guys, which cars do you think it will actually detect? Let us know in the comments below. Like,
bro,
okay, man. See, you gave it the. Yeah, I know you gave it away, but this is. Come on, bro. You gotta not give it away so easily, you know. But
easy mode. I mean, like, it's impossible to predict, bro. Like, not even us. You just run the program and see what happens. Like, come on. But still. Anyways, so yeah, it's gonna detect this one and this one. Okay, so there's only 2. Spoiler alert. But these are
Okay.
the two cars. So these are just the coordinates of where the car is. It just kind of like defines this square. That's all it's
Okay.
doing.
Okay.
Okay. So there's two cars, one car here, one car here. If there's 10 cars, like in the video stream, there's going to be like 10 of these in here instead of just two.
Right.
All right. So that's really
Okay.
it. Let's go back. And now all we need to do is once we have these coordinates, we just want to draw a rectangle around that car so we can actually see it. Because we know where it is, we just can't see it because there's no rectangle drawn on the image yet.
Wait.
So the last
So
step,
those numbers were actually rectangles, is what you're saying?
yeah, they kind of define the coordinates of the
Oh,
rectangle.
this
Just tells
guys.
you the top
Yeah. So
left
this.
point.
Yeah. Interesting. Okay. I got it.
This
Okay.
is the
Okay.
top-
Okay.
This is the top left point of the rectangle, and this
Okay.
is the width, the height. See, it's the same because it's the square. This is the
Yeah,
width
yeah.
and the height. It's the square.
Yeah.
That's all.
Interesting. Okay. Gotcha. Yeah. Applause for that. This is really cool stuff. Yeah. You guys don't hear Aaron. You
Yo,
don't
no,
hear the
you
sound.
in the chat?
Aaron, you don't.
So-
I'm in the chat. Aaron, you don't have you don't hear the sound effects, but we have some amazing sound effects going on in the background, just so you know.
It's amazing sound effects.
Yep. You'll see it later. Don't worry. No, you'll see it later.
Oh, in the stream. Okay, I thought
Yeah,
there was
yeah,
like
yeah.
something was like dying outside in my background, but there's nothing happening, bro.
Yeah.
Awesome.
All right.
Anyways,
let's continue on.
so yeah, so this is just like because they're squares by default,
Mm-hmm.
we're detecting things within a square. So this is the width and height of the square because it's the same
Okay.
number, width and height square, and then
Okay.
this is the top left point in the image of where it is. So from here we can be like, okay, this is the top left point. Now just draw a square of these dimensions at that point, going down to the right, and that's actually where the car is in the image. So there's two in this one.
Mm-hmm.
Okay, so we have top left point and width and height. Okay, if you guys watched the face detection video a couple weeks ago, very similar. We're just detecting different things and applying it differently, but same idea. Okay.
Got it.
So
Guys,
let's
who's
just do
ready?
that.
Who's ready to see some squares and detection squares, huh? Who's ready? You guys ready? Drop in the comment below. And Aaron, let's see it. Bro.
Got it. All right, you guys. So, yeah,
'Kay.
it's gonna be
What's up?
BGR. So this is actually wrong. Let me explain this. So I just copied and pasted. Actually, let's get rid of this for now. I don't
Okay,
want to
okay.
ignore this loop for now. Actually, let me just delete
Okay.
it straight up. Delete it because
Okay.
I want to explain it line by line.
All right.
Oops.
Let's go, Logan. Hey.
So here we go. Here is the line to draw a rectangle. So OpenCV allows you to draw a rectangle on any image. Very
Okay.
straightforward and simple. So it's just called dot rectangle. So OpenCV dot rectangle, and then it's like, okay, what rectangle of what size, what color, what thickness, and where do you want to draw that rectangle? So this is all these specifications here. And of course, we have
Okay.
that data within cars. So if we have the data in there, then we can just print it out here. Okay.
But where are you getting the
So-
X and the Y, though, is a question. Where's the X
Um,
and Y coming from?
From here. So we're gonna get that data out of here. So remember,
Okay.
remember we have these here. So this is
Yeah,
gonna
yeah.
be X, this is gonna be Y,
Y.
this is gonna be width, and this is gonna be height.
Ah,
for
I see.
both of these images. And then from there we can just X, Y, and then X plus width and Y plus height. And then this is the color. This is the color of the rectangle, and this is the thickness of the rectangle.
Oh, that makes so much sense now, guys. That's not so bad at all. Guys, do you get this?
Nope,
Like, drop it in
that's
the
it.
comment below. Do you get that? Like, it's actually not bad. You're simply drawing a rectangle with X, Y coordinates, and you're saying here's the height and here's the width. Like, that
Yep.
is pretty interesting, and it's actually not that bad to understand as well.
Not
You
at
can
all.
do it. Like, we can do it. You can do it too. Trust me.
If they watch the face detection stuff, this is very similar.
Yeah,
They're probably breezing
yeah.
through this right now, just watching us bicker, which is awesome.
Exactly.
But that one was with Kazi, you know, so it's a little bit hard
Yeah,
to
yeah.
make fun of him than make fun of
Yeah.
Nas, you know.
Yeah.
He's more of a challenge. Anyways, so let's just actually prove that this is working. So we're gonna want to unpack this. So in cars, it was actually an array, right? So there's an
Okay.
array here,
Mhm.
and then within the array, there's two arrays within the array. So let's just grab out these two arrays, okay?
Okay.
So this is gonna be array at index 0, and this is gonna be
Okay.
array at index 1, okay? Because there's
Okay.
two elements in this array, and then there's a list of numbers in there.
Okay.
So all we're gonna want to do is say, I guess cars at 0. So this would be car 1, okay?
Okay. And the
Equals
why
that.
car
So
0?
let's-
Why
let's
car
just
0?
Let's just ignore the ignore the second car for now, okay?
Okay.
So
Okay.
car 1 equals car 0. So
Okay.
if we print out car 1, just like that. Let's go here, run it again. As you can see, we have just the first car. So 375, 375. That's what we're looking for. And from there, we just want to get the x, y, width, and height. So what we're going to say is we're going to unpack this. I'm going to unpack this list here and say this is x, this is y, this is width, and this is height. Okay?
Okay, seems
so we can do that
guys,
simply
you're still
by-
with us, guys? Guys, give us a thumbs up if you're still with us. This is kind of like it's all coming together. It is honestly not that difficult. Give us a thumbs up if you're still with us. And Aaron, let's go ahead and start seeing, the result of all this.
Hell yeah. So all we're doing here is we're unpacking this. Okay, so car 1 again is these 4 numbers, and we just want to pack these 4 numbers into these 4 variables: x, y,
Okay.
width, and height.
Okay.
Okay, and then from here, now this code should work. So x and y is the top left point.
Okay.
Okay, we have the image you want to put it on, the color image, not the black and white image. We want to color on the color image, and then put the top left point x, y, and then the bottom right point, which is going to be x plus width and y plus height. Okay, that's how the math works. And then from there, this is just going to be should be red color. So BGR, remember, instead of RGB. So blue is 0. Green is 0, but red is maximum. 255 is the highest value you can have.
So we're creating a red rectangle, basically. That's it.
Yeah, a red rectangle of thickness 2
Okay.
pixels thick.
Got it.
On this image, at this top left point and this bottom right point. That's all
Got
it
it.
is, because that's all a
Got it.
rectangle is 2 points.
Makes sense.
And then you just put the rectangle between those 2 points.
Okay.
So let's run this and see what the heck happens.
Guys,
Actually,
ready?
nothing's gonna happen.
No,
once I
come
click.
on, man! I'm so
Because-
excited, man. Aaron, you
we're-
gotta. The way you bring the excitement.
Bro, shut up. Oh my god.
I'm done with this. I'm done with this, guys. I'm done. That's it. Hold on.
So we drew it on the color image, not on the black and white image, but we're still displaying the black and white image. So let's just display the color image, which has the rectangle drawn on it now. Okay, so now it should work. So again,
Guys, ready?
arrow. And
ready?
enter. And
Hey, let's go!
got here. So
We
this
got an air
square-
horn.
This
Hey.
pew, 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 pew.
Do you actually hear that? Do you actually hear that?
10,
Pew pew
10
pew.
hours for that. That's it.
Hold
Holy
on.
crap.
I got the perfect gift for it. Look at that. Oh, look at that. Oh, look at that. You don't see it, Aaron, but trust me, when
I
you
mean,
see
I
it, it's
can't do the
hilarious.
stream. I'm looking at my code, yo, but I'm pretty sure you're making fun of me or something.
I'm making very much fun of Aaron, guys. Give Aaron a thumbs up in the comments, guys. This is so epic. Look at this. We just detected a 1 car. Like, how crazy is that? With how many lines of code?
Directly in front of you. I don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines of code.
14 lines of code, guys. Like
13, bro. Learn to count. Holy shit.
Man, you count, okay? You learn how to count, okay? I count fine.
13 plus 1, 15 minus 1.
Alrighty, guys. Yeah, that's just epic stuff. So, okay, we got 1 rectangle. Now, my question is, how do we get the second rectangle? If you guys know how to do that, drop that in the comments below. And a lot of you guys are like, whoa, let's go. We got Abdullah in the house. We got Harsha. Like, yeah. We got Logan. Whoa. We got, oh man, you guys are pumped for this. Look at that. You guys are pumped. I love it.
If you
I
guys
love
are
it.
liking this, when this stream is done, definitely go check out the face detection too, because it's similar, but it's a different application and it's pretty damn cool.
Yeah. Sweet.
But
All
this
right,
one's for car and pedestrians.
All right, so let's see how do we go ahead and actually like get
In the second car?
Yeah.
Okay, cool. Well, first of all, why don't we just change this, because this is a very easy change. We're currently looking at the first car. Why don't we just get the second car instead by changing? So here, instead of grabbing this first car, we just grab the second car, and let's just draw the rectangle around that. So we simply do that by just changing this to grab the second car instead of the first car. So second car, right? And let's change this to 2 just to be clean about it. And that there should just change all of this to the second car instead, and we'll display it to the screen. So let's just run it.
Let's see it. Ready?
And
Hey!
boom!
Boom!
Hey! Pew, pew, pew. I can't.
You say it, and then I play it.
Annoyed with us, bro. We're going pretty slow. But
It's actually funny.
yeah.
Bro, I'm not kidding. Abdullah is like in the comments. Abdullah's like, damn, Aaron and Nas seem like siblings fighting.
Yeah, pretty much. I mean, like we spend pretty much every day together working on stuff all the time, coding. Like we practically live together. It's kind of annoying. You know?
Yeah, I know. I'm annoyed
We
with
all
this
know
guy.
each
That's
other.
it. Yeah, I'm annoyed with this guy.
I hate everybody.
Too much.
But I love
Too much. But anyways, let's continue on. We're here to learn, right? Let's go.
Yeah.
Yeah.
So that's the second car, and like I said, in this image, this trained classifier is only good enough to like identify full-on cars from the back like this. These half cars, you can't actually get them, but actually, if you trained something to detect half cars, like the right half of a car or the left half of a car, you could actually find a way to detect all of these as well. But you'd have to train it even further.
Yeah.
And so on, or like the bottom half of a car, something's being. But right now, like this pattern is what we're checking, is a full back of a car.
Right.
Okay.
Right. True.
So now the point is, all we want to do is, instead of manually going through the array like this, we just want to loop through all of them and draw every rectangle on the image for every car that we find. Okay. So that's what I had before. I'm just gonna have a loop, and this is gonna make it super simple. So let's just start from scratch. I'm leaving this here for reference, but just pretend we deleted all this, okay? So what we're gonna want to do is, just like in cars, so in cars, which is an array of arrays, we want to, an array of arrays, we want to iterate through every subarray. So we want to iterate through this first one and the second one and the third and fourth and fifth if there's any of those. So basically we're saying, in cars, you want to take out the XY and the width and the height of every list in there. So actually, I think if I copy and paste this, it'll be a little bit clearer.
Yeah.
So
and I think sorry, let's cut you off. So one important thing, guys, to mention. One important thing, guys, to mention is the way that this works. The way the whole X, Y, W, H, right? This right here is interpolation. Like interpolation, or there's a special name for it. Where basically it will take the object that's in cars, right? It will loop for that, and it will basically grab the X, Y, the width and the height out of those numbers, right? So it will abstract those numbers from those different places. And so that is actually in Python, right? I'm not sure it's called interpolation, what it is.
I don't know, bro, but you're getting super confusing, but keep going.
No, but it's important because they're like, okay, where's this X, Y, W, H coming from, right? But because here's the thing, it's looping through one single object, so that maybe I can do like a screen brush. Hold on, show screen brush. If I can do it, I'm not sure if I can. So right there, right? So this is the first object, right? So this first object is going to be on here, right, in here, and it's going to map to the X to here, the Y to here, the W to here, and the H to here. And you don't see it, but I'm drawing basically on your screen. So So that's the really cool part about Python, and JavaScript actually does this too. But I just want to explain that and so that you guys know. But anyways, let's keep going.
Awesome. Yeah, I have the stream up on my phone. Looks like it's still live.
Yeah, we're good.
We're in the bottom right. That's
we
cool,
got
man.
300 people in the house,
so
yo.
Wait,
we got 300
which
people.
way? Are you that way? Can I punch you?
What? wait.
I think I can.
Wait. There we go. Go. There you go. Hold on. Hold on. Ready?
Punch him.
Hold on. No.
Beat him up. So who would win?
Man, I wish we could like I wish it's like real, Maybe it can punch you. Yeah, that'd be good.
And then, man, you want to get in the cage, bro?
Let's go, man. I'm ready, man. I'm ready.
Have you seen the Fight Club? Have you seen Warrior with Tom Hardy?
Steve is like, please punch him. Wait, punch who? Punch who is the question?
Punch each other. Bro, they want to see us in a ring. It's like Logan Paul and the KSI.
Guys,
let's
who wants to see a live call? Who wants to see a live call like that?
Or Conor McGregor and Mayweather. We can do it like that.
Yeah. But let's keep going. We're here to let's keep going, bro.
Yeah. Anyway, so this is like the longest explanation of a loop ever.
Yep.
But screw it. We're having fun, you guys. I mean, we're having fun. So we're gonna loop over all of these, and then within each of these, we're just gonna unpack the X, Y, W, and H. Okay. So that's all that's happening there. And once we have X, Y, W, and H, we just want to draw all of those rectangles on the screen. We can get rid of this hard-coded. So we're gonna iterate through every pair of coordinates in that list we're gonna get all of them, and then it's just the same exact line of code here. We're just gonna draw every rectangle on the screen. But actually, what I want to do is, screw it. That's fine.
What?
Nothing. There was a little flavor styling thing I was gonna do, but I'll do it later.
Let's just
Right here,
okay.
this should work. So if we run this will actually loop through both cars and draw both rectangles, both squares. So why don't we just save this and give this a run? But this spin. So we just give this a run, up arrow, and hit enter, and ta-da!
Boom!
We looped over both squares.
Oh,
and
shit!
Just like the upper left-hand point, then we know the width and the height. And then we with the width and the height and this point, we can calculate this point. So it's just boom, boom, red,
Guys.
2 pixel width, boom, boom, red, 2 pixel width, and
Damn.
that's it. And
That's
then
it,
for
guys.
video,
Uh-huh.
yeah, that's it. And then for video,
Guys.
you just want to do this for every single frame of a video, over and
Damn,
over and over.
guys, if we just did this for a picture, guys, who's pumped to see this for a video? Drop that in the comment below. Aaron, are you ready? Are you ready to show this in the video? Because that'd be epic.
Oh, bro, I stayed up all night coding and I just come kind of like bored, you know. But
Hey,
nah, man,
let's
of
go.
course, I'm excited. Stuff is awesome. Like, I'm gonna send this video to Elon Musk and be like, adopt me, please. Like, like Big Bang Theory,
Yeah.
Howard or whatever. He wants.
Yeah.
Yeah, that's basic.
Or but pay me money. I just did this for you. You're welcome. You're welcome.
Yeah. But yeah, or maybe he'll hire me. Who knows? I mean,
Maybe
one day
Well,
I'll work at
I'm not
Tesla,
sure.
so-
I'm not sure about that. I don't know why you hired, but Aaron. But anyways, yeah.
Bro, I'll just be a comedian. I'll be a comedian and MMA fighter, like Joe Rogan, and then I'll have Elon Musk smoke weed on my podcast.
Oh man, Abdullah was like, I put all my bets on Nas. Thank you, Abdullah.
Oh, really? All his bets on Nas, bro. You want to slow down? I think Nas would be too scared to hit me. I think that's what would happen. Too scared.
Oh, not sure about that. I'm not sure about that.
Whatever.
Okay. All right, let's continue on. Let's see it.
Let's
go.
move on. So now that we have it done for one image, now
Okay.
it's as simple as getting it into a loop. Okay.
All right.
So I have that here. It's pretty simple to add it. The only difference is we have to read a video in instead of a video in instead of an image. So let's go up here and actually change that. So instead
Okay.
of image, it's going to be
A video.
video. Yeah,
Okay,
so let's just
interesting.
paste this. So I have a video on my desktop called Tesla Dashcam Accident. So this is
Okay.
actually real dashcam footage from a real Tesla that was running autopilot and avoided an accident. Okay, so let's just here, Tesla Dashcam Accident. Okay.
Okay. Okay, so, and this is just a video basically you got from somewhere, but like from YouTube, I think,
It's
right?
linked in the description. Yeah, it's in
Yeah,
the
yeah, yeah.
description.
Yeah,
It's
yeah,
an
gotcha,
information
gotcha.
Of, like self-driving
Cool.
Tesla. So as you can see,
Interesting.
this Tesla almost it like auto drove and like got out of the lane and safely did that. So we're gonna be detecting all these cars in this video. Okay, it's almost over. So that's it.
Sweet.
That's the car I have. I trimmed it to that little clip. But that's the first clip of the video in the description if you can go check it out.
Okay.
So that's the first thing. So instead of an image, we just wanted a video. Okay. And from there, so all a video is just a bunch of images. So we can just grab out each frame of this video and just apply the same thing as we did to this image to every frame, and then display the rectangles on every frame and just loop forever until the
Oh,
video
so
is done.
okay, so let's do that. Okay, so I'm really interested to see how this actually works out. Okay, cool.
Yeah. I'm gonna.
Hey,
Just
what's
copy
up,
paste.
Caesar? Caesar in the house. Hey,
Today.
what's up?
Why
Hey.
retype code but you can copy paste it, you know?
Oh
But,
yeah, that's the best way. It's best way to code, guys. Always just copy and paste. Don't ever create your own code. I'm kidding, by
Yeah.
the way. I'm kidding.
Nah, it's fine. So, yeah, I'm just taking a peek here. So yeah, we need a while loop and everything. So well, I'll type out this one because it's short. This is the
Go
first
ahead.
line of code I'm actually coding on the stream. I copy and pasted everything up to this point.
Okay.
Okay, but pretty much what we're gonna want to do is we're gonna want to have a while loop. Okay, not caps,
Mm-hmm.
supposed to be lowercase, and we just want it to run forever. Okay, because the video might be, if you're driving a car, you don't know how long the video is gonna be, like a real self-driving car. So you just want it to run forever. And then at some point when the car is turned off or like it reaches its destination, you could be like, okay, turn this to false, and then it'll stop reading. It'll stop reading stuff from the camera. So this is just gonna run forever. So that's the first step. Now within here, we want to run this same logic on every frame. So again, we had an image here, but instead of an image, we want to get a frame from the video. So we're actually not going to read an image. We're going to be reading a frame from a video. And that's what this thing here is. So let's just copy and paste this. Okay.
Okay.
Let's make sure it's indented properly. So the way we do that is, okay, run forever until car stops or something, or crashes.
Okay.
Yeah. Yeah, there we go.
Until
So
crashes.
this is,
Until what? The car crashes?
no, I don't want to get sued by Tesla.
Oh man.
But yeah, so there's in OpenCV, once we have the video here, okay, we have it's called video capture. So OpenCV2.video capture and the name of the file. Then we can just run this, and we can just run read. So all this will do is it'll read one frame from the video.
Okay, and that's a function part of it's a function part of CV.
It's dot
Okay.
read.
Interesting. Okay.
So
okay.
once you have
got it.
a video capture object here called video, then you can call dot read on that video capture object, which is just the video.
Dope.
So you're just gonna read. You're gonna read a single frame from this video.
Okay.
And then once it reads a single frame, it keeps track of it. So when you call this a second time, it gets the second frame. When you call this a third time, it gets the third frame. Again,
got it.
through all the frames, and that's how this is implemented.
Cool.
And what it returns is it actually returns two values. So the first value is if the read was successful or not. might be actually keep this in parentheses.
Yeah.
If the read was successful or not, and then the second value is if the frame is the actual frame. So like this frame is actually the image, which is just going to be the same as this. So this frame here is actually what we want. Instead of using image and reading an image in, we're reading a frame from this video.
Got it.
So we got the frame here. And then this here is if the frame was read successfully. So we definitely want to have good code and make sure that there wasn't errors before we try to display it.
Yeah.
Okay.
And the way I see it is like this video.read basically returns an array, which we simply basically map the first portion.
Not an array. So
no.
When you call
a tuple, it's called. No, it's a tuple, right? It's a tuple. Yeah, a tuple. A tuple. It returns a tuple until we map the first. The first. Yeah. Okay. Fine. Because it's tuple. Because we map the first part of the tuple to here, and then the second part of the tuple is gonna map to here. Now we don't actually see this, but in the background, that's actually what happens. So I just want to make sure that you guys understand this. But yeah. Anyways, let's keep going.
It's the same thing as here. We're unlacting a forple here. I mean, it's just a four variable tuple.
A fourple. I can't even say that.
100 pool. So we're unpacking these four variables out of this array. Same thing. We're unpacking these two values out of this array.
Okay.
And this array is a frame, which is itself an array. It's an image, and then this is a Boolean yes or no.
Yo, Kazi's in the house. Yo, what's up? All right, keep going.
What's up, Kazi? All right, so next, what you want to do is, of course, I'll just type this one out. What you want to do is you only want to handle this frame if it was successful. So you want to make sure you're checking. So here, we'll call this safe coding. Use protection, you guys. Safe coding. So we only want to continue if the read was successful. I mean, there was a little option on the live stream. It's like, is this video made for kids? I was like, no. I turned that option on hard. So if there's any kids here, you're just not supposed to be here. Okay, you're supposed to
it's okay. You can still learn. You can still learn. It's fine.
But yeah. So here, if read is successful, then you want to operate on this frame. Okay, so I'm just gonna copy paste the rest because I'm lazy.
Okay.
So so if the read was successful, only then do you want to continue. So then at that point we'll get the frame, which is here, and then we'll convert it to grayscale. Okay.
Interesting. Okay,
because if the frame didn't read correctly, if this returns false because the frame is broken, you can't actually call this. This next step is this needs to be a valid frame for it to be converted to grayscale. So if this is an invalid frame because the read screwed up, then you just want to skip this and just break out of the loop. Okay.
All right. But when would it ever be a non-invalid frame?
When the last frame of a video, it'll automatically end the video by itself automatically.
Okay.
Or
Gotcha. Okay.
if you error out, or if you manually say, "Hey, stop this video."
Yeah. But wait,
So
guys,
there's
we're completely kidding about the kids thing. If you're a kid, it's okay to say. A lot of you guys like, oh my kid, I'm a kid, and I'm a kid, I'm a kid, I'm a kid. You know, I'm like, guys, it's okay. We're completely joking about this stuff, guys.
I mean, it's already far gone at this point. Like, if
Yeah.
welcome, kids. Welcome to Willy Wonka's Chocolate Factory.
Oh God. All right, let's continue.
Um,
Oh man.
my mom.
So where we at?
Yes, it's gonna break out. So once we have the grayscale frame here, the same idea of an image and black and white, we can actually change this to black. I'll just keep it grayscaled. That's the proper term instead of black and white. And then we have a grayscaled frame from here. Okay.
Okay.
And why don't we just display that? So
Okay, let's see it.
actually, let's comment all of this out, because it's gonna break something. Okay.
Okay.
And then let's just, this is not going to do anything because it's not displaying anything, so we do need the display code again. Okay, remember the display code, we want to display the current frame. In this case, it'll be grayscaled frame instead of image. Okay, instead of image, it'll be grayscaled frame. And it'll only get here if the frame was successful. Remember that, you guys, because else we break out of this while loop, and then we don't even get to this code. So it avoids the errors.
Let me ask you a question. We have Logan actually asked a question. Would it be better would it be better to only would it be better to only use every other frame for speed?
Yeah, you could do that too. Of course, you'd have a little bit lowered quality. You could even lower the resolution of each frame to go even faster, because the resolution of an image is halved, like if this was kind of blurry, you as a human could still tell this is a car. If it was super blurry, you could probably still tell it's kind of like a car. You could kind of make it out. You're like, okay, this is a highway and a car. So there's many things you can do to speed it up. You can downscale it. Actually, I'll touch on that quick. If you go to detect multiscale, that's what scale factor is. Actually be like, okay, blur this image a little bit to make it faster. You can like increase the factor.
Oh, interesting. Okay, that was good. I think that was a good question.
Yeah, like if you have 4K footage, it's going to be kind of like really hard to run all the algorithms. But if you scale it down to like, scale 4K down to like 360 pixels, 360p or 480p, it'll be a lot faster, and it might still work. So you can,
and that's probably what Tesla does as well, right? Because they probably scale down the image so that they can process it much faster, right? Because you can't process like a 4K image, right? Yeah.
There's some trade-off between having accuracy with high resolution images and also speed, because when you're driving a real car, you need to have real-time feedback. So they go as high as the accuracy can be, while keeping it real time, because speed and accuracy are both important. It's like, oh, this car is gonna hit me, and then 2 hours later, you don't turn. You know, you're still they're gonna hit you.
Yeah.
You gotta turn like
too late.
this video. Yeah, just like this video playing, like this guy crashing before. Remember, like Tesla here, it sees this, and as soon as he comes over, he's instant.
So it's quick. It's quick. It's really quick.
Yeah, it's like instantaneous. So there's the trade-off of accuracy and speed there.
Yeah. Okay. Cool. Sweet.
Moving on. So from here, we're going to display the grayscaled frame, and then of course you need to have this, because this will just display for a split second then disappear. So we want it to stay on the frame, the current frame, and this actually tells us stay on the frame for 1 second or 1 millisecond or something like that.
Okay.
And then it'll loop up and show the second frame. It'll read the frame. It will, if it's successful, it'll turn it gray, and then it'll display it, the grayscaled frame, and then it'll wait a second, 1 millisecond, and repeat. And it'll do this for every single frame.
And so this is basically you're not creating a video.
No,
okay.
I am creating a video.
Okay, you are.
So this is going to be a black and white version of that same video.
Got it.
The video that
okay. I get it. Okay.
You know what blue is, Nas? You know what blue is, right?
No, I don't know what blue is. Is it red?
All right. Why do you have to kill every joke, bro? Like, it turns unfunny when you say it. Anyways.
Hey, I'm laughing. Boom. Hey, look at that. Oh, this is like it's like sped up. Why is it so sped up?
Because we changed it to grayscale, so it can compute it faster.
Oh.
See how that?
Okay. Interesting.
Yep. So it's going faster, and this is the whole video. The video is going, and then when the video ends, it automatically closes.
Guys, do you understand? Like, and drop in the comments below. Do you understand how it is even like displaying that specific video, right? Because I mean, look, like, drop in the comments below if you understand like the way this is working, right? The way I understand it personally, is literally, right. If we have the way I see it is like, yes, we have a video, right? We have a video right here, and what we literally do after that point is we unpack the video and we go through frame by frame, and then we output that frame again to create yet another basically video. It's just that this time we added the video simply because we changed it to grayscale. So every single frame, as you guys know, every video, right, is created with frames, right? What we do is literally take that frame, we convert it to grayscale, and then we show it again. And again, you went from video to another video, except this time it is grayscale. So I just thought it was really interesting. If you know what I'm talking about, like, drop it in the comments below, because that's mind blowing to me, you know?
Yeah, what he said.
Yeah, what I said.
What Nas said. All right, guys. So we have the grayscaled images here in a loop, and it's properly looping through every frame of the video. Now all we need to do is run the detection code again, and then from there, once we have the detection code, we can draw the rectangles again on the colored image and then display the colored image, the colored frame, instead of the grayscale frame. And
Interesting.
that pretty much does it. And then at that point, we also want to introduce pedestrians and use different kinds of videos with both and mix them together. But that's the last step. So let's go with that next. So the next thing is, once we have our grayscaled frame, we want to run the car classifier on it. Remember, we have our oh, I don't even have it. It's I deleted it, didn't I?
What?
Car tracker. So let's get this back. Okay. So let's get our car classifier back and paste it up here. Once we have the classifier file, then you want to feed that into Cascade Classifier, and we have a car tracker now. So this is the pre-trained data that we downloaded from this file.
Okay.
Now with this car tracker, we can do the same thing. We can just go down here and copy paste the code because laziness. And detect cars.
Especially for Aaron.
I mean, copy and paste as much as you can, because what's the point of typing it out? Like, you wanna tackle bigger and bigger problems. This saves time. You know, this is literally cutting the stream length in half, and we can fill it up with jokes.
Yeah. Okay.
So now we want to detect all of the cars in this current frame. So again, we have our car tracker up here, auto highlights for us, and then again we want to detect all of our cars, regardless of the scale of the car match. And then what we're feeding in is the grayscaled frame, okay? Because this is the current frame in black and white, and black and white is much faster.
Okay. So, and if you just so you know, guys, like when we say frame, a frame is simply, hold on, let me show you. A frame is simply just a still image. It's just a image from the video, right? That's why it's able to detect the car. So it's not actually moving. It's just one image. Right, that's the interesting part about it, right? We took the image out, so yeah, let's keep going, and that's how we were able to detect, right, detect those cars in there.
Hell yeah, what he said.
Yeah, what I said.
What he said.
Hey, no, not hitting me. Let's take it outside, okay? We'll take it outside next
when
time.
Are you getting back to LA? After this Corona thing's done, I'm back in LA in September.
Are you kidding me, man?
September?
Guys. Man, this is gonna be a live stream, okay?
I'll cough on you, bro.
What? That's not gonna do anything to me. You can cough at your own pace. Cough at your own plows, you know. Don't cough here. Don't cough in LA.
This is the stupidest stream ever, but whatever.
Oh man,
we made like $2, right? Like, people have donated to us.
I know. We made €2.
Make one more dollar, bro. We can go get coffee. You can get the $1 coffee from McDonald's.
Hey, let's go. Let's go.
Anyway, so yeah, we have the cars here. And again, remember, this is an array of a bunch of different coordinates of the cars. So why don't we actually print that out? So let's print out cars. And each time, for each frame, you're going to see a bunch of different stuff print out. Because every frame, there's multiple cars. So you're going to see a bunch of stuff print out in the terminal forever, because it's a loop. So let's actually run this, okay? And as you can see, we have all the cars detected in each frame. We just haven't drawn them on the video yet. But you can see them all getting spit out here. You know, top left point, bottom right point, the width, and the height.
That's insane.
The width and the height is always the same.
That's insane.
By default. And then
you can see some of them, and you can see some of them don't even have a car.
Yeah, they don't have cars. So I read correctly, but there is no car in that frame, and it just skips it. And then once it gets to the end, this when there's no frames left, this actually becomes false because it can't read anymore. So this actually does error out. So it actually does get to this break statement on the last frame of the video, and that's what you're seeing here.
Gotcha.
The last frame happens, and then it gets to the code completed. Remember?
Got it.
That's why it's good to have this because you can see.
Got it.
Little error there. Dope. So now last step is just drawing the rectangles on the colored image, just the same as with the image. Okay, so pretty simple. We don't need print cars anymore. And of course, on the copy paste master.
Of course.
Go to yeah, this one, right? I think so. Rectangles. There we go. So pretty much this should work now. Only error is that this image is not an image. It should be actually frame. It should not be image because we're not doing images anymore. We're doing frames. So we just pop frame in there. So it'll iterate over every single car it finds in each frame, and then it'll just draw a rectangle around that car on that current frame. Again, with a red color and a 2 thickness.
Got it.
So let's just run this and see what happens. Let's run this baby.
You guys ready? Are you guys ready for this? You guys ready? All right, let's see what happens. Actually, okay. Okay. Oh, dang.
It is not working, and
oh no! Oh man! Oh no! Oh no bueno! This is not good. No good.
Let's
No
clear
good.
this.
No good. No good. Guys. This is
Reason
not
being
bueno.
is we are still displaying the grayscale image. We actually want to display the frame because we drew the rectangle on the frame. So
Okay.
little bug there. Actually,
Did you guys see that? Did you guys get that? Did you guys get that? I hope you did.
Yeah, because it was black and like when I ran it, I'll run it again.
Okay.
Oops. It was. Oh, okay. So now it's working.
Oh, hold on. You guys, are you guys ready? You guys ready? You ready for this?
Oh, no,
you ready for this?
It's black and white.
No, come on.
Because when I ran it, yep, still black and white. Okay, because it says grayscaled frame here. But if we're displaying the colored frame, which has the squares drawn on it, then I can save this and display the frame. So let's go back here.
This is normal frames right now.
Cancel this. Clear again.
Okay.
Now we're displaying the colored image with the rectangles drawn on each frame over and over and over again. Okay.
Gotcha.
This is within the while loop because you want to make sure you're drawing.
All right, you ready? Ready? Hey, let's go!
So it's not perfect, but I mean, hey, it's not random. You can tell that it's more correct than it is incorrect. Like it's not just random squares all over the image. It's pretty damn accurate. Like we think about it, this is like 80% accuracy. That's not nearly good enough for like real world scenarios in cars, but we're 80% there.
Bro, that is insane. This is some magic, guys. Seriously, like this is some magical stuff. Like how pumped are you to see this or to even build something like this? Especially the fact that we just built this. Like, guys, we literally just built this in like what? In how many? In what? I mean, an hour and a half, 2 hours maybe. Holy shit!
I mean,
holy
it's like,
shit!
Not the code, bro. Chill out.
Guys, I only have one gift to show how I think we feel like right now. Are you ready? Ready to see this? I'm sorry, Aaron, you don't see this, but they will see this. So only one way. Only this way. Oh yeah. Peace out, guys. This is how we do it.
All right, let me check this.
Drop in the comments, guys, for some. You'll see it. There's gonna be a small delay, but that's all right.
Holy. Who is that? Just some random.
Just some random.
Random girl in the crowd. That's funny, bro.
Oh man, this is hilarious. Logan's like, this is awesome. Belly, this is epic. We got Logan. Wow.
I mean, we haven't even gone to pedestrians yet. How do we detect pedestrians and cars in the same
video? Oh wait,
video?
so we haven't got to pedestrians yet?
Nah, bro. We haven't even touched that yet. We still got to download that classifier and get that running, and we have to scan across every frame for both of them, so that we can detect pedestrians and cars.
Okay.
And you could also train it for anything. Like you could train it to detect NOS, in videos and stuff if you wanted to.
That's important.
But,
detecting NOS.
I mean, who would want to do that?
What? What are you talking about? Who wanted everybody?
Okay, yeah, guys. But what I'm gonna do is I also want to show you some other videos. So I actually have a bunch here.
Okay, let's see it.
I have a couple other videos that I pulled out from YouTube. This is all from the same video linked in the description. There's like,
Okay.
it's like within the first 3 or 4 minutes, all 3 of these clips are in that video. I skipped some of them because it was like dark and rainy and it wasn't performing that well. But I mean, this is pretty good performance for stuff you downloaded off the internet. Of course, if
This
you
is
trained
epic.
your own hardcat classifier extensively and you let it run for like 3 weeks and you trained
Yeah.
it, then that have really, really, really good results. But these are just ones I just downloaded off the internet. Like I said, like the car data set, this was created by people at Caltech, the California Institute of Technology. But these cars all look old, so this must have been done in the freaking 80s, you know? So like this is old data that we're using, but they did use this to train their heart cascade. But we could
That's
go out
cool,
and
that's
take our
cool.
own thousands of images, but I mean, I'm not gonna do that. Sorry, guys.
Okay, yeah. That's too much work. That's too much work.
Not
Why
gonna-
why redefine the wheel when it's already defined for you? You know.
Yeah, and, you know, it's like use a library because it exists. But I
Hey,
mean,
we
Tesla-
got Robin donated 100. I don't know what mine that. I don't know what mine that is. 100 not euro something. I don't know how much mine that is. It's like Robin. Yeah. Anyways, 100 something. Thank you, Robin. Appreciate it.
appreciate what was his name? Robin.
Robin. Yeah.
Appreciate that, Robin.
Yep.
Appreciate that. Now, let's continue on. So the next step would be, oh yeah, I was gonna show the other videos. So let's
Okay.
just change up this video. So this
Okay.
one is actually one where, the Tesla self-driving car actually detected and avoided a tumbleweed. So it was a huge thing on the road, and it
Interesting.
actually avoids it. So let's run this footage. So this happens
Wow.
here.
Okay.
It's running in color, and then boom,
Okay.
tumbleweed,
Where?
and it just dodges it. Bro, you missed it.
Oh, I missed it. Oh man. Oh, there it is.
Right
There it
here.
is. Oh,
Slow
dang.
motion. So
That
it
is
detects it.
insane.
Yeah, and in an actual video, the guy's talking, and then somebody behind him actually hits it. So I don't know, but hopefully they're okay. But it's just a tumbleweed. It'll damage your car, but unless they swerve, that might cause an accident. But if they just hit it, it should be fine, I hope. And yep. So that's another video from that clip. And then
Okay,
here's another
okay.
one. I just pulled this off like randomly off the internet. I just did Tesla
Okay.
dash cam
Okay.
footage, and I just found this video. And then
Okay.
here, this last one is some highway footage, also from that same clip. So feel free to go watch that same clip. And
That's
Here
insane.
you go.
Damn. Guys, how cool
Yeah.
is that? Like, how
Pretty
cool
cool.
is that? The fact that we just created a system that, you know, I mean, I would say Tesla-like. I mean, I would say it's not perfect, right? But the
Yeah.
gist of it, and that now you understand kind of how it works.
Oh,
That
the not
to me
perfect
is.
thing, I want to point that out. See how this is constantly saying it's
Yeah.
a car? Because think
Yeah.
about that. There's the dark window, the light bumper, the dark
Yeah.
shadow. So it keeps
Yeah.
mistaking this for a car because it has that same profile. Remember, the car
Yeah.
feature of light and dark, dark and light, and then light and dark. Remember
Yeah.
from here.
Yeah.
So
yeah.
this matches these things. This thing kind of looks like this because there's a dark window, a light bumper, and a dark shadow underneath the car. See,
Yeah,
dark
yeah.
window, light bumper, and a shadow underneath the car.
Got it.
So
got
that's
it,
why
got it.
it's misclassifying this. It's a
Right,
false
so-
positive.
That's why it's
here.
not a perfect system, right? It needs a
Yeah,
lot more
it's not.
classification basically for this.
Yeah. I mean, if you ran it super extensively, you could detect every single car in the single image perfectly, but it would take
Yeah.
forever to run. It wouldn't be running that
Got
fast.
it. That makes sense. That makes sense.
Uh-huh.
Okay. Cool.
And so that's it. So these clips are in the description. You're gonna have to download the YouTube video yourself, and then trim out the clips. But you can definitely do that, and then just name it whatever you want. It's an MP4 file, so make sure you download the video.
Got it.
And-
Got it.
That's really it. So I had those three examples. Oh,
Okay.
one thing I did forget to show is nah, that's okay. It's too late.
No,
I
it's
already
fine.
showed them with the image thing.
Yeah.
With that video.
So what should we do now? So what's the next step, Aaron?
Well, why don't we detect this? The thing I started off with, the demo, where there's cars and pedestrians.
Okay.
How do we detect
All right.
both in the same video? I don't know if you guys can hear that, but yeah,
Okay.
there's audio going. But
Yeah.
this is the original footage I showed. So now we
Okay.
want to actually introduce pedestrians as well.
All right, let's
Okay?
do it, bro. We got cars. Next thing is pedestrians. Then we got cats and dogs. No, I'm kidding. We're just gonna do pedestrians, I think.
Yeah, pedestrians.
So yeah, who's
I
pumped
mean,
to
we
see?
could do cats and dogs next time, but I mean, I think self-driving cars is cooler.
Yeah. Maybe next time. But yeah, if you're pumped to see that, let's get into it. Actually, drop it in the comments
All right.
below too. Drop it in the comments below.
Yeah. So what we're going to want to do is we are going to want to actually download another classifier. Okay.
Okay.
So we have a car classifier, and that's what's doing all the work for our car classifier. But we're also going to want a classifier for pedestrians and have both of them running. Okay.
Okay.
So how we do that is we're just simply going to download another pedestrian classifier. So again, the link is in the description. This one is actually supplied to us from OpenCV by default. There's a har cascade file, XML file again, called har cascade full body right here on my desktop. Open this up. So it's the same exact thing. Again, it has all these crazy numbers, and it goes on for thousands and thousands of har features, and it filters through all of it. But this series of har features kind of matches up with what a pedestrian would look like, whether they're standing or walking or running or whatever, or even like on a scooter. It would still be able to detect it. Okay.
Yeah.
So a bunch. You can see it goes on forever, and it takes forever to train this and actually generate these correct numbers, just capturing the relationship and the patterns.
Avil is like, wow, this is amazing. Wow. Oh, Robin just donated another 200. I think it's called V dollars. I don't know what it's called, but another 200. Dang.
I don't know what $V are, but it sounds like a lot. Thank you, Robin. Appreciate that.
Appreciate it. Oh wait, well, no, actually, he asked a question. Actually, his question was, and I can't put it up on the screen because I don't have it. For example, for some reason it didn't actually show up on Ecamm. But his question was, if a different IDE is used, will speed and accuracy get impacted in output?
A different IDE?
Yeah.
No.
No.
Reason being is this IDE is just a code editor. It just makes the colors nice. It makes strings orange. It makes comments green. It does all that nice stuff. But when you're running code from the terminal, it's literally just getting this raw text file, this raw Python file, which is just a text file that has Python code in it. And then it runs that Python code. So like I could even open up this Python code. I could open it in text edit. Okay.
Got it.
This is the code we're running in VS Code. So it doesn't matter what you're using to edit it. It's just running this raw text code. It's just translating this to ones and zeros that the computer understands. So actually what's running all that stuff is literally just this text file. This text file is generating all of this tracking. So it's reading the file name, getting all the stuff. It's making the classifier. I mean, you kind of can't see, but like...
Yeah. So to answer your question quickly, no, it will not, Biscuit. It will not matter. It will not impact any processing or anything like that.
At all. Zero.
Yeah.
Zero.
Sweet.
And so let's just move on to pedestrians, okay? So let's just move on to pedestrians, okay? So I have a video here, a dashcam of dashcam pedestrians, which is this video of a lot of pedestrians here. There's not so many cars because I want to show this first.
Okay.
And what we're going to have to do is we're going to have to actually get the pedestrian classifier as well. So actually, let's just grab this and paste this here. So classifier file is car detector. Really, this should be called car tracker. So actually, let's change that. So it's only popping up here and here, but let's change this to car tracker. All right. Change this to car tracker. So now it's a little bit clear that this is a car tracker. And actually,
what? We have two different trackers, right? One is a car tracker, and then
I screwed it up a little bit. So we should actually this is car tracker down here. So this should be car tracker file. Oops. And this should be car tracker file. Okay. So ignore this stuff. Let me just delete it because it might be a little confusing. So let me ignore that for now. So what I did was I changed this name to car tracker file to be a little bit more descriptive with the name. And then again, we're just popping this car tracker file into here to get the class K classifier, which gives us our car tracker. Now let's repeat these two lines of code, but for pedestrians. Okay. So for us, it's going to be pedestrian tracker file equals this. Okay. So it's the same thing as this line, but here for pedestrians. Okay. We have a different XML file for cars, a different XML file for pedestrians. And let me just comment this again. And actually, I think it'll be better to keep these together. So our pre-trained car and pedestrian classifiers with an S. Okay, so we have both of them here. And now we can have our pedestrian tracker. So this would actually be this is where we actually, well, actually, I don't even have to do it. I can just copy and paste this here, the cascade classifier. Okay. So pedestrian track is going to be this. I'll just type it out this time. So CV2 and cascade classifier, and it auto completes for me. And then from here, then you want to get the pedestrian tracker file and paste that in here. So that should make sense. So we did it once for car file, car tracker. Now we have pedestrian file and pedestrian tracker. All right. So we have both. Now that we have both, all we want to do is detect both in every frame and draw rectangles around both in every frame. Very straightforward. So the thing we're going to want to do is, of course, for every frame, we want to run the loop. We want to read the frame. That doesn't change. But and then we change it to grayscale. Okay, that doesn't change either. Once we have the grayscale image, then we want to detect cars and pedestrians. Okay, see that? We're only detecting cars right now, but we want to detect cars and pedestrians. So that would be something like this. Okay, pedestrians equals pedestrian tracker. Okay, pedestrian tracker dot, again, detect multi-scale, because you want to detect pedestrians of all scales and all sizes. And we're just going to in the grayscale frame. So this is just exactly the same code as for cars. We're just using a different classifier, okay? Which means it's going to give us different coordinates, different squares of different whatchamacallit.
What do you mean? They have different squares, basically, different squares for like pedestrians and stuff like that. Oh yeah, I get it. Yeah.
So this is a list of cars, and this is a list of pedestrians. That's all it is.
Okay. Yeah.
Okay.
If you guys don't know, it's basically we got pedestrians, so we're detecting different pedestrians. We're using one classifier for pedestrians, right? And then we're using another classifier for cars, right? And that again is what that is detected through where? Through here. Well, I don't know if I can draw, but yeah, you can see one for car tracker and another one for pedestrian tracker. So that is really cool. Okay, all right, let's keep going.
Yeah. And once we have these, then we can just repeat the same exact process with the rectangles for drawing the pedestrians that we do for drawing the cars. So it's literally the same exact thing. I'm just going to draw the pedestrians in yellow instead of red. Okay. And that's really it. Okay.
That's it?
Yeah. That's
man.
it.
All right.
So I just copied and pasted it. The only difference is for cars, you want to iterate through all the cars again for those points. Then you want to draw on the current frame, the current color frame, top left point, bottom right, the top left point, the bottom right point, and make it red with thickness of 2. Now for the pedestrians, we want to, again, we can just reuse the same variables of X, Y, W, and H, because at this point we're done with them. So we can just overwrite them. X, Y, W, H. In pedestrians, so again, this is its own list of pedestrians. Then we want to draw a rectangle, again, on the colored frame, top left point, bottom right point. This time we want to do yellow, so this is the color for yellow. So if the green and the red are maxed out, it becomes yellow. I don't know how that works out.
And again, guys, it's not so much about like, red, green. Like we simply just pick those colors because why not? You just pick the random colors, right? But you can pick any color you want, right? That's those 0,
Sure.
22,
Like
55, and
white.
2. Yeah, this
That
would be
would be
completely
white.
white. So
If
you
everything's
can pretty
maxed.
much change it to anything you want.
Yeah. Unimportant detail. I mean, to be honest, on Tesla, when they're doing self-driving cars, they don't even bother drawing the rectangles around the car because from this point, they just know where the car is, and the car doesn't need to see it. I mean, the car already does see the other cars or the pedestrians with this data. It doesn't actually need to draw a rectangle. No, the rectangles are just for humans. So this
Logan in a live stream, man. Logan, appreciate your freaking energy, bro. Logan says like, I love this live stream. This is so much helpful. Much nicer way to expose myself to OpenCV with this than reading the commutation. Yeah.
Oh, hell yeah.
Yeah. Avel is like, Aaron, you're crushing it, buddy. Keep it up, bro. You're crushing it, bro. What?
You can watch our video and our jokes.
Let's just read this through the live stream. That's all we do. That's all we do. Just read the commutation.
Cascade classifier : detect multi-scale. Detects objects of different sizes in the input image. The detected objects are returned as a list of rectangles. I mean, this is exactly what we're saying, right? It's it sounds very nerdy. You detect objects in our case, cars and pedestrians of different sizes because it's multi-scale.
Okay.
And the
and
input
images.
image are frame.
Yeah.
The detected objects are returned as a list of rectangle points, and then we just draw them. So that's it.
All right, let's do it,
Okay,
man.
guys.
I'm so
So let's
excited to
give it
see
a
this.
shot.
Let's go, guys.
We're gonna see a bunch of pedestrians because the video we're using, okay, there's a bunch of pedestrians, but not very many cars. Like I think there's like one car here, but all these pedestrians will all get identified. Okay, so let's just go for it. All right. Wait, did I delete something?
Ready? What'd you delete?
Oh, I deleted the whole loop. Oops. I was like, wait, where did the code go? Yeah.
Did it not work?
Drawing. No, I didn't. I deleted a bunch of the code I just typed out, and then I didn't even run it yet, but I caught myself.
Okay,
So,
okay. All right.
Let's just do this nastiness.
All right.
And let's run the Python file. So car and pedestrian tracking.py. And boom.
Oh
As you can
shit!
see, it's doing
Oh
a decent job
damn!
of detecting the pedestrians.
Guys, holy
And-
moly! Hey, pew. Guys, this is a wow. Okay. Holy shit! Wait, okay, so this
do it
is
again.
just pedestrians right now. You guys ready? Check this out. How cool is that? How cool is that, guys? Drop that in the comment below. That is sweet. Oh man, that
Yeah,
is
man.
amazing.
All right. So
Wow. Is that it? That is that?
that's pretty much it. What I want to do is I want to add a little bit of flavor to something, and then
Alright.
add a couple other safekeeping things that we're gonna go
Okay.
over,
Alright,
and then
alright.
add a little bit of style, and then run it on some new videos, and then that'll conclude it. Pretty much. Pretty
That is
concise
my,
app.
that's
you know?
my face right there, guys. This right here is probably your face right now. I'm kidding. I'm not kidding. Like
What?
make that face right now, and as you're watching the video, make that face right now. You know the face I'm talking about.
Oh, like Cloudy with a chance of
man.
meatballs. I just thought
Cloudy-
pop up.
Is that okay? Yeah, exactly.
Come on, bro. Didn't you grow up when that came out? We were like 12 when it came out.
Hey, this is still an awesome movie, bro.
Yeah.
Who doesn't
It's
watch
an
that?
alright
Come on,
movie.
come
You
on,
know,
man.
Incredibles is better. Shrek
Come
is better.
on, man.
But
People are like, this is
yeah, so
fire.
what I want to do. Guys, what I want to do is, I don't know about you guys, but in the thumbnail of this live stream, I had like a little quirky styling thing where for the cars it was red and blue, and then for pedestrians
Okay.
it was just yellow. So I just want to chuck that in. So all I did was I'm just drawing 2 rectangles here instead, just for a little bit of flavor, and just pop
Okay.
that in. So I actually, for each car, I actually draw 2 rectangles, 1 red rectangle and 1 blue rectangle. So this is
And
the red.
what's the reason? What's the reason for that? I'm just curious. Just because you want to be fancy?
Yeah, I just want to be fancy, bro. Come on.
Okay, fine. I mean,
So all I did was I just drew a
Aaron
red
out here
rectangle
being
here with the red channel max, everything else closed, and the blue channel here, 255 and closed, but I offset it by 1 and 2 pixels a little bit so you can see it changing, This is completely useless code. It's just for a little bit of, front-end development. But when you run it, you can see, I mean, there's not that many cars here, but you can see
Yeah,
whenever
yeah.
a car one pops up, there's a little bit of blue as well as
oh
red. So
man.
a little bit of
Wait,
flavor.
put that image in the center. Put the video in the center.
Oh,
Oh, never mind. Just keep going. Never mind. Just keep going. You're fine. You're fine.
like that.
Guys, how cool is that? How cool is that?
Oh,
To got like okay, that makes me excited, bro. Honestly. All right. Shit. All right.
calm down. Calm down.
I love this
Alright,
AI
well,
stuff.
That
I
is
used to.
that.
I actually, guys. Actually, interestingly enough, I used to do AI stuff as well for a company, but we did AI. So interestingly enough, I'll just tell you a really quick story. I did AI for actually detecting signatures, detecting fake signatures. So we use a similar. We also used OpenCV as well, and we detected if signatures were fake or they were real. And we had, I'm not kidding, we had signatures from like thousands and thousands of like images, and we were able to detect like if the images was like real or not. By the way, I just want to let you know, Robin, seriously, holy moly, thanks again. He donated
more money?
400 V something. V
Thanks,
dollars?
Robin.
I don't even know. I don't know. Robin, you're the best. Thank you. Appreciate it. Always appreciating donations, Oh
Dang.
man. Yeah.
Hey, Robin's on
anyways.
fire.
Yeah, Robin's on fire. Robin's like, yo, let's go. We just hit the goal.
All right, we're almost done, you guys. Just a couple more things, and we can run on some extra videos, and then we can just let it run, and that'll complete the app, you guys.
Yeah.
So, last things I want to do are actually, when you're running the video, I want to be able to actually quit the window with a key. So I
right
pop
there,
this
guys.
little
There's
code
Robin donated right there. Appreciate it, bro. Right there. You guys can see it. Yeah. There we go. Hey. All right, let's continue on. By the way, I don't see you. Do I see you? No, I don't see you. Oh, there we go. There, now I see you. There you are now. There you go.
Am I good?
No, you're good. You're good. Keep going.
Okay, got it.
Yeah.
So here on the code, I'm just gonna copy and paste in a little housekeeping here. So if the Q key is pressed, Q for quit, then I want to break out of this loop, which means it'll abort the video stream like whenever you type that key. So the key for lowercase q and uppercase q are 81 and 113. You can look that up online. Every letter and every keyboard button has its own number, and you can just find it with a Google search. You just be like lowercase q and uppercase q, what are the numbers? You just put that in, and once you have these numbers, then if either of those are pressed, if key equals that or that, then it will just break out and we'll just stop.
Okay.
And the key is automatically whatever you press from wait key, because it's waiting for a key. You see what I mean? And so if it's waiting for a key and you press Q, automatically it goes to the next one, and then key becomes Q, and it'll match. And that's really it.
Cool.
Okay, last thing is you want to release the video capture. So
wait, what is the release? Why release what?
So video here. Our
Okay.
video is the video capture object that we got from our video file.
All right.
And it's constantly reading a file. Okay. And so video is constantly reading a file. So when we're done doing it, we just want to release reading of the file. So it's just
Got
like
it. So it's
you have a
like okay.
a stream of data coming in.
So basically, it's like stop. Basically, stop reading the file. You're good. That's what it's saying.
Yeah.
Okay.
It says we're done reading this file. Just release all resources from trying to read this file, so we're done. And that's really it's just a cleanup, like a memory management thing.
Yeah.
And that's really it, you guys.
Guys,
I don't think I
that's
missed
pretty
anything.
much it.
That's everything
That's
I
pretty
had
much
planned. We
That
can
it?
change this to
All right, let's see.
self-driving car.
All right,
There you go.
I'm excited to see some videos, bro. Let's do it.
Yeah, let's
do it.
go here and let's run it again. Your name
Guys
key
ready?
is not
You guys,
defined.
are you
Why
guys?
is key
Oh,
not defined?
what key? What key?
Oh, there is an
shit.
error here. It says key is not defined because
Do you
key
guys
here-
know what the key is? You guys know what the problem is? Drop in the comment below. You guys, huh? I think I know. I know what it is. Do you know, Aaron?
Yep. Of course I do not.
Are you sure you do? I'm not sure. I'm not so sure about that.
So, yeah, the problem is that this key variable doesn't actually exist, and the reason for that is we didn't actually set that equal to here. So this does wait for a key to be pressed, but it never captures that. So we got to capture it in key, and now when key is pressed, then it should work.
Okay.
So
Dope.
back here, let's just clear this out so it's nice and clean. Run it again, and there we go. So it's going.
Hey, okay.
And if
Sweet.
I press the Q key, it should quit.
Quit. Sweet. Okay. Cool.
Go.
All right. Damn, guys,
Yep,
this
that's
is
it. If
crazy. Guys, this is amazing. Holy shit. Like, we just created a system that detects pedestrians and cars within, an hour or 2 hours
Mm-hmm.
with some training data
That's it.
that we didn't even create.
No,
we just
no,
borrowed.
didn't.
We
didn't
borrowed.
create it. Yeah,
we borrowed.
but I mean,
Okay, we borrowed.
you can download all this off the internet. Like you can download XML files for anything.
Yeah.
You could probably download an XML file for a cat, for a dog,
Yeah.
for a water bottle, for a football, for anything. You can download. Somebody else, probably somewhere on the planet, has trained a hard cascade file for you somewhere and uploaded it somewhere. You can probably download it and you could probably use it and do a very similar thing depending on how well they trained it. And of course, you can train your own too if you want to go that route. I'm sure that exists on Google how to do that, but that's a much longer process. You have to find all your own data. Yeah.
Cool.
Your own images,
Sweet,
which takes
guys.
a while.
So let's keep viewing some more videos. What is we got?
Yeah, so we have a couple
Alright.
more.
All right.
So that was like a pedestrian heavy. Let's run it again. This was a very pedestrian heavy video. Okay. Lots of
Alright.
pedestrians.
So what do you
we
guys
wanna make
see?
sure-
What do you guys see? You guys see just a lot of pedestrians walking, right? And it's able to detect those systems. And if you think about it, right, what would a system do? Since you can now detect something, you basically can now tell a system, hey, You know, if you detected it, stop the car, or hey, you know, stop anything you want. So that's kind of why this stuff works really well. You know what I mean?
Yup. So let's just do this, okay? So another video file I have is dashcam cars and pedestrians because it has a little bit more mix of both. This is actually the video file that I showed you at the beginning, okay? So how long is this video?
All right. Okay.
Yeah,
so that's a different video.
It's like 4 minutes long.
All right.
So let's go. And let's just let it run. So this is the video I showed you at the beginning.
Oh, man, that's cool. Damn. Guys, give us some fire in the comments, guys. That is cool. All right. Look at this guy's walking. What is that? You see how it's able to detect the like little pothole at the bottom? I thought that was interesting.
Yeah, it's not perfect, but
yeah, of course.
It's better than nothing. Better than random. Much better than random. And there we go, you guys. If you can see, it looks a little bit slower because it's doing double compute power.
Yeah.
You see? So you can think about it for Tesla, like a real self-driving car. Think about it. It has to detect pedestrians. It has to detect cars. It has to detect signs, all different kinds of signs, speed limits, stop signs. Has to detect traffic lights. Has to detect different nighttime and daytime things. Has to detect rainy conditions and non-rainy conditions. It has to actually send those values to the car to brake or turn accordingly. There's so much going on. So this is just scraping the surface. This is pretty cool, but this is just the very, very surface of what's actually going on.
I mean, in general, honestly, it's like it's crazy, right? Because the amount of data that it has to process, right, in terms of pixels, right, in terms of how fast it has to do it as well, it's insane. But you can see I think, guys, what's really interesting. And hold on, actually, no, let's keep watching the video. As you guys can see, right, the really interesting part is like the fact that all we simply did is if we divide a problem, right, into certain little parts, right, into small little parts, right, which is how do we divide this up? Like, drop in the comments below, how do we divide up this huge problem, which is we wanted to detect like pedestrians and cars in a video. How do we divide that? Well, first is we found a lot of training data. That's part one, right? Two, right? We first did testing on the pictures, individual pictures, right? Individual pictures. And then what happened is once we got the pictures, right, we were able to bring in a video. We were able to take certain pictures, right, every single frame from that video. And then next thing you know, we're able to display it back to the user. So by dividing this up into 3 or 4 different parts, you literally are able to solve this humongous issue, not an issue, but this crazy epic, thing in an hour or two. Do you guys see that? Yeah, just drop that in the comment below if you agree with me. Like, seriously, because that is, to me, is insane. A lot of people think that this is crazy stuff, but honestly, you just some work and you're good. Am I right?
Yeah, man, look at it go.
What goes?
A bit slow there. I think it's slow motion.
Yeah.
I mean, it's detecting that sign wrong, but it's getting the girl. It's getting some of the cars in the back.
Yeah, right there.
Some of the pedestrians a little bit.
Yeah.
Yeah, and there's ways you can optimize this. You can be like, okay, if there's two rectangles in the general same area twice in a row, you can kind of be like, okay, there's a higher chance that this actually is a pedestrian. It's not just a random thing, a random detection. So
hold on, I want to ask you a question. So somebody asked a question. Actually, George asked a question. How can I get this source code? If I can take a look at it, please. So I can take a look at it.
I'll post it in the description. I'll upload it to a Replit or something, Replit.it, and then you can download the code if you didn't type it out yourself with us. Yep.
Cool. Yeah.
Granted, it won't work in Replit. Like you're gonna have to download the OpenCV package within Replit itself and run it there. But you can just I'm just gonna host it there for code reasons, and you can just copy paste it to your own Visual Studio Code.
Yeah. Wait, but can we just host on GitHub or no?
We could do that too.
Yeah. Right.
Doesn't matter.
That's it.
Yeah. Either or. GitHub's probably the proper way to do it, but I'm a Replit fanboy. So yeah, we'll post it to GitHub. How's that? That's the proper way to do it. We'll post it to GitHub and you can download the code from there.
Exactly. So guys, how sick was this? How sick was that to create such an insane Python tutorial, such an insane Python program? Aaron, amazing job.
I think it's pretty dope. I'm just admiring the work
Am
that
I
other people have
admiring
done.
your work?
'Cause this
Don't
was
get
me.
too cocky, bro. Don't get too cocky on this. It's just like
I said I'm admiring the work that other people have done, bro. That's the opposite
Oh,
of cocky.
okay. I thought you said admiring
Bro,
my work.
open your ears. I mean, what? I wrote like 20 lines of code. Like, it's pretty badass, but I mean,
Yeah.
I didn't do all the training. The training, that's the hardest part.
Yeah.
But,
But that to me is insane. So yeah, but
yeah,
awesome
look at
job,
this
guys.
stream.
Guys, give Aaron a round of applause in the comments. Right, he worked
And
on this for
Nas too. All of us,
well,
give all
you know,
yourselves a round
I
of
was,
applause.
I was partially involved in the code. I was just like,
Oh, this
okay,
one's good. Look at this.
wow.
Holy, it's getting these pedestrians
Yeah.
super accurately.
It's like stop. There's pedestrians in front.
Yeah.
Yeah.
And then the bigger the rectangle, the closer it is. You can do stuff like that. Like if it's a big
Yeah.
rectangle, you can tell that the thing is close to you.
Yeah. Look at that. That's insane. That's cool. That is so cool.
Okay, this one's not working at all. This one's terrible.
It's like I think there's just too many people, man. Probably.
Yeah,
There's
I
too much
think, yeah, it gets a
information.
little bit confused with crowds and stuff.
Yeah.
If you had just people walking, like on a white sand beach, just a single person walking, it would track it almost perfectly. But just because there's so much noise and stuff, it's not quite perfect.
Yeah.
But dude, this motorcycle driver is like freaking.
He's trying to run people over,
Yeah, he's murderous, dude.
People are
He's
like,
trying to-
the hell are you going?
His name is Royal Jordanian, so maybe
Oh,
he's
yeah?
in Jordan or something. Yeah, I
Okay,
mean,
okay.
I found him this morning because I needed this video. But he has like 2 million subs. It's ridiculous
Oh wow.
for riding his motorcycle.
He just rides his motorcycle and he records it. Is that it?
I guess so.
Wow.
I mean, he probably talks about his motorcycle and stuff too. I didn't really look at his channel. But
Evil is like evil. I'm the evil. I don't know how to say that. Evil is like, Aaron, do a project with me.
whoa, look at this truck. Got that truck hard.
Did you hear me, Aaron?
Yo, it's getting the cars in the advertisement. That's funny.
Where? Oh, up
Here.
top?
Yeah. Are those even cars? Oh, they're not even cars.
I don't know if they're cars. Yeah, I mean, guys, obviously it's not perfect, right? This is not perfect,
Yeah.
but still,
perfect.
it's insane.
It's more right than it is wrong.
Yeah.
just say that.
Yeah.
That's a monumental task.
Yeah. Hey guys,
Monumental.
I'm
That's
asking you a
okay.
question. Like,
A
what
pass, not a
else?
fail.
Let me ask you a question. What else would you like us to see? Like, what else would you like us to do in terms of, AI or face detection? Anything that you want us to do? Like, let us know. Drop it in the comments below, right? Because we read your comments, right? So we have great ideas for what to come next. So we have great ideas of what you guys want from us, right? We read those comments. I am not kidding. So if you got any suggestions, right? If you got any suggestions on what to do, yeah, just drop it in the comments below. We'll take a look at it. Aaron, and then Aaron is just gonna take a crack at it, and then create something amazing, right, Aaron? Am I right?
Semi-amazing, bro. I mean, just whip it up.
Yeah, semi-amazing,
whip it up overnight.
like 1/4 amazing, 1/4 amazing.
Yep. And boom, some cool projects. Any cool ideas you guys have for projects going forward related to Python and any kind of artificial intelligence, then drop it in the comments too. Then we can consider it, and maybe we'll make something.
Yeah.
Maybe we'll use OpenCV again. Maybe we'll use something else.
Yeah.
Something else.
Somebody
There
said.
is
So we have
scikit-learn.
Ido said to detect numbers. Okay, we could do that actually. Detecting numbers like 1, 2, 3, 4, 5.
You could detect numbers on a page. Like if you had a piece of paper and
Okay.
you had OpenCV, you could technically scan that and then find out like all of the places where there's words. Like that's actually how PDFs are able to like scan the numbers and letters in it and like auto populate all the numbers and letters is through scan. It doesn't use. I don't think it uses hard cascades. It uses something different. But yeah, same principle. You can detect different letters and shapes on a piece of paper. Same exact principle.
Gotcha. What about somebody said Sparsh asked age detection. I'm not sure if we can do that. That's a little bit hard, man.
Age detection?
Yeah.
I mean, in theory, it's possible. Like if you had like facial recognition, you know how Facebook can recognize your face and be like, oh, this is Kazi, this is Nas, this is Aaron.
Yeah.
Tag your friend automatically. If it can recognize an actual independent face, it can easily recognize old versus young. So yeah, you could, but it would take more training. And you would need a lot of picture of old people and a lot of picture pictures of a lot of young people and to distinguish between those.
Yeah, that's true. But like, I think it's like when you get to like when you're 20s to 30s, it's really hard to get the exact age. Like if it can get the exact age,
it could be like old, middle-aged, child, infant. You could just split it into 4 groups. Infant,
yeah,
kid, middle-aged adult, and
yeah.
elderly, senior citizen. You could have like those 4. That's close enough.
That's true. So guys, if you want us to do like an age detection system, that would be actually interesting. I'm making an age detect error, and they'll probably say like 50, or something like that.
Yeah, the thing with that is I don't know if that exists on the internet. We might have to train our own hard cascades, and there's other algorithms. Hard cascade
I'm
is
sure
not
there
the only
is.
algorithm used for this. But
Ooh,
maybe
we had
because-
we had someone say, hold on, Itzhak said face expression detection.
Oh, like smiling.
Smile, sad,
Smile
like
versus-
mad, be like, no, I'm mad. I'm like, you smile,
Yeah, we could do a smile detection,
That'd be interesting.
and just have it's like smiling or not smiling. Because let's just keep it simple: smiling versus not smiling faces.
Could
And
do
then
that.
you could have like a
That'd
little
be-
label. It could say like smile on top.
yeah.
That's not a bad idea. We can look into it.
So
And
guys,
anything else?
would you want us to create a face expression system?
A smile detector.
A smile detector system.
Yeah.
Because that way, if you guys don't smile, we could, we detect some points, We detect points from you. I don't know how, but we would deduct points if you guys don't smile. So yeah, sweet. I think that's pretty much it, bro. Right? We're good.
Yeah, that's it. So again, if you guys are interested in coding more and actually making a living from it, if you're not currently doing that, if you're Uber driver or working at a retail or fast food place or something like that,
Yep.
we offer courses here at Clever Programmer to help you learn how to do that. So we teach you a bunch of different projects in Python and how to actually monetize those skills. So there's a 15-week program hosted by Kazi and our
Jacob.
other Python expert, Jacob.
Yep.
And then also there's a little bit of me in there. We're going to add in some stuff in there at
Just a
some point
little
of me. And we all teach Python and how to actually use Python to make a living from it. So if you're interested in that, then definitely give it a click in the description. There's a free 3-part masterclass and also the actual course is there, so you can check out both. If not, then yeah, just keep watching us on YouTube. And thanks for watching, you guys.
Yeah, sweet guys. And I just want to say, guys, just one small thing, guys. If you're interested, like I said, with the Profit with Python, you get amazing success coaches. You get to learn how to make a killing with Python, right? So it's not just about teaching you skills, right? But it's also teaching you about how to actually make money from that, because that's the most important thing that you're gonna get it from a course, right? We get weekly training calls, literally. Every single week, you get a coaching call from a developer who knows his stuff, right? You have an amazing community who helps each other, and you have an amazing Facebook community at the same time. So, yeah, if you're interested in, becoming a Python developer or learning Python and just making a killing with Python, where do they go, Aaron?
They can go to the link in the description and check it out there. Profit with Python.
Profit with
There's
Python,
a Profit with
guys.
Python course.
Yep.
And then there's also a free 3-part masterclass. It gives you a little bit more information about making money as a Python developer. You can check that out. It's just about like the opportunity there is and stuff, and there's some activities in there. You can check it out.
Sweet.
And then you can join the course after if you want or something like that. But
exactly.
Yep, that option's there for those who are interested. For those who are not, come back to the smile detector next.
Yeah, the smile detector. All right, guys. Awesome, guys. This was amazing. This was so much fun, guys. Oh, hold on. Somebody evil said Evil says my heart is Python.
My heart is Python.
My heart is Python. Yes. What about JavaScript, bro? What about JavaScript? JavaScript cool too. You guys are not, not cool. Anyways. But sweet. Awesome, guys. In that case, I think we're done here. Hope you guys have a great day. If you guys have, I don't know. Hope you guys have a great day. And other than that, we will see you in the next video. Right, Aaron?
Yep. Next video. Probably tomorrow, right?
Yeah, probably tomorrow.
Scheduled for tomorrow.
Yeah, I think so. Awesome, guys.
Stay tuned for that, you guys.
Stay tuned and have a great day, guys. Let's go.
Peace.
We are going to be building a real-time AI smile detection app in Python. I am Sunny, and today I am here with
Aaron. What's up, guys? Remember me? I'm the Python guy, apparently.
Super pumped, guys. Super pumped for today. Aaron, what are we building today?
Can they see my screen right now? Or the
It
stream
should be
started.
coming through
There,
now,
well,
yeah.
let me pause this. Mute this. All right, guys. So this is what we're building. I got my little app here, and I got a little face detection app.
Let me go ahead and share the screen 1 sec. All right, let's go. Yep, they can see you.
All right. Here's my face, and when I smile, it should be able to detect that I'm smiling, and then it displays. I mean, it's bugging out a little bit right now.
So go ahead and throw a smile. Hey, look at that.
There we go, guys.
And what we did, how are we getting that to work right now?
This is the code, bro. That's how stuff works.
So,
This code right here.
what are we using?
Oh, yeah, but that's pretty much.
So we're using AI, right? And we're using what in particular to get that working?
OpenCV. So we're gonna be using the Open Computer Vision library, as usual. If you guys are watching the other couple streams in similar, but this one has some cool optimizations in the code. So it's pretty short. So it's pretty powerful library. I mean, what, 50 lines of code with comments and spaces. So
Yeah.
pretty bite sized, but you can do some cool stuff with it.
Awesome, dude.
Yeah.
Okay, so let's go back to us guys. There we go. Nice. So let's go ahead and see where everyone's at. Nice. We've already got 250 people in here. That's dope. Hope you guys.
Dang. Okay.
This is the first time, guys. Me and Aaron are going live together, so this will be exciting.
Yeah, very first time.
Exactly. And also, guys, I'm not actually a Python developer, so many of you guys know me for React. So this will be cool for me as well. So I've never done machine learning with Python, so I'm excited for today. Yeah.
Let's go, Sonny.
Let's do it. So Aaron, let's go ahead and let's just jump straight in, I think, yeah?
All right, yeah. Let's get straight to the project, okay? So here's the stream. All right, got a little presentation here for you guys. Let's just start off to get a little bit of context. So smile detection with Python. All right. First of all, you just want to, pay respects to the Joker himself, the infinite smiler. I mean, he's always smiling, but really not. The legend Heath Ledger. Rest in peace. Rest in peace, bro. But yeah, guys, just make sure you're smiling a lot because it's important. It's good for your mental health, and people will probably like you more, or just think you're freaking crazy. So how are we gonna do this? Sunny smiles a lot. I've noticed. So you can be blessed with his super white teeth. It's a British thing. Nah, you guys just misspell words. That's all it is. It's misspelled words. All right, so how are we gonna do this? So you guys guessed it. It's all thanks go to machine learning, okay? All thanks go to machine learning. So we're gonna be doing that. We're not gonna be training anything, but we're gonna be doing some pretty crafty stuff in the app with some pre-trained models this time. It gets a little bit fancy here and there, but I'll explain how it's happening. So here's a quick code breakdown of our app. I just kind of want to give the overall idea of the code logic, just so that people have some context going in before we start coding. Because I don't like when they just jump in. They're like, oh, what are we doing? But this kind of gives you a holistic view. So step one, the very first thing we got to do is find faces in our photo. In our case, it's going to be a frame from the webcam. That's what I'm going to be using in the app. But here,
awesome.
The first thing you want to do is you want to find faces, and that's using the HAR algorithm.
What is the HAR algorithm?
Yeah, so I'm not actually going to be explaining the algorithm in this video, but if you want to know how the algorithm actually works in depth, you can watch our face detection video or our car and pedestrian tracking video from a week or a couple weeks back. And in those two videos, I explained them in depth. Different explanations in both. At the face detection, it's at the end. And then the other video, it's at the beginning. But if you want to actually see how it works, you can go watch those videos. Those are cool. But this app's a little bit longer, a little more complicated, so I'm just glossing over it.
Okay, awesome. Also, I just want to say, so step one is find the faces. So at this point, we're literally just finding the face, right? So we're not actually finding the smile.
No smiles yet.
Okay.
So you want to find just the face like that. Yep. Step one. That's find the face. Very simple.
Yep.
And then we also want to crop it out just so we're dealing with this.
Okay.
Step two, we want to find smiles within those faces because, I mean, it's pretty rare you have a smile outside of a face. I mean, maybe if you had some dentures lying around or a weird piece of art on the wall. But I mean, 9 times out of 10, a smile is always going to be within a face.
Yep.
Okay. Again, this is the HAR algorithm. So again, if you want to see how it works, it's just generic object detection, but we can detect smiles within the faces. Okay. So we just detect the smile there. Then step 3, all we need to do is just put the rest of the image back, get rid of that bounding box, and give it a nice little label on the bottom, because this makes more sense, you know? I mean, you could have a box around the mouth. I guess that's kind of cool, but this is cooler because then you just kind of want to know if the face is smiling or not. It just seems more human. So that was the design choice there for the app.
Nice. So
and that's really it, guys. So
yeah, I noticed that you basically you found the face first, and then then we found the smile within that box, right?
Yep.
And then why do we do that instead of just doing the whole?
You'll actually see once we get to there.
Okay.
A lot of AI stuff. You kind of need to get clever with the optimizing and layering different layers, because if we did smile detection just everywhere, the performance is actually really, really terrible.
Okay.
So I'll show you guys that. I'll show you guys that once we're coding, and then you'll see, because it's actually pretty accurate. Like when I'm running the code.
Yeah.
Well, here, so I actually ran it here on the. I mean, here it's a little bit bad because it's blurry, the lighting's bad, but I just wanted to run it on this GIF before to show you that it's kind of working. Like when he's smiling, you can kind of see it picking it up a little bit here and there.
Awesome.
But on the webcam, it was pretty accurate.
Nice.
So yeah, you'll see how ass the performance is if you run it on the whole thing. But there's a little trick to make it like really, really accurate.
Awesome.
So guys, let's get to the code.
Yeah.
So
and guys,
get
if you're
out of here.
pumped for this, just all we ask is that before we get started, just smash the thumbs up button. what we got here? What was that, Elon Musk?
Yeah, I have the other from the car and pedestrian tracking. I just forgot to delete it. Anyways, yeah. So let's get to the code, okay? Real quick, guys, before we start though.
We just got a donation, dude, from Tushar Nearest. He says, character doing a shaka
Nice.
sign with his hand saying cool. Oh, okay. No, he actually sent in something. We can't actually see it properly on the super chat, guys, but it's some guy waving cool. So thank you for that. Cheers.
Nice. All right. Real quick, Sonny, you want to show them the screen about the free training?
Yeah.
Mention that real quick.
Yes, let's do it, guys. So we have a free Python masterclass that I recommend everyone goes ahead and signs up to. I haven't actually got the link, Aaron. I've got Profit with 1 second. Let me go ahead and show this. So guys, let me go. Do you mind just slacking me the link for the? Where's it going?
Yeah, or I can do it. Just share my screen and then I can go through it.
Let's do it.
Yeah.
Yep.
There we go.
There we go. Nice.
Can they see on my screen?
They got you.
Yeah. What's up, guys? So if you guys are interested in learning how to actually make a living from Python, then we have a free Python training here that teaches you the 3 secrets of how to become a Python freelancer. So link is in the description. You can click down there to check it out. Or if you just want to jump straight to our Python course, then we also have a course which teaches you how to do that as well. This is a paid course though, so if you're interested in that, there's also the link in the description. Okay, a lot of cool stuff in here: free trainings, private communities, weekly live calls with a couple instructors, and yeah, feel free to check it out. But other than that, let's just get to the code, okay, guys?
Also, guys, just want to point out one thing. With that said, something that I really want to point out that I think is always cool is that we actually offer weekly live training calls in that program. So if you do want to go ahead and you get a bit bored of the sort of Udemy courses that you see online, then make sure you go and check it out. But before any of that, be sure to sign up to that free training, guys, because it's completely free. So you have nothing to lose. Go ahead and check it out if you enjoy the video. Awesome.
All right.
Let's do it, dude.
All right, man. Is the focus back on my screen?
The focus is back on your screen.
Let's go, guys. Okay. So let's just jump right in, all right? So remember, we're going to be finding faces first, and then from there finding smiles and layering it over. So this is the full app. Again, OpenCV, very powerful. We can do some stuff in a pretty short app. So first thing is you're going to need to download a couple files. These are in the description down below. So you just go to those web pages and download these 2 XML files to start out. I'll explain this in a second.
Dope.
And once you've done that, you just need to make a Python file. So start with smalldetector.py.
Yep.
And actually, I think I'll just code in here.
Yeah, let's do that. It's always nice to see a bit of fresh code.
Yeah. Oh yeah, of course. But I was gonna make a new file, but I'm not feeling it. So we'll just pretend this is a new file, okay? So just make a new file in a new directory.
We just got another donation as well. We got Vishal S dropped a 20 rupee super chat. Thank you very much, dude. And
Oh,
Tushar dropped another one. Thank you guys.
Tushar. Thanks,
Says,
Tushar.
thank you.
Shock
Free
right back.
knowledge, everyone. Appreciate that, dude.
Much appreciated, man.
Yeah.
All right. So let's get started, okay? So first thing we're gonna need to do is install OpenCV if you don't already have that. So I think that is through the command. Well, let me quit out of this. There we are.
Hey.
Quit out of that. You're gonna need to install it from pip install opencv-python.
Okay. I'm new to Python. So
Python.
what is pip? Firstly, like for those that are new to Python.
Is the Python. I forget what it stands for, but it's a package installer Python or something.
Okay, so
Package
it's a bit like npm then, right?
Yeah. So it just allows you to install a bunch of libraries that are for Python. So there's pip, there's Anaconda, there's Homebrew. There's a few you can use to download different things, but we're just using pip. It's the simplest one in my opinion. So yep, just run pip, and then this is a command install, and then we're going to be installing opencv-python. It might be python-opencv. Just try both, and then the one that works. And if you're having issues with that, then adding headless at the end can sometimes fix stuff.
Awesome.
But yeah, just do that, or do a Google search if you really can't figure it out. Once you have OpenCV installed, then we can start coding. Okay.
Yep.
So we can just import CV2. So that's the very first step. Is just importing OpenCVs. This 2 is the second version. This is the second version of CV2. I actually don't know why it's like that, but CV2 is the library for OpenCV.
Okay.
And let's just start with this just to make sure that our code is running correctly. So OpenCV2. Import CV2, and then it's big enough, right? Let me get rid of
yeah, we're good. Yeah, and that's how we run our Python script. We write Python with the file name .py, and that's it, right?
Yep. Just make sure you're in the same directory. So in my case, I'm actually in a folder, and then make sure you're in a folder here. If you guys don't know how to do that, then I don't want to make this too much of a command line thing, but CD is change directory.
Yep.
Yeah, so actually, let me just go back here. So see I'm on the desktop here. You probably, you'll probably be here when you open your terminal. It might look different, but you'll probably be one above the desktop. You're going to want to put CD and then just type in desktop to go to your desktop. I'm in the desktop. And then from there, you're going to want to CD to OpenCV. Well, this is the name of my folder. It's OpenCV smile detection. Awesome. And then from there, now I'm in this folder. And then I can run this command, okay, because that's where the file is located.
Okay.
Yeah, I don't know. So, smalldetector.py.
Yep.
And if we run this, it should just print what's up, because that's all we have in here, okay? So it's working correctly. That also means this is working correctly. It'll pop an error for you if you don't actually have it installed correctly, but this one, it just doesn't say anything. If it says nothing, you mean you got it installed correctly. If it says something, you got to install it correctly.
Go ahead.
All right. So let's just move on, okay?
Let's do it.
Let me pull some of this code from down here. So first thing I said is we're going to actually start with just the face detection. So let me copy the comments as well, just so like we have a nice app with comments and everything.
Nice.
So face classifier. All right, so here, this is a pre-trained model for detecting faces. Like all the fancy machine learning stuff happens in here. It's just a bunch of numbers that the image gets passed through, and then it tells you face or not. That's all it is. You pop in an image to this, and then it says yes or no, and it gives you an answer.
Right.
Again, if you want to see how this is actually made, the whole algorithm and step-by-step of everything that's happening inside the computer, then you can go watch one of the other face detection or car and pedestrian tracking videos.
Yeah, I think it's worth saying.
But let's just start with this.
Just like from my understanding, Aaron, like a classifier is something where we have like some kind of input, right? And then we have this model. So in this case, we have the Haar cascade frontal face. So some kind of like model is inside of that classifier. And then, so let me go ahead and I'm just writing on the screen. So we have some kind of model. And then from that, so we have some kind of input, right? Then we have a model. And then we have, one sec. and then we have some kind of output. And what would that output say? Would it like a certain value which says if you're smiling or not, right?
Yeah, literally just a 1 or a 0.
Yeah. Okay.
It'll
So in
just
this
say,
case, yeah, a 1 or
well,
a
yes or
0.
no, but yeah, but well, technically, it'll give you coordinates on your image of where the box is around the face
Got it.
in practice. But I mean, basically, it just kind of says yes or no.
Okay.
Kinda. I mean, the implementation is different, but the idea is it'll just say smile or not smile. That's all it'll say.
Got it. So we have some kind of input, a classifier, which is what we're using here, which is that Haar cascade, and then some kind of output, which is whether it's telling us if it's smiling or not, or some kind of coordinate. But that's how it roughly works, guys. So as Aaron said, you pretty much, this is the line of code to go ahead and get that working. Nice. Yeah. Carry on. Cool.
Yeah, actually, I guess I can explain a little tiny bit. Technically, if you have a whole entire image or a frame from a video, then it will look over every little box inside that, and then it'll tell you if each of those boxes of different sizes, if that's a face or not, or if that's a smile or not.
Nice.
So that's what it's actually saying. If it's a yes, it sends you the coordinates within the whole image of the little box, and then that's how we draw the little box, because we have the coordinate, and we can just draw a box at that coordinate.
Got
So
it.
that's actually what's happening. So
Nice.
it's the whole image, and then you just go over the whole thing, and then each is like no, 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 no. Oh, found a face. That's a yes. Give me the coordinate, and then no, no, no again. So if there's multiple faces, it'll find multiple faces as well.
Awesome. Okay, so it's not just one
Yep.
face. We can support multiple faces. Oh, nice. Surab
Yeah, we
Khani just dropped a 100
Yeah.
rupee donation. Says thank you so much for sharing.
Nice.
Awesome. Thank you, dude. Let's carry on.
Thank you. Yeah. Here, actually, let's run the code really quick.
Yep.
I want to show it with 2 faces. I didn't show with 2.
Oh, nice. Yeah.
I should have shown it with 2 real quick. I can just use my phone. There we go. Well, I mean, hopefully it works. It might bug out because one of them is an image.
Yeah.
But we'll see.
Oh, nice. That's dope, dude.
And it says smiling.
Yeah, and it's real time, and it's quite performant. Like that's pretty like fast. Like it's as you move your phone around. If you try and move it around fast. Yeah, look at that. That's just smooth. Nice. Okay, and so there's some kind of loop, I'm guessing, that's running, or like some kind of thing that's gonna happen there. Yeah.
Yeah, we're just pulling out the. Let me clear this. We're just pulling out the webcam footage.
Okay.
Pulling the webcam. It's the easiest way to get some real time footage. Yeah, I mean, this could be a security camera, it could be a whatever, but in our case, we're just gonna be using the webcam.
Got it. Nice.
All right, so let's do that next. Let's just pull out the webcam and show you how to get the webcam with OpenCV. If you guys are watching the other streams, you guys know how to do this. You'd be very comfortable by now. This is the 3rd time we're doing it. But let's just do this right there. And this is the best way to do it because then there's no typos and I don't embarrass myself. Right, Sonny?
Let's do it.
Sure, that happens a lot.
Yeah.
But anyways, so this is how you want to grab your webcam. We just call it webcam a variable. You're gonna need to have a variable for that because this is how we access all the webcam stream footage. But really, it's just video capture. So you just call the OpenCV library .video capture, and then if you put 0, this is the webcam. But you could actually also put like something like whatever .mp4.
Okay.
You could also get video files and run it on there.
Nice.
Like the Joker one that I had.
Yeah.
Over here. This is how I did that. I just imported this file. And then I ran it through, and then I recorded it and put it back here. But for us, 0 is webcam.
Nice. Go ahead.
So it was pop at 0. And let's just, I think it's CV.im show.
Okay.
No, not im show. Wait, what is it? I always get confused between footage and, yeah, it is im show.
Okay.
I always get confused between images. So yeah, show the current frame. So let's just pop in a quick loop and just show the webcam live to the screen, okay?
Dope.
And from here, then it should be, we should clean up. I think it's destroy all windows. Yeah, cv2 destroy and
Oh, okay. You have to release the webcam as well. Nice.
yeah, just clean. I mean, you technically don't have to, but I mean, it's just like good practice. So this here is what's actually going to show. So while true, we're just going to be showing the frame. Oh, I forgot another line of code. We're actually going to need one more. This is actually a big chunk size. Let me go line by line. Let me just get this last one here.
Yep.
Where the heck did it? Here it is. I'll read the current frame. All right.
Nice.
Let me go line by line because this kind of was a big chunk. So what's happening here is after we get the webcam variable, How we get a frame is we actually let me just show this real quick. So let me comment out all this just so that we can go step by step. It's a better way. Doing this on the fly, guys. So here we go. Look at this single line here. Ignore everything after that.
Okay.
Okay. We can. Okay, we'll do this. The way I like to do it.
Just have
code completed. So if this prints, yeah, it means if it prints, then there is no errors because it's at the end.
Got it.
So this is how we actually read the webcam. So you call .read on the webcam, and what this returns is a tuple. So this is actually a two tuple. So this is the first one, first element. This is the second element. Okay, and oops. Yeah, what this is just a Boolean of if it was a successful frame read or not, and the second one is the actual frame. So this is like an image that we can actually run things on. So let's actually just show that.
Okay.
Now I can grab the cv2.imageShow right there. And this is the name of the window. So I just put why so serious, but you can put smile detector if you want.
Yep.
Okay. And let's go back to the terminal. Oops. What did I do? There we go. Smile detector.
Yep.
And I forgot one more. So after this, you're going to need to run cv2.waitKey.
Okay.
Right?
And what does this do?
Let's put this. What this does is, so what happens is we get the webcam, okay, and then we call webcam.read, which is just reading from the webcam stream. And it'll get the first frame, the very first frame of the webcam video. And then if it succeeded or not, but ignore this for now. It'll get the first frame. Then from here, it'll say cv2.imageShow. Image show means it'll show that image to the screen. Nice. We're going to show frame and then the window name will have small detector. Like up here at the top of the window will be small detector.
Nice. Okay.
The thing is, this shows only for a split second as long as it needs to, and then it quits out.
Right.
What this does is it says, let's wait for a key before we continue to the end of the program. So it'll stay open until we press a key. Okay. This basically means display.
Right. Yeah. Okay. So this means that without this line of code, it pretty much hides it super quick. So now we're saying wait until you press a key on the keyboard to hide it, right?
Yeah, pretty much. And this is here because once we're going frame by frame, you don't want to be pressing a key every time the frame changes. It's going to automatically change in real time. Okay. So we really only need this for this case of doing just the first frame, the image. So let's run this and see what happens. There we go. So that's the first frame.
Go ahead.
Okay, so like it's not an actual video, it's just one frame.
Okay.
But we're gonna wrap this in a loop and then we'll see it in real time. Okay.
Oh, I see. Okay, so you just got a single frame. Okay, I got you. I'm with you.
Yep.
Nice.
Yep, because .read will read a single frame.
Okay.
And then it keeps track of where it is. So every time it calls .read, it'll read the next frame, next frame. So we just wrap this in a loop, and that's how we can get the real-time webcam footage.
Right. So I'm just gonna write reads a single frame, right? Read single frame. Oops. Single frame. Nice. Okay.
You taking some notes for them?
Yeah. There we go. Awesome.
Nice, bro. I'm running out of coffee. This is a disaster.
So this makes sense. Yeah. We're gonna read a single frame and then we're gonna wrap it in some kind of loop so we get that real-time functionality.
Exactly, which is what we're gonna do down here.
Got you.
So let's get back to here now. But I'm just gonna plug in things one by one. So like I said, this is the webcam, and then read a single frame, display that frame, and then display that frame. Like wait until a key is pressed before you hide the frame.
Okay.
So now all we want to do is just pop this in a loop. Okay. So we got the webcam here. Now, the loop is going to be here because once we have the webcam, we want to keep calling .read on each frame over and over again.
Yep.
Okay, so we would just want to run this forever, and that's why it's a while true loop. You just want to run forever until we're done.
Got you.
So let's pop all of this into there, and from here, let me get the cleanup code. Okay, so this here at the end, let me show you guys this real quick. This here is just some cleanup. Okay, so it's not super important. It's kind of boring code, but I'm just going to say at the end of the whole app, you want to make sure you have a webcam.release. It's just letting the operating system know that, hey, this app is done using the webcam. Free up all resources so that something else can use it. Like Zoom or Skype can now use the webcam without any memory issues.
Go ahead.
And then the last thing is CV2 to destroy all windows. So this just kind of closes all windows to make sure nothing's still open.
Okay.
Because sometimes that happens. Yeah, this is a cool little thing I forgot about, but I found recently, so
Nice.
very handy. Yeah. Okay, so after this, then we get webcam, we have a while loop, and same exact thing. So this should work. The only caveat is if this is empty, it's gonna keep waiting for a key press. So let's run this, and then I'll show you how that works. So here we go. It's a frozen frame, but as I press a key, it keeps going to different iterations of loop. So it keeps running. It keeps. Yeah, and each time I hit it, it gets the current frame because it's calling dot read. All right, so it calls dot read on the frame.
Yep.
Dot free, and if I spam it, and then kind of like real time, but that's annoying. So what we actually want to do is, dot wait key actually just waits until a key is pressed forever. But if we put something in here, this is how many milliseconds it'll wait before it automatically goes by.
Right.
So if we put 1, it'll automatically spam a key every 1 millisecond, and that's kind of like the behavior. If I put like 1,000,000, then it would just wait 1,000,000. That'd be too long. It'd be like 10 minutes.
Yeah.
But if I just put 1 millisecond, now when I run this should be updating every millisecond by itself, and it actually be in real time. So let's give it a shot.
Nice.
Well, let me quit out of the old one. Oh wait, I gotta kill it. 1 second. How do you kill it in
it should
ZSH?
It should be Control C. Yeah. So if you just spam Control C, sometimes it takes a little bit.
It's not working.
Oh,
That's okay. I'll just force quit.
Yeah. Also,
Yeah,
guys, just want to drop in while Aaron's sorting that out. We have one comment over there which says, Wamik Ajaz says, Banath, you people are really amazing. Awesome. I have no words to express my feelings. It's only because of you people. Today, I got a job at Google.
At Google?
He got a job at Google, dude. That's insane.
Damn.
Like seeing that.
Holy crap. I couldn't even get a job at Google. What is... Bro, get this guy on the stream. He should be teaching, not me.
I know. That's
not
insane. We love that, guys. And we also got another donation from Tech Programmer. Thank you very much, dude. We massively appreciate that. And also,
that is amazing.
Guys, drop us questions in the chat. And literally, we'll be happy to answer it as the stream goes on. We really love when you guys engage with us and let us know. Yeah.
Hey, whoever landed the job at Google, send me and Sunny a DM on Instagram, and then we want to hear a little about your story. That's awesome. That's exciting.
Yeah.
What was his name? Sunny?
What did he say? He said. Yeah. Let me go ahead and find it again. So.
What is his name?
It's.
I don't have it on. I don't have the stream open.
So I've just popped it open. It says Wamik Ajaz.
Wamik Ajax. Got it. All right, Wamik. We'll be expecting you to DM us. Okay.
Yeah. Awesome. Reach
just
out
say,
to us.
Just say I'm the Google guy.
Yeah, I'm the Google guy. That's insane, dude. We love that. Nice.
Kind of jealous, actually.
Yeah.
You soured my mood. Nah, man, that's amazing. Great. That's exciting.
We have another awesome comment by Sayatan Bakshi. He goes, "You guys are just amazing. I've learned a lot from these live stream. Your work is very inspiring. Thank you so much." That's awesome, dude. Thank you for watching. All right, let's carry on.
All right.
Let's carry on.
Yeah, it did. The Control C didn't work, so I don't know what's happening, but I just killed it manually.
Yeah.
So where were we before I got distracted? Oh, I was running the frames. Yeah, so when I run this again, it should actually refresh every millisecond by itself. Okay, so that's how we fetch this. So let's run this and go back here, and there we go. So I'm feeding the webcam footage. OpenCV is getting the webcam footage, the webcam stream, and then it's just displaying it in this window. And then I called it small detector.
Right. Okay. So that by putting 1 inside of the wait key, that's pretty much saying every second, like go to the next frame, right?
Yeah. Like it says only wait for 1 second. It says wait for 1 second, then press a key like a fake key, like a pretend key, and then it presses a key every 1 second.
Got it. Okay.
So this waits 1 millisecond. Yeah. But nothing waits infinitely.
Nice.
So that's the difference.
Awesome.
Or 10. We could do 10. 10 milliseconds is fast, so this would still work, but it doesn't really matter.
Awesome.
All right.
Yep.
Nice. And okay, let's see if it'll kill. Okay, so now Control C is working. Nice. Yeah. I don't know what this red thing means. Sunny had me install this weird shell thing, ZSH. I've only used it like once, but I ran away. But he says it's colorful.
Yeah. So. Usually, I think that's when your branch is dirty. I think so. I mean, That's usually when you're in it,
Got
or
it.
something like that. Yeah, yeah.
Got Yeah, I probably changed the code in here and then it changed. But no big deal. Just ignore this, like the color of the arrow.
Cool.
But yeah, let's just move on, okay?
Got it.
So I can actually get rid of this stuff because we actually pulled everything out. So now we're back to the um, code ran without errors.
Nice.
Okay. Here, let me just pop in some comments for
Also,
anybody
guys, we
jumping around.
have 350 people
Current
watching
frame.
right now. So thank you so much for watching. And yeah, if you're enjoying what you're seeing right now, with the face detection, you think it's pretty cool, all we ask is that you just smash the thumbs up button, and that will help this video get out to more people. Nice.
Yeah. Yeah, like smash the trackpad, like slam your mouse, just
Yeah,
hit
like
it as hard as you can.
eat that thing.
Domestic violence and domestic violence in the software programmer's house.
Exactly.
Stop the, that's a terrible joke, but uh, so yeah, this is step one. All right, so we got the webcam footage in here.
Got it.
You guys should be comfortable with this if you guys done this before. Pretty straightforward. Now, one check we want to put in though is actually this. So, I mean, it wasn't breaking before, but we do want to put in a check here, right here. So after we read the frame, okay, the first frame with the .read method, the first variable, the first element is actually a boolean of if the read was successful or not.
Okay.
So all I want to do is put because sometimes it might bug out. With the webcam, it's usually fine, but for a video file, if you're reading in an MP4 or something, like if you put a video file in here, like sometimes if one of the frames is corrupted or whatever, then it'll not work. So you just kind of put a safe check in here. So if it wasn't a successful frame read, just break out of this while loop and just like abort the program, and it'll go down to here and close everything so that it doesn't break. It just kind of quits.
Awesome.
So, yep, that's all that is. Just a quick little.
Aaron, somebody asked a decent question here. They said, how can I install the face XML file? So the one that we used at the top, where did you actually get that from again?
The OpenCV GitHub GitHub repo. So they provide all of that. The link is in the description, so you can just go down and scroll all the way to the bottom and just download this the face XML file. There's also a Smile one, but we haven't gotten there yet. We're going to be using both. We need both to make this work. You guys will see later why that is.
Yeah.
But
awesome.
yeah, let's just continue.
Let's do it.
So after we get the frame read and we have this little check here, then let's actually start detecting faces, okay? So if you guys watched the face detection video, you guys already know how to do this. Pretty straightforward. It's very similar, but there's a little trick here that you guys are probably going to blow your minds at some point. Hopefully. but maybe not. Okay, so after we got the frame, to actually run face detection on the current frame using this XML, we need to use, we're using OpenCV, of course. It's a very simple code. It's just like detect faces pretty much.
Yep.
But we do need to change the frame to black and white though. This is just an optimization because in a black and white image, you can still tell what a face is. You know, if a human can still tell, then a computer can still tell, and then there's less data to deal with. But the actual recognition ability of face isn't hindered by it being black and white. So we just convert it to black and white to greatly optimize it. It increases it by a lot actually because RGB has 3 channels, black and white only has 1 channel.
That's super interesting. I had no idea that would be an optimization. So we're making it grayscale so that it actually reduces like the sort of the amount of processing that it has to do on the video.
Yeah, because you're kind of just like jumbling RG and B together into one number, red, green, and blue. Because then you can just kind of be like, then you can just play with brightness. You can be like, okay, somebody's eyes look a little bit darker than their bright cheeks, something like that.
Oh,
and,
nice.
Or somebody's eyebrows are darker than their forehead. You just want to see the relationship of brightness between different areas on the thing, and those all added together, if you do it enough, you'll eventually define a face. Like, okay, eyebrows darker than forehead, eyebrows darker than nose, lips a little bit darker than cheeks, eyes a little bit darker than cheeks, stuff like that. Like hairline a little bit darker than if you have dark hair. So like it's just those kinds of things over and over. You eventually can explain to a computer what a face looks like after thousands of those little relationships.
Got it.
Or a car, or a pedestrian, or anything, or a smile in this case.
Awesome.
So like teeth,
Yeah.
teeth are whiter than your lips, so like it would understand what a smile is.
Nice. Okay, that's awesome. I would never have thought that would be optimization. So that's cool. Also, just to jump in, Chinmoy Kalia says again, because of you, I'm able to make my college fees by freelancing. Just wanted to throw that in.
Dang,
I love stuff like
dang,
that.
these people.
Thank you,
I
dude.
feel like these people are making more money than us. Like, I'm kind of upset.
I know, guys. I think you
Nah,
guys should start running.
that's amazing, you guys.
Yeah. Amazing.
Well, we're helping a guy make money so he can go to school to learn from people that are not us.
Oh
Is that
yeah.
actually a win for us, Sonny? Is that actually a
I
win for
know,
us?
right? Let's think about this for a second. I think we should cut the
Hmm.
stream.
Yeah. Abort.
Yeah.
Like,
Nice.
cut all signals, Sonny. Cut it.
What I love though
But
about Python
anyways,
is that is this like literally so few lines of code to get this all working.
yeah, that's what I love about it too. And then if you optimize everything under the hood, which is how
Yeah.
you should be doing stuff, like if you use like C or C++ under the hood, then it's still pretty fast, but you can be very expressive with your stuff. I think that's why they choose it for machine learning,
Yeah.
because there's a lot of weird, yeah, there's a lot of weird, nasty stuff. And you'll actually see the power of Python here later on.
Nice.
If this was written in JavaScript, it'd probably be like 2 or 3 times as long, you know? Like,
Yeah,
I mean,
100%.
maybe not.
Yeah. I can vouch for that. Yeah.
Of course.
Yeah. This is nice and clean compared to JavaScript. All right, let's carry on.
Yeah, I don't like JavaScript.
Yeah.
Yeah. I know, no, JavaScript's amazing, Sonny. I don't want to hurt your feelings. I know
It's gonna make me hulk out, guys.
JavaScript is amazing.
You might just see, you just see a
Yeah.
video feed
Yeah.
reconnecting.
Oh.
Nice. Let's go.
Sonny's the Hulk. That's his nickname. Um, but yeah, let's continue on. So once it's gray, okay, this is actually a requirement. Like OpenCV, you have to take it. And so, oh, I should explain how this. So what this is OpenCV has a function called convert color, which just allows you to convert the color of an image to black and white, or back and forth, or just the red channel, or just the blue channel. You can do all different kinds of things. But in our case, we just want to change something from a color image to gray. Okay. I mean, well, this is BGR, which is RGB backwards, and then to gray. So that's all this means. There's like different encodings we can use. So we're going to be using this one to convert this from a color image to gray. So let's actually run this now.
Go ahead.
And well, actually, we need to display the actual black and white frame. I feel like I've done this a bajillion times because I actually have. It might be boring some people who've seen the other streams, but whatever. And there we go.
Oh,
Black and white webcam. Yep. So you can still tell that this is a face. You can still tell that my mouth is smiling. So we don't need color to be able to
already
identify stuff.
it actually
It's black
looks
and
a
white.
bit smoother. It actually looks a bit smoother when you.
It is.
Huh? Yeah.
Because there's only a third of the data. You know, with color you have 3 channels, or 4 channels actually. There's a brightness channel as well.
Yeah.
But on this one, it's just the brightness channel.
Nice.
That's it.
But
So it's actually 4 times as fast because there's 1 channel versus 4 channels.
awesome.
And let me just quit out on the terminal. Control C. And let's just clear this up because it's getting messy.
Nice.
All right. So there we go. Black and white frame. Now it's literally as simple as popping this grayscale frame into our classifier for faces.
Yep.
And it'll spit out the coordinates of where my face is. And then we can just draw a rectangle over my face. And bada bing, bada boom, that's a face detector.
Go ahead.
That's the first step. And then we got to do smiles. You have to like overlap them in some weird way. And there's some cool there's a little trick I'll show you guys later that is critical for this to work. And then some tuning. You have to tune some variables at the end too, which actually make it work properly. But
I love how simple you make it. It's like, yeah, we just got to use this machine learning classifier, and then, gonna get some coordinates back, and then we just got to draw a box around the face. Yeah, no big deal. You got to do that, and you got to have an infinite loop. And
I mean, I'm explaining every line, so I feel like people can follow along if they know Python. If not, then I'll fire myself.
yeah,
Donald Trump's.
nice.
Yeah. So let's go down here and actually just detect faces, okay?
Let's do it.
Pop here. I might go a little bit faster because I'm just kind of this is like repeating the face detection stream.
Yeah.
We haven't even gotten to the smile stuff yet, but here's the line for detecting the actual faces.
Okay.
So, yep. So how this is gonna work is we have our classifier up here, okay? Face detection. face detector, which we created from this XML file, which has like all the data about like what a face actually looks like, depending on the brightness relationships, like we talked about.
Okay.
Like, and then from there, so we have this face detector.
Yeah.
Now with this face detector, okay, with this face detector, we can call a function called detect multi-scale.
Okay.
Okay, and then it just takes in an image, and then so what this will do, it will tell us where all the faces are in this image. Okay, it'll say, oh, there's a face here, there's a face here, there's a face here, and that's what it'll do.
So is it returning an array?
Yes, an array of points.
Okay.
An array of rectangles. So the reason it's called detect multi-scale is because you just want to detect faces of any scale. So if there's a small face, you want to detect a small face. If there's a big face, you want to detect a big face, and you want to detect multiples of them. So you detect all of them. That's why it's called detect multi-scale. Because we can really pop in. We can use any detector. Like we have a dog detector or a cat detector. We could also detect multi-scale of cats or dogs.
Okay.
So that's why it's called that.
Nice. Okay. Go ahead.
So it takes in a frame, a black and white frame, and then it'll say, okay, at these places there are faces in this image, and that's what this is. So this is just an array of points.
Yeah.
In my case, it's going to be array of length 1 because there's only one face. But when I had the Joker on the face, when I had Joker on the screen too,
Yeah.
and let me pull up real quick. Then there would actually be, so when there is both of us,
Yeah.
then there would be this faces would be of length 2 because there's two faces in the video.
Got it. Makes sense.
Okay. Yep. So from there, let's just print out actually faces. Okay. So this is just going to be a list. Let's just show this, and it's going to spam the terminal here over and over again because we're in an infinite loop. Remember. So as I'm here,
oh, nice.
you can see the location of my face is being detected, and then it's just being spit out here.
Okay.
So this is like XY coordinates, like blah blah blah.
Yeah.
And then from this, we can just draw a rectangle on the face. That's it.
That's clean, man. I was expecting like some really intense stuff, but that's super clean how it comes back. Like, nice.
Yeah,
Yeah.
that's it. So it's a list of lists. So if there's two faces, so actually watch this. Now there's two faces.
Hey, look at that.
See how there's two faces on the screen?
Yeah.
And then when I get rid of it, we're back to one face. The list is length 1, now the list of length 2.
That's
and there's 2 per.
awesome. That's nice. Okay, got it.
And if there's 3, then 3. If there's bajillion,
Yeah.
we're in the Matrix, Mr. Anderson. A bunch of agents going.
I think it's
So
worth saying, guys, that like just from like that classifier, you're able to do all of this. So this is just the power of machine learning. Like, and as Aaron said, this is a face detector, a human face detector, but you could easily go and pick up like a dog detector, put that here, and I guess it would do the same thing, right?
You can detect anything. So Har Cascade is a single algorithm that can detect any arbitrary object. So basically, you're like, if the computer was a person, we're literally downloading this is what a face looks like into its brain. That's literally what this is doing. You just have to teach this before we give it to it. So this was a result of machine learning with a bunch of face images that somebody created, and it takes probably like a few hours or a few days to create it. But then once it's created, then anybody can use it. So that's kind of the power of it.
Awesome. Got you.
Yep. And of course, Har Cascade is just one algorithm for object detection, whatever object happens to be, in our case, a face or smile.
Yeah.
There's many algorithms, but this is the simplest and the oldest one. It's actually based on Viola Jones. These names probably mean nothing, but if you want to look up Viola Jones algorithm, and then Har Cascade. So these are just names of people who came up with them back in like the 70s or 60s or whatever.
Nice.
But
awesome.
Smart people. Yeah, very smart people. So, okay, so that's the face. So from here, we just want to draw those rectangles back on the image here, and then when we show it, then it'll actually have the rectangles drawn on this as well, instead of just showing just the raw frame.
Okay.
So that's really all we're doing. Then from there, then we can get to the smile stuff. So at this point, we probably should have said at the beginning, if you want to get to the smile part, just skip ahead, but it's too late. This is a stream.
Yeah.
For anybody watching the replay. But
I mean, I guess
it is what it is.
Yeah,
free
at
content.
45, at point 45 minutes or so, like that's when we start the smile stuff. So yeah, we can add that in the comments afterwards.
Yeah, let's put the timestamps, and then like the YouTube has that thing now where the play bar is like segmented. That thing, mind
Yeah,
blowing.
exactly. Yeah, that's insane.
Bro, you
That's
should
nice.
do that. That would be a cool clone to do. You should be like YouTube, segmentation clone. Like you scrape out like the stuff and then you
Oh
segment up the
yeah.
video or
Oh,
something. I don't
that
know if you know
would be
that.
cool. Yeah.
That'll be
Nice.
sick. All right, stay tuned tomorrow for that because
Yeah.
Sonny's a beast. He can code things in 5 minutes.
Wait, guys, just as another reminder, so we actually have quite a few people on this live stream right now. Tomorrow, if you're excited,
Dude,
we are building a WhatsApp clone. So we are building a WhatsApp clone tomorrow. It's going to use Firebase. It's going to have a real-time
yeah.
chat functionality. So if you're excited about that, smash the thumbs up and make sure you set a reminder. Tomorrow. Yeah.
Have you coded iMessages yet? An iMessage clone?
No, that's a good idea. Yeah, we'll do that as well. Yeah.
You should do that because you did Facebook Messenger, but you should do iMessage too instead of WhatsApp. You know
that
what I
would
mean?
be
WhatsApp
dope.
is more international friendly.
Yeah.
Yeah, bro.
Hey.
Forget the Android people. All right. Okay. So now what we want to do is we just want to run. We just want to draw some rectangles on the frame. So I'm going to kind of go over this quickly. If you're getting confused, then again, the other videos go a little bit slower to explain this in detail, but I'm just going to go a little bit faster, okay?
Let's do it.
Because we're going a little long here, longer than I thought. It's already been an hour, bro.
Yeah.
So all we're going to do, like I said, faces is a list of points.
Yep.
So we just want to iterate over all of the points. So all of the faces that the algorithm found, it's just going to have lists. Let's just iterate over all of them and pull out those points. So like I said, there's 4 points here for each face. So we're just going to iterate over all of them, okay?
Go ahead.
So the first point is x, the x coordinate. The second point is the y coordinate. This is
Okay.
the top left point of the face.
Yep.
And then this is the width, and this is the height of how big that square or rectangle should be. So for a face, it's squares by default, but for smiles, it can be any shaped rectangle. So it just gives us like the width and height of the rectangle. So we're given a point and a height. From there, that's all we need to actually draw it, because we can just say at this point, go this far and then go down, and you can figure out the rest with math, which is what we're going to do here.
Go ahead. Okay. Nice.
So here, CV2 allows you to draw stuff on frames.
Yep.
So like this, we can draw rectangles. We can also put text on the screen, which is how I put the smiling little thing
Yep.
when it says smiling. So you can also put text. We'll do that later. But for now, we're just going to draw a rectangle.
Go ahead.
So the way this works is you just give it the image you want to pop it on. So
Yep.
in our case, we want to draw the rectangle back on the colored frame, not the grayscale frame, but the colored frame,
Oh, I see. Okay.
because we're only doing the calculations on the grayscale frame, because the coordinates and everything is exactly the same. But once we have the data of where the face is, we can just use the color again.
Got
So it's an optimization. Yep, because you're doing the calculations on the black and white image, but then we're actually still only seeing the color image, which is what you want.
you. Okay. Got you.
And for rectangle, all you need is the top left point and bottom right point of the rectangle for it to draw, because those 2 points, it makes it easy to draw the rectangle.
Yep.
So the top left point, like we mentioned, is XY. That's
Okay.
what we have here. Then the bottom right point is just going to be XY, but you add the width and the height to the correct coordinate. So X, you want to go an extra width, because that's the width of the rectangle. You just add W to it.
Okay.
And then Y, you just want to add the height to it. And those two together will be the bottom right point of the rectangle.
Oh, okay.
If you guys don't know this, then just like look at your geometry. Yeah, brush up a little bit.
So that's
But
X
that
plus
should,
width and then Y plus the height, and that'll give us the square, right? Like the rectangle, sorry.
Yep.
Yep. Go ahead.
Yep, square. In our case, it'll be a square, but any rectangle, you can draw any rectangle.
Go ahead. And what's the numbers on the right? So what are these?
This is RGB, the color of the rectangle.
Okay.
Well, technically BGR, because it's backwards in OpenCV.
Yeah.
This is just a random color. You can put whatever you want. You can play. These can go from 0 to 255.
Okay.
You can use whatever color you want, but I just chose this as a nice green color. Okay,
Nice.
because like it kind of like it matched nicely with the Joker screenshot. So this is just a random green color. You can use this if you want, but yeah, use whatever color you want. Then this is just the thickness of the rectangle.
Okay. Nice.
So 4 pixels thick. That's all.
So-
So this is just like customization stuff.
This one line is gonna draw the rectangle on that frame.
Yep.
Oh,
Yep.
damn.
It's gonna draw on that frame. Well, a single face on that single frame.
Yeah.
So we're gonna draw all the faces on the frame. Then we're gonna display that frame.
Nice.
And then on the second frame, it'll detect all the faces in the second frame, and then show all the faces in the second frame.
Right.
And then again, third frame, because we're in another loop. So this is a nested loop.
Yep.
And then there's going to be another nested loop within this one, which is going to be crazy later on. But
Yeah.
uh, we're going to have three
Let's go
nested
ahead
loops.
and run this to see if we can actually see the rectangles that you just talked about.
Yeah, definitely. So displaying the colored frame here, which is what we drew the rectangles on, colored frame.
Yep.
And let's just run this. As we can see here, this is the X point, this is the Y point,
Yep.
this is the width, and this is the height.
Nice.
And faces are always squares by default because that's just the parameter they set. So you can see the width and height is always the same.
Nice.
See? Width and height is always the same, but different sizes sometimes because detect multi-scale, it can be smaller or bigger.
Okay. Awesome.
Let's run this, and there we go. Magic.
Oh snap, dude. That's insane. In JavaScript, that would be like 30 lines of code. You know, just to get that kind of thing working.
I know.
Yeah, it'd be something.
We know.
Yeah, this is
We
where
know.
like I really do come back to Python a bit and like, whoa.
Yeah, man. You know, you can do web development with Python too. You know, you don't actually need JavaScript. You know, you can just use Django.
Oh, we're gonna start a war now, dude.
I'll fight you and Nas both.
Yeah, you might have a green circle around your face, but you're talking to the Hulk.
Hulk, yeah, with no legs, right? There's an ongoing goat, guys. I think we should just tell the community. Like, Sunny's good at so much stuff. So when he joined the team a few months back, I was like, one day we're on a team meeting. I was like, yo, Sunny, you're so good at everything. There has to be something effed up about you. But he lives in UK. We're all in Los Angeles. So Kazi was like, you know, we've never seen Sunny's legs. And we're like, he must be in a wheelchair or something. Like, there's something there.
Everyone thinks I don't have legs.
Bad about people in wheelchairs, but yeah, it's just a joke because we've never seen his legs, so he's always insecure and showing his legs in the video chat. It's like,
yeah, but guys, at least today, I'm not the only one wearing a black shirt, so you know.
Is that a thing? Are you always wearing a black shirt?
That's always a thing, dude. Everyone's always like, "Yo, Sunny doesn't have any other shirts besides black t-shirt." he's like Steve Jobs wears a whole you know what's it called
turtleneck, right?
Yeah, row neck, and then they're like, Sunny wears a black t-shirt every single time.
Zuckerberg wears a blue t-shirt, right?
Yeah, like a gray t-shirt. It saves you time in the morning, guys. So that's why.
Technically, this is dark gray. It's not black, so you're still by yourself, Sunny.
Oh shit.
But anyways, let's get back to this. So that's
it.
the face detection app. I basically just repeated the face detection video, but whatever. So now, that's pretty good. So like, wouldn't a small detector be as simple as just changing this out for a smile and writing the same thing? Well, yeah. Let's try that. I mean, you would think so. You would think so, but you guys are about to see some really, really weird crap, and then really, really cool trick to fix that weird crap.
Let's do it.
Which is interesting. It's a smart thing to do. So let's create our smile detector. Okay. Let's create our smile detector, okay?
Yep.
So did I spell smile correctly? Yeah.
There we go.
Smile detect. So same exact thing. We're gonna be using hard cascade and to detect faces, but we can also use it to detect smiles. Okay. So in this case, there's another file in description. It's just called hardcascade.smile, I think. Let me double check down here. Yeah, hardcascade_smile.
Yep.
And we just use this pre-trained classifier instead. So this took a bunch of images of people smiling with their teeth showing. It doesn't detect like regular smiles that good. It's mostly like teeth smiles from the training data, but you can teach it to do both. But in our case, you kind of have to show your teeth for it to work like really well.
Right.
But that's there. So why don't we just use this instead of the face? Like, because it's detecting the face so well, right? Like it was tracking my face perfectly, and if there's multiple faces, shouldn't it be able to detect smiles too?
Yeah,
supposedly. So let's go down this code and make the changes. Okay, so we get the webcam. Okay. We want to iterate over every frame. We want to read every frame in each iteration, and then our little check, and then frame grayscale. So we get the current frame. We change the grayscale. Now, instead of detecting faces, let's actually detect,
oops,
smiles. Okay.
Nice. Okay.
detect smiles, and instead of on face detector, let's call smile detector, and we want to call it on the same frame, so grayscale frame.
Yep.
And then again, let's just copy this exact code, but instead of and we can use the same variables because this and this loop will never overlap. Like this loop will completely finish before this loop starts, so we can use the same variables, which is fine. Just to
Okay.
keep it nice and clean looking.
Yep.
There's no, if it was nested, we cannot, because then they would get they'd fight over the variables. But loop completes before this even starts, so it's okay to use the same variables here.
Got it.
But instead of faces, let's draw smiles. Okay, so now this is going to be, so this is what it's doing is the same exact thing. It's going to find all the smiles in the image and then return a list of points, the exact same thing. Upper left hand point here, and then the width and height of the smile. In this case, it's going to be like a horizontal rectangle instead of a square.
Okay. So it's returning the same thing, right? The same coordinates, the same format we saw earlier. Okay.
Yeah. Yeah, it's going to look just like this, but instead of giving us the coordinates of faces, it's going to give us the coordinates of smiles.
Go ahead.
It's like just a different rectangle on the image. It's smaller around the mouth, and it's like horizontal looking.
Go ahead.
Let's change the color though. I had a this color.
Okay.
That's the color I chose. This is like a nice red color.
Yeah.
And because right now it's the same color as the face, but I want to change it to this red color.
Go ahead.
Like I said, BGR. So R is at the end. That's why it's so high. So it looks more red because the R channel is the highest.
Go ahead. Okay.
Red. So let's run this, and let's actually not draw the faces. Let's just get rid of the faces. So I'm not even going to draw the faces.
Okay. So we should just see
only
the
smile.
Okay.
Yeah. So not even faces. It should just have things of smiles on my face.
Right. Go
Okay.
ahead.
I mean, it should just have rectangles around the smile on my face.
Yep.
So let's run this. And
Whoa.
voila, as you can see, it's working perfectly.
Holy crap. Okay. So this is what you meant by it's just a lot.
It doesn't work for shit.
Yeah.
Yeah, it doesn't. It does not work, but it does.
Yeah.
And I'll explain that in a second and how that actually works. But as you can see right now, the default, it's like this isn't even working properly. Like what the hell? Like how? Like okay, it's actually getting my smile. Look at my smile.
Oh, it's actually getting the smile. Yeah. Nice.
It's actually getting it, so it's smart enough to find it. But there's a lot of false positives.
Right.
Like it thinks this stuff over here, like this little windowsill is there because it probably thinks this white is like teeth and this is my lip or something.
Yeah.
But I mean, there's also getting things here on the freaking curtain which make no sense. You know, like what? I mean, this may be a little bit too. Like it looks like the upper teeth and the lower teeth, and the little gray line is like maybe the gap between the teeth a little bit. Like you can kind of understand.
Maybe we just built a ghost detector or some shit, you know? Like
yeah, that's what they said in the face detection video or the pedestrian tracking. But
yeah.
Point is, this is working like ass. Okay.
Yeah.
So how do we fix this? It's like this isn't even working. First, let me explain why this is happening. So there's probably a couple reasons why I see what this is happening, and I'm gonna explain both.
Okay.
First thing is, so let's just quit out of this first. So why is this performing so shit?
Yeah.
I realize it's swearing screen. It's fine.
It's fine.
First reason is, to be honest, faces are one of the very first things that people detected from the beginning. That's like the very that it's like the coolest thing to detect to start with, and has like a very defining feature. Like detecting squares or detecting a soccer ball is kind of like, okay, it's kind of cool, I guess. Detecting a face is like pretty cool.
Right.
So there is a lot more data in this trained algorithm than there is in anything else. So there was actually just more face data, and this was just trained better than Smile was to begin with. So that's the first reason why face detection was working so well, because it ran on more data for longer.
Yep.
While this one probably didn't get much data.
Nice.
Okay, just because, yeah, it's like, okay, if you want to have like a left fingernail detector, like there's not going to be as much data as faces, just because faces are cooler. Or like a blade of grass detector, like who codes that?
Yeah.
You don't want to take a vigilante.
And also,
blade.
Guys, like if you think about it, a face has so many features. You have your eyes, you have loads of things which basically are going to tell that model that, okay, we can be sure that that's a face. Whereas a smile has a lot less to look for. Like you just have pretty much like the curvature of your smile. That's why it can easily get confused. Like the lamp behind Aaron has like a little curvature to it, so it could get confused thinking that's a smile. Whereas a face has several different reference points that it will look for in terms of features. So just something to bear in mind as to why you would get that.
That was the second point I was going to make. You stole it out of my mouth. But that is absolutely correct, guys.
Yeah.
It's exactly what I was going to say. Is there's
Nice.
less features. Like detecting a tooth is much harder than detecting a face, because how do you detect a tooth? It's just a flat white thing with like a specific shape, but it's harder to detect.
Yeah.
Like it might get a tooth and a marshmallow mixed up, but it wouldn't get a face and a marshmallow mixed up unless you're the Michelin Man. But or the Pillsbury guy, you know, the little bakery guy. But but yeah, that's the point that Sunny made. That's the second point. So first one is face probably just has more data overall, just because it's a more defining object and it has more emotional connection to humans. So it's like, cool, let's detect faces. But also it just has more data that I can go by to determine, hey, is this a face or not? Versus a smile, you're kind of limited.
Nice. Go ahead. Cool. Man.
So that is absolutely correct. So that's why it's performing like ass. I mean, it could be better. It could be better if they trained it better with more data.
Yeah.
But even then, it's still harder to detect than a face.
Right.
So how do we get around this? Well, first of all, there's different parameters we can tune. So you can actually be like, hey, if something only counts as a smile, if there's like 2 or 3 things around it that are also a smile, because then it kind of thinks, okay, if this area kind of has like 4 smiles detected, then it's a smile. But if it's just one random thing that might kind of be a smile, but there's only 1 instead of like 4, then you can be like, okay, that's not a smile enough. So like there's kind of like a redundancy.
Okay.
Code one more time and explain that visually.
Go ahead.
So like here, we're just getting a bunch of stuff, okay?
Yep.
So but you can see like there's random one over here, they're blipping up every now and then.
Yep. So are you trying to say like
get rid of those?
Right, so in a simple sort of like in a one sentence sort of answer, like rather than checking the entire sort of webcam view, we kind of want to narrow down that sort of selection down to just your face, right?
Not quite there. That's the other optimization I'm going to show. But what I'm saying is, see how there's like random boxes showing up over here?
Yeah.
Like by themselves? We can kind of get rid of all the standalone ones that just kind of flash really quick.
Okay.
But if there's a big group, if there's a big group of boxes overlaid on top of each other, though, we can kind of say the chances of that actually being a smile is a little bit higher. Like up here, we could maybe boil this down to like 1 smile. We could be like, okay, there's freaking 7 boxes here. This is probably a smile. There's 7 here. This is probably a smile. There's a bunch here. This is probably a smile. But these little ones on the sides that are flashing randomly, you can say, nah, we don't want those.
Right.
And we can actually get rid of that.
Is there some kind of sensitivity or?
Yep, that's all it is. It's just a sensitivity number, and you have to tune it to faces. So you find the perfect number, which I'll show you guys in a little bit. But we can actually do that. So let's add that in. Right. And you won't see that much of an improvement here on this, but I'll show you guys the second optimization, which is going to clean everything up and make it go from complete ass to super, super accurate, which is pretty impressive.
Nice.
So detect. So this happens in the detect multi-scale. Okay.
Yeah.
So there's 2 different things called, or 2 different parameters you can use called min neighbors and scale factor.
Okay.
Okay. So let's get these.
Yep.
Up here. Here we go. So this, and let me actually type it out. So this is going to be scale factor.
Okay.
I think I might have spelled it. And then this is going to be min neighbors.
Okay.
It might be the wrong spelling, so it might not work, but let's just try it. So what this is going to do is, it says scale factor. This is an optimization to how much you want to blur the image, because if you blurred this image, you can still kind of tell it's a face if you don't blur it too much.
Okay.
And then if you blur it, that's another optimization on top of the black and white. Okay, you can kind of like generalize, and then you can kind of compare the data a little bit more. Because there's less data, but you can still kind of tell it's a face. So you want to kind of optimize this. Basically, this scale factor is blur. Like how much do you want to blur the image to make it easier to detect faces and kind of like get the defining features and brightness, or not. So the higher this number, then the more it'll get blurred. So I found that 1.7 is the best.
Right.
Then
So just to be clear there, so you're saying essentially to blur the sort of the entire frame, so that way it will be easier to detect facial features as opposed to like a curtain or like a lampshade.
Yeah, because you get rid of a lot of the details, which are unimportant. So like if there was like a 4K image and there's a lot of details, then it can get very confused with the data. But if you blur it enough, you can kind of, if you blur it like a crap load, you can kind of be like, okay, there's kind of a blurry face in the middle, and then everything else is just like a blurred mess in the background. So it actually kind of like contrasts like the objects. So you can be like, okay, there's a face, and then there's a bunch of blurred background. You can't even tell if it's curtain or wall or whatever, but you can kind of be like, okay, there's a face here.
Got it. Okay, nice.
So that's the idea. If you can blur it down more, you can actually detect faces even better.
Yep.
Then min neighbors is what I was just talking about. There has to be 20 neighboring rectangles in total in that little area for it to actually count as a smile.
Okay.
So if this was 1, then literally just everything would be passed through. But if you make this higher, then it's like, okay, there needs to be a lot of redundant rectangles on this one little area for this to actually be a smile. So it's like it found 20 smiles in this little region of the image. Because they're all overlapping, it has 20 neighbors. The minimum amount of neighbors of a rectangle needs to be 20 for it to actually be counted as a smile. So this will help a little bit.
Yeah.
Let me show you guys. And then, well, actually not even at all. Like, well, actually it helps a lot.
Oh, one sec.
More than
Go
before.
back. All right. So there we go.
All right.
Yep. We're back.
There you go.
Whoa.
So as you can see,
okay,
it's actually better. A lot better.
That's a
but
lot
I mean, there's
better.
still a little. Yeah, there's still a few things. So here, yeah, I don't know why it's so fixated on this light. To be honest.
Yeah.
Like, it's probably thinking that this is teeth. It's probably looking for like a horizontal line of white. So it's thinking this is teeth.
Okay. That way, I mean, like you can see why the lamp, but I mean, the top left is a bit of a weird one.
Yeah, but I mean, you can kind of see like this little white oval, and my teeth look similar.
Yeah. So it's probably trying to find like teeth and then the curvature of your mouth. Okay. Got you.
Yeah. So something like that. So that works really, really well. So like a lot of fine tuning needs to be done for things to work properly.
Yep.
So just that little change there, that worked way better than when I was testing it. But I mean, that's amazing. So tuning different numbers can actually play a big role in that. So like maybe like in a real world application, if you're detecting smiles, you would want to save these numbers. Okay. And be like, okay, for smiles, always use these parameters. This is like additional machine learning on top of all the crazy numbers of machine learning that's in here. You have this plus a little bit more. So this is kind of like manual machine learning. You manually went through and tested a bunch of different sensitivities, and you used your eyes to be like, okay, this is actually machine learning. So that you actually taught the computer that these two numbers are closer to a smile than anything else. So this is like manual machine learning that you're doing.
Okay.
Pretty cool.
Yeah. Nice.
Okay. Now going forward, another optimization that we can do is actually get rid of these errors, because like Sunny said, and what I said in the slides is smiles only show up in faces.
Yeah.
So why don't we, instead of trying to get it across the entire frame, just find a face and then only run smile detection within that face?
Yeah.
Because we already did the work of the face detection. So why don't we do that?
That's awesome.
And that's what we're going to do next.
Because
it makes it faster and more accurate.
Yeah, when I first thought of it, I kind of thought that like, oh, we're just gonna slap a model on the entire webcam and it'll figure it out. But guys, you have to be prepared. Like, take it in mind that you there's a lot to process here. Remember, in the beginning, we said like you pretty much have some kind of input, your model, and then some kind of output. So if you can reduce the amount of input going into the model, you can actually speed up the entire thing a lot more. Like, and it's drastically going to be faster, and it's also going to be like more reliable in terms of we're only going to select Aaron's face and then find the smile inside there. So something to bet.
Yeah.
Yep.
Yeah, on the self-driving car live stream we did, the car and pedestrian tracking one, you can see a really good example of this in real time. When we were doing it, because there were so many cars on a highway, so some highway footage, there were so many cars and a lot of pedestrians, because here you're only detecting like 2 or 3.
Yeah.
But in those, there's like 10 cars and 20 pedestrians, so it was going crazy. When you do that one, when you scale it down, so if you blur the image more, it's faster. If you make it black and white, it's faster. and then some other optimizations, you can actually see the footage gets played back really, really fast. So that's a good visualization if you go check it out. Go watch that stream too.
Nice.
It's badass as well.
Yeah, go check
But
that one out, guys. I'm gonna watch that one as well, as well after this.
somebody's not watching my content.
I know. I do. I'm the guy smashing the dislike. I'm joking.
Wow.
Okay.
So Sunny woke up this morning. He was like, "Aaron, I'm really grumpy. I don't want to do the stream." And I was like, "Bro, I need you. I don't have my internet sucks. I need you, man." And then he's like, now he's all in a better mood because he's been hanging out with me. So
It's fun,
The whole
dude. We'll definitely do some more streams. Yeah, this will be cool. We can even probably do some kind of Python React. You know, like hybrid.
yeah, dude, let's do that. We could like tie it together, like do like a cool front end app with JavaScript, and we can have some cool like back end Python stuff like happening like this. You know,
Yeah.
like a front end thing where you click like smile detector, face detector, you know, like car pedestrian detector, and have like you pick like different files and it feeds it in.
Yeah.
Something cool like that.
Exactly. That would be awesome. Aaron, quick question here from Shantao. He says,
Yo.
"Is it beginner friendly?" So just maybe a quick answer to that.
Is this video beginner friendly or is the other ones beginner
Yeah,
friendly?
like just for anyone that's new to the video or who might have joined afterwards, is this video beginner friendly? Like, do you need to know Python before you do this?
Yes, you need to know Python, but if you know like for loops and all the basic Python stuff and how to like call functions, then no. I teach you the rest from there, but I don't teach the basics here. So you got to go learn the basics, then you can come back. If you're a complete from zero beginner, no. If you're just a beginner who knows Python but you haven't coded much, then yes, you can go through this.
Yeah, and
step by
also
step.
just worth mentioning, guys, I don't code much Python, but I know JavaScript. So coming to this is actually super, super simple in terms of how Aaron's broken it down. So if you have any coding experience, then yeah, you can do this. So definitely go ahead and do it. Yeah.
Very straight. Awesome. So I popped back in the faces. So let's do this now. Okay.
Yep.
Let's go back to the terminal and run it again. And now we should have error. Oh, because I commented out faces. So it's giving me an error because I'm trying to use faces here.
Yeah.
When I commented it out, let's just get rid of that and run it again. So there we go. So we got the faces here and the smiles.
Nice. Hey, look at that.
Yep.
Awesome.
But I mean, it's still getting this. You want to get rid of all these random ones.
Yep.
So what we can do, like I said, is we can actually just run smile detection within this window instead of the whole frame, which is a smart optimization because, I mean, in the real world, you wouldn't see a smile out in the middle of nowhere unless it was like a piece of art or like dentures or something, you know. But generally, smiles only show up within a face. So that's why we can do this.
Nice. Okay.
Yep. And then I'll actually show the effectiveness of that too. I'll get rid of these tuned parameters and actually show you how well that works.
Okay.
I mean, it kind of works well, but these scaling factors, the sensitivity plus that little trick together makes it super accurate from what we had before. Just like freaking rectangles all over the frame. But just a single smile, we tune that down from just two little things. So that's
nice.
It's like really smart, clever things to make your code work. Using something that doesn't work and making it work. Just with a few numbers.
Awesome.
Yeah. So let's continue, okay? So how do we actually make it so that we only check within a face if there's a smile? So how do we actually make it so that we only check within a face if there's a smile, okay? So like we said, we're in the global loop here that is looping over the entire frame. We read the frame. So from here, we keep going down, blah, 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 and then we get to faces, okay?
Okay.
Oops, run small detection within each of the faces. Run face detection. So some of these comments might have not made sense the entire time because I kept popping them. So this is what I had before, run face detection. But now we want to actually do this within each of those faces. This is what we're currently going to be installing. So how do we do that? Okay, let's look at it just from here. So we're in the frame, and then we find all the faces, and we have all the boxes of frames. So we have the box of a face. So we have the box of what a face is, and we draw that box, right?
Okay.
But we have this box, so this is actually the box we want to look at. This is actually the sub-image of the whole image that we want to find smiles in. We're actually given it right here.
Go ahead.
So we can actually just be like, okay, instead of looking at the whole frame, just look at this rectangle for the smiles instead.
Okay.
And that's what we're gonna do. So how do we do that? There could be multiple smiles within a face though, right? If, I mean, not technically, but if there's errors, like it might detect like a little before your mouth. So you just want to make sure you find all of them. So what we're gonna do is we're actually going to have another loop in here. It needs to be nested because within a face, you have to find all the smiles.
Okay.
So we're actually going to need to find the XY width and height of each smile within the face. So same thing, we're just nesting it. Okay, does that make sense so far?
Yeah. Quick
The thing
question.
is though, because
Quick question. This is a Python question. So you have are your variable names not going to clash here, or is it going to be in a scope?
they will.
Okay.
No, they will. They will.
Right.
I believe I'm 99% sure. I didn't even try because I thought they would, but I'm pretty sure they will. So what you can do is you could use like capital letters or something. I believe it's case sensitive.
Yep.
But you probably don't want to do that. What I did is just a little sloppy, but I just did this.
Okay.
Just so they don't contend, but it keeps it simpler. Because if you start doing stuff like this, the code starts looking really hard on the eyes.
Yeah.
Because this is so clean, you know, x, y, x plus w, y plus h.
Yeah.
You want to keep it nice and clear. But if we started doing this, then it would look like, you know, freaking x smile plus y smile. Like,
Yeah.
it starts looking like that.
Yeah.
So,
Horrible.
yeah. So I just did this. Just it's a little bit messier, but it's still easy to understand. I just added an underscore to the end.
Okay.
Okay. So we're going to need to look over the face. Okay.
Okay.
I mean, I should probably talk about getting the subset first. Let me go over the logic first. So what we want to do is you want to find in the face. Okay, so you want to find all the smiles in the face.
Okay.
So find all smiles in the face. Okay, so this is what we're going to do. This doesn't exist yet, but I'm just using this as a placeholder thing for right now. This code will not work because it's currently broken.
Yeah.
And then just draw all the rectangles around the smile. Okay?
Or the rectangles.
Just like that. Right. Oh, shut up, dude.
Must be an American thing.
Okay, let me...
Yeah.
So let's just do this so it doesn't break. Oh yeah, I was making fun of your spelling before, right?
Yeah.
Oh god, that's hilarious. That backfired, didn't it? Anyways, so this is the kind of idea. We're gonna iterate over all the faces, and then within each of those faces, we're gonna find all the smiles. Okay, and then we just want to draw the rectangle in there. So kind of similar to what we did here, actually. Okay, the only caveat is you have to change the names here.
Yep.
So why don't we do that actually? Let me just copy this down here. So this is the same exact code as we had before. We just want to draw a rectangle around the smile.
Okay.
Okay. And then instead of X, Y, W, and H, it's just going to be this. Okay. Just add the underscores to the end.
Okay.
It's kind of hard on the eyes, but if you space it out like this, it's not too bad.
So just to bring everyone to speed, right now we had an initial loop which was going through all of the faces, and then so that was the first one on line 28. So I was going through all the faces, and then on line 34, we're going through the individual face that it detects, because you might have more than one face, and then we're drawing a rectangle around that individual face, right?
No. Within each of those faces, you want to find all the smiles and draw a rectangle around all those smiles.
Got it. Okay. Got it.
So what we're going to want to do is we're going to want to actually not run this here. We're going to want to run this. Oops. We're going to want to run this here.
Okay.
Okay?
Yep.
Well, actually not here. That's incorrect. But I need to explain something else first.
Where do we get where do we get the face from? Is that like placeholder for now, or
that's? Yeah, I'm about to explain that. This is the tricky part, and this is the really cool part. So let's just pretend that the face equals this for now. Okay, this code doesn't actually work, but this is what it is in flavor. Okay.
Yeah.
Just pretend this code does not work. This code does not work, but this is the idea. We want the face to be this little mini sub image within the whole image, because this is the current face, like the little square that surrounds the face. So we want this to be like a little image. But the thing is, you can't just pass in like these detect multi-scale and get the smiles out of it. So we have to do some crafty stuff here with the array and slicing. But just this is the idea. Is that clear, Sonny?
Yep.
Okay.
So
if it makes sense to you, then hopefully it makes sense.
You're kind of putting it into an object, right?
Kind of. Well, what we're gonna do is we're actually just gonna slice into the image and get like a sub image in some cool way. I'll show in a bit, but I just want to show the overall logic first before we do that.
Yeah. No worries.
Yep. So let's walk through this again. So yeah, we have all the faces here. Then we draw the rectangle around the face. Then we say, okay, get this little square image instead of the whole frame. Just get this little square. Now within this little square, use that to detect multi-scale. So we want, instead of looking at frame grayscale, we want to actually look at the face.
Okay.
So let's, of course we have to go to grayscale again though, for the same reason. We have to convert this face, because if this was a color image, then we would need to change the face to a black and white color image. Like, actually, let me show you here. This is actually a good thing. So I said step 1, okay, we want to find faces in our image.
Yep.
Okay. Then step 2, get just this, so that we don't have to search the whole image. Instead of searching the whole image, we're only going to search within this face.
And we're doing
that
because we were getting like random sort of findings outside the face.
Yeah.
Right? Yeah. Okay.
Yeah, we're kind of just eliminating everything outside of the face as automatically no. Even if it says yes, it's going to say no, because we know that smiles only show up on faces.
Right.
Okay. Then step 2, we find smiles within those faces, so we're only going to search within these bounds. And then at the end, we'll do a nice little labeling that we haven't gotten to yet.
Got it. Okay.
But yeah, so the idea is the face, this is going to be this.
Okay.
Okay, so this is frame, this is the whole frame, this is the face.
Got it.
Okay, so we need to get this, but it's still color, so we need to make this black and white as well, just the same as the other image.
Yeah.
So let's go back and call, where is it? Let me just copy, paste this. And change it to face grayscale.
Okay.
So face grayscale is going to be the face. So same idea here. We have the face, the colored face, but now we want to change to black and white. So we use the convert color function again.
Okay.
And we pass in the face, the color face. We say change it from color to gray.
Okay.
And save it as face grayscale.
Right.
Okay. Then now in the smile detector, now instead of detecting it on the whole grayscale frame, let's only run it on the grayscale face.
Got it. Okay.
Yep, right there. And now this should be working, but the only caveat is this doesn't exist yet properly. This doesn't actually work. But this is the general idea. So once we have this, then we can run the smile detector only on the face there.
Okay.
And then we can draw all the rectangles around the smiles within that face after we find the coordinates of smiles. So it's actually going to be smiles.
Right, I'm with you.
Now this should be a little more clear.
Yeah.
Awesome. Great. So yep, find faces, draw the rectangles, get the little face, change the little face to grayscale, run smile detector on that little face, then draw all the rectangles on that little face.
Got it.
And that's how we're gonna get this kind of behavior. Okay.
Awesome.
So you can see how there's no red boxes outside of the face. It's only within the face.
Yep.
Yep. You said yep like a bajillion times on the stream, bro. Yep.
All right.
Yep.
I was gonna say,
Yep.
but the one thing I'm kind of confused on. So we have okay, no, I see now, because you're doing it on face grayscale, and then that's where smiles comes from. Okay, no, that makes sense. Cool, got you. Yeah.
Mm-hmm. So yep, you're running smiles on the face. You're not running smiles on the whole frame.
Yeah, that's where I was a bit lost.
Yeah.
Right.
So that's there. So this should work in theory, right? But the thing is, this doesn't work. So how do we do this one little line of code? So this is a little tricky. I'm gonna have to explain it, but it actually is just a one-liner. We can actually achieve this, but I need to explain how it's done. And there's some weird details that I'm gonna explain.
Cool.
So let's get rid of this, okay? Run small detection with each of those faces because we actually just copied that from over here. We just added the underscores at the end so we don't overlap with the variable names.
Got you.
This remains unchanged. Still want to display the current frame and the wait key of 1 millisecond and then release everything at the end, yada yada. But how do we do this, okay? So we have the frame, right? We have the overall frame, but and then we also have the face, X, Y, W, H.
Yep.
So how do we get a sub-image of this whole image? Like if you have a big image, like right here, you have a big image, how do we find this sub-image?
So
How do
you're
we
kind
get
of saying
just
like,
this?
how do I cut out just that image, right?
Yeah, cut out that image.
Right.
There might be like a sub-image function OpenCV, but I didn't want to do it that way because I wanted to show you guys this smarter way of doing it,
Okay.
or maybe a more efficient way. It's a little bit different. So, are you guys familiar with slicing in Python? I mean, if you know the basics of Python, okay.
I mean, I'm new to Python, so even if you run through that, it'd be kind of cool to see.
Got it.
Yep.
Okay, so let's look at this little environment here. Let me open up a Python environment completely separate. You start Python, and this is Python 2. It's fine though. Python 2 is fine.
Okay.
It's the same thing. So let's say we have a list, okay?
Yep.
And let's just call it list. Let's just call it L. Okay, whatever. So we have a list.
Let's call it colors.
Of
colors.
I'm trying to think.
Or people.
Yeah. Colors. Let's do colors. Let's just do red, blue. Blue, green, yellow, black,
Got you.
white. That's good. Okay, so we have six colors here. Okay, this is a good length list.
Okay.
And let's hit enter. Red. Oh, because it needs to be strings.
I was just wondering.
Hello.
I was like, can you do that in Python? I wanted to see if you could do that. Yeah, nice. Okay.
1 second. Yeah, little mistake there.
Right.
There we go. Okay, now we have a list of strings.
Colors, plural.
Got it.
Yep.
Colors.
Nice. Okay.
There we go. So now we have our list, okay? We have a list called colors and it has all these in here. Now, as you know, we can index into colors with a 0 and we would get what, Sonny?
You'd get the red.
Absolutely.
Yep.
And we can index at 1,
Blue.
to get blue, and 2 to get green, so on and so forth, okay? So we can index. Pretty straightforward. In Python, you can also slice.
Okay.
So you can get, instead of just indexing at the first one or just the second one, you can actually get a subset of it. You can get like the first 3.
So you could say
And
like from
you-
point 0 for 2 points forward from point 0, get me like red, blue, green or something like that.
Exactly. We could get like just these 2, or we could get just these 3, or we could get just these 4. It's called slicing because you can slice up the list into like some you can trim it to whatever you want.
Okay.
So the way you do that is you use a colon. Okay, you put a colon here, and then you just put the first and the last. So very
Oh
simple.
my
So
God. It's so nice in Python, dude.
I know, man. That's why JavaScript
Yeah.
sucks.
Slicing in JavaScript is a
But-
little bit more confusing, but yeah, that makes sense. Got you.
Yeah, that's all it is. So what this is saying is, in colors, give me the sublist from 0 to 3. So it'll have red, which is 0.
Yeah.
It'll have blue, which is 1. It'll have green, which is 2. And it won't have yellow, which is 3. So it includes the first one, but does not include the last one.
Right.
So it's going to give us element 0, element 1, and element 2, but not element 3. So 0, 1, and 2. It should give us this as a list
Got you.
when I hit enter. Okay.
Yeah.
Red, blue, green. And when I hit it, that's exactly what you get. Okay.
Nice.
That's how you slice. Of course, if I, what is it? So 0, 1, 2, 3, 4, 5. If I put 5, it would ignore white. So let's try that. It would give us everything except for the white. But if I put 6, okay, then it would actually, which doesn't exist, then it should give us all of it. Or it might break. Let me see if it breaks. No, it doesn't. So there's a safe check. So 6 goes past here, and it'll give you everything up to 6 because this is 5.
Nice.
Alternatively, because this is the maximum list, you can just not give it, and it'll just say 0 to the end of the list.
Oh, nice.
Okay. And vice versa, you could even be like beginning of the list up to 4.
I've seen that in a tutorial somewhere. That's nice. Yeah.
Yeah.
Awesome.
Yep, you can just do that. So this is like 0. This is the same as saying 0 to 4.
Yep.
Just cool stuff like that. One more cool thing I want to teach you guys is you can actually be like from 0 to 6, and you can actually add another colon, okay? And what this is the stride. So if you put 2, it's going to skip every 2.
Oh.
So this would actually give us red, stride of 2 instead of, if it was stride of 1, it would give us every 1, but stride of 2 will give us red, and then skip 1, then green, skip 1, black. So this should give us red, green, black, okay? There you go.
That's insane, dude. I love that.
Right?
Yeah, that's nice. Yeah.
It's cool. So red, green, black. And again, if I put a stride of 3, it would jump in groups of 3. So it would go red, skip, skip, yellow, skip, skip, nothing. It would just be red, yellow.
Got you.
So let's try this. There you go.
Awesome.
And then again, if you did stride of 4, it would go red, skip, 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 black, skip, and then nothing else. So this would just be red, black.
Nice.
Boom.
So guys,
So
like,
that's how you do that.
That's something
Slicing
new, even for
Python.
me, like slicing
Yeah.
in Python. So if you guys found that useful, what can they do, Aaron?
They can send a money request to my request to my PayPal. Yeah, send a money request to my. Nah, you guys can smash the like button. Show us if your minds are blown. Just show us. Tell us in the comments, or if I'm being boring and going over basics. But yeah, guys.
I think that's
if
awesome, honestly, because like I didn't actually know that you
clean.
could do that in Python. So awesome to see how you do that. Nice.
And we're not even done yet, bro. We're only halfway there. Well, look at this. Watch this.
Dope.
So this is called striding. This is called slicing. The first colon is slicing. The second colon is called striding because you wanted to define your stride.
Okay.
You can be like, if a stride of 1 is the same as not having a stride at all,
Yep.
and if you delete it, like having, like we said, it's like having nothing there.
Got
It's
you.
1 by default. The cool thing is you can also reverse a list by using negative numbers. So now, instead of going from 0 to 6, you'll go from 6 to 0, and this will actually reverse the whole list.
No way. Wait.
Oops. Let's try this. There we go. So now it's reversed.
What?
Here, let me actually explain that. So,
Yeah.
actually, this didn't work. I made a mistake there. So 0 to 6,
Yeah.
this determines the direction of the stride. So it's still going to go from index 0, which is red, to index 6 or 5, which is white. But it's going in the right direction.
Should you have done
So you're
6,
starting
0?
from 0. Exactly, bro.
Yeah.
Exactly. Should have done 6, 0 because negative means you want to go in the left direction. So you want to start from index 6, which is really, well, actually, that's incorrect. You want to start from index 5 because remember, the first one is inclusive.
Yeah.
So you want to start from index 5. It'll include it and it'll exclude this last one.
Kodeep
And,
Joshi actually pointed that out in the comments. Nice. He goes, also that reverses the list. Nice. Yeah. Awesome.
Yep. So if you did that, then it'll go through. The reason this isn't going, the first one red at the beginning is getting deleted. Remember, blue, there's supposed to be a red at the end, but it's getting deleted because it doesn't include 0. So you could technically put -1, okay? And then, okay, that doesn't work. But I mean, I thought it would. But if you just if you just omit it and don't have it there at all, then it kind of says like to go from the beginning all the way to beginning, but don't stop at 0, go like 1 further.
Okay.
So this is kind of similar to not when you omit it, you just kind of like go to the end when there's not a number there.
Nice.
So this would be reversing the list.
Dope.
Reversing the list. I've been talking too much. 1 second.
That's really
I got
powerful,
hiccups.
though. That's massively powerful because even in JavaScript, like to reverse a list, you can do. I mean, there are tricks around it, but it's not as clean as that. Like that's really nice. Yeah.
Yeah, so Python makes it nice. For like dealing with complex problems, which happens a lot in machine learning, you want to be able to express these ideas really simply. So this looks simple, but when you have to do like crazy slicing and like 7-dimensional arrays on like different images of like things, this adds up quickly. So it's difficult in Python and impossible in JavaScript. So that's why Python is the best, honey. You can cross over.
Oh man, if we do a collab like a React that Django, it's gonna be like some
It's gonna be bickering the whole time.
fist fight the whole time. Like ES6 is better than this fucking slicing shit, bitch.
That's what I thought, bitch.
Nice.
But yeah, so that's slicing and striding and using negative strides. Okay, so very, very cool there.
Nice.
So we can do that, and then of course we can omit both of them. And by default, because it's negative, it'll just start. Because it's negative, it'll start from the rightmost spot and go to the left. Because negative means going to the left. So this will also work for reversing a list. So this is how you can reverse any list in Python with one little line. So you have colors.
Yeah.
And then you have colors at -1. So this and this are reversed.
Got you.
Cool stuff.
Awesome.
Now I'm going to talk about slicing multi-dimensional arrays, which is what an image is. You can actually slice an image by using the same thing and just get a sub multi-dimensional array from that big array by using the same thing.
Okay.
So that's why this is relevant. So let's say you had a multi-dimensional array, because this can be kind of hard to explain visually with this example. Okay, let's quit out of this. Okay, clear, seller, clear, and then let's go back into Python. Let's have a multi-dimensional array. Okay.
Yep.
And let's have 1, 2, 3, 4. Okay.
Yep.
5, 6, 7, 8.
So this is one array with 3 arrays inside of it so far. And 4.
Yeah.
Okay, we've got 4 arrays.
14, 16. So this should be like a it's gonna be kind of hard to do it in here. Could you have like a new line on here? No, you can't.
I mean, if you log it now, if you do M array.
Actually, let me I kind of want to explain this. I don't want to start editing stuff in here because it might get confusing.
Yeah. Also, guys, I just wanted to say we just are nearly about to hit 800 likes. So massive thank you, guys. And if you haven't already, smash a thumbs up because Aaron's about to drop some knowledge on Python tricks and tips. Nice.
Holy crap. Actually, let's just try to jump into the code. I feel like people probably understand slicing enough at this point to like translate over the ideas. Like I don't want to drag on too long because I spent 20 minutes explaining slicing.
Yeah.
So this is the goal. We have a frame. We have a face in that frame with our coordinates. How do we get this as an image of here as a sub image? Well, we can just use slicing with these numbers to slice a portion of this frame, which is just a multi-dimensional array. Okay. And that will actually give us an image instead of just this point, because all we have is points, and then we're actually drawing a rectangle on it ourselves. Up here, we're just drawing a rectangle around it, but we actually want to get like the full image, like all the pixel data of this bounding box.
Okay.
So the way we do that is, instead of doing it this way, we actually want to have the face be a slice. So what we want to do is we want to take the frame.
Yep.
Okay. And for a multi-dimensional array, you can actually slice in both dimensions. So what we could do is we could be like, okay, from 0 to the end in the x dimension, and from 0 to the end in the y dimension.
Whoa.
Remember how to slice?
Okay.
So this will just say get the whole frame. This is actually the same thing as representing the whole frame, because from 0 you're getting every single column and every single row and every single column. I'm getting the x and y confused. I gotta double check which one is which, but we'll try both. And we'll learn together. Okay. We'll refresh together. But one is x and one is y. And of course, if you had like a three-dimensional thing, then you could even slice it in 3 dimensions. Like if you had a cube, and then you want to like find like some subset, some cube in there or some rectangle inside there, you could also slice that way.
Okay.
The idea is this: 0 to the end and 0 to the end. This will get us the full frame. So you can probably see where I'm going with this. All we really need to do is just utilize these 4 numbers to actually define the exact frame, the exact subframe of the full frame that we want.
Okay.
Yep. And so that's really simple. I mean, all you want to do is just slice. So where do we want to start? So from the beginning, the top left corner of it is going to be x.
Yeah.
Okay. And then x plus width.
Okay.
That's it. And then in the y direction, we're going to have y and y plus height. That's literally it.
Okay.
So we're going to slice this whole frame and get the subframe of x plus w, and y plus h But I'm pretty sure this is backwards. I think y needs to come first. I think I just eliminate something. So I'm pretty sure y has to come first. And then, of course, if we had a z coordinate as well, you would want to do like z and then z plus depth or something. But we don't have this. We're not doing crazy like 3D modeling here. We're just doing images. But I mean, I'm just showing here that you can do this. One thing I do need to point out, very, very, very important, is this does actually not work. This does not work in vanilla Python.
Oh,
the
right.
reason this does work
Yeah.
is because OpenCV is built on NumPy, and NumPy this works. This works in NumPy. NumPy is a library for dealing with numbers and matrices in Python, very powerful, and it allows you to do cool stuff like this. But this is not in vanilla Python. So that's why in this terminal, it wasn't going to work, and I didn't want to explain it here because this wouldn't actually work. You would need to import NumPy, which is just NumPy like that, okay? I mean, I guess I could have defined it here. So let me actually show this a little bit.
Yeah, because I
so-
kind of get it, and then there's a little bit of a gap. So yeah, it'll be handy to go through this. Yeah,
Yeah.
got it.
I think there's like a pretty print in NumPy.
I think it's, isn't it? Oh, printf is variables. Isn't it?
Yeah. What is it? What is the NumPy nice print method? How to pretty print a NumPy array without scientific notation.
Also,
Print,
for those of you
curious,
asking if this live will be
question.
saved, yes, this will be available afterwards. All of the live streams are available afterwards, guys.
Yeah. Format. I mean, there might not be a pretty way to print it. That's the thing. I didn't think there was. That's why I can't remember. Let's try a bigger matrix. Yeah, you gotta do some crazy stuff.
Yeah.
Actually, let me just have like, is there like a grid of numbers? Maybe
What are we trying to show right now?
you wanted to see how this is getting sliced, right?
Yeah. I think maybe we could do it here. I think it might be clear on just on the terminal.
Okay. The thing is, I don't know how to print. Okay, or let's just try it. Yeah, let's just try it.
Yeah.
From here. So you guys can kind of see like it's not nice and formatted like vertically. I was hoping we could like because this is a 4x4 two-dimensional matrix.
Yeah.
Because we have a list of length 4, and each of those there's a list of length 4 in those. So it's like a 4x4 box actually if we layered these on top of each other.
Okay.
But we can actually slice, like I said, using the comma and colons.
Somebody said np.array. I'm not sure if
np.array.
you heard of
That's
that.
what it is. Yeah, you just print np.l.
So thank you, Kodeep Joshi, for
Okay.
that. So he says np dot array and then open parentheses and then square brackets inside.
Wait, what? No, I know what he's saying. It's coming back to me.
Yeah.
Because I haven't used NumPy in a few weeks, so I kind of forget it. Can you type it? Is it in the comments?
You could do 4-line in array.
But I don't know. I don't want to iterate over it.
Yeah.
I think it's array.l or something. NumPy pretty print array. I mean, we're back here.
Somebody said
What did he say exactly?
Somebody
Line by
said
line?
Somebody said import numpy or numpy as np first, and then you'd end up doing numpy.array. So you could do numpy.array.
Dot array.
So do numpy.array.
Oh yeah, because you import NumPy.
And so numpy.array.
Or just
No,
just
I think you
print
do numpy.array and then open parentheses L.
there we go.
Hey,
There we go.
thank you guys. That is awesome.
I thought it was pretty print, but I mean that's the normal.
Yeah.
All right, there we go. So this is what I was talking about. We have a double two-dimensional array here.
Yeah.
4x4. So this is easier to visualize than I was trying to do from the beginning. So
Yeah.
Oh god.
Guys, I think he deserves a thumbs up for that.
But terrible.
Oh.
We'll hire him, have him teach it.
Yeah.
NumPy master.
Nice.
I don't know why it wasn't popping up because I remember it's something simple with the array, but they're iterating through all the crap. I'm like, okay, I don't want to have to do all that again.
Nice.
But anyways, so here the way we can slice this is you can go by the y dimension, then the x dimension. So let's just slice this. So let's start with the y dimension. Let's just get the first two, okay?
Okay.
So this is the first dimension. So what we're doing here is we're getting the first element and the second element. So in this over array, we're getting the first element, which is this list, and the second element, which is this list.
Okay.
Is that clear?
Yep.
And now, so we're getting this. Now, what if we wanted to get like this 3, 4, and this 7, 8 as like the sub array of the whole thing? Then all we want to do is just pop in a I don't know, maybe.
Oh, I think we, Aaron, no.
So the element 2.
Oh wait,
you want to go from element 2.
we're back. Okay, we're back. I think I lost you for a second, Aaron.
Did we lost the stream for a sec?
I don't know if it was.
Okay.
I think it was Skype. I think it might have just been Skype.
Oh, it just broke down for a sec.
Yeah, we're good. We're good.
Anyways, so if we have the first two elements here, slicing from 0 to 2, 1, 2, 3, 4, and 5, 6, 7, 8, we're essentially getting these first two, the first and second elements, because 0 up to 2, but not including 2.
Yeah.
Now, if we want to get this subarray, 3, 4, 7, 8, then we're going to need to further, well, actually, let's do this subarray, 2, 3, 6, 7, okay? How would we get this out of this whole thing?
Okay.
Well, again, it's just going to be a simple slice. But within each of these arrays, this is element 0, and this is element 1. So we want to go from element 1 to element 2, but this isn't included. So element 3 will give us these two, if we say element 3, right?
Yeah.
Does that make sense, Sonny?
Yep, we're good.
So we're in this, but I think it might be backwards. Yeah, it's backwards. So when you're adding dimensions to the array, you need to actually go in reverse order. So it's going to be like this.
Okay.
So this will give us from these two to these two, and then also of these first two arrays.
Okay.
I believe.
Yeah.
I mean, it might break. Indices.
Do you have
Must
to
be
use
integers,
NumPy?
not too. Huh?
Do you have to use
OpenCV is built on NumPy.
Yeah, but
I mean, will they utilize NumPy?
OpenCV is, but you're inside of
Yeah, that's what screwed me up. Yeah, because I need to call the NumPy stuff.
Yeah, so it
Just
might be
rusty on it.
NumPy
dot
array
yeah, NumPy dot array
L, and then you do what you did.
L. Yeah, because it's a NumPy, right? Getting turned around over and over. Still not working. I should have brushed up on my NumPy syntax before this. I wasn't expecting to show it in here. I was just gonna show the OpenCV part. But all right, okay, guys, let's investigate together. So whenever you forget code, just go to Google and figure it out. How to display NumPy subarray. I mean, it should work. I don't know why it's not working, because it was working in the OpenCV here.
Oh, maybe you gotta do actually no, that's gonna work.
Frame, the face, NumPy array. Well, let's display the type. So this should be a NumPy array. So let's print the type. Just make sure that typing is all correct. So when we actually have
somebody said store that in a variable and then use that. So I think what we need to do is
memory thing.
Yeah, but even you see, have it as you had it before. So numpy.array, but have the square brackets outside the parentheses.
The square brackets outside the parentheses.
No, so you know where you've got numpy.array L. Yeah.
Yeah.
Do that and then have the square brackets outside the parentheses.
Outside the parentheses? What do you mean the square brackets? Like
so do numpy.array.
Yeah.
L, and then outside that bracket. So have L inside the brackets.
Yeah.
Outside the brackets have square brackets. So now on the right. So on the right, put the square brackets and do 1302. Will that work? No. So outside the parentheses.
Outside the parentheses.
Yeah.
Oh, just index like this directly. I think this might actually work.
No. I was saying so have numpy.array L. Yeah, and then change them and then get rid of the parentheses. Just make square brackets there.
Oh, dang, dude. Coding in this terminal is terrible.
Yeah. No, yeah, like that. Maybe that will work. Yeah. Hey.
There we go. Okay.
Because then you're doing it on
Freaking
the
numpy, you
object that
guys.
you're getting back.
Yeah, but I mean, this is also wrong. This is indexing it wrong. You get all turned around with these numbers. Okay, let's try the other way around. 0 and 2, 1 and 3,
Okay.
2, 3, 6, 7. Let's see. There we go.
Nice.
All right, we finally got it, guys. So the ordering is, if you wanted to get this subarray, then in NumPy, using raw NumPy, if you're to do it, then you need to use NumPy.array, get the list. So this is, because L is just, what is L? L. Yeah, L is just a raw Python list. Okay, so we have to convert it to an array here. Yeah, you have to explicitly convert it to an array by using NumPy.array. Change this, and then once it's in NumPy form, then you can index it. Like I was saying, you can't actually do this on vanilla Python.
Yeah.
So that's where, not enough coffee, man. I ran out of coffee.
And now, and what we're doing with that indexing is we're saying get the first and second array inside of the sort of overall array, and then we're saying slice it to get the first and second items.
Yep, first and second in the y direction. So in the y direction, going top and bottom.
Yep.
Then we want to get the first and second, and then in the x direction, you want to go from index 1 to 3. So we're getting these two, and then from 1 to 3, it's going to be these two. And that's how you...
Benit Dekal says Sunny is also becoming pro in Python. Hey, let's go.
Yeah, but not as pro as the guy that was helping me out, because I'm just here forgetting about NumPy.
Yeah.
It's been a bit. But...
Oh. I think we lost Aaron again.
But just treat...
he's back.
This array.
I think I lost you for a sec, Aaron. We're back.
Oh my god, this internet, man.
Also,
Can you hear me now?
want to add a comment here. So Saurav Rajput says, "Hello there. I recently joined PWJ community. It's awesome, and I'm really excited. Welcome, dude. I love seeing our own students on the streams. We can see you here. Nice. Let's carry on, Aaron."
So here, this is casting list, this Python list.
Okay, Aaron's internet is being a little janky, or is it me? I'm not sure if it is. I think it's connecting. All right, now we have
it. Did it cut the stream?
No. I don't think it's cutting the stream. I think it's it's
okay, good.
Type, yeah.
So
carry on.
Just lagging.
Don't worry, let's carry on. Yeah, we'll carry on.
Sunny?
Yep.
Okay, got it. I think it's a shoddy connection.
Yep.
I can't hear you, man.
You can't hear me?
Okay, cool. So, no, there's a lag. I think there's a huge lag.
Okay. Oh, we've lost Aaron on the stream. Okay, so Aaron, do you want to share your screen?
Yeah, can you hear?
Yeah. Bear with us, guys. Little bit of an internet moment. I'm not sure if it's Aaron. Okay, I think we're back. I've got you now. I've got you.
Can you back, Sunny?
Yep.
All right, good. Yeah, I think there's an internet hiccup there. Can you hear me?
Oh, dude,
there was a lag before.
Yeah. So can you hear me now?
Yep. Okay. Well, what's happening?
Yeah, we just got a 50, I think it's Mexican dollars super chat from Jessica Apolinar saying, "I love your streaming. I don't have lots of professional experience in Python, although I'm fond of learning and build my personal projects." Huge thank you, Jessica. That's insane. We massively appreciate you watching this, and yeah, hope keep on enjoying the content. That's insane. I love that, especially when we just had some streaming difficulties, but we're back. Nice. Let's go.
And coding difficulties.
Yeah.
I'm running on 3 hours of sleep, bro. This is not good. Why did I do this? But what was I saying? So yeah, here in the NumPy, I ironed this out. So the issue I was making was this is a Python list. So you got to make sure NumPy list. So you got to pop into the array function, and then from there you can slice in this manner. So what I want to make that parallel here in OpenCV, it's much easier because everything is a NumPy array by default. Like the frame here this is a NumPy array, so we can just slice it normally. Instead of having to do the whole NumPy, you don't have to actually make a NumPy array yourself.
Okay.
But I'll try not to forget that again. But yeah, so this NumPy array, and then we slice it like this. And again, so we're gonna do the Y direction first and X direction second. So this is actually the correct way of doing this. Coming back to our application.
Okay.
So let's delete this out, and the sub frame.
Yep.
Using pi n-dimensional slicing.
Nice. Okay.
All right, that might be kind of big, but there we go. Yep. So OpenCV built a NumPy, super powerful, and going forward, this should work. So let's walk through this again, just to touch base again, because that was a long ass tangent. These streams go on way too long, son. It's once the breakfast.
Don't worry.
But yeah, so we get all the faces.
Everyone's sticking around.
We find the face within the frame. Yeah, I can't even see the stream because I'm just in my code, but I'm trusting you, Sunny. We have like 2 viewers, right? 2, maybe 3?
We got about 250 people, dude, watching.
Dope.
Yeah.
Lag is super bad. Like you reply like 6 seconds.
Yeah, I know.
But it's okay.
Yeah, it's just keep going. We're good.
All right, Sunny. I don't know if it's a. Holy crap! This internet, man, is really killing us. Anyways, so I'm just gonna keep talking, and that way it's like So we get the faces. We find the frame. We use NumPy slicing to get just the face, and then we convert just the face to grayscale.
Yep.
And then once we have just the face at grayscale, then we can run the smile detector on that little face, and then print all the rectangles around those smiles. And this out of here.
God damn it.
There we go.
Yep.
We there?
Yep, we're there.
We're there, Sunny? Awesome. So quit out. Let's run this one more time and see if it works.
Hey, dude. There we go.
Got it. Something's
slightly.
yeah, I have a bug. So
I think the X and Y
as
might
you
be
can
off.
see, yeah. So this is the one last thing I want to say. The error that's happening here is, so we're finding the faces, right? We're finding the faces. We're drawing the face. We're drawing a rectangle around the face. Okay, we're drawing a rectangle around my face. That's the first step.
Yep.
Second step is we're getting the face here. So we're creating the subarray, and then we are searching for the, we're making a grayscale, and then we're searching for the smiles within that face. Once we get those coordinates, those are correct. The issue is we're actually drawing the rectangle on the frame instead of on the little face. So the reason here is we're getting coordinates. So within the face, it's a little square, right? It's a little tiny square.
Yep.
When we run smiles on this little tiny square, we're getting some coordinates back. For those smiles. Does that make sense, Sunny?
Yep. No, it makes sense.
So like, actually, it might be easier to explain here on the here. So here, holy crap. Here, we're getting the face first, and then we get the sub image, and then we want to find the smiles in here. So the thing is, because this is the sub image, the XY point is actually pretty small. It's starting from here, and we're going to say, okay, go down this much Y and go across this much X. This is the top left point, and this is the bottom right point, and we can draw this. The problem is, I was actually drawing this rectangle based on these coordinates. So this was offset way up here in the left. So it was actually taking this Y and this X and drawing it on the big frame.
Oh,
when we actually want to, we actually want to draw it within the little face. So how we fix that? I mean, this actually doesn't matter too much because we're going to get rid of it and show small anyways, but just for educational purposes.
Yeah,
And so
I think it is
redeem some
important.
of my
I think it
dignity.
is important. Some people might want to show that draw rectangle, you know? Yeah.
Yeah. So what we need to do is in Smiles, when we draw the rectangle, instead of drawing it on frame, right, we actually want to draw it on the face. So we take this sub image and we draw it on the face, because before here, when I smile, see, it's drawing it like if you took this green square and put it in the top left, you can kind of see that that's where my face would be, my smile.
Got it.
You see?
Yep.
Yeah, so we're just drawing it on the wrong frame.
Right.
Now, if we go back here and we quit out, just interrupt that, then we can actually draw it on the face instead.
Nice.
So this is another thing I want to say. So the face is actually just a subarray of frame, like I said.
Okay.
But the thing is, when you slice like this, I believe you're actually just accessing the actual memory of this full frame. So you're not making a copy. You're not like saying, oh, this is a new subarray that's equivalent to like this little range, but you're actually saying, just get me this portion of memory in this weird slice, because you have direct access to the memory like that with NumPy.
Okay.
So if I change this data within here, if I change the data of the frame within here, then it'll actually change it on the main frame as well, because we're just saying, okay, this little slice of the whole frame. This editing this in here will also edit this, which means editing the face will still edit the frame. So we can draw on the face, which will work. If you draw on the face, then it'll actually also draw on the master frame.
Okay.
Even though we're not drawing on the frame. So that's how that works there. Because when OpenCV draws a rectangle, it's actually just going into the memory and just like changing the memory there.
Got you.
Yep. So now let's try it one more time. And
oh, hey,
there you go.
Nice. With that said, guys, we just hit over 850 likes. Let's push that to 900. And if you found that cool, and Aaron, guys, Aaron just debugged everything in front of you, so I think he deserves a smash the thumbs up button and just some
the NumPy nightmare, man.
Yeah,
fucking syntax NumPy nightmare.
Exactly.
That's the one thing I hate about NumPy. I wish they had some nice, like, easier syntax but it's all like function based. That's the one downside. But I mean, NumPy is awesome.
Yeah,
I used to use it a lot. It's cool.
You fixed it, exactly. So that's the main thing. Nice.
Thanks. With help from the community.
Yeah.
Shout out to whoever that was. I couldn't find it on Google, and I was like, I give up. not important. Run away. But anyways, from here, now though, but I mean, this is cool. But I mean, this is kind of just like the same as face detection or car pedestrian tracking. But it's like outlining it. But I think it'd be more cool if it like just detected that I was smiling and put the word smiling underneath. But I think it'd be more cool if it like just detected that I was smiling and put the word smiling underneath, because you're only concerned with smiles if it's like a face. You're like, oh, this face is smiling or this face is not smiling.
Yeah.
So I think it's cool to do that instead. So let's do that next.
Nice.
Let's quit out of here. And the very last thing we're going to do is, instead of drawing this, okay, instead of drawing the rectangles around the smiles at all, we're not even going to do that. We're just going to completely ignore drawing the rectangles. I mean, it was relevant because I wanted to show you the cool little like offset thing, how the memory is actually being saved here. When you slice, it's the same exact memory. So it goes into the same memory and changes it. But I do want to show you how to put some text. So I want to avoid another syntax mistake. I'm the master copy paster.
Yeah, I think it was massively valuable to show them how to draw the actual smile, because then it gives them context as to what we're going to do next.
Yeah, so I got rid of drawing the smile because I don't want that there. But now I pasted this ugly looking thing here. Yeah. So what this is now, instead of drawing the rectangle around the smile, I want to actually draw the word smile. Write the word smiling. Okay, I have it right here, smiling, underneath the little portion. So like when I go here, you can see smiling pops up for a few seconds. That's what we're going to be doing now, instead of having the red.
I think you're going to have an error because you said if smile length. if length of smiles, so go back to the code. Is it meant to be plural? If length of smiles, because you've done smiles array.
Yeah, I think so. Yeah, so length of smiles is greater than 0.
Yep, nice.
Yeah, because let me just double check. Yeah, because down here I think I used
You must have used,
yeah, I
yeah.
used smile singular. Yeah, so yep. So yep. So pretty much all I'm gonna say is if length of smiles is greater than 0, because remember smiles is a list of all smiles it found within the face. If it's greater than 0, which means there's one or more smiles, then we're just gonna put some text on the screen. So this is very simple. This whole thing here is just displaying the word smile at some coordinate. So similar to a rectangle, it's CV opencv.putText. We're gonna put text on the frame.
Okay.
And that's the first thing, the image. The second argument is going to be the words you actually want to put. So I'm just gonna put smiling.
Yep.
Or you can put like why so serious or something.
Okay.
And then next is the location, the top left point of where you want to display the text. So in my case, since I want to put the word smiling just outside the green box of the whole face, I'm gonna use the green box coordinates.
Okay.
Okay. So I want to put it below it. So the x coordinate will be the same, but the y coordinate will be y coordinate plus the height.
Right.
Okay.
So I'm just gonna actually draw this as you do it on the screen, yeah, because I think it might be handy.
What?
So carry on talking over it, and I'll draw like as we do it.
I have it here if you want
Oh
to.
yeah. We do it. We can
I
use
can
it.
explain it here.
Yeah, let's do that. Yeah.
Yeah. So we have the coordinates. So we know this picture is smiling, but we want to put the word smiling down here. Instead of having this, we want to have this.
Yep.
So if we have, we know this is a yes, so we know to display smiling. Then, but how do we get the coordinates of this? So we have the coordinates of the whole face, which is what we want.
Yep.
So why don't we just use this top left point to figure out how to get down here? So we have the top left point, which is x. So we can just say at x is where you want the top left point of the text to start at x.
Yep.
But then the y point, we don't want it to start here because it would say smiling up here. So we add y, this is y,
Yep.
plus h, plus the height.
Right. So it
y
gets y
plus height,
and then we're saying plus the height, which is this. So like y,
which is
plus
going to
the
be right
height.
here.
Yeah.
And then I added 40 just to have a little bit, so it's not touching the box.
Right.
I just added a little bit, and then that's it. So this point is going to be x, and then y plus h plus a little bit more.
Right. So you guys
And then
can see
that'll put it right here.
exactly. We have x and y in the corner. Just go back to that side for a second. So we got x and y in the corner, and then we're doing y plus the height, and that gets us to the bottom of the box. And then you see Aaron's
here.
got smiling exactly, but if he didn't add the 40, it would be sitting on top of the green right now, or pretty much on top of it.
It would just be touching. Yeah.
So we want to add 40 to basically push it past that little bit extra. So yeah, awesome, nice.
Yep, and that's really it, guys. So as you can see, that's going to be the x is the same, and then y plus h plus 40 is right there. So that's the top left point over the text is going to start.
Yep.
Then from there, font scale is just the size of the font. So size 3. And then the font face is just the font you want to use. So OpenCV has different fonts. So that font is called font_Hershey_plain. It's the one that looked the nicest. You're kind of limited on the fonts, but I mean, it gets the job done. And then last is the color. So BGR again, but all 3 are maxed out. So this will be white, because if all 3 channels are at maximum brightness, 255, then it'll just be white.
Nice.
So if we run this, hopefully with no hiccups.
Whoa, before you run it, we actually just got a super chat from Velocity Trading. He says,
Nice.
My girlfriend introduced me to your videos. She is a data scientist in NVIDIA, and she loves your content on React.js. Shout out to her, Princey Singh. That's amazing.
Nice, Sonny.
Yeah, thank you. Yeah. And look at that. How crazy is that? It's like 2 worlds came together.
Yeah.
React.js. Now we're talking about data scientists, where the majority of data scientists code with Python. So yeah, this is dope. It's awesome.
Yeah, man. You should do a collab with her. Do like a React data science project.
Yeah.
But
nice.
Awesome. People are showing Sonny the love, the Hulk. You should demand people in the comments call you the Hulk. Anybody who wants to call Sonny by the Hulk, pop that in the comments right now. Going forward, we'll legally change his name to the Hulk, because he can handle anything except standing.
We have Papa React. We have the React God. Now we have the Hulk.
The React God.
Nice.
React God. Nah, it's just Hulk. Just Hulk. The British proper Hulk. But where were we? So yeah, so we're gonna draw smiles underneath the face instead of actually drawing the box. But let's put both for now, for demonstration purposes.
Nice.
Let's run this. There we go.
Hey, nice. That's awesome, dude.
Yeah.
It looks a bit like that
Yeah.
horror game, you know, that Slender Man. That's what the text looks like.
Yeah.
Yeah, that's
Oh,
awesome.
the Slenderman text.
Yeah, the smiling, I mean. That's awesome, dude.
And then now, if we just get rid of the, drawing of the rectangles, then it should work.
Nice. Guys, if you find that cool, because it is like, look at this. Look, if now we should see no rectangle, but we should see the smiling, which means that we have that finished sort of, hey, look at that. That's nice, dude. That's awesome. And even if we have two faces on there, because we have that loop, it will actually go ahead and do it for a second face as well, right?
At will. Yeah. So let me just get.
And guys,
I wish there was a way to get your face on the screen too, but the stream tech kind of limits that. But
yeah. Let's go ahead and see it. Hey, look at that. Nice. That is awesome. Guys, if you think that's cool, smash the thumbs up button. That is awesome. And if you haven't already, and you are following me and Aaron on Instagram, go ahead and shoot us a story right now. So this is my tag and this is Aaron's tag right over here. So my tag's over here. Aaron, you just point somewhere down and you'll see it. Yeah. So go ahead and shoot a story and yeah, tag us in it and to let us know that you're watching. And yeah, we can have a chat with you guys if you found that cool. I think that
yeah.
like it's so impressive. Like how many lines of code was it in total? Oh shit! Even when you zoom in, look at that. And guys, that's a really good example, bro, because that's showing the actual dynamic width and height changing.
Yeah.
Yeah, that's awesome. That is dope.
Cool shit, man. Cool
we
shit.
almost hit 900 likes as well, guys. That is insane. Thank you, guys.
But yeah, guys, that's pretty much the completed app. I mean, there's other things you could probably do to clean up the code. You could probably pop some of this stuff in a function. I just kind of blobbed it all in one go. So not very good code design here. But other than that, yeah, I mean, we went over using the face detectors and smile detectors using XML files, which are pre-trained. If you want to learn how these actually work, then you can go watch the other streams for the actual algorithm of how that works. We captured the webcam footage. We're iterating forever until we're done with the webcam footage. We're reading every frame one by one, and then for the current frame, we are doing a quick check to make sure the frame is good to go. Then from the frame, we're creating the frame grayscale so that we can optimize it and we can speed up the process and the calculations. Once we have a grayscale frame, then we find faces within that frame. Then from all the faces, we want to actually draw the rectangle around each face.
Nice.
And then from each face, we want to create the subarray using the NumPy slicing here, which is NumPy under the hood. So we got the little subarray here, which is the same data in memory as the regular frame. So when we edit this little subarray, it's still going to edit the main frame.
Yep.
The main frame. then we change the face to grayscale, so we can run smile detection on the face, and then from there, once we have that, then we can just label it as, hey, we found a smile, instead of drawing the rectangles.
Right.
So
remember, guys, what we did that nested approach for when we were drawing. Where did that happen again, Aaron? So where we avoided doing it for everything, we did it for just the smiles. It was line 38, right?
Yeah.
Yep. Nice. That's so cool.
And then we put the text there, and then at the end, then once we found the face, drew the rectangle, found the smiles, wrote the word smiling. Once we've done all that and we've edited the complete frame and all the correct rectangles and words are on the frame at the right locations, at the very end of all that, at the end of the detection, we use cv2.imageShow just to show the frame, and then we wait for 1 millisecond, and then we repeat to the second frame. So all of that's happening every single frame, all of this code.
Dude, it's insane. Like, if you actually think about it, like, let's say we went ahead and got rid of the comments and we got rid of everything. That's so little code to get that powerful functionality happening. All right, so let's actually do that. Yeah, so let's make this super optimal. Nice.
Yeah.
Guys, drop in the comments how many lines of code you think this might be. If we can do that before Aaron gets to the top. I'm gonna say maybe like 30. I'd say 30 maybe. I think it'll be like around 30. This is insane though. Like, if you was to do this kind of thing in like JavaScript, you would have to write more. And I'm a big fan of JavaScript, but I will say it firsthand. Like in Python, you can get a lot of power out of this with just having a small amount of code. So that's dope. Oh, we're getting okay. We're near 30. Near 30.
Anybody want to put money down? Sonny?
Yeah, let's do it, dude.
22, bro.
Oh, damn.
I mean, this doesn't even count. This doesn't even count.
Holy crap, that's insane.
And actually this, because it's just a break statement, you could probably get away with doing this. I mean, probably not good, but I'm cheating because I just want to.
That's insane. We have machine learning, AI, everything invoked in there at like 22, 21 lines of code. So we got, oh, Manan Shah was close. He said 25. Abbas Abdilia said 32. Young Ibsek said 31. Guys, it's less than we all thought. Like, somebody wrote 1. I don't think we can do 1.
I mean, just pop this in a function, you know? Just call
it
smash function define.
That's insane. I love that, dude. That's so cool, man. Like, yeah, that's awesome. And guys, I think this also goes to show you how yeah, there you go. That's the hack to everything, guys. 1 line. Nice.
I'm doing it, bro. I'm doing it. 1 second, just for that guy, because I got nothing better to do with my life.
I see a lot of people saying like this is like calling the Haar Cascade AI isn't really AI. Guys, anything where when you have a classification model that is that comes under AI, and trust it, take it from a guy who's done a master's in this stuff. Like, it is that is what we classify as AI. Yeah.
If you wanna go see how these are actually generated, because we did just download this and just used it. But if you want to actually see how you create this, like how you can train anything to like recognize what Pepsi cans, recognize coffee mugs, whatever you want, then I explained that in the face detection video. This is like an extension using smiles, but I explained that in face detection and the car and pedestrian tracking of like actually how the algorithm how the computer actually learns this. Like, how the hell does the computer take an image and know? How does the computer use its brain to figure out what it is? So I explained that there. But it is AI because this is how computers can learn. It's not just random stuff.
Yeah, and that's the powerful thing, guys. Like, once you have trained models, and like a lot of people, I think even in Firebase, there's a bunch of like trained models that you just have access to, which I'll be dropping some videos on. So thumbs up if you're excited for that. But yeah, like you can pretty much go ahead and use guys, to train a model by yourself. You need
takes a long time.
Yeah, you need a massive amount of data. That's why things like Tesla, everything gets better over time, because you get more data over time, which means the model can get more accurate.
Yeah, so like it's not super feasible for us to train our own. If you understand how the algorithm works and then you utilize it, that's really all you need to know to innovate. I could technically go and get faces from the internet, a bunch of different faces, a bunch of different smiles, and find those pictures and trim them all myself, get the data set, and then run it through some training software to do it. But then even that's just an extra step of just taking images, plugging it into this thing, and then going up. If you actually want to code up this algorithm, that gets pretty deep and nasty. I did that at my schooling at Georgia Tech. It's interesting and fascinating, but it's a big headache. So like, why reinvent the wheel? So we're doing that here. But if you want to get down in the nitty gritty, then by all means go through it. There's a free computer vision course from Georgia Tech on Udacity. You can look it up. It's called Computer Vision. They talk about all this stuff in complete detail. They talk about other object tracking like Kalman filters and CNNs, which are convolutional neural networks, which is another way to do like tracking and object detection. But Haar Cascade is just the simplest way that I'm showing you, because you just download this one file and then you pop it into OpenCV, and it's all nice and free and easy to use.
Exactly.
But
yeah,
if you do want to get deep in, you don't do like legit AI. This is like baby stuff compared to real stuff. Like, even me, I haven't done too much. I haven't worked at Tesla on self-driving cars, unfortunately. I wish I have, but you can go pretty deep. So if you want to check that out, then by all means go check out the OpenCV course, and feel free to like just go ham.
Yeah. For those of you who are JavaScript developers, you can use something like TensorFlow. TensorFlow is pretty much a very similar thing to what we used here, but it's not CV2, it'll be TensorFlow. And then you can actually go ahead and get models, just like the Hard Cascade, and you pretty much plug them into your TensorFlow and do the same thing as what we did today. So what I challenge everyone on this stream right now to go and do is actually go ahead and like follow along this tutorial, get it working on yourself, but go ahead and swap the Hard Cascade one that you're using and try and detect like an eye or something like that. That would be kind of cool.
Yeah.
Yeah. Try and detect like an eye or something like that. That would be kind of cool.
Yeah.
Yeah.
Yeah, there's literally an eye one. Like if you just Google it, the OpenCV documentation or the GitHub repo, there's an eye one where you can detect eyes as well. We could even do it really quickly. Why don't we just do it on the fly really quick as a bonus? I'm supposed to be done here, but let's
do it, dude. I'm
because
so
I actually
down.
I have it downloaded already. The
Yeah.
eye, because I was gonna do that, but I was like, it's not important for small detection, but let's do it really quick. Okay, what time is it? It's 41. Okay, how fast can we do this?
Let's do it.
Boom. All right, boom. I.xml.
Guys,
detector. So what we
pump
want to
Aaron
do
up
is
in the comments right now to let him. Let's get him in let's get him in that flow state.
eye detector. So what we're gonna want to get is okay. So the face. We have the face, face grayscale, smiles, smile detector. Eyes is going to be eyes will be eye detector dot detect multi scale face grayscale, and scale factor. I didn't tune the eyes, so like it might not work, but yeah, we'll see how it goes. So eyes equals that.
Yep.
Then we're gonna want to draw the smiles, and then also we're gonna want to draw the eyes. And eyes.
Yep.
And why don't we just go double? This is very sloppy, but I mean, well, actually, I can just use this because the for loops aren't overlapping. So let's just leave it like this.
Yeah.
And then the eye.
Okay.
And let's just change this to 255, 255, and 255 in eyes grayscale. So this should work.
Nice.
I mean, it should. Let's see if it works.
Guys, if it works, destroy that thumbs up button. Because Aaron just done that on the fly. Like,
the eye is not defined. I have a typo somewhere.
oh, I was gonna say that, yeah, because you have the eye, but we need to slice it. Sorry, right?
No. I mean the face.
Okay.
That's what it is.
Oh, snap, dude. I mean, it might.
Kinda. I mean, mouths and eyes look kind of similar sometimes. You know. You can kind of see.
Yeah.
So let's try to tune it. We got to tune it a little bit. Let's tune the variables a little bit and see if we can get it working better. So that's where these two things come in handy: scale factor and mid neighbors. So there's probably some ideal number. Let's just try like, I don't know, 1.3 and 10 and see what happens. Okay.
Yeah. It's like some Iron Man video. Okay. Okay.
Not quite. Let's try 1.1 and 10.
Oh, we're getting there, dude. So what was the
Well, I just because I'm Asian, but if I open my eyes big, it works. It looks creepy as hell, but
nice.
Like big eyes, big smile, then it can get it nicely.
That is awesome. The greatest ever. Let's get this to 1K likes, everyone. I think we deserve.
Yeah, this kind of stuff. Yeah. This kind of stuff is what Snapchat and Instagram use on their filters. You know, like when you like vomit the rainbow and stuff, they're like, and then when they see it, they can locate it and have it like drip down, stuff like that. So this is actually what's going on behind the scenes when using a Snapchat filter, like the selfie camera, and you have like the crazy filters over your face. This is what it's doing behind the scenes. It might be using convolutional neural networks instead of hard cascades, but it's similar principles.
Yeah. they would have a model that's already sitting there, that's already ready, and it's just the input would be the camera that you're seeing, output being that little tongue emoji or like dog thing, whatever you're using. Yeah, nice.
Yep, that's
That's
it.
dope,
Or yeah,
dude.
and about what that took 4 minutes to get the eye up and running.
Yep.
So it's the power of Python and having pre-trained models. Of course, if you trained yourself, it's going to take hours or days or weeks if you have to get your own data. It depends where you get the data. If you're taking your own photos with your own phone, it's going to take forever. Or you can just use what people have done.
You got some good comments coming in. It says, Aaron, you are awesome. Aaron OP.
Thanks.
We got
Apparently not a NumPy.
Nice.
Whoever in the comment, I don't know who you were, but thanks, man. You saved my ass, man or woman, whoever that was. Much appreciated. I could stop embarrassing myself.
The greatest ever says, that's amazing information. I'm gonna squeeze that in when I'm being interviewed. That's awesome,
Nice.
dude. That will impress them. Yeah, I will impress them.
Yeah, this is a real smile. Look
at that. It's so funny when that is nice.
And we could even be like, we could even like have it dynamically changing, like smiling and wide-eyed, like or un-Asianified or something. You know, it could be like smiling and have like another piece of text like un-Asianified underneath. Let's do that,
dude. You know what you could do? I reckon there's probably some kind of model there which tells you the ethnicity of someone, and then you have the sensitivities based on ethnicity.
that'll be hilarious. But let's just look at this code. If length of eyes, I mean, is that racial profiling? Is that like racist?
No, I mean, no. I mean, we've got one. We got one Asian. We got one brown.
Asian, un-Asianified. Let's just do.
So literally, the greatest ever just said un-Asianified.
There we go. Here, let's try it. Let's try it.
Says, Aaron, you're a good teacher. I like it. Nice.
Oh wait. I think we need to tune this a little bit better. To eyes needs to be maybe 20. Let's try this, and this is way too much. Let's try 90 and quit this out here. That's hilarious, bro.
That is dope. I love that.
I think we gotta tune a little bit more. Let's try 30. Bro, I'm so late. I'm supposed to go work out with my friend, but I was supposed to leave 20 minutes ago. But the NumPy thing, really put a cog, but whatever.
Oh man. Oh wow. Tala Shah says that's the most amazing live video of programming ever. We love that, dude. That's insane.
That's hilarious with the eyes, bro. And look at the light on my face better. Oh, that's so funny. I'm having so much fun with this, man. I wish I could send it to you, but yeah, I do gotta get going.
No, that's cool, dude. You've crushed that. Yeah. And we didn't even plan on getting the eyes done, so we got the eyes in there.
I mean, yeah, that's the power of pre-trained models. They also have like dog and cat. Let me just pull up the OpenCV real quick. Yep. Where did my Chrome go? Oh, it's in full screen. So if you just go to OpenCV, har GitHub, then you go here, har Cascades. They have all these pre-trained. OpenCV is like open source, so it's free and low weight. The algorithms and stuff they use at Facebook and Snapchat, like and Instagram for real, they're trained even better than these are. That's why they're so much more accurate. These are just kind of like halfway there, but they're also like pretty old. But here's the eye tree eyeglasses. I don't even know what this is. This is the frontal face default we're using for frontal face. There's other frontal faces. See how much is frontal cat face, full body. This is what we use for the pedestrian tracking.
No.
For cars, I had to download a har XML file from somebody else. It wasn't provided by OpenCV, but you can find other trained models too. Like once an XML file is created from any object detection, then you can just download and use it for yourself. So like here, like this is literally what I typed in. There, har Cascade XML file. I went here, I clicked on it, and then I literally just downloaded the XML file. It's somewhere linked in here, but you can find the XML file once you find it. So like literally it could be anything. It could be like what else? What else besides car is cool to identify? Har har cascade file. I mean, that one might not exist, but the idea is
yeah.
here, soccer ball cascade. So there, soccer ball cascade.xml. And then so this could probably detect soccer balls in a video.
Nice.
If a video or something like that. So like it's generic object detection. You can detect any object, any arbitrary pattern in a frame. So that's the power of that.
Using what Aaron just showed you there, you can easily detect like some balls, like on the screen.
Like, are your balls round like a soccer ball, or are they lopsided like a rugby or football? American football.
Oh man.
Yeah, but here there's har cascades. There's also some here. There's hog cascades. So hog stands for hog is like another way to do it. It's like optimization for har or something. I forget what it stands for, but it's another object detection algorithm thing that you can use. But here we have all these, and then there's cats and or if you go into hog, what is in here? Pedestrians. Okay. But yeah, guys, that's it. Smile detection and Asian detection, Asian person detection in Python.
Awesome, guys. If you guys enjoyed that, let's give Aaron a massive thank you, because I think he crushed it today with that. And even I learned so much with this tutorial today. So like, I thought it was cool. Thank you, Aaron. That was amazing, dude.
You're welcome, Sonny. Thanks for streaming for me, because my computer's a rock.
Saurabh Singh says, Aaron and Sonny looking for some more in the future. Cheers. Yeah, we'll definitely be doing more. That was fun.
Definitely, yeah. I am planning on doing some TensorFlow because I've kind of exhausted this OpenCV stuff. We got 3 streams on it, but I do want to get into TensorFlow, maybe even PyTorch, like Sonny mentioned. So maybe in the next few weeks, stay tuned for that. I might have like a TensorFlow like crash course stream or something like that. Maybe we'll actually train a model ourselves with somebody else's picture data. I'm not going to do it myself. But I'll find some online data set of a bunch of images, and we can maybe train something, and you can watch the neural net get created, and then we could do something like this again.
That would be dope, dude. That would be awesome. Yeah. I think also worth mentioning, guys, for anyone who joined and maybe missed this in the beginning, Aaron, what's lingering in the description right now? So if you guys like coding in Python, if you enjoyed this and want to do this for a living, then that's what we do at Clever Programmer. So we teach people how to take their coding skills and make money from it. As web developers with JavaScript, as Python developers, Python freelancers, whatever it is you want, like automating stuff with Python or whatever, then go check the link in the description. There's a free training that teaches you how to do that. And then there's also a full-blown course that you can join if you want to invest some money into that and time and actually pursue becoming a Python developer as your career choice. If not, then feel free to enjoy our free content. That's what this is here for, and make Asian stupid ass apps like this. Yes. Un-Asian.
My mom would smack me like, yo, respect your culture. Okay, mom. I love you, mom. You eat your rice. Yes, mom. Yes, I eat. You get A+. A- means death. Yes, mom. Oh, yes. And then I dropped out of school and she killed me.
That's truly un-Asianified then.
Yeah, that's the truth, isn't it? Yeah, we're all dropouts here, aren't we? Yeah.
That's awesome, dude. I think if there's Aaron, got any last few things you want to add? Oh, we also got a donation. Thank you. Saurabh Singh just dropped a nice little donation there. Appreciate that, dude. And lots of wicked comments coming in. Yeah, nice.
I think last thing would be hilarious would be actually get rid of the boxes.
What was that?
And then it would be hilarious to get rid of the boxes and just have like the full clean app. Let's do this last demo because I'm all hyped.
What's that? Hey, let me go ahead and show it on that. There we go.
Is this racist? I'm making fun of my own race.
I think it's okay when you're the same race. It's all good.
Half ununified. Anyways, okay, I'm gonna stop goofing around because now we're just wasting time. All right. Yeah, so if you guys want to check out the free training or the course, then it's in the description. If not, then keep watching our daily streams. I think we've been going for like 4 weeks now straight.
I think it's longer, dude. I think we've gone over a month and a half now.
Weeks.
Maybe. Yeah.
How have we not run out of like project ideas?
Dude, we have so many project ideas now still to come. Like tomorrow's a big build. Tomorrow's a massive build coming up, so we'll be amazing.
What's that?
Yep, we have WhatsApp tomorrow. Stay tuned, guys. Go ahead and literally set a reminder on your phone right now for that. And we're doing that at, what is it in? I think it's 9:15 EST and 6:15 BST. That's my time. Yeah. Yeah. So awesome, guys. Hope you guys enjoyed that. And with that said, make sure if you're not following us already, go ahead and check us out. We're always posting some content. So you got me and Aaron over there, and we love to have a chat with you guys. But yeah, I think
Yep.
Aaron needs to go and hit a workout. Some
Yeah, eat some food, some more coffee.
That's
I'm
it.
totally sleep deprived. But yeah, guys, thanks for joining me and Sunny and coding this up. It was a lot of fun, and we'll do it again in the future sometime, right, Hulk?
And that's it, dude. We'll do it again, Samurai.
Alright?
Yeah.
Yeah, samurai.
Yeah.
Samurai.
That's it. Right.
私を. Okay.
Awesome.
All right, guys. Peace out.
Peace out, guys. Thank you. Bye.
So today we're going to be coding up a image classifier app in TensorFlow, and we're going to be extending a little bit from last week, and we're going to be building a slightly more advanced, a slightly more complicated neural network here, and we're actually going to be using TensorFlow to be able to classify different images. So I have this data set here that has a bunch of different images of different kind of clothing pieces, so shoes and shirts and bags and stuff. I'll show you guys a little bit more in a bit, but the idea is that we just want to train our neural net on a bunch of these little pixelated images of different clothing types, and then eventually be able to recognize these images and classify them correctly going forward on new unseen data. So that's kind of what we're going to be doing today. Okay, let me see if I can find some other data in here too. Let me close this. I want to show you guys a couple of the pictures. I think there was a link I found, but I lost it, that had like a better. Okay, here we go. So this worked fine. So this is another image that we're going to be using. So this one kind of looks like a shirt, as you guys can probably see. And this data set is actually really big. It's actually built into TensorFlow because it's kind of like the introductory data set that people can use for image classification. So let me look at a couple more and see if there's a few that we can look at together. Okay, so this one kind of looks like a dress, I guess. And let me just keep going through the data, a couple more. Yeah, another dress here. And I think you guys are getting the idea. So there's just a bunch of images. There's like 70,000 images of different clothing pieces. And what we're going to be doing is we're actually going to be training our neural net on about 60,000 of those images, and properly classifying and training the neural net. And then on the remaining 10,000 images, we're going to want to actually use that as our test data to see how accurate our neural net is. All right, awesome. So let's get back to the code. So yeah, I showed you guys a bunch of those images. So the idea is we're going to code up a neural network, and I'm going to kind of like go step by step of how we would solve this problem. So the thing we're trying to achieve is we have 70,000 images of different clothing pieces like we have, and there's actually 10 different types. If I go back to the documentation here, there's 10 different types of clothing here, and they're just labeled 0 through 9 just for simplicity. So as you can see, like the first one was an ankle boot. Like, let me go back to this, and let's just show the first one again and print this out. As you can see here, this kind of looks like an ankle boot or a shoe, but I guess they call it ankle boot. And the label is 9. So actually, let me show you the label too, just so you guys can get a little bit familiar with the data. There we go. So labels at 0. So yeah, so I pulled this data, or let me actually show you guys. I should show you guys this in a second. Let me just show you the label. So here I'm actually printing out the label for the first image here, which is at 0, and then this is the shoe, like I just showed you guys. But when I print it out, it'll actually give us the label as well. So, well, let me quit out of this and run this. And as you can see, so this is a shoe, and it actually printed out the label of 9. And if we go back to the data here,
You can see that 9 corresponds to ankle boot. So pretty simple. There's 70,000 of these images of different things, and then each of them has a label attached to it. So we'll be using this data to train our neural network. And then we'll be using another subset of this data to actually test our neural network to see how accurate it is. And it's pretty good. Yeah, as you can see here, so the fashion, this is called the fashion MNIST data set. MNIST is this thing, I actually don't know what it stands for, but I mean, there's a lot of like pre-trained and pre-labeled data sets that MNIST provides for us. There's like handwriting ones and other stuff. So this one just happens to be like a bunch of fashion stuff. And yeah, as we said here, I just mentioned this, we're gonna be using 60,000 images, grayscale images of different clothing pieces, and then we'll use the remaining 10,000 for testing. So now let's just jump into the code and let me start explaining these each line one by one, so you guys can follow along and everything will make sense. Any questions up to this point, or is everybody following along?
Following along.
Perfect.
What is this keras thing? I have heard a lot about it. Like, what does this do?
Keras is like okay, let me just spend a quick second on this. It's basically like here, let's just go to the actual documentation. So it's just like a library that allows you to like build neural nets. So TensorFlow itself is like a wrapper, or it utilizes Keras because Keras allows you to like make like graphs in different structures, like graph structures. So it's perfect for neural nets. And you can look into it if you want. The idea is though that just TensorFlow is just built on top of Keras. Like it utilizes Keras to build the neural nets and all the graphs. So
and like you can also think of it like a neural network. You know, the base is neural networks, and on top of that, machine learning is built, right? So machine learning is actually like, sorry, neural networks are a part of machine learning, and Keras just allows us to do that.
Yeah, that's a good way to explain it. Yeah, so Keras is good for creating neural networks, but then TensorFlow is actually good for pumping data through that to actually achieve machine learning and like solve machine learning problems. But Keras is just for building the structure, like the data structure and defining that. And then TensorFlow on top of that allows you to like, train and import data and pump the data through and do all the number crunching. Does that make sense, Nazir?
Yeah.
I think that
So
was
this is basically like a data center for TensorFlow.
Yeah. All right, so let's just start going through all the code here so that you guys can follow along, and then I'll answer any questions as we go. But this one's going to be a little more interesting than last week. So let's just start one by one. So this stuff up here, you guys can actually pretty much ignore this. I was running into some downloading errors when I was trying to download the data. I just had to do some permission stuff. So just completely ignore this. The proper way to do it is to actually install a different package on your computer, but I just popped this hacky thing in the code. So just ignore it. I'm just gonna not even show it. So let's start here. We'll just go one by one. And of course, we want to import TensorFlow. That's the first thing we're going to want to do. And then also import Keras because we're going to need both. And also NumPy because NumPy is how we are going to be dealing with all of our data. So actually, like this here, this is actually just a NumPy array. So this image is a 28 by 28 grid of grayscale images. And it's actually stored as a NumPy array. So we need NumPy to hold this data, and then we're just gonna be pumping it into our neural net. So that's what we need NumPy here. And then also we need Matplop just to, Matplop is just to display the images. So that's why I'm displaying it here. So you guys can kind of just ignore that. It's just for visualization purposes. So this is where the code actually starts. So the first thing we're going to do for any kind of machine learning thing is we're going to need a bunch of data. So fortunately for us, they have all of this labeled data, like with the shirts and shoes and stuff, already installed in TensorFlow for us. So it's as simple as just downloading it here and just accessing the built-in data set, which is nice. In the real world, if you were trying to collect your own data, which sometimes happens, sometimes doesn't, like if you're working on a team, like I did this
I had a machine learning, artificial intelligence paid internship thing where they actually went and would like capture their own data, and then you'd have to like label it yourself, and it was kind of annoying. So I mean, I guess you do have to do it in the field if you are going to be doing that in the future. But ideally, you just have the data already labeled and somebody already did it for you. So that's what we have here. We have a bunch of the data here. So just got to get a handle here to that data set. And you just do that by calling Keras. So within Keras, we have the fashion MNIST, which is what I was just looking at in the documentation here. Wherever it went. I don't know where it went. Keras fashion MNIST. There we go. So like I said, Keras has like these data sets built in. So I just basically call this code. So fashion.mnist.load data is what I called here. Well, actually I call it down here, but this is just like saving the handle to the data. But down here, you can just call fashion mnist.load data, just like it says in the documentation here, and we get the data in. So this might differ if you're using a different data set, but for this data set, this is how we're getting it. And the way this is returned is by default, it returns 60,000 of the images here for training, and then the remaining 10,000 of the images here for testing. So now we have these four variables here that we can use for training and data. So these are just simply just lists of a bunch of different images and whatnot. This is actually how I was displaying all of the images. So right here, I'm displaying the first element of the training images, which is actually this boot image that we see. So very straightforward. So if I index train images at 0, then it just spits out this NumPy array, and then I just use Matplotlib to display it so you can see that. And then I showed you guys the addresses and stuff at like the first index and second index, and it goes all the way up to 60,000. So that's how the data is structured. So all you guys got to remember really is just that these four variables here is how we're going to access our data. So, and then these are just lists of NumPy arrays or images. And that's all it is. This here is just for printing, so we don't have to worry about this too much. This is just using some Matplotlib. I'll actually show you guys this. This is kind of interesting because you can even see the actual data in the terminal if I quit out of here. Oops. There we go. So what I'm doing here is I get the data, like I said, I have the 60,000 images and labels here, and then the 10,000 images and labels here. And all I'm doing is I'm printing out the label and then the actual image in the terminal. So if you look in the terminal, you can actually see like the data here. So this is the actual image that we're seeing of the shoe. But I mean, of course, it doesn't look like a shoe in here because it's just a bunch of numbers. But it's just a black and white image. So on the range from 0 to 255 is the range of numbers that they can be. It's just kind of like the brightness of each pixel. But then that's reflected here. So I'm just using Matplotlib to show that. And that's through the image show and the show here. So any questions up to this point? Is that pretty clear cut for everybody, or does anybody have any questions?
Is that just for one image?
Yes. Yeah, just for one image. So we can actually get rid of this because I don't want to print it in the terminal and like clutter it. But all that's happening here is I'm using Matplotlib. I just renamed it to plot for simplicity. And then you call image show, and then you just pop in whatever NumPy array you want. And then this is just for making sure that it's grayscale. So you just kind of say like, yeah, it's the color map is grayscale, and then min and max values is that. You have to specify those, and then you just show it, and then that's how the this image shows. Was that you, Tom? Was that, it sounded like Tom?
Yeah, it was. Yeah. Sorry, I'm not well this week, so I'm staying on mute.
Oh goodness. Well, make sure you drink some water and get some food in you or something. It's not the corona, is it? Or
no. No. I had to get my kid tested. It came back negative, but it's just flu.
Okay, good. Yeah, we all got tested here too at all the guys here at Clever Programmer, because we all kind of live together or work together on a daily basis, and then we're all negative. So that's a positive sign, because I know Los Angeles is kind of iffy. But
is that the 28 by 28? That's the matrix that the 70,000 of 28 by 28.
Yeah. So if I go back to this data set, then this predefined data set in Keras is a bunch of 28 by 28 grayscale images of different fashion categories. So like shoes or dresses and stuff that I showed you guys before. So we keep it small just because there's so many, and if it's recognizable by a human by the eye, then it's arguably recognizable to a computer. Like if it was like 2 by 2, then you wouldn't be able to recognize it. But 28 by 28 is like as small as they could get reasonably by still being recognizable as these different things.
And what you printed out was, because it didn't have 28 columns, so what was the mapping of what you printed out again?
You mean this or the image? When I print off the image,
that whatever that's showing there, is that 28 by 28? Is that what that's representing? Or
yeah, this should be. I mean, it should be. Is it not 28? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Yeah, 20. So it is 28. So this is 28 long.
Okay.
This is the first row, and then this is the second row. And then it's just the formatting is kind of crappy. That's why, because I was dealing with this
counted
before.
From the top only. I didn't follow the ending.
Got it. Yeah, so this is just a 2-dimensional NumPy array. So this is the outer wrapper, and then each of these is the rows.
Right.
Yep. And then as you can see, so like this is all zeros. So like there's nothing on the top, and then when we actually run it, then you can see. Yeah, that the whole top row is completely black, which is what 0 stands for, because those pixels are off. So the first row is all black. The first row is all black there.
Right. Makes sense.
Awesome. So that's the data we're going to be dealing with. And now we can actually jump into creating a neural net for it. So let me just go line by line. There we go. So like last week, we're going to be creating a very similar, the code is going to be very similar, but the neural nets is actually going to be a lot more complicated. But that's what's nice about TensorFlow, because you're able to create really, really complex neural nets, and the code is pretty concise and straightforward. Like it never gets too advanced, and that's a really good thing. So let me do a little recap too, just so for anybody who doesn't remember, let me annotate. I think red is good. Okay, can you guys see? You guys can see me annotating, right?
Yes.
All right, cool. So let's just have like a sample neural net here. So anybody who doesn't know what a neural net is, it's just like a bunch of different layers of nodes, and they call them like neurons, and then they're all connected. So let me just draw this out really quick. And there we go. So it's kind of covering the code here. Let me put out. Can you guys see down here, this code down here? So line 28, it says model. So the first thing we want to do when we have a machine learning problem or something like TensorFlow is you want to design our model in a way that will be compatible with our input data and also our output data. So in this case, for anybody who doesn't know, a model is just a neural net. So this here is an example of a neural net that has three layers. So one input layer here with three nodes, and then one hidden layer with 4 nodes, and then one output layer with 2 nodes. So this is kind of like a model that I just drew up here. Ours is going to look a little bit different, but I just kind of want to visually represent it here. So in Keras, like we established earlier, Keras allows us to define different graph structures. So it's really good for this purpose. And so as we're utilizing Keras here. So Keras, there's a thing called sequential. We went over this last week, and this just means that there's a sequence of vertical columns like this of different layers, and then they go in a row. So this column of nodes can only connect to the next one, and so forth. You can't like skip and hop over. So this is like the most basic type. So sequential is the first one we want to do.
and we're going to make this a sequential neural net. So from there, all we need to do is just within this list is just define all of the different layers that we have. So let me get rid of this drawing real quick. Clear all drawings. Okay. So it's sequential. So for the first thing we want to do when we're dealing with a machine learning problem or for neural nets is we want to make sure that the input and the output is correct. So for the first one, we remember, let me just show you guys the first one, the first layer. So the first layer that we're going to want to have in our neural net is going to be the input layer. And as we know, the data that we're dealing with is going to be a 28 by 28 image. And those are the data we're going to be pumping in. So the way, I shouldn't have deleted that neural net. Let me see. I'll just make it a little bit simpler. So I'm not going to draw the lines just because it's kind of long, but right, something like that. So the idea is for our input, we want to have a 28 by 28 input for our input here, a 28 by 28 matrix. And what we want to do is we actually want to flatten that out into one long layer. So the input layer, actually, each node is going to have one pixel. So that of each of those images, so that we can pump in the full data all the way across, and then from there the data will filter through, and eventually at the end we'll spit out, be like, okay, is this a boot, is this a dress, is this a shirt, and that's the overarching idea. So the first thing we're going to want to do is just make sure the first layer is compatible with our input. So again, we just call this here. So it takes in a 28 by 28 image, and we actually want to flatten this. So like I said, each layer of the neural net is just one long vertical column of our data, and so we want to make sure that we flatten this 28 by 28 thing into one flat layer, and then I think it comes out to 784. Let me see, 28 times 28. Yeah, 784. So let me actually just copy this code out, or the comment. Yeah, I wrote here. So the flatten here just flattens this 28 by 28 matrix into one flat 784 by 1 input layer. So actually this neuron that we started building up to this point, so this only has one single layer, will actually look like this. Annotate. So it's sequential, of course, but right now we only have one layer, and what this is going to be is this is actually going to have a bunch of input layers here, and this is actually going to be 784 long. So this whole input layer is going to be 784 neurons long. So this is the first layer, okay? And then we're going to have a hidden layer, and then we're going to have an output layer. But does that make sense so far? So that we have one little node for each pixel of each of these images?
Is there a reason why you need to flatten it?
It's to simplify the structure of the neural net. It's because each layer of the neural net is just a singular column. So instead of treating it as a multi-dimensional array, then we just kind of want to flatten it, because at the end of the day, like, each pixel is just a piece of data. It doesn't really matter where it is. We can just kind of treat like, okay, the top left pixel is the top left pixel. And as long as that's consistent across all the images when we're training and testing, then it should be okay. So it's just a way to simplify the data into one long layer to make sure that every pixel is represented in a clean way.
Is it more efficient?
More efficient, it actually doesn't really matter. Like the implementation under the hood, everything is just, it's boiled down to optimize matrix multiplications at the lowest level. Like TensorFlow abstracts all that away. This here is just kind of to like make it more understandable for like a human. When you're thinking about a neural net, like, okay, we have this whole input layer is just one long column, and every single pixel has its own little node. And then each of those pixels has a number. So like if this was black, then this would be like 0. If it was white, it would be 255 in this node. And then it's just every pixel is represented. Then we can kind of be like, okay, this set of numbers, this long 784 list of numbers represents this first image. Like if I run this, yeah. So this first input layer will just take like all of these, all these pixels. So the first row will just be like up here second, then the second row will just be right after, the third row will be right after that, just going all the way down until the very last row. And these last 2 pixels down here in the bottom right are these 2 little nodes here, just so that every pixel is represented. Then from there, we've fully gotten all the data of this image. And then from there, we can kind of like tweak the different parts of the neural net. And eventually we will be able to like filter this image through. And then by the end of it, it'll spit out like, okay, this is a ankle boot and not a shirt or something like that.
Actually, I've just thought of a question.
Mm-hmm.
Why is the grayscale numbering from 0 to 255?
So it's just the way the computer hardware has been implemented, like as computers evolved from like the 1940s till now. 0 to 255 actually just means there's 256 numbers, because 0 is the first one. So 256 is just the power of 2. So it's just a way to to encode the data. So I think this is what, 2 to the 12th? No, 2 to the 8th. Yeah, so 2 to the 8th, which just means that there's 8. It's just 8-bit. So this is an 8-bit image of black and white. Mm-hmm. That's all that means. So we can be on a scale from, yeah, so that's the range of all the different steps. There's 255 steps of colors from black to white, and then there's 255 colors of gray between that you can specify, and that's all it is. Okay, let's go.
So if you didn't flatten it, it would
Mm-hmm.
it would still come out. Your output would still be the same, or
I actually don't know. I mean, I just always use flatten just because it's easier to understand. I mean, we can try, because I mean, remember last week we used dense, and we're going to be using dense going forward. But this kind of just defines it. So it kind of, what this does, I think, is it has kind of like this 28 by 28 thing. And then, but it says, hey, just flatten that. So there's actually a layer, there's actually a matrix over here of 20 by 28. And then it just kind of like magically turns it into one layer. And then we kind of just treat it as our first layer, but it kind of like maps the matrix 28 by 28 to this one single input layer, which is simpler for our neural net design. Because ideally down the road, we're going to, I mean, not ideally, but what we actually are going to be doing is creating like another layer of stuff here. And then at the end, we'll have like a bunch of different nodes here that is like, okay, what's the probability that this is a shoe versus, probability versus a shirt. It's really hard to write with this, but, and then so on and so forth. And there's going to be 10 different ones. As we saw here, there's about t-shirts, trousers, pullovers, dress, coat, sandal, shirt, all these. So there'd be one of, so yeah, actually, let's talk about that a little bit. So what our neural net is eventually going to look like is we're going to have this input layer, which is just the image. Then we're going to have one hidden layer that's going to kind of try to capture the patterns of what actually a shoe is, what a shirt is, what a dress is, stuff like that. And then from there, we're going to have an output layer that's going to have 0 to 9. So it's going to have 10 nodes in the output layer. And each of these nodes is going to tell you the probability how much the neural net believes that it's going to be a shirt or a shoe or something else. So there's only 6 here, but you can just imagine that there's going to be 10 like that. It's going to be 10 nodes there. And then, so the idea is if we put in an image, like the first shoe image, we'd pass it in and say, okay, this shoe should be really close to 1. It might be like 0.9 or something, because this is a probability. Then we want this to be really high and everything else would be low. And then from there, we can kind of train it eventually to the point where when we pass in a new image, the new image will pass through here, every single pixel. It'll filter through all of the hidden layers that we're about to create. And then at the end, it should say like, okay, the second image might be a shirt. So this should be really close to 1 and everything else should be like lower, closer to 0. Is that kind of clear?
Yeah, and your hidden layers represent the model? Is that what the model is?
Yeah, the whole neural net itself is a model. So
okay.
Like we went over last time, this annotates a little bit. I gotta find a better tool for drawing, I think. But it'll be okay.
That's everything.
Yeah, model. So the model is inclusive. The entire neural net is the model, and we're going to be designing it. So right now we only built the 28 by 28 matrix and we flattened it into the 784 input layer. And you can kind of ignore the 28 by 28 now because it's just a simplification to make the neural net look nicer. Because if you have this weird matrix that pumps into this column layer and everything is just kind of like a weird thing. We just want it to be a sequential series of columns of nodes. And eventually you pass in an image, it goes through all this magic and figure out all the patterns and then spits out the probabilities here at the end. And it's like, okay, shoe is max is the biggest one. So we can probably say that this image with all these pixels filtered through this neural net is a shoe. We can confidently say with a 90% accuracy that it's a shoe. But this entire thing is going to be the model. So again, these are going to be connected. I just didn't draw these. And then there's a bunch of lines everywhere connected. Like every node is connected to every other node the way it can. And then these are just going to be numbers multiplied together, like going through the neural net. So let's go back to the code a little bit. I want to explain the input and output a little bit to you guys, and then I'll explain a little bit more about how the neural net is actually going to do the work. So let's go back to the code, and let's actually just delete all this because it's getting too messy. There we go. So this is the first layer, is going to be a flattened layer, okay? And like I said before, that's the input, and then the output is going to be a series of numbers from 0 to 9, and those are the probabilities that it's going to be each of those. So the output layer is actually going to need 10 nodes, okay? It's going to need 10 nodes from 0 to 9, and from there, then we can create the hidden layers after that. So the first thing we want to do is let's grab the output layer. So you always want to go like input layer and output layer first, and then you can kind of experiment with the hidden layers to see what you get. You get like the biggest bang for your buck, because there's always that trade-off of accuracy and speed. So, and this one we're only going to have one hidden layer, and it works pretty well. But let's just start with this. So input layer is again the 28 by 28 image, and then we flatten that. So this is just the input layer of 784. And now the output layer is just going to be 10 nodes going up and down. And each of those is going to correspond to one of these numbers. Is that clear so far? Or is anybody, or did anybody get lost?
No, we're just so far.
Awesome. And so that's the first things we want to do is the input and the output. And again, we're using dense here. Dense just means that every node in each column is connected to every other node in each column. So there's a bunch of like crossing over lines between each neural net. Let me just find an image actually. Densely connected neural network. I think I showed some of these last week, but here, this one works. Nice.
It's not working. Here we go. So this here is like this one has a bunch of inputs. So for us, we're gonna have the image and all the pixels in here. And at the end, we're gonna have the 10 different numbers here corresponding to each of the clothing types. Ignore this for now, this thing here. I'll explain this in a little bit, but just remember that I think I did this last time to make it a little bit clear. So units will actually define how many nodes are in this column. So the type of column is going to be dense. This layer, the layer or column, I'm kind of using those terms interchangeably, but they're the same thing. So that layer is going to have 10 units coming out of the back. This only has 4, but just pretend there's 10. And then the input has 784 again. So once we have those specified, then usually you can just start off by just testing it with one hidden layer and then kind of see how well your neural net performs. Testing it with one hidden layer and then kind of see how well your neural net performs, because simpler is better. And then and in our case, it'll work pretty well, only one hidden layer, and we're about to build that. But sometimes you need really, really deep layers to actually create robust systems. So for us, like we're simply classifying like 10 different types of clothing, which is pretty simple. But sometimes you want to have like a really, really deep neural network, and that's actually where deep learning comes in. This is where like there could be like a lot of hidden layers, like tens, hundreds of hidden layers. And that's why it's called deep learning, just because the neural network is really, really deep. But those can get really powerful. Like if people have like learned how to optimize it enough to not take like years and years to train. But then it's able to like be really, really powerful for like recognizing like a large array of different things. Like it can tell what a cat is, what a coffee mug is, what an airplane is, like who Obama is and stuff like that. All in one neural net, but you need a lot of hidden layers. But for ours, it's pretty simple. So we only need one hidden layer, and we'll just start with one, and we'll see that it actually works pretty well. So let me go pull that out next. We're currently designing our neural network structure using Keras. So this here is actually the final neural network that we're going to be building. So we have the entire thing specified here. The hidden layer we're going to be using is another dense layer. So again, it's going to be fully connected like this, as in every column layer here is fully connected densely to the next one. So this is what it's going to look like, but we're only going to have one hidden layer. So you can ignore 2 and 3. You can pretend those aren't there. And then we're going to have 128. Again, let me type in units to be a little bit clear. We're going to have 128 nodes in that one. Okay, so there's actually going to be 128 tall. So the first one is going to be 778 tall. Second one's going to be 128 tall, so smaller, and the last one's going to be 10 tall. So you can kind of see like we're filtering from a big image, and then we're boiling it down to like a few patterns, and eventually we're going to boil it down to 10 probabilities of these different clothing types. So that's kind of the structure of our neural net. You kind of just want to like guess for this one. You can just kind of like last week we started with a very, very simple one. But for images, you usually want to try like some decent number. So you might want to start. You could even start with like 60, 64 or something, and then you can just jump up to 128. But 128 is like a good median ground. Like it's not too big of a number for a computer to deal with, but it captures a good amount of relationships. You kind of just have to like play with it and stuff. For pre-built projects, usually people figure out these fine-tuned numbers for you. But for us, you can just kind of like just pick a number and see what happens. You kind of have to play with it and see how the computer learns, like how accurate it learns. Okay, so is everybody following up to this point? This is just all kind of like preliminary code stuff of like importing the data and everything. But here, designing our neural net, we have a sequential neural net with input of an image, one hidden layer of 128 nodes, and a output layer of 10 nodes. Is that clear to everybody?
Is it a good, I don't know, common practice to make the hidden layer some factor of 2 or a power of 2?
Not really. It can be anything. I don't know why they actually choose 128. Because I found this project online, and it's like neural nets you can use any number of nodes. It's just a arbitrary number of nodes, and then you can capture the relationships. So I actually don't think it needs to be like some special number. Actually, I mean, we could probably even choose a different number, but they just I guess people just like powers of 2 because it kind of goes nicely with like how computers work internally. So maybe it's good practice, maybe not. But I mean, in theory, you don't need to have it be a power of 2, but maybe in implementation.
Yeah, I didn't know if there was conventions or something.
Yeah. I guess, I mean, yeah, a lot of stuff in code in general is like based on powers of 2. So maybe it doesn't hurt to just start there. If you're choosing a random number, then that you just choose a power of 2 because it might simplify things. But it doesn't matter like on a theoretical level. So from here, we have our entire neural net created and designed. So let me actually just draw this out visually once so that anybody watching the recording can see exactly what it looks like. So we have our entire neural net created and designed. So let me actually just draw this out visually once so that anybody watching the recording can see exactly what it looks like. So first layer is going to be 784 layers of like that. It's going to be 784 flattened. And then this one is going to be 128. Oh, hello? I think my connection cut out for a second. You guys there?
Yep.
Yes. Yes.
Hello.
All right, perfect. Then this is going to be 128. And then the last one is going to be 10. 10 here. Is going to be 10. And then of course, these are all connected. There's all those crazy lines between each of these, just like we have here, okay? So you can kind of just assume that this is the neural net, but then just pretend the lines are all there. So this is what our neural net actually looks like that we just built. Again, it's just as simple as just calling Keras and the type of neural net, and then just listing the layers in this list one by one. So layer, 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 input, hidden, and output. Okay, I think I explained that adequately enough. Let me get rid of these drawings so we can continue on. Oops.
Aaron, I had a question actually.
Yeah. What's up, Ruben?
Yeah. Hi. When we add hidden layers, okay, so does that number have to be consistent? For example, we have 128 nodes in the first hidden layer. So for example, if we are creating further hidden layers, so for example, we are creating 5 hidden layers. So it has to be 128, 128, and 128 for all 5 layers, or it can increase and decrease based on.
It can increase and decrease based on anything. This is where the neural net design gets kind of like up in the air. For this one, this is a pretty simple problem, like relatively, because we're dealing with small black and white images. We're not dealing with like 4K big images or anything. But yeah, it can be anything. Usually what you want to do is the neural net usually starts big and then eventually gets smaller and smaller into something small, because you want to take like a big thing of data and then like all the pixel data and then just say shoot, or a bunch of pixel data and say, okay, this is like Martin Luther King Jr. or something, if it's his face. Like you just want to like have like simple labels at the end. So usually the neural network starts big and eventually filters down smaller and smaller into some set of outputs. In our case, it's going to be a list of 10 numbers, which again correspond to the probabilities listed here for each of these.
Okay, so the number of nodes in the hidden layer has to be less than the input layer, or it can
No,
increase as
it
well?
can be anything. It can increase as well,
So
because
what?
you could theoretically capture more patterns. The thing is, the data that's there is 784 tall, right? The input layer, we have all that. So you can kind of, if the input layer is also the same size, then you're kind of like not boiling it down to like smaller patterns. You can, because there's like weird, like how to explain this? There's patterns you could pick up on if it's bigger. Like you can kind of like find like weird like underlying patterns in the data that you can't really like visualize, like a human wouldn't really understand it, but like you can kind of uh, pick up these patterns in numbers if you get more complex. But then also at the same time, as you create more hidden layers, it takes longer to train. So as a general rule of thumb, it's usually better to just get smaller and smaller and smaller, or stay the same size. You could go like big and then have like 2 layers of 16 or 3 layers of 16, and then like go down to like layer of output of 2. If it was like you're trying to be like, oh, is this a cat or a dog or something like that? It could be like image, then 16, 16, 16, then 2 for
Okay.
that neural net. For like if you're
So
trying to do like
what
a
would
dog
be
cat
an
classifier.
okay? So what would be an efficient approach to have us like for the example, 128 is 2 power 6, I guess, or 8 something.
Yeah,
Okay,
some
so
power of 2.
yeah, 2
7, 2
power
power
8.
of 7.
Okay, so 2
Yeah.
power of 7. So what if I want to split it? Maybe 128 into like it's 7, right? So it will be 2 power 3 and 2 power 4. I want to have two hidden layers. So will that be a more efficient approach, or having it both in a single hidden layer will be uh,
Um,
more simple?
Usually less layers is better. If you can get it to the least amount of layers possible, that's usually better because it keeps the neural net simpler and they're not as deep. But as you go deeper, you can actually, you can like pick up on different patterns. So like um, for us, it might be like, okay, for a shirt, like it might pick up like long, like, or actually, let me just print. Let me give an example.
So when you say going deep into the neural network, so
Mhm.
does that mean going into more into hidden layer number one, hidden layer number two, or increasing the length of the hidden layer? What exactly
Um,
that mean?
oh,
Or
you mean
both.
like you mean making a hidden
Yeah,
layer
that
taller versus
longer.
having 2 hidden layers?
Exactly. So what if I want to have that hidden layer just beneath the hidden layer one? I want to append the hidden layer two under hidden layer one, maybe.
Mm. Yeah, well, again, there's a fine tuning thing of like the complexity of the neural net versus how much you have. So like, the more nodes you have in a layer, in
Yeah.
principle, the more patterns you'd be able to pick up. But then also it'll take longer to train. So, yeah, you could just have like, um, you could like you could have. Are you asking like one 128 layer versus
Yeah.
two 64 layers or something like that?
Yeah.
Yeah, usually
Exactly.
you'd want to pilot into just one 128 layer, which is what we're doing now,
Okay.
because it gets the
Okay.
job done with one layer, because each layer you add kind of adds a level of like it gets exponentially more complicated, faster
Okay.
than
Okay. So keeping it to into a single layer makes it like keeps it simple.
yeah, for now.
Okay.
There
Okay.
yeah, there's a lot of different trade-offs, but I mean, just as a general rule of thumb, just try to keep the layers as low as possible, because it keeps it. And also, I mean, like if 64, like this is 128, but like if 64 gets us decent results, that's a better choice to go with. But
Okay. So
128 seems to be the sweet spot.
that would be the number of units would be the minimum number which would get us a result of a decent accuracy.
Yeah, something like that. Yeah. So you just
Okay.
kind of want to optimize this neural net for this task. And that's kind of like the name of the game, is like figuring out the neural net design, the numbers, and the training set to get it working pretty good for
Yeah.
whatever problem you're facing. For us, we're just trying to classify clothing types
Yeah. So
versus, yeah,
our aim would be to keep a minimum number of nodes and minimum number of hidden layers to get the maximum accuracy.
yeah, yeah, like that. And just find that balance point for whatever you're
Balance.
trying to
Yeah.
solve. Like if you need like a real-time solution, you'd probably sacrifice some accuracy to be like instantaneous classification. Like for Tesla self-driving cars, it's like, okay, that's a person walking, that's a telephone pole, it needs to be real time. So they'll probably rather have it be real time and be a little bit less accurate, and then just kind of like be extra careful with their things. It's like, okay, I'm not sure if that's a human. I'm just going to say it's a human so I don't hit it. You know, like just kind of like sacrifice the accuracy, but make sure it's fast. So you just got to, depending on the problem you're trying to solve, you have to kind of like balance that out.
Okay. Yeah. I'm clear. Thanks.
Aaron, yeah, I was going to ask something similar.
What's up?
Is it almost the same thing or equivalent of the increase as you increase your hidden layers, that increases the time complexity, meaning it's like almost like exponential? So if you added a second one, it's, you know,
Yeah,
because it's
I've forgotten
got
a
to
lot
go
of the
through.
deep
At least
theory.
this is sequential.
Wait, say that again.
Yeah, so is it more like, you know, it adds the number of permutations or combinations because the node has to touch the node, so it becomes
it increases the
exponential.
Yeah, it's exponential. I think I might have gotten it backwards. I know, like, but if you just want to like trim it down as much as you can, but yeah, as you increase the nodes and stuff, then because every node and every connection, or they're called neurons or synapse, like neurons and synapses, like to reflect the human brain, but it's just nodes and connections between those nodes. Like here, so like these are nodes, these are the connections or synapses, or these are neurons and these are synapses, whatever you want to call it. Each of these lines has a weight, so like you would have the pixel, and then you would have the weight of each of these lines, then you would just multiply that pixel value by that weight, and you get a different number here. And then from there you would do it again and again and again, and then eventually all these little numbers together kind of like represent a function that captures the patterns, and will eventually spit out the correct numbers. So since every single line and every single node has its own number, and then there's a bunch of like crazy multiplications going on, they're at the bottom level, they're just matrix multiplications, which has been highly optimized with NumPy, so it's as fast as it can get pretty much. And once those are all like multiplied together, then that's how this is all computed and it goes through. But yeah, as you add more layers, you can see that each extra layer and each extra node adds like an exponential kind of thing to it, so the computation goes up, and then I guess also the time, the space complexity too.
Okay, and so there may be times where you may have a higher number of nodes in your hidden layer if like your input layer, I guess you don't have that many nodes to increase your pattern, you know, increase the number of patterns that you might be able to find.
Because sometimes there can be like weird nuanced patterns in the data that aren't really clear. So like, yeah, like if your input was like really small, like what's a good example? Like, yeah, like maybe you had some training data of like, maybe you had some stats, so like you're trying to do some stocks, and you're like, okay, these are the prices of the stocks over here, and you only have like a small little thing, like the input layer is maybe like only 64 long, but you kind of want to like capture some weird like numerical patterns between everything. You could have like your hidden layers be much bigger to try to capture some patterns that a human couldn't pick up on.
Right.
Okay. Something like that.
Okay. Yeah, I'm just trying to understand the strategy of how you design your layers and the length of them.
Yeah, the simplest way, like I'm explaining here, is you just want to start with your input, and then your output first. Always start with that, and then the hidden layer, just start with 1 and see what happens, you know, and play with the number, and then maybe it's like, okay, this is doing crap. And then you can play with the activation functions too. I'll touch on these in a second, because this is another kind of number crunching thing that happens, and then there's different things you can pick. Like these two are different, like they're both activation functions, but these two do different things. And so it's kind of just like you play with it, and you play with all the different numbers and different types, and hopefully get some useful use out of your neural net. But yeah, just start with 1, and then you can always expand out from there. Okay, let's continue on, unless there's any more like burning questions from people about this. All right, I'll take that as a no. That is good. Okay, so we designed our neural net here. Now let's continue on. There's actually not too much left, because TensorFlow makes everything nice and concise, so we only have a few more lines of code here. Let's just go one by one. So let's grab this, paste it in. So anybody who remembers from last week, then after you create your model, we have to compile it, which basically just means take all the stuff that Keras built, because we just specified the nodes and the numbers and the types and all that, like, you know, densely connected, make this flattened, make it this big, make this hidden layer 128 tall, make sure it's sequential, all the stuff that Keras put together. Now we want to actually compile it so it's ready to be trained, which just means kind of like, I actually don't know exactly what's happening under the hood when Keras, but it just kind of says like, okay, take all this, put it into a form where it's ready to do stuff. And then we also have to specify an optimizer function and a loss function. So let me just touch on this again really quickly one more time for anybody who forgot or is new. So just remember there's a loss thing and an optimizer thing. So let me go to this neural net here and kind of explain visually what's happening. So what happens is when you put in an image in an input layer, you would put one through, and you'd want to pick random numbers for all these lines and for all these lines and just filter it through. So once you have an image come in, you'd multiply it by all these random numbers, and then you'd get another set of numbers here. You take those and multiply by all these random numbers on all these lines, and then you'd get it all here. And then again and again to get to the very end, and you'll get some output. So again, we're gonna get 10 outputs in ours that correspond to the probabilities of it being these 10 things. And basically, whichever one is the highest, we can kind of say the neural net believes that the image we passed in is that thing. And then we can compare that that answer that the neural net gave us to the actual label of what the data set gave us, because the training data actually tells us what it is, what it's supposed to be, like a human went in there and actually labeled it for us. And so what we want to do is the loss function here will tell us how correct or how incorrect we are. And basically it'll say like, okay, the neural net said it was like maybe the neural net said it was a t-shirt, but it was actually a boot for like this first one, for the boot image that I showed earlier. Then we know that that it's very wrong, and we can kind of say the loss function is like, okay, you're this much wrong, but how do we get better? So if we're super wrong, then we want to get closer to being right, and that's where the optimizer comes in, which just kind of tells us like, okay, make these changes to all these weights here to be a little bit more correct, because we can just like we can alter these by saying, okay, if we know it's an ankle boot, but it thought it was a t-shirt, all we need to do is just kind of like adjust all the weights that connect to the t-shirt node at the end and be like, okay, lower all those weights because that was way wrong. But we know it is a boot, so it's like, okay, well, we know it's a boot, so let's increase all of the numbers that were connected to the boot, because this should be higher and the t-shirt should be lower. And then that's how that changes all these weights here. And then we repeat the same process here, and then here, and then here again. And then that's what one epoch is with one image. And then we, for anybody from last week, remember the whole epoch conversation we had. And then we can repeat that again with another image. So to cover that again, so the loss function, we pass in some data, it goes through all these random numbers, and then we get something out. Then the loss function will tell us how wrong we are. So this fancy name is just like a name of a function that we can use to tell us how wrong we are. And then the optimizer is a way to alter these weights in a way to make this neural net a little bit more accurate in being able to classify different images as these data types. I mean, as these clothing types. Does that kind of make sense? It's kind of a complicated thing to explain. I think there's probably people on the internet who've explained it better, but I hope I didn't lose you guys again. Hello? Is anybody there?
No, it's good. Yeah, it's clear.
Okay, awesome. Okay, so yep, loss tells how long we are. Optimizer tweaks all the numbers in the neural net. And actually, I don't. Yeah, did somebody say something?
I'm trying to remember it from last week. Is that a different optimizer and loss functions than we used in the last week's?
Yes. So the thing about loss functions and optimizer functions is, and even neural nets too, like there's different neural nets and different optimizers and different loss functions that are useful for different types. So for images, these are actually pretty good. for image data. Like last time we were working with just like straight numbers, a very, very simple one-to-one number relationship. But now we're trying to map a 28 by 28 image to like a series of 10 numbers, which is the probability of, okay, maybe this is a shirt, maybe it's a shoe. So these are different, but basically there's just a bunch you can use and you can go and test all of them. But, and then all the math behind this is there. I don't actually understand. I don't remember what atom is or sparse categorical cross entropy, whatever this is. But they're just things you can specify. You can just like choose whichever one works. So
Right.
these are I'm pretty sure are good for images.
So I'm guessing like TensorFlow or Keras, whatever it's coming from, has got like predefined libraries of all these functions, and somewhere on the internet somewhere there'll be a list of them with like an explanation of what they're good for.
Yeah, probably like that. I mean, we can maybe look a little bit like what is this sparse? I'm curious because I actually didn't learn the specific. There's just so many.
Oh yeah,
sparse. I mean, the documentation is a good place to go. So like if you look here, so tensorflow.keras.losses. So this is loss function. So that's why it's losses. And then this is called sparse categorical cross entropy. So, I mean, just from the name, I mean, it sounds scary. I mean, the first thing that comes to mind is it's probably trying to pick up on like different splotches of like brightness and darkness in each image. And then it's trying to like find like the amount of chaos and randomness inside of those images. And then like, I don't know what categorical means, but it's probably doing something like that and trying to like translate that to like how right or wrong you are. I mean, I kind of just pulled that out of my ass, but that's what it sounds like. It says computes the sparse. Oh, I mean, okay, well, it's just explaining itself here. That's not very helpful. Yeah, I don't know the math behind this one, but the idea is it just tells you how right or how wrong you are. You just get a number from 0 to 1 at the end of it, or something like that. For this specific one. But
I'm sure someone documented it like a dummy's guide.
Yeah, hopefully. I mean, there's some crazy math behind it and stuff. Yeah, I mean, it's a whole like field of thought, right? You know, machine learning and all these different. There's always like new papers and research coming out about like all these different things. Like this actually is something fairly new. ReLU, I'll touch on this in a second. ReLU is something that they started doing more recently. There used to be a different one, but this is like a huge optimization thing that makes neural nets like 10 times faster, but still get pretty good accuracy. They started using this instead of something else, and now it's kind of like a accepted standard to use this ReLU thing. I forget what it stands for, but oh yeah, I wrote right here ReLU. So okay, let me explain this a little bit. I forgot to touch on the activation functions actually. Okay, let me explain this a little bit. I forgot to touch on the activation functions actually. So how the neural net works is, again, we have all the pixel numbers here from 0 to 255 on each of these nodes. Then we have a bunch of weights here that could be any numbers at all. It could be 0.1, could be 4.6, could be anything, could be negative numbers too. And you just multiply it and then you get like hidden layer stuff. Then from here, when you get numbers, you wanna pass this into another function called the activation function. Like once you get the pixel data, we multiply it by all these crazy numbers and we get like a new column of data here of new numbers. These, we also want to do an extra step that's hidden within these nodes that's called the activation function, which kind of treats it as, it's like another layer of filtering. It kind of like specifies the threshold of like, okay, this is good enough or not good enough. Like for one good example is in the output layer. We can say, okay, if the output is above 0.9, aka above 90%, we can confidently say that this is a shoe, but maybe it's a sandal. You know, like maybe shoe and sandal are both above 0.9, and we can specify that threshold of 0.9. But then just the highest one will be the actual answer. Like maybe it's like 0.95 and then 0.99. So the 0.99 would win, but we can kind of like specify some threshold of like it's passed on and stuff. So you can kind of filter that stuff there. You can be like, okay, anything above 0.9, let it keep going. Anything below 0.9, completely turn off because we're sure it's not a shirt. We're sure it's not a bag and stuff like that. So the activation function just acts as like a filtering mechanism within each layer that can further filter out our data. does that make sense with that whole like 0.9 example of like in the last layer?
Yep.
Did it make sense? Okay, good. So that's what that does. And basically, so what we're doing here is, before they had some crazy function called a sigmoid function. It's not important. It's this thing that kind of like, it's a perfect continuous, it's a nice pretty curve function that kind of like, okay, if we're above this little threshold, then let it by. But it's really computationally intense when you get really big neural nets. So basically what they did is this ReLU thing. They said, okay, literally, if anything is zero, like below zero, just return zero, just passes zero through. But if it's above zero, just pass the actual number it is. So basically it's just like chopping off all negative. It's just getting rid of negative numbers. That's all it's doing. And it sounds really simplistic, but it seems to work in practice. So TF is TensorFlow, and I believe is neural network. Then ReLU is, it just gets rid of negative numbers. So basically, like I said, these weights can have negative numbers, but once it gets here, if it's a negative number, it automatically just gets turned to a zero. And then any positive numbers just stay what they are. And it kind of simplifies like the pattern stuff. I don't remember the exact theory behind it, but it does that, and it actually improves the performance of the neural net. And it does that for each layer that has ReLU specified. So ReLU is like a really popular one. This one down here is, so the activation function here. So this one is softmax, and all softmax does is it just picks the greatest number out of everything. So in our point, because I said that the last layer is going to be 10 layers here from 0 to 9, and it's going to have the probability of each one it being one of these, then it'll just pick the one that has the highest probability and spit that out. So for our case, if I go back to this, quit out of this, and run the code again. So this is our first data image. Then we know this is a shoe. So this probability would probably be the highest. Like this bottom node might be like 0.99 or something, or 0.97, and all these might be like 0.1, 0.4, 0.3. Like it's pretty sure it's not all of these. And since this is the highest, it'll just give us 9. It'll just give us 9. And then we know 9 is mapped to Enkelboot, but it'll just pump out the number 9. So softmax basically just gets the maximum number within that layer. And that's all that activation function does. Very simple, because that's all we need to do in this last layer is just kind of like, which one is the highest? Like that's the final filtering mathematical thing we want to do in this last layer. To finish off the neural net is just find the greatest one. In actual practice, what it does is, I believe it does this, like it might be like 0.1, 0.3, 0.4, 0.2, blah, 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 blah. And then all the way to 0.99 for the last one. All it really does is it just does this. So it just makes all these 0. Oh wait, I screwed it up. It just makes all these 0, and then makes the greatest one 1. It would be like that. So that's really what it's doing. That's what softmax is actually doing. It's just kind of like boiling this down to this. And then from there we can be like, okay, so the 9th one is the one that's on. Okay, this is a shoe. And that's kind of what's happening within the neural net. Is that clear so far?
Yeah, it's kind of clear, but I have a doubt. That basically what's happening is the hidden layer is filtering out all the negative values, and it's just keeping the positive values, and the outer layer, what it's doing, it's just picking up, selecting the max value and setting it to 1. Or like it's telling it's, oh yeah, it's the max value 0.99, so it's gonna be a shoe. Yeah, so like why are we introducing the hidden layer? If can we do this operation using a function, maybe like a simple function? Or like why is the need to introduce the hidden layer? Can we do it without the hidden layer? Is it possible? Or like is it computationally tough, or like it's not possible, or like what could be the solution?
So the point of the hidden layer is to actually, well, I mean, you need the hidden layer for it to be like a neural net in the first place. Like if we just went from, um,
So
if we
what
went,
happens if we eliminate the middle layer? What happens then?
it,
If we
it
just
wouldn't, it
directly
wouldn't, it
connect?
wouldn't work that well at all because here, let me draw it out. Let me annotate a little bit. So you would have the, the 784 here, the 784 input layers here, which is just the pixel data.
Yes.
And then you would simply have the 10 output layers here, right? Which is what you
Yep.
were asking.
0 to 9.
Yeah. So let me just draw this out. So you have the 10 here, and you have the 784 here, like that. And then we want this to be like densely connected. So you would get, I mean, haven't actually tried it. You would get like decent results, maybe, but the idea is you have all the pixel data, then you want to multiply all the pixels by certain numbers and get an output. The problem with this is this actually really isn't a neural net because there is no hidden layer. The idea of the hidden layer is to capture some kind of pattern and kind of generalize like some visual patterns or any, in this case, visual because it's image stuff, but any pattern in any data, and capture those patterns and then eventually filter through enough times to get some kind of results. So, I mean, this does qualify as a neural net, but if you get rid of the hidden layer, the idea of the hidden layers is the more hidden layers you have and the bigger the hidden layers are, then the more patterns you can pick up on and the more accurate you can get. So this kind of completely eliminates like all that pattern seeking stuff because you only have like one layer of numbers to tweak. So it probably wouldn't work that well. But one single hidden layer does work pretty well in
As
this
in
little
the
case.
comments, Nigel says the hidden layer and its connection is the function. So
Pretty much, yeah. It kind of like it is. I mean, it's a function in the sense that you have input and then it does a bunch of computations and then you have some output. So the whole neural net itself is a function, but also each layer is like a mini function within that. So yeah, but then, I mean, the function we're trying to do here is input image, output label of what the heck it is. So that's the high level function. But then the inner function would be like, okay, maybe for this, it's like, okay, does it have a curve? Like, is there like a weird looking curve thing here? Because that it might pick up this curve and be like, okay, this might be a shoe because most shoes have a little curve, like where your toe goes up to your ankle. There's a curve in shoes a lot. And does this look like an L? Something like that. Like, is there a curve here?
Are we gonna dive into the computations and how these neural networks work? Are we gonna dive into that, or it's just the basic outlay of?
A little bit. I want to touch on it a little bit, but not too much, because I mean, yeah, you can go down the whole math rabbit hole if you want, but then it doesn't get too applicable. I've touched on it a little bit before, but I don't want to go too deep into it.
So is it a good practice to dive into what these neural networks do, or it's just like, oh yeah, this functions does this thing, so I need not worry about what's going on within the hidden layer, and it's just like gonna do what it's gonna do?
It depends what you want to do. If you're trying to become a professor or become like an academic or research kind of person, then yeah, you should understand the math. But if you're just trying to create apps and you want to find a way to apply this and make money from it, like as a freelancer, then you don't need to worry about the math. So it really depends what your personal goals are. I'm trying to find like a good middle ground between both, just to kind of give like a general understanding of, okay, the underlying math, so somebody could like converse about it like in a more intelligent way, but then also have some kind of tangible result at the end without getting lost in the calculus, because it gets really messy and I don't remember half of it. I'd have to review all the dirty math.
Actually, I'm pursuing my master's degree in data science, so
okay.
was little bit curious. I'm just starting off, so just was little bit curious about what's really going on within the hidden layers. So as of now, let's keep it simple. Maybe I'll go through your previous videos. It's my first like coaching call with you, I think.
Oh, welcome.
Yeah. So I'll definitely go through those your previous videos as well and grab most of the information from there, and maybe I will get back to you later.
Yeah, awesome. Yeah, I can pass you a couple of resources too. Like if you're actually studying it there, I know a couple other guys are doing similar stuff. They're getting their masters. I dropped out a few months ago, but I was also pursuing my master's in machine learning, but then I stopped to work here full time. So Yeah, I'll pass you a couple. What is your, or just message me on Slack and then I'll pass you a
Uh,
couple resources you can check out that you might find interesting.
yeah, definitely. That would
Yeah,
be
for
great.
the math
Thank you.
stuff. Yeah, of course,
Yeah,
of
yeah.
course.
Thanks, Aaron. Yeah.
Um, what was I saying? Oh yeah, so the hidden layers are definitely needed because that's kind of like where the power, the work gets done. It's like that's the function, like the main part of the function. Like this is just an input function, this is just an output function, but then you need like the pattern recognition, like okay, what is happening function, which is the hidden layers. Okay, let's continue on. So okay, let's continue on. So I'll leave that there because it might be useful later. Okie doke. I was talking about the activation functions and then, okay, loss functions. Again, loss functions tells us how wrong the neural net is, and then optimizer tells us how to tweak all the numbers. And that's what we need for compiling, just because we need to specify like how to do the correct calculations. Like once we pass data into the neural net, we need to know what function to use once it's gone all the way through to measure our incorrectness, and then also what function we need to use to change all the numbers, and repeat that with every image over and over and over again. So that's what compile does. We're just getting our model, our neural net model, ready for training. Now we're just specifying all these things. So next step from here is just to probably just pass in the data and get it going. So let's do that next. How many people are still on here? Let me see, 1, 2, 4, 15 people or so. Not bad.
Hey, Aaron.
Hey, Joe, what is up?
I'm trying to make sense of what the hell is going on here.
Did you come in, were you here from the beginning or did you just jump
No,
in, Joe?
this is my first coaching call. I
Oh,
mean,
got it.
I was on a first call, but
Mhm.
this is the first call with TensorFlow. Is this the first call where you're starting TensorFlow? You did one before.
Last week we did one.
Oh,
Yeah.
shit, I missed that then. Okay.
Yeah, but the recording's in the course, so you can go watch it. That one, yeah, it's about 2 hours. It's a little bit messy at
Yeah,
times,
so
but I think if you go
if you
through,
can
then you
give me
can
like a
catch them.
quick 2-minute pitch of what's the final goal here are we trying to achieve
Yeah,
and
sure.
then how?
Yeah, I'll do
So
that again because doing that over and over again is not a bad idea either, just because it helps kind of solidify the ideas. So again, yeah, TensorFlow, we're using this to design neural networks and solve problems. So we're creating a neural network like this within TensorFlow. The idea is we want to pass in a bunch of images here.
okay.
Within here, each one of these correlates to a pixel brightness, and then from there it'll filter through the neural net. All that means is each of these numbers has each of these lines has a number, and you multiply that number by all the pixel values, and then over time you can pick up weird patterns. And at the very end, we can be like, okay, this might be a shoe or this might be a shirt, because the data we're looking at is actually some, oops, was it supposed to do that? Whoa, what happened? One second. There we go. This one. There we go. Did you see the data that we were looking at? Were you here from the beginning of the call, Joe?
No, I just joined like maybe 5-10
Oh,
minutes
okay,
ago.
got it. Yeah, so we have a bunch of images. So like this is a shoe, and then let me just show you one more. So this one is a oops. Yeah, it's running all this stuff because we have all the code in there. Just ignore that for now. So we had a shoe before, and then we also have a shirt here, okay? So what we
Okay.
do is we have a bunch of images of different types, and it's just like 28 by 28 images like this for shirts. And
Mhm.
basically they're of these 10 different types. So boots, bags, shirts, t-shirt, top, trouser, dress, all this stuff. And the idea is we want to train our neural net on a bunch of these images that are labeled, like this is a shirt, the one before it was a shoe.
and we want to go through our neural net here and train this neural net so that going forward we can put in new images that look like this and then properly identify what they are.
Gotcha. So that is the
right now.
practical example of it. Basically, you're training the network to recognize certain images associate. It's like how your brain functions. When you see something, then next time when you see it, you kind of associate it with that. Correct?
Yep, that's it. So that's what we're doing. So what we did is we designed the whole model. We designed the whole neural net. We have the whole input layer correspond to the whole image. So 28 by 28. We flattened this out into a 784 by 1 column, which is here. So every pixel is represented. Then we filter it through all these crazy numbers. So each of these lines has a number. You multiply the number by the pixel value and you get a new set of numbers. And then you do some other stuff. And then you keep doing it over and over. And at the end, we're going to have 10 different nodes. And then each of those is going to have a probability of how much it believes it's one of those things. So in this case, this is probably going to be probably shirt. It probably spit out a 6. And then the one before was an ankle boot. And so that's what we're currently doing.
Okay.
Yep. And let me just quit out. If it will, my computer is kind of screaming right now. There we go. Oh no. I think I broke it. Dang it. Okay, I'm gonna need a new. All right, CD, desktop, TensorFlow app, and source vn bin activate, I think. Does anybody remember what the command for, let me just find it. Why isn't it opening? There we go. Bin, yeah, bin activate. That's correct. So this should work. Okay. And then Python 3, image classifier 2.py. And okay, there we go. Add the. Okay, yeah, this is the annoying thing because it's training the model every single time over 5 epochs. Just wait a second, guys. Okay, let's get rid of this one because this one is broken. And there we go. Okay, back to where we were. Yep, so welcome, Joe. So that's what we're doing. Now let me continue on in the code.
So each of these, just to interject, so each of these lines, when you say model, so if you scroll, no, not here. Go back to your code. Scroll up for a second. So model, are you assigning this like is that a library, Keras not sequential?
Yeah, okay,
29?
so really quick, you can watch the recording later to get the full explanation, but really quick, Keras is a library that TensorFlow uses to create graphs, which is what we use for the things. And then TensorFlow allows us to do the actual computations. All this means sequential just means that there's a sequential thing of columns, one by one at a time. There's no jumping between. There's no jumping. It's each is in sequence. So that's the overall neural net. Then we specify 3 layers. So the first layer for us is a layer of 128, and then of 28 by 28, which comes out to 784. And then we have one hidden layer of 128. And then ignore these two, pretend these 2 layers aren't here. And then there's an output layer of 10. Which is going to correspond to these 10, which is going to have the probability that each of these, how much it believes the image is one of these 10 things.
All right, I'm with you.
So that's how we create the model. Then from there, we created, we have to compile it. We have to specify a loss function and optimizer function. So this just tells us how wrong the neural net is. And this tells us how to change the neural net to make it a little bit more correct. We just specify those 2 there. You can choose a bunch, like these names aren't important. It's just there's a bunch you can choose from. Then from there, we can just start training. So once we have the model built and we tell it which functions to use, then we can start training the model here. So this is how we do it. So all you do is you call model.fit, and fit just means we're going to fit our current model that we just created to the data set that we have given to it. So in our case, we have a bunch of these images, like the clothing images. There's 60,000. So there's 60,000 images in the training.
and each of those is also labeled 60,000. Some crazy person went through all 60,000 and manually labeled all of them, which is something I would not want to do. And then we also want to specify how many times you want to go through this whole thing. So an epoch is just one pass of this. So you would pass through all of the images, all 60,000 images, see how wrong all of them were, and optimize all of them 60,000 times for all 60,000 images, because there's 60,000 in here. And then you would change everything in the neural net one time. So what we're doing is we're actually adjusting all the weights in the neural net 5 times. And that's what an epoch is we pass all the images in, see how wrong they all are, take the average of all how wrong it is overall, and then optimize it overall. And then we do that 5 times. And that's actually what you're seeing here. You can see that it runs 5 epochs here. Epoch 1 of 5, 2 of 5, blah, blah, blah. From this was covered last week too, if you want to watch the recording. So that's what this does. We're just taking our model and we want to fit it to our training images and labels. So you just pass it in this way, images first, then labels, and then you specify the amount of epochs. And 5 seems to actually be pretty good because the images are pretty small, only 28 by 28. They're not even like, they're really, really tiny. So 5 epochs is sufficient here.
Cool.
Yep. Last thing is, now that we trained our model, now we just want to actually test it. So all you do is you call the evaluate function instead. So because after we run fit, it's trained. Our model is now trained across 5 epochs. That's why it was taking a while. You saw well, let me just run it again. So when we run this, you can see that the image is going to pop up. Just ignore that. So here, so you can see the epoch is running. So it's actually running all 60,000 images, and then it's seeing how wrong it is, and then optimizing, then how wrong it is, and optimizing, how wrong it is, and optimizing across all 60,000 images. And it does that 5 times, and then it stops. So that was the training. And then and then you can actually see the loss. So it's telling you how wrong it was after the first epoch. And then you can see the loss is actually getting smaller and smaller and smaller. And then I believe this is the average or something. I think this is like some overall arcing loss or something, like some global loss, the whole neural net overall. And then from there, so that's what's happening here. Now we can actually.
Is it just learning one image, or is it learning all the 10 images across when you feed it in?
So it's actually taking all of the 60,000 images, and it's training it on all 60,000.
Oh, okay, and that error
5 times.
And that error is across all those images, right? Averages of all the images.
Yeah, how wrong they all were, because we know the correct answer, and then we know the answer the neural net thought it was, and then we can kind of like measure how wrong it was, and then from there, which is what this does. And then the optimizer will tell us how to optimize the weights a little bit better.
Cool.
And quick question, then, if you're only running 5 epochs on that and it's still down to, what was it, like 0.5 something for an error?
Pretty.
If presumably if you ran that like 10 epochs, could you get that? You would get that down even closer.
I mean, I guess let's try it. I don't actually know. I just know that the numbers within this app were actually pretty finely tuned to be like decent performance. So let's run this for 10 and see what happens. So first loss was 3, and then it got down pretty small. I mean, it's a pretty big jump, and then the jumps get kind of smaller. So I think there's like a point of diminishing returns. It doesn't look like it's getting too much smaller. Yeah, you can see it's kind of leveling out there.
Yeah.
So there's probably the data set isn't good enough and the images are just too small. So at a certain point, it's just
proportionally steeps and then levels out, right?
Yeah. So I mean, that's also kind of like you need to like just use some human brain power there and just kind of be like, okay, well, this seems kind of useless for the amount of time it took. Like this got 80% of the results, so maybe we can just keep it to 5. So we'll just put it back to 5. But okay, I need a faster computer.
So if you increase the number of epochs, this image won't get any clearer, right? Now it's blurry.
No. So what's happening is there's a bunch of different images. So like I just showed you the first and second image, the shoe and the shirt. There's actually 60,000 in here. So I could even go like, 50,000 if I wanted. And I could show you this image. Why don't I do that just out of demonstration purposes? But the idea is you're just passing in all these different images, and then you want to train across all those images, but the image will always be 28 by 28. So this is just another shoe. So the 50,000th image in this data set is another shoe, but a slightly different shoe. Okay. Oh my goodness. I gotta stop doing that because it keeps retraining the whole neural net over and over again every time.
Okay, so you're only focusing on a shoe. I thought you were focusing on even the shirt and the other 10 altogether images combined.
Oh, we are. So, I mean, if I chose like 40,000, hopefully this is not a shoe, but there's 10 different types of clothing types, and it's just shuffled. It's just randomized data, but it's all labeled.
All right.
It's all labeled. So here's another shoe. Okay, I keep getting shoes for some reason, but
well, yeah.
And then again with the
you have a 1 in 10 chance.
Yeah, I mean, how many times am I gonna get a shoe versus like dresses or bags or something?
By the 10th time.
Yeah, I mean, I wish they had images in here. They don't have, they don't like show you like the images. Like it would be nice to actually have some sample, but you have to go into the data set yourself. So it is what it is. But you can just kind of take it with a grain of salt that this is what the data is. It's just like randomized images that look like these things. So let's see what we have here. So so we trained our model across 5 epochs, and we saw kind of like the diminishing returns there. So epochs 5 seems to be like a nice finely tuned number there for this specific training data. And then the next thing we want to do is we want to test our model. The next thing we want to do is we want to test our model. So we do that from using model.evaluate. And very similarly to here, instead of training it or fitting it on the training data, we just want to test it on the test data. So like I said at the beginning, there's actually 70,000 images within this data set. We use 60,000 for training and the remaining 10,000 for test. So we put the 60,000 in here, and we're going to use remaining 10,000 images to see how accurate our neural net actually performed. And the thing it's going to return is just test the overall loss, which is it's actually just going to spit out this number, this last one. I think this is like some kind of loss average or something like that. But it's not super important. I just kind of put there to save it. I mean, there is an accuracy number we can get. I think there's like measure accuracy or something. We can actually add that in a second, but let me just finish off the app first, and then we can add it at the end. So when I do that, then we kind of have to do all this code together because nothing's going to show. But what happens here is it's basically evaluating and tells us how wrong it is, but then we can also make predictions. So let's do that next. So yeah, this will get us to accuracy. I'll do that in a second afterwards. But the predictions here, so what we can do is we can actually take the test images that we have, the remaining 10,000, and we can use our model to predict each of these images, and then we can actually compare that to the actual data, the actual labels we have, because we have the correct labels here, the test labels, but we don't want to give it the labels. We just want to give it just the image and see how well it performs. So this is going to give us predictions. And what predictions is it's actually just going to give us the 10 probabilities of each of these last 10 things. So let's start with that. And let me just actually show you predictions at 0. And predictions at, well, actually, let's do this. So I'm going to get rid of this stuff and go down here. So what we're going to do is instead of train images, we're going to go on test images. So let's go to the first test image here. I want to show you guys the first test image. And then show that. And let's actually just comment all this out first so we can go step by step together. So we have the whole model trained and built and all that stuff. Now I just want to show the first test image, and then let's just see what it is together, because I actually don't know what it's going to be.
Aaron, I have a question. Instead of running the whole program again and again, like it will again train the data and this thing, we can use Jupyter notebooks for just running the cell, right?
Yeah, we could use Jupyter notebooks. Yeah, there's like a thing that has TensorFlow built in, and it's called the Google Collaboratory. But I just prefer running it locally. But I guess we could. I still haven't looked into that. Collaboratory, Google Colab, TensorFlow. I think I mentioned this last week. Or we could just use a regular Jupyter notebook if we wanted to. But I came from C, so I'm a big fan of just writing it in the local machine.
Yeah, because even for testing a single data, we need to train the entire model. That's
over and over. Yeah, it doesn't keep the state. I mean, there's probably some way to keep the state there between runs in some way. Like actually, you can probably save the neural net in its current state and then just keep running it. But yeah, I haven't looked into the Jupyter notebooks. I haven't used Jupyter notebooks that much actually at all in my time programming. But I'll try to look into it if it streamlines the process for next week.
Yeah, sure.
Thank you for the suggestion. But okay, so this is the first test data. So again, another shoe. So apparently this data set is very shoe heavy. And let's actually also print out the label. So let's go down here and print out the label of this first one. So this should be test labels at 0. Yeah, so we're just gonna have to wait for it to train each time for now. All right, cool. So it's a shoe here, and then when I quit out of this, it should say 9, which is ankle boot. So 9 is ankle boot. So that's the correct label. So that's what we want to see. We want to see the correct label here. So we're just focusing on this chunk of code here. The first test image is a shoe, and the label is 9. So now we want to use our trained model to actually predict what it's going to be. So if we print predictions at 0, so this is the first image of a shoe and the label, then we call model.predict and we pass in all the test images, and it's going to give us all the predictions. So, and then all we need to do is this is just a list of a bunch of outputs from the neural net. So if we go at predictions at 0, what we're going to get is we're actually going to get the list of 10 probabilities for the first image. And then if this was predictions at 1, we would get the list of 10 probabilities for the second image, so on and so forth. But let's just focus on one at a time. So let's go back to here and run it again. Yeah, I'll look into Jupyter notebooks because this is gonna get tedious. At least it doesn't take, it just takes like 7-8 seconds. Not so bad. All right, and there we go. So you see this here. This is actually the list of probabilities that our trained neural net popped out for that test image of that shoe that we just saw pop up. So it needs to be 9. So ideally, this is going to be the biggest number, and it looks like it is. Like this is all scientific notation. So as this gets bigger, that means it's a smaller number. So 19, 13, 38, 15, 38, 3, 18, 3, 12. Yeah, 1. So this is actually the biggest number, which is the 9th place, because this is the probability of it being the first thing, second thing, and the last one is ankle boot. So this is the biggest number. And we can see it's actually performing correctly there. But this is really messy and ugly. So what I did is I put in a little hack to make it nicer to look at. So let's do that together now. And that's actually these 2 lines. And all this is doing here is instead of printing out that nasty list of all these probabilities here for each of the 10 different things in the neural net, all I do is I use the max function. So the max function here. So look at this highlighted portion of code here. This max function finds the max number within this list for us, which is going to be this last one. It'll find this, and then I just call index on it, so that I can find the index of the max number in that list. So all this is doing here, this is kind of messy, is it's just getting the index of the biggest number in this list. In this case, it's going to be 9. So this will just return us the index of the biggest number, and that's what I'm printing here instead. So let's print that out and see what happens. Predictions and labels at 0. Oh, again, it's got to train. Okay, one last time for this demonstration purpose. And I'll do one more image too, because I think it gets these correct. There we go. So here's the shoe of the first test image, and it's labeled. The label is supposed to be 9, which pops up. And then as you can see, here's the 10 probabilities. Again, the probabilities are a little bit different this time because I guess it trains it in different, it trains the neural net in random orders of the images or something like that. So it's not always exactly the same. But as you can see, it says that this number is the highest because it's the last one. So it actually predicted this image correctly. I don't know why I printed out twice. I think I'm printing it. Oh, because I print out this again. I don't need this. Actually, let's get rid of that one. So as you can see, or actually, let me put that back. Let me get rid of this last one. So as you can see, it actually predicted it correctly. So it's supposed to be 9, and then the neural net predicted it to be 9 as well. And if we go to the second image, which hopefully isn't a shoe, this is bad coding design, just popping in the 1 there like that, but just to show you guys. So let's see what this is. Hopefully it's a shirt or something. Okay. Ah, nice, a shirt. Okay, or some type. I actually don't know what it is. It might be pullover. Or probably going to be pullover because it's long sleeve. It looks like it's a sweater or something. So this is the image, the second test image, and we see that it's a 2, labeled as 2. So yeah, it is a pullover 2. And then this is the probabilities of everything, and it seems like it predicted it to be correct. So it accurately predicted it to be a pullover. And if we look at this 0, 1, 2, yeah, it looks like this index is the biggest number because this is only -1 compared to everything else is a little bit bigger. Don't know what this is. It's a little funky. Not sure why these are zeroed out, but yeah, it looks like it's predicting it pretty accurately. So that there is actually it for the app. Let me see if I can get that accuracy thing, because this will actually test the accuracy of the thing overall. I think it was measure accuracy. Metrics equals accuracy class. There we go. Maybe this. Yeah, so when you're compiling the model, you can actually also specify different metrics for it to spit out. So if you go back up to compile, and I add it here, I think it's metrics equals accuracy, I think. And then let's just try that and see if it breaks. It might break. Actually, I think it worked. Well, I think it's going to give an error right now because I didn't specify the. Oh, okay, it didn't complain. I think they changed some stuff in the new version TensorFlow. Matrix accuracy. Maybe this one. Let's try this since that's what they're telling me to use.
No, actually the accuracy is written there below under each epoch. Open the terminal. Maybe I noticed.
Did you see something?
Yeah, here, right. 81.97 accuracy.
Oh, nice. One. I didn't even see that because it was. Okay,
yeah,
nice,
after each epoch, it shows that.
Finally, I didn't see that at all. Good eye, good eye. Thank you. Oh, nice. Yeah, I'll usually only look at loss because all of machine learning is when the neural net is you're just trying to minimize the loss. Like at the end of the day, you want to get this as close to zero as possible, and then this has like an inverse portion to the accuracy. So cool. So we didn't even have to worry about it. Wait, was this actually running? Oh no, when I did pop in accuracy, it added it on. Nice. So like when I added on this metrics accuracy, so this actually is correct. What it does is I guess it added on the accuracy metric here. So we have the loss, and then I guess not sure what this is. Probably just the timing, but yeah, the accuracy is here, which is good. So we don't have to. That's it. So that was correct. I didn't notice it. Thanks for noticing that. Was that you, Ruben?
Yep.
Was it you? Thank you, Ruben.
No problem.
So yeah, the accuracy there. So we can actually say that across everything, it has a 0.81% accuracy for all of the test data. So when it's running those 10,000 test images, then the accuracy is about that much. Oh, pretty cool. I mean, if we run 10 epochs, I wonder how much that'll actually improve the accuracy of the neural net. And I think this can be the last thing we do to wrap it up. Seven. Okay. Yeah, it looks like it's increasing slowly. Nice. And then there's the second test image of the shirt. But yeah, it looks like it's going up slowly. I mean, it's probably going to level out at some point because of the structure of the neural net. Like if you have a deeper neural net, we might be able to get this up into the 90s or something, the accuracy. But I mean, this is pretty good. I mean, if it's right 83% of the time, I feel like that's a pretty decent neural net for the time it took to train it. It only took like, what, 20 seconds, 30 seconds? So that kind of completes it, guys, for the like computer vision example of using TensorFlow. So a lot more interesting than last week. I know last week we kind of just did this cute little number mapping thing. It wasn't that interesting, and it wasn't that it was just kind of numbers and stuff. But this one, I think it kind of shows the power of TensorFlow a little bit better because it's so easy to define your models and then flatten it. You can tweak all the numbers, and all the different functions are already implemented for you. All different types like dense and flatten, it's all there for you, which is amazing. So I mean, that really concludes it for this image classification. Of course, we can get a lot more complex and a lot deeper than this, but this kind of gives a good introductory example to computer vision and image classification with TensorFlow. So does anybody have any questions about anything at all regarding this?
Just a quick one. If you go up to where you've got your hidden layer again,
mm-hmm.
Is it as simple if you wanted to create a network with more than one hidden layer? Is it just duplicating that piece of code there and having it like exactly the same thing in?
Yep, just like that. So why don't we try to see what happens?
I didn't want to.
Hopefully, it doesn't break anything. I mean, sometimes like I don't know, like there's might be some memory issues or because it exponentially changes stuff. Or let's make this 64 and see what the heck happens. Because yeah, the input and the output is still consistent with our data that we're dealing with. The hidden layers can be abstracted to anything we want. So yeah, let's see. Actually, let's run it for, that's fine. I can just cut it if it breaks. All right. Nice. All right, there we go. So it ran, and it seems like the first loss is a little bit lower than general. It doesn't look like it really improved the effectiveness that much. I mean, also the time didn't go up too much either, so it kind of really didn't do anything.
Yeah, it doesn't really add any value.
Yeah, it didn't really do much with this data set and this problem. But I mean, why don't we try to add? Well, it's, I mean, if adding a second one didn't do anything, adding a third one's not going to do anything either. That's usually how it goes. Well, let's try to go to up to 128 and see if that changes anything. Just see what the heck happens. I mean, it still predicted it correctly because we added more accuracy to it, so it makes sense that it's still correct when it predicts. And the accuracy was a little bit higher, right? I think it was a little bit higher by like 2%, but it's kind of okay. Well, it seems like this one got worse, even though I increased the length of the hidden layer. So yeah, I guess this is where the fine tuning comes in. And then like, there's also like, you might overfit to like your training data sometimes. Like sometimes if you train it too much, then it gets so familiar with the training data that it actually has a reverse effect on new data. Like it gets so well trained to the training data and like that data exactly that it gets stupider the more you train it. So there's like a weird trade-off there too. You kind of want to don't train it too much because then you can kind of preserve the generic patterns that are existing in the training set without overfitting it. The term is overfitting. So when you fit it to this training thing, you kind of want to like not do it too much. It's this balance act, this balancing act. All right.
Aaron, what would be a practical example of this? In a real life kind of, is it like a facial recognition that does the FBI and they run? Is that something similar?
Yeah, so I mean, TensorFlow, like there's a lot of applications for machine learning in general. One that I like to use that just kind of like, let me just pop up the TensorFlow.org.
The dog cat classifier.
The
Dog
classifier. Yeah. I mean, from a standpoint of like, okay, where is this useful? It's just like you could use it for anything. Like one of the classes, I mean, I didn't take it, but I did a little bit in my time at Georgia Tech, was using machine learning for trading. So it's like doing stocks and understanding trends and stuff in the economy for day trading and stuff like that. But yeah, so like you can use it for applications like that, Joe, to maybe like find patterns in like stock prices, and you're like, okay, you can kind of use machine learning to figure out like, okay, Tesla stock is going to keep rising because historically it has. You can like pick up patterns that humans really can't pick up that well. So there's stuff like that there, but little projects like this are just kind of showcase your ability to use TensorFlow and stuff like that. But you do need to understand, like the general machine learning concepts. You need to understand how to actually code TensorFlow itself and all the little different nuances and the syntax stuff there. But then also how you can apply this to like the real world if you actually want to use machine learning to your advantage to make it like a monetizable skill for yourself as a freelancer or as a full-time developer or something. So
if you take your stock trade analogy, how would that transpose when you're talking images versus numeric data, right?
At the end of the day, the images are just a 2x2 matrix of numbers, which is the pixel brightness. So it's just picking up arbitrary patterns in a 2x2 matrix of numbers. So you can actually even pick up similar data within like stock prices and historical data or something like that. Pick up patterns there, be like, okay, this is a good trend, this is a bad trend of a stock price, this is a good stock, this is a bad stock, stuff like that. And then you can kind of like label it as this trend is good, this trend is bad, train it, pop in new trends, and then it can kind of tell you if it's good or bad. Stuff like that's the kind of.
Have you thought about doing a class project to do the lotto numbers?
Lotto numbers? That would be kind of interesting.
You could train it to pick lotto numbers for you.
Well, lotto numbers are kind of, aren't they completely randomized? So I mean, I don't know if machine learning, I mean, maybe.
No, but you get the data on the if you go to the lottery website, they give you the past 10 years of data, and based on historical, there are a very good chance that they repeat the numbers on that day for that day. Like they run, if you do the, what is it?
It's not truly randomized? Wait, the lotto isn't truly randomized?
No, this is a friend of mine. I think he figured out a way. So you know how you play in the one is at the 2 o'clock and there's another at 10 o'clock at night?
Yeah, I've never actually done it, but I'm
so so this guy, he would download 5 years of history from the lotto website. And then he had Excel macro created that would color chart basically, and then he would just play the numbers that the macro would spit out.
Mm-hmm.
And he was making 42 grand a year.
Oh wow, really?
Yeah, I mean, this is no joke. This is the guy I worked with, and
Dang. Yeah, I mean machine
something
learning. Yeah,
similar.
it's powerful. Yeah, because like lotto stuff. I know guys in poker who use it. You know, they like use it to like play poker and maximize stuff using machine learning by like doing that. You can apply it to anything. It's just like at the end of the day, yeah, it's just picking up patterns in data. And I guess yeah, if the lottery isn't 100% randomized, like truly randomized, then yeah, you can pick up patterns over time and kind of like bend it to your um, gambling benefit. But I've never personally done that. I mean, it sounds like a cool project though. I mean, I touched on a good amount of TensorFlow so far because it doesn't get too much from here. Like it doesn't get too much in depth. Like I've kind of covered like half or 60% of like the basic like skills you need to like kind of get started. Then of course there's all these different functions and then you have to kind of like figure out like, okay, like which optimizer is good for this thing and the different data types and making sure everything is like lined up correctly. Even me, I've only done like 5 or 6 projects with it, like in depth. But from there, then I mean, yeah, we could probably. It might be interesting to do something like that, like just kind of build a lotto thing together.
Just to see, you train the model and then you pick a ticket. It's $1, and see, are you close?
Or like
how far off
actually
you
do
are.
it. You want to like actually get a real lotto number. I mean, it's not like $1 or something, right?
Yeah,
Maybe.
and then they have they draw at 2 o'clock in the afternoon, and then they draw it 10 o'clock at night. I don't know. In Connecticut, at least they do it. I don't know how they do it up in LA. Might be different.
Yeah, I've never even looked into it. I try to stay away from that because I feel like it's like I'd rather just go to Vegas, like at least have some fun with it instead of, oh, they picked my number. No, they didn't. Like Vegas, there's people and there's
Yeah,
more fun than lotto. But yeah, I mean that's a cool idea. I did want to ask though, because I have been doing TensorFlow stuff, and I mean it's been kind of like a 2-month process of like teaching you guys like the algorithms, insertion sort, and going through NumPy and Pandas and everything slowly up to this point. But I was talking to Kazi the other day too, and then he was like, yeah, like I mean the idea of Clever Programmer is to get you guys the results, like maximize results, like maximize value for you guys. So this stuff, I mean, it interests me, and I'm teaching you guys, and I feel I finally gotten to this point of teaching you guys a good chunk of TensorFlow. You guys kind of get your feet wet in it. If you're not pursuing your master's in data science like some people are in the course, which is great. But I wanted to ask you guys what would be most of value to you. Like, would it be more of value to you to like go back to web development and like the freelancing stuff? Because I can kind of brush up on that because I know Nasir was talking about he wanted to learn some Django REST API stuff. So I'm pretty rusty on that, but I could try to brush up for the following weeks. And then I know your e-commerce website, Tom. I see you posting about that periodically, stuff like that. So I just want you guys' input if you guys like doing this TensorFlow stuff, or if you guys would prefer to like go back to web development. And we're still in the process of looking for a really good Python developer. We're trying to find a guy that can who has more experience than me to really help you guys scale up.
You're doing good, Aaron. I really like the content of the. It was today. Today was my first class, first coaching call actually with you, and I pretty much learned a lot of things out of it. So I think like you had a machine learning career in the past, and you're teaching machine learning related stuff. So I think you should pretty much focus on this. Maybe for a bit of change or something, you can skip on to web development just for the taste of it. But maybe you should keep your the path clear and like in which you are comfortable with, which suits more for you, most for you.
Okay. Thanks
That's
for
my
the
opinion.
feedback. Yeah, I mean, I could. The only thing is that like there are a lot of beginners, so that's the problem you run into when you have group calls and group sessions. Is everybody's kind of at a different spot, so it's kind of hard to figure out something that's good for everybody without being too beginner or too advanced. Machine learning, I mean, there's probably only like a few edge cases where you'd actually need it, like for people if they're advanced and they could probably like land clients, or it'd be applicable to some project they're working on. But usually they're more advanced. Usually like whipping up like like the Amazon clone or something front end might be a little bit better, like the way like they are in the JavaScript course or something. But
how about combining? Say you have create a web interface with maybe a REST interface, and you run this algorithm or another algorithm on the back end, and then you output it to the browser or something like
that would
that.
be cool. Yeah, like tying it together. I mean, it'd be cool to like just take this project we just did and then like kind of wrap it in like a front end thing and like maybe save save the state of the neural net in like some Django database so that we don't have to keep like training it like we did, and then maybe we could do something bigger, something like that could be cool. Okay. Anybody else have anything they want to say about that though? Like, would they feel like web development might have a little bit more value for them when it comes to like actually having
Yeah, I mean, if you look at anything that's on Upwork or any of those, that's more. I don't see any TensorFlow stuff. That's, I mean, unless you have that skill and niche, I think it's very hard to find that kind of projects. But you would find a lot of web development projects there.
Yeah. I think like more than 60% of the web development. I mean,
or as Leaf suggested, a kind of a blend of both, where leverage. And you get machine learning output.
Yeah, definitely. I mean, it would be cool and fun to blend it. It would be a fun thing to do, but these are all recorded, which is why I kind of want to touch on it, because anybody who wants to learn all this thing, there's like a series of like 6 videos, recorded sessions that they can go through and kind of get started with it, which is the great thing with these live calls, because they're kind of like, they stay there forever. But going forward, I just don't know if that would be more useful for you guys. So like, yeah, looking here, I haven't freelanced in a long time, but TensorFlow, machine learning data. I need to look under jobs, not people.
In my opinion, JavaScript has a more solid grip in web development, and Python is more oriented towards machine learning, data science. It has more to do with the data than
backend,
the side effect. Yeah.
Aaron, have you the content you produced on YouTube? Why don't you go over some of that image recognition or car face detection? I mean, why don't you go over some of that?
I could, yeah. I was very OpenCV heavy, so I didn't really use TensorFlow too much for that stuff. And then actually we implement, I mean, because I was at Georgia Tech, so they're very much about like academic research and everything like that kind of school. They're very much about like, cutting edge research, blah, blah, blah. So like we actually had to code like stuff up from scratch. Like we use OpenCV, but we would code things like not even using TensorFlow at the beginning.
I didn't mean it to be specific to TensorFlow, but just types of projects.
Oh, like OpenCV. I'm trying to think of what I did. Yeah, there was some more. The issue with that is some of the stuff I learned is like, it's fascinating to me because like we get into the dirty math, but at the same time, it's kind of hard to explain these really complicated concepts too, because like it requires like understanding of a lot of calculus and weird things. So it's sometimes it's hard to like regurgitate what I learned to you guys. So the stuff on YouTube was great though, because I kind of boil it down to like the general principles of, like self-driving cars and car and pedestrian tracking and everything. Face detection, small detection, all that stuff was cool. But
it's more tangible. You can relate, you can show and demonstrate, and then people can understand. Is that?
Yeah, I just trying to find like the good middle ground of just like interesting content but useful. I mean, I could go into OpenCV a little bit more. Maybe I could find some cool projects there instead of TensorFlow, or even tie it together both. But
Just on that last topic, I was just thinking, like, where would AI be used in commerce, like on a commerce site or something, where people are like matching up buying and selling, or search algorithms, or
so I mean, I guess like like recommend on Amazon, like Amazon has like, that would be actually pretty cool, because I know Sunny and them, they did the Amazon clone and stuff. It'd be cool if we implemented like a like a recommended items.
Yeah, that's exactly that's what I was.
Recommended systems are huge in AI or machine learning.
Yeah, definitely like that, or like Netflix clone, you could have like recommended shows, or Spotify clone, you could have recommended songs.
How
it's just noticing the trends in people's behavior.
in Netflix, it say if you watch a certain genre movie, it recommends, hey, since you watched this, maybe you would interested in, and the others.
Mm-hmm. Like where's recommended? So yeah, right here, inspired by your purchases. So apparently I was, why is it recommending this stuff? I don't know what this is. It's recommending these
is
light
why I
bulbs.
mentioned the topic, because Amazon
I
does
think-
this to me all the time.
I think
Get an insight into your life here.
flour, water, salt, yeast. So apparently I want to learn how to cook bread.
At some point, you bought something.
Yeah.
Today I
Amazon
searched for pizza and I got results for bikinis.
Again, this could be someone tagged you on Facebook that they do
No
a lot of
idea.
cross. They do a lot of cross hashing too, meaning if one
Yeah.
of your friends who tagged you, she must have brought
I
it.
have no idea.
Yeah,
Maybe
and it was like
Kind of
tagged.
put
10
two
years
and two
ago.
together.
Yeah. So
either the algorithm is weak or the user or the buyers are stupid. It could be either of them.
Yeah, I mean, if I had to give any feedback on it, this stuff's really interesting. I've never heard of TensorFlow before last week or the week before.
Mm-hmm.
I mean, so I would probably just echo what the other guys were saying. Just kind of play to your strengths. If this is the stuff that then stick with it. I think the only thing I would say, being new to this, is it's all really it's very abstract.
Yeah, a lot of math behind it.
Yeah, but I mean, just the whole concept of what it's doing, it's kind of, it's really abstract, and I think if you can find something like what you're just looking here, the recommended things and how it could be applied in real world situations. If you can come up with something like just a really obvious one, like you said, Amazon recommended or whatever, and say this is how you could leverage what this, the sort of stuff, whether it's TensorFlow specifically or this, the same similar sort of theory, just different platform, whatever they're using.
Would TensorFlow be used in like speech recognition, and you have 1,000 different languages across the world, right?
Yeah, absolutely. Yeah, you can use it for voice recognition too, because voice recognition that it's a little different because the files, the data is like a little bit different. I mean, like once it's within the correct form, then it's fine. But like voice data is like a continuous stream rather than like an image. But I mean, same with like.
So when I buy the Alexa, right? It's
I think there's an Alexa here.
Alexa, is this thing built into Alexa, or when you talk to Alexa, it's communicating with another server that has the machine level being constantly updated. It's constantly learning. And
I actually don't know.
Is that how it works?
Yeah.
Probably some mixture.
I think you need to be connected, because every time I get disconnected from my Echo or whatever devices, it doesn't respond.
Mostly the second case, Joe. Actually, I read about it somewhere that it actually the server trains your data received by this echo dot. It's like it continuously trains your
Holy
data.
shit. So they're eavesdropping on me, or they can hear what I
was
say.
a huge issue.
They have all your
Good
data
Lord.
actually.
Yeah, and it's always learning, because I've looked at my Alexa and it comes up with like a yellow flashing band on it, and it's just, you say, "What are you doing?" and it says, "I'm listening to you." Like it's listening.
Oh shit.
It's listening. Yeah, it says Alexa, I'm listening to your speech and things going on in the background to learn.
As long as it's powered. If you don't want it to listen, if I take off the power, it won't, right?
No, there's supposed to be options to disable it. I mean, this was a huge issue a couple years ago that it was a very big issue a couple years ago.
Yeah, the privacy and everything, consent and all that, right?
Yeah.
I know Mark Zuckerberg got busted, right, for like a similar thing, right? Like.
Yeah, because of the data analytica,
Cambridge Analytica.
They did the whole fucking election thing.
Well, they took the data and they did, and they used it for whatever the ads without.
Yeah, but this is interesting.
What they were doing with the data.
It's vast. Like whoever's doing the machine data science for them, they have this as a part of the curriculum, then it's awesome. But for us, getting to trying to get a project, make money off of it. I mean, the blended would make more sense this way. At least you can put it in a portfolio that you did this, and I'll look it up. No worries. Thank you, guys. Appreciate it.
Yeah, absolutely. All right. I think we've been going on for like almost 2.5 hours now. Any last questions, or is it time to go get some lunch?
Dinner.
Yeah,
Dinner for
yeah.
me.
You guys are on the East Coast or something.
Up at time.
It's 3:30 a.m. over here.
Oh, where?
Breakfast time.
India.
Goodness, India. Goodness. All right, you guys. Well, thanks for sticking to the end. All right, you
Thanks,
guys.
Aaron. Appreciate it.
Of
Bye,
course.
Aaron.
Talk to you
Thanks,
guys
guys.
next week.
Thanks, Aaron.
Yeah, guys, and that's really it. So I handpicked these 4 projects for you because I feel like they're just really like a good bite-sized projects for a beginner to go from complete beginner to maybe like beginner intermediate in AI and really get you started. Okay, other than that, you guys, hope you enjoyed the video. But if you're interested in actually excelling your skills in Python and actually making a real income from it, a real living, then please click on the link below to check out our course Profit with Python, which does just that. It pretty much assumes you're a beginner and takes you through the complete roadmap from beginner to actually making an income from beginning to end using Python and to actually become a full-fledged Python developer. All right, you guys, I know we've been sleeping on Python for a long time. We've been doing all the JavaScript stuff, you know. This mic's not even plugged in, by the way. But we've been doing JavaScript, React, Merge Stack, all that stuff. But don't sleep on Python because Python is huge, okay? From the back end, pretty much everything uses Python. Python's everywhere. So you really need to know Python as well. Make sure you know your Python.